The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant, Part 2, continued, Cassette 6, Side 2. 10 years after Fénelon's Traité, Defoe published his appeal for the higher education of women. Except in rich homes, English girls of the 17th century found little opportunity for secondary education. Like Esther Johnson with Jonathan Swift, they had to rely on tutors, or like Evelyn's favorite daughter, they had to purloin knowledge by private enterprise. Macaulay judged that even in the highest ranks, the English women of that generation, 1685 to 1715, were decidedly worse educated than they have been at any other time since the revival of learning. Swift estimated that hardly one gentlewoman in 1,000 was taught to read or spell, but that gloomy dean throve on exaggerations. In any case, Defoe thought the neglect of feminine education a barbarous inequity. I cannot think that God Almighty ever made women so delicate, so glorious creatures, and furnished them with such charms to be only stewards of our houses, cooks, and slaves. So he proposed for girls an academy similar to the public schools of England. There they should learn not merely music and dancing, but languages, as particularly French and Italian, and I venture the injury of giving a woman more tongues than one. They should study history and acquire all the graces and courtesies of speech. The gallant novelist concluded that a woman well-bred and well-taught, furnished with the additional accomplishments of knowledge and behavior, is a creature without comparison, the finest and most delicate part of God's creation, and that the man that has such a one to his portion has nothing to do but rejoice in her and be thankful. By far the best considered and most influential contribution to pedagogical theory in this age of Louis XIV was John Locke's Some Thoughts Concerning Education from 1693, written after the author had served several years as tutor in the family of the first Earl of Shaftesbury. Taking cues from Montaigne, the philosopher proposed that the teacher should first aim at physical health and stamina. A sound body is prerequisite to a sound mind. So his pupils are to eat a simple diet, accustom themselves to scanty clothing, hard beds, cold weather, fresh air, plenty of exercise, regular sleep, no wine or liquor, and very little or no physic, or medicine. Second in time, but first in importance, is the formation of character. All education, physical and mental as well as moral, should be a discipline in virtue. And as the body is to be trained to health by hardships, so character is to be molded by inculcating self-denial in all things that run counter to mature reason. Children should be used to submit their desires and go without their longings, even from their very cradles. The discipline of desire is the backbone of character. This discipline is to be made as pleasant as possible, but it is to be insisted upon throughout. Nor will single good actions suffice. The pupil must be formed by the repetition of virtuous actions into good habits. For habits work more constantly and with greater facility than reason, which, when we have most need of it, is seldom fairly consulted and more rarely obeyed. Locke oscillates between Aristotle and Rousseau. He prefers a libertarian education to one that ignores the bent and individuality of the child. Lessons should be made interesting and discipline humane. But he accepts the occasional desirability of physical punishments for conscious misbehavior. Moreover, inuring children gently to suffer some degrees of pain without shrinking is a way to gain firmness for their minds and lay a foundation for courage and resolution in the future part of their lives. The education of the intellect should be a discipline in methods of thought and rigor of reasoning, not a digest of classics or a bandying of languages. French and Latin should be taught to the children at an early age and by conversation rather than by grammar. Greek, Hebrew, and Arabic should be left to professional scholars. It would be better to give time to geography, mathematics, astronomy, and anatomy, later to ethics and law, finally to philosophy. The business of education is not to make the young perfect in any one of the sciences, but so to open and dispose their minds as may best make them capable of any, when they shall apply themselves to it. And as virtue is to be trained by habit, so thought is to be trained by repeated reasonings. Nothing does this better than mathematics, which therefore I think should be taught to all those who have the time and opportunity, not so much to make them mathematicians as to make them reasonable creatures. We are born to be, if we please, reasonable creatures, but it is use and exercise that makes us so, and we are intended so no further than industry and application has carried us. I have mentioned mathematics as a way to settle in the mind a habit of reasoning closely and in train, that having got the way of reasoning which that study naturally brings the mind to, they might be able to transfer it to other parts of knowledge as they shall have occasion. Locke's treatise was designed for a liberal education, that is, one chiefly in arts, literature, and manners. It was intended to produce a gentleman, that is, a man of gentle birth, who would never have to work for a living. Its curriculum, while admitting some sciences, generally adhered to the humanities, the studies favored by the Renaissance humanists. It included also dancing, riding, wrestling, fencing, and even a manual trade, nay, 2 or 3, but as helps to health and character, not as means of livelihood. The arts were to be taught as recreations, not as professions. The young gentleman was not to take such affairs very seriously. He should enjoy poetry, but not write it except as a pastime. He should be taught to enjoy music, but not to seek proficiency on any instrument. This would take too much time, and besides it would put the youth into such odd company. So Locke's treatise was both conservative and liberal. In its repudiation of scholastic absorption in ancient languages, its lessened stress on religion and theology, its emphasis on health and character, and its effort to prepare well-born youth for public life and service, it pointed to the future and had immense influence in England and America. It shared in forming the physical and moral side of education in the English public schools. Translated into French in 1695, it went through 5 editions in 50 years and gave many suggestions to Rousseau. Locke's own pupil, the 3rd Earl of Shaftesbury, whom we shall meet again, did credit to his teacher's theories and character. 3. The Scholars. Despite their apparent preoccupation with dying languages and dead debates, great scholars continued to mold the future by illuminating the past, and some found themselves embattled in the struggle of Christianity against free thought. Certain minor devotees merit a passing reverence. Charles Dufresne, Sieur Ducange, astonished his contemporaries, who knew him as a lawyer in the Paris Parlement, by issuing in 1678 a dictionary of late and medieval Latin in 3 volumes so meticulous in scholarship that they are still the authority in their field. Pierre Bayle discovered and edited a major manuscript of Origen, learned Syriac, Arabic, and chemistry, made 800 anatomical dissections, wrote poetry and fiction, and shared with the learned Madame Dacier in editing for the instruction of the Dauphin the famous 60-volume Delphin edition of Latin classics. He was made Bishop of Avranches, and dying left the library that is now a treasured part of the Bibliothèque Nationale. The Jesuit Bollandists continued their centipedalian Acta Sanctorum. In Paris, under the lead of Jean Mabillon, the Benedictine congregation of Saint-Maur compiled, from 1668 to 1702, a 20-volume history of Benedictine saints. In the process, they shed precious light upon the annals and literature of medieval France. Mabillon himself gave a new form to Latin paleography by his De Re Diplomatica from 1681, not a manual of diplomacy, but a treatise on the date, character, and authenticity of old charters and manuscripts. Completing one of his fat folios, Mabillon wrote, "May it please God not to impute it to me as a crime that I have passed so many years studying the acts of the saints, and yet resemble them so little." The giant of classical erudition in this age was Richard Bentley, stern master of Trinity College, Cambridge, for 42 years. His youth was consumed in consuming the Bodleian Library. At 29 he was already among the most learned pundits of Europe in Greek, Latin, and Hebrew literature and antiquities. In that year, 1691, he published a 100-page Epistola ad Milium, a letter to an early John Mill, so accurate and recondite in its scholarship that it gave him a European fame. At 30 he was chosen to give the first series of the lectures for which funds and a name had been provided in the will of the pious chemist Robert Boyle. He responded by arguing powerfully that the cosmic order revealed in Newton's recent Principia proved the existence of God. This was a great comfort to Newton, who had been accused of atheism. Bentley was appointed to the post of royal librarian, with an apartment in St. James's Palace. There he met frequently with Newton, Locke, Evelyn, and Wren. And from that citadel he fought one of the most famous battles in British scholarship. The contest arose from the English share in the debate on the relative merits of ancient versus modern literature. Sir William Temple opened fire with the essay of Ancient and Modern Learning in 1690, defending antiquity. Bentley would probably have praised the essay had it not praised Phalaris as an example of Greek superiority in literature. Phalaris was a dictator who governed Acragas in Greek Sicily in the 6th century before Christ. History or legend described him as roasting his enemies in the belly of a brazen bull. But it honored him as a patron of literature, and 148 letters had come down the centuries allegedly from his pen. Charles Boyle, an undergraduate at Christ Church College, Oxford, published the letters in 1695. William Wotton, preparing a second edition in 1697 of his Reflections upon Ancient and Modern Learning, in which he opposed Temple, asked Bentley to judge the authenticity of the letters. Bentley replied that their attribution to Phalaris was a mistake, that they were written in the 2nd century A.D. Incidentally, he pointed out some errors in Charles Boyle's edition. Boyle and his teachers issued a hot defense of Phalaris's authorship. Jonathan Swift, secretary to Temple, entered the fracas on his master's side by ridiculing Bentley in The Battle of the Books. The general opinion of scholars supported Boyle, and Bentley's friends bemoaned the apparent collapse of his reputation. His answer to them deserves remembrance. No man was ever written out of reputation but by himself. In 1699, he issued an enlarged dissertation on the epistles of Phalaris. Not only did it prove his case, but it shed so much light on the evolution of the Greek language that the world of scholarship acclaimed him as worthy to join the line of the Scaligers, Casaubon, and Salmasius. Even the style of the letters betrayed their century, said Bentley, and he added, "Every living language, like the perspiring bodies of living creatures, is in perpetual motion and alteration. Some words go off and become obsolete. Others are taken in and by degrees grow into common use, or the same word is inverted to a new sense and notion, which in tract of time makes as observable a change in the air and features of a language as age makes in the lines and mien of a face. All are sensible of this in their own native tongues, where continual use makes every man a critic. For what Englishman does not think himself able, from the very turn and fashion of the style, to distinguish a fresh English composition from another 100 years old? Now, there are as real and sensible differences in the several ages of Greek, but very few are so versed and practised in that language as ever to arrive at that subtlety of taste." Here was a scholar who could write English as well as read Greek. In 1699, the unanimous vote of the 6 bishops appointed by William III to nominate for the vacancy raised Bentley to the mastership of Trinity College, Cambridge. He reformed student discipline, improved the curriculum, and built an laboratory for chemistry and an observatory for astronomy. But he so alienated the faculty by his pomp and overbearing ways, his affection for money, that he was twice sentenced to removal from his office. He fought back and kept his post to the end. Meanwhile, he edited a large number of Greek and Latin classics, encouraged and financed the 2nd edition of Newton's Principia, demolished Anthony Collins in Remarks on a Late Discourse of Free Thinking in 1713, and ventured rashly from his field by editing Paradise Lost with pedantic corrections of Milton's grammar and text. He made an enemy of Alexander Pope by saying of his translation of the Iliad, "A pretty poem, Mr. Pope, but you must not call it Homer." The portentous cub, Bentley reported, never forgave him. In the Dunciad, in April 1742, Pope ridiculed him as the mighty scholiast, whose unwearied pains made Horace dull and humbled Milton's strains. In July, Bentley died from a complication of Pope and pleurisy. He was the greatest and most insufferable scholar that England ever produced. Meanwhile, another Englishman, Thomas Stanley, broadened the British mind with the first English history of philosophy from 1655 to 1662, and surprised his readers by devoting the last of its 4 volumes to Chaldaic, or Arabic, philosophy. Scholarship was venturing beyond ancient Rome and Greece to the Near and Middle East, with disturbing results. Edward Pocock discovered and edited 4 Syrian versions of the New Testament epistles in 1630. For him, Oxford established its first chair of Arabic, and his lectures there opened English eyes to Islamic civilization. In France, Barthélemy d'Herbelot's life-work, an immense Bibliothèque Orientale, from 1697, subtitled universal dictionary containing generally all that concerns a knowledge of the Orient, was a revelation of Arabic history and learning, and played a part in that broadening of intellectual horizons which burst all bonds in the 18th century Enlightenment. Students wondered at the wealth of Arabic poetry, historiography, philosophy, and science. They noted how the Arabs had preserved Greek science and philosophy while these were being forgotten in the dark ages of Western Europe. They learned that Mohammed was no mere impostor, but a subtle statesman, and they were puzzled to find no more crime and no less virtue in Islam than in Christendom. The relativity of morals and theology became a dissolving ferment in the Christian mind. Studies of Oriental, including Egyptian and Chinese chronology, undermined the Jewish calculation that the world had been created in 3761 BC, and the computation in 1650 of James Ussher, Anglican Archbishop of Armagh in Ireland, that the creation had occurred at the beginning of the night before Monday, the 23rd of October, 4004 BC. Spinoza, as we shall presently see, was inaugurating in 1670 the higher criticism of the Bible, the study of it as a human production, rich in grandeur and nobility, in errors and absurdities. The most learned biblical critic of the 17th century, in an attempt to answer Spinoza, brought down upon his head the thunder of Bossuet for finally conceding much of what the philosopher had claimed. Richard Simon, a blacksmith's son, had joined the oratory at Paris and had been ordained a priest in 1670. In that year he wrote a pamphlet defending the Jews of Metz, who had been accused of murdering a Christian child. In 1678, after years of research, including studies with several rabbis, he prepared to publish his Histoire critique du Vieux Testament. He proposed, en passant, to refute Spinoza's arguments against the divine inspiration of the Scriptures. He admitted that the books of the Old Testament were not entirely the work of the authors to whom they were ascribed, that Moses could not have written all the Pentateuch, which described Moses' death, and that the biblical books had been considerably altered from their first form by the scribes and editors who had transmitted them. Simon struggled to keep his orthodoxy and imprimatur by holding that these revisers too had been divinely inspired, but he confessed that all existing copies of the Old Testament were so mangled with repetitions, contradictions, obscurities, and other difficulties that they could offer only a frail basis for a dogmatic theology. He thought to turn this point against the Protestants by contending that their belief in the verbal inspiration of the Scriptures left them helpless against textual criticism, while a loyal Catholic could survive such scholarship by accepting the interpretation put upon the text by the Roman Church. In any case, Simon concluded, the divine inspiration of the Bible applied only to matters of faith. The general of the oratory sanctioned the publication of Simon's book, but while it was in the press, some of the proof sheets came under the eye of the great Arnaud of Port Royal. He was alarmed. He showed the sheets to Bossuet, who at once denounced the volume as a tissue of impieties and a bulwark of free thought, which would destroy the authority of canonical Scripture. Bossuet appealed to the secular authorities to prevent publication of the book. They confiscated the entire issue of 1,300 copies and reduced them to pulp. Simon retired to an obscure curacy in Normandy, but he found ways of having his manuscript printed in Rotterdam in 1685. 4 years later he published his Histoire critique du Nouveau Testament. He proposed to complete his labors with a new translation of the Bible. He finished his version of the New Testament, but Bossuet, shocked by the freedom with which Simon handled the sacred text, persuaded the Chancellor to suppress the book in 1703. Simon abandoned his enterprise, burned his papers, and died in 1712. His work on the Old Testament elicited 40 refutations, indicating its irrefutability. With Spinoza's Tractatus Theologico-Politicus, it remains one of the landmarks in the modern study of the Bible. LEIBNIZ, reading these early critiques, warned that this line of inquiry, if continued, would destroy Christianity. It is still too early to say whether LEIBNIZ was right. Chapter 18. The Scientific Quest, 1648 to 1715. 1. The International of Science. Slowly the mood of Europe, for better or for worse, was changing from supernaturalism to secularism, from theology to science, from hopes of heaven and fears of hell, to plans for the enlargement of knowledge and the improvement of human life. The upper classes, pursuing their Epicurean ways, made little protest against a religious faith which they conceived to be salutary for the unfortunate masses excluded from the paradise of pedigree. Yet even among the gilded few there were some who played at science, balanced equations, burned their fingers or sniffed their noses in laboratories, or gazed in puzzlement at the multiplying stars. In Paris, fashionable ladies crowded to Lemery's lectures on chemistry, to Duvernay's demonstrations in anatomy. Condé invited Lemery to his very exclusive salon, and Louis XIV appointed Duvernay to aid in educating the heir to the throne. In England, Charles II had a chemical laboratory of his own. Barons, bishops, and barristers contrived experiments. Elegant mistresses came in their carriages to observe the marvels of magnetism. Evelyn dabbled in physics, and proposed to establish an institute for scientific research. Pepys, between ships and skirts, plied the microscope, the air pump, and the dissecting knife, and became president of the Royal Society. The universities lagged behind the public in the new interest, but private academies took it up. First, apparently, the Academia Secretorum Naturae at Naples in 1560, then the Accademia dei Lincei at Rome in 1603, to which Galileo belonged, then the Accademia del Cimento, which his disciples Viviani and Torricelli founded at Florence in 1657. This last institute was dedicated by its name to experiment, and took Cartesian doubt as its starting point. Nothing was to be received on faith. Every problem was to be investigated without regard to any existing sect or philosophy. Some of these academies were short-lived, but they left successors when they died. Academies were established at Schweinfurt in 1652, Altdorf in 1672, and Uppsala in 1710. In 1700, after 30 years of pleading by Leibniz, the Berlin Academy took form, and to Leibniz's credit we must ascribe also the Academy of St. Petersburg in 1724. In France, the Académie des Sciences developed from the meetings between 1631 and 38 of Mersenne, Roberval, Desargues, and other scientists in the home of Pascal's father in Paris, or in Mersenne's monastic cell. It formulated a program to work for the perfection of the sciences and the arts, and to seek generally for all that can be of use or convenience to the human race. It resolved also to disabuse the world of all those common errors that have long passed for truth. But it counseled its members to avoid discussion of religion or politics. In 1666, the Academy received a royal charter and a room in the Bibliothèque Royale. At Versailles, we may still see a large canvas by Testelin, in which Louis XIV presents this charter to a group headed by Christian Huygens and Claude Perrault. Each of the 21 members received an annual salary from the government and funds for expenses. In effect, the Academy became a department of the state. Louis was especially kind to astronomers. He invited Cassini from Italy, Römer from Denmark, Huygens from Holland, and built for them a splendid observatory. When Hevelius of Danzig, who had distinguished himself by his studies of the moon, lost his precious library in a fire, the king sent him a substantial gift to repair the loss. Laplace credited the Académie with most of the scientific advances made in France, but its dependence upon a king closely allied with the Church proved detrimental to the progress of French science, and the English forged ahead. It was characteristic of England that its scientific academies were private foundations only incidentally indebted to the government. About 1645, according to John Wallis, he became acquainted in London with divers worthy persons, inquisitive into natural philosophy and other parts of human learning, and particularly experimental philosophy. They agreed to meet once a week to discuss mathematics, astronomy, magnetics, navigation, physics, mechanics, chemistry, the circulation of the blood, and other such subjects. This invisible college, as it was then called, took its inspiration from the House of Solomon in Bacon's New Atlantis. When Wallis removed to Oxford as professor of mathematics, the association divided into two sections, one of which met in the lodgings of Robert Boyle at the university, the other in Gresham's College, London. Wren and Evelyn were early members there. The political turmoil intervening between the death of Cromwell and the Restoration interrupted these London meetings, but they were resumed soon after the accession of Charles II. And on July 15, 1662, the king conferred an official charter upon the Royal Society of London for Improving Natural Knowledge. The 98 original fellows included not only scientists like Boyle and Hooke, but poets like Dryden and Waller, Wren the architect, Evelyn, 14 peers, and several bishops. Between 1663 and 1686, some 300 additional fellows were enrolled. No class distinctions divided them. Dukes and commoners rubbed elbows in the enterprise, and poor members were exempt from dues. In 1673, LEIBNIZ, admitted to membership, declared the Royal Society the most respected intellectual authority in Europe. As early as 1667, Thomas Sprat published his excellent History of the Royal Society. He, too, though he became Bishop of Rochester, was stirred by the Baconian breezes that were blowing over England. Some theologians complained that the new institute would undermine respect for the universities and the established church, but the moderation and caution of the society soon calmed ecclesiastical opposition. Its strange experiments amused the court and the king, who laughed when he heard that it was weighing air and meditating mechanical flight. Swift satirized it in Gulliver's Travels as the Grand Academy of Legado, whose members made plans for extracting sunshine from cucumbers and for building houses from the roof downward. And Samuel Butler, author of Hudibras, told how a club of scientists was excited by discovering an elephant in the moon, only to find that it was a mouse in their telescope. But it was under the auspices of the Royal Society that Evelyn improved English husbandry, that Sir William Petty established the science of statistics, that English science and medicine advanced beyond anything known in contemporary France or Germany, that Boyle almost founded chemistry, that Ray revolutionized botany, Woodward geology, and Newton astronomy. The Society made thousands of experiments in chemistry and physics. It received, dissected, and studied the bodies of executed criminals. It became a repository of clinical reports from physicians in all parts of the country. It collected reports of technological developments. It kept in touch with scientific research abroad. Its emphasis on natural processes and law discredited superstition and the witchcraft persecution. In 1665, Henry Oldenburg, its secretary, began to publish the Philosophical Transactions of the Royal Society, which has continued to our own day. It invited and received contributions from abroad. It was among the first to print the findings of Malpighi and Leeuwenhoek. Oldenburg had come to England in 1653 to negotiate a trade treaty for his native Bremen. He remained and became a friend of Milton, Hobbes, Newton, and Boyle. He corresponded actively with scientists and philosophers in all parts of the world. The members of the Royal Society, he said, have taken to task the whole universe. And he wrote to Spinoza, "We feel certain that the forms and qualities of things can best be explained by the principles of mechanics, and that all effects of nature are produced by motion, figure, texture, and the varying combinations of these, and that there is no need to have recourse to inexplicable forms and occult qualities as to a refuge from ignorance." Through these philosophical transactions, the Journal des Savants, the Giornale dei Letterati, and the Acta Eruditorum, the scientists and scholars of Europe were able to overcome national boundaries, to keep in touch with one another's work and findings, and to form a united army of advance in a vast creative enterprise. Almost hidden away in their studies, laboratories, and expeditions, ignoring or surviving the clatter of politics, the march of regiments, the din of dogma, the mists of superstition, and the prying agents of civil or ecclesiastical censorship, they pored over texts, test tubes, and microscopes, mingled chemicals curiously, measured forces and magnitudes, plotted equations and diagrams, peered into the mysteries of the cell, burrowed into the strata of the earth, charted the movements of the stars, until all the motions of matter seemed to fall into an order of law, and the overwhelming immensity of the universe seemed to obey the predictions of the amazing human mind. In France, Fermat, Pascal, Roberval, Mariotte, Perrault, and whole families of Cassinis. In Switzerland, the Bernoullis. In Germany, Guericke, Leibniz, Tschirnhaus, Fahrenheit. In Holland, Huygens and Leeuwenhoek. In Italy, Viviani and Torricelli. In Denmark, Steno. In Scotland, James and David Gregory. In England, Wallace, Lister, Boyle, Hooke, Flamsteed, Halley, Newton. These and many others in this brief period of Europe's history from 1648 to 1715 labored apart and together, solitary and conspiring, to build day by day, night after night, the mathematics, astronomy, geology, geography, physics, chemistry, biology, anatomy, and physiology that were to effect a fateful revolution in the modern soul. Oldenburg, feeling this internationalism of science and never dreaming that nationalism might make science itself a partisan and cataclysmic tool, saw in this inspiring cooperation an omen of a better life. "I hope," he wrote to Huygens, "that in time all nations, even the less civilized, will embrace each other as dear comrades, and will join forces, both intellectual and material, to banish ignorance and to make true and useful philosophy regnant." It is still the hope of the world. 2. Mathematics. First, the new International sharpened its instruments. Pascal, Hooke, and Guericke developed the barometer. Guericke's air pump explored the possibility of a vacuum. Gregory, Newton, and others made better telescopes than those of Kepler and Galileo. Newton invented the sextant. Hooke improved the compound microscope, which transformed the study of the cell. The thermometer became more reliable and accurate under Guericke and Amonton, and in 1714 Fahrenheit gave it its English-American form by using mercury instead of alcohol as the expanding medium and dividing its scale at 0, 32 degrees, and 96 degrees, which he assumed to be the normal temperature of the human body. The greatest instrument of all was mathematics, for this gave experience a quantitative and measured form, and in 1,000 ways enabled it to predict, even to control the future. "Nature plays the mathematician," said Boyle, and Leibniz added, "Natural science is naught but applied mathematics." Historians of mathematics acclaim the 17th century as especially fruitful in their field, for it was the century of Descartes, Napier, Cavalieri, Fermat, Pascal, Newton, Leibniz, and Desargues. Ladies perfumed with pedigree attended lectures on mathematics. Some of them, joked the Journal des Savants, made the squaring of the circle the sole passport to their favors. This may explain Hobbes's persistent efforts to solve that baffling problem. Pierre de Fermat fathered the modern theory of numbers, the study of their classes, characteristics, and relationships, conceived analytical geometry independently of, perhaps before, Descartes, invented the calculus of probabilities independently of Pascal, and anticipated the differential calculus of Newton and Leibniz. Yet he lived in comparative obscurity as a councillor of the Parlement of Toulouse, and formulated his contributions to mathematics only in letters to his friends, which were not published till 1679, 14 years after his death. We catch the mathematical ecstasy in one of these letters. "I have found a very great number of exceedingly beautiful theorems." He was delighted by every new trick or surprising regularity in numbers. He challenged the mathematicians of the world to separate a cube into 2 cubes, a 4th power into 2 4th powers, etc. "I have discovered," he wrote, "a truly marvelous demonstration of this," now known as Fermat's last theorem. But neither his nor any conclusive proof of it has yet been found. A German professor in 1908 left 100,000 marks to the first person who should prove Fermat's proposition. No one has yet claimed the reward, perhaps discouraged by the depreciation of marks. Christian Huygens, barring only one, was the outstanding scientist of this age, facile secundus to Newton. His father, Constantine Huygens, was one of the most distinguished of Holland's poets and statesmen. Born at The Hague in 1629, Christian began at the age of 22 to publish mathematical treatises. His discoveries in astronomy and physics soon won him a European renown. He was elected a Fellow of the Royal Society in London in 1663, and in 1665 he was invited by Colbert to join the Académie des Sciences in Paris. He moved to the French capital, received a liberal pension, and remained there till 1681. Then, uncomfortable under a king-turned-persecutor of Protestants, he returned to Holland. His correspondence in 6 languages with Descartes, Roberval, Mersenne, Fermat, Pascal, Newton, Boyle, and many others illustrated the growing unity of the scientific fraternity. "The world is my country," he said. "To promote science is my religion." His mens sana in corpore aegro was one of the marvels of his time, his body always ailing, his mind creative till his death at 66. His work in mathematics was the least part of his achievement. Yet geometry, logarithms, and calculus all profited from his labors. In 1673 he established that law of inverse squares, that the attraction of bodies for one another varies inversely as the square of the distance between them, which became so vital to Newton's astronomy. Newton, of course, was now the central luminary in the galaxy of British science. He deserves a separate chapter, but there were satellites to his star. His friend John Wallis, an Anglican priest, became civilian professor of geometry at Oxford in 1649 at the age of 33, and held that chair for 44 years. Grammar, logic, and theology diverted his pen from science. Nevertheless, he wrote effectively on mathematics, mechanics, acoustics, astronomy, tides, botany, physiology, geology, and music. He lacked only some amours and wars to make him a full man. His De Algebra Tractatus Historicus et Practicus, from 1673, not only contributed original ideas to that science, but was the first serious attempt in England to write the history of mathematics. His contemporaries were delighted by his prolonged controversy with Hobbes over the quadrature of the circle. Wallis scored his point, but the old philosopher fought on to the end of his 91st year. History remembers Wallis chiefly for his Arithmetica Infinitorum from 1655, which applied Cavalieri's method of indivisibles to the quadrature of curves, and so prepared for infinitesimal calculus. Calculus meant originally a small stone used by the ancient Romans in calculating, but only the devotees of calculus can now define their science properly. Archimedes had glimpsed it, Kepler had approached it, Fermat had discovered it but had not published his findings. Cavalieri and Torricelli in Italy, Pascal and Roberval in France, John Wallis and Isaac Barrow in England, James and David Gregory in Scotland, had all carried bricks to the building in this astonishing cooperation of a continent. Newton and Leibniz brought the work to fulfillment. The term calculus was suggested to Leibniz by Johann Bernoulli, member of a family as remarkable as the Bachs, the Bruegels, and the Couperins for the social heredity of genius. Nicolaus Bernoulli, from 1623 to 1708, like his ancestors, was a merchant. In his son Jacob Bernoulli I, 1654 to 1705, mercantile accounting passed into higher forms of reckoning. Taking as his motto, in vito patre sidera verso, against my father's will I study the stars, Jacob dabbled in astronomy, contributed to analytical geometry, advanced the calculus of variations, and became professor of mathematics at the University of Basel. His studies of catenary curves, curves described by a uniform chain suspended between 2 points, came to later fruition in the designing of suspension bridges and high-voltage transmission lines. His brother Johann, 1667 to 1748, also against paternal plans, took up medicine, then mathematics, and succeeded Jacob as professor at Basel. He contributed to physics, optics, chemistry, astronomy, the theory of tides, and the mathematics of sails. He invented exponential calculus, constructed the first system of integral calculus, and introduced the use of the word integral in this sense. Another brother, Nicolaus I, 1662 to 1716, took his doctor's degree in philosophy at 16, in law at 20, taught law at Bern and mathematics in St. Petersburg. We shall find 6 more Bernoulli mathematicians in the 18th century, and there were 2 in the 19th. By that time, the Bernoulli battery had run down. The establishment of statistics as almost a science was among the achievements of this age. John Grant, a haberdasher, amused himself by collecting and studying the burial records of London parishes. Usually these records stated the reported cause of death, including dead in the street and starved, executed and pressed to death, king's evil, starved at nurse, and made away themselves. In 1662, Grant published his Natural and Political Observations upon the Bills of Mortality. This is the beginning of modern statistics. He concluded from his tables that 36% of all children died before the age of 6, 24% died in the next 10 years, 15% in the next 10, etc. The infantile mortality seems much exaggerated here, but suggests the labor of love in keeping up with the angel of death. Among the several casualties, said Grant, Some bear a constant proportion unto the whole number of burials. Such are chronical diseases, and the diseases whereunto the city is most subject, as, for example, consumptions, dropsies, jaundice, etc. That is, certain diseases and other social phenomena, though incalculable in individuals, may be pre-calculated with relative accuracy for a large community. This principle, here formulated by Grant, became a foundation of statistical prediction. He noted that in many years the burials in London exceeded the christenings. He concluded that London was especially rich in opportunities for death, as from business anxieties, smokes, stinks, close air, and intemperance in feeding. As the population of London grew nevertheless, Grant ascribed the increase to immigration from the countryside and the lesser towns. He reckoned the population of the capital in 1662 at some 384,000 souls. Statistics were applied to politics by Grant's friend Sir William Petty, again exemplifying a versatility impossible today. Petty, after studying at Caen, Utrecht, Leiden, Amsterdam, and Paris, taught anatomy at Oxford and music at Gresham College, London, and won fortunate knighthood as physician to the Royal Army in Ireland. In 1676 he wrote the second classic in English statistics, Political Arithmetic. Politics, Petty held, could approach to a science only by basing its conclusions on quantitative measurements. Therefore he pleaded for a periodical census that would record the birth, sex, marital condition, titles, occupation, religion, etc., of every inhabitant of England, on the basis of mortality bills, number of houses, and annual excess of births over deaths. He estimated the population of London at 696,000 in 1682, of Paris 488,000, Amsterdam 187,000, Rome 125,000. Like Giovanni Botero in 1589 and Thomas Malthus in 1798, Petty thought that population tends to increase faster than the means of subsistence, that this leads to war, and that by the year 3682 the habitable earth would be dangerously overcrowded, with 1 person to every 2 acres of land. Insurance companies used statistics to turn their business into an art and science that took account of everything except inflation. From the mortality reports of Breslau, Edmund Halley drew up in 1693 a table of expectable deaths for all years between 1 and 84. On its basis, he calculated the odds against persons of a given age dying during the calendar year and deduced the logical price of a policy. The first life insurance companies established in London in the 18th century made use of Halley's tables and turned mathematics into gold. 3. Astronomy. The stars were subjected to science in 100 countries. In Italy, the Jesuit astronomer Riccioli, in 1650, discovered the first double star, that is, a star which to the eye seems one but is seen through the telescope as 2 stars apparently revolving around each other. In Danzig, The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant. Part 2, continued. Cassette 7, Side 1. Recognizing the importance of astronomy for navigation, Louis XIV provided funds to raise and equip an observatory at Paris from 1667 to 1672. From that center, Jean Picard led or sent expeditions to study the skies from different points on the earth. He went to Uraniborg to note the exact location from which Tycho Brahe had made his classic map of the stars, and by a variety of observations ranging from Paris to Amiens, he measured a degree of longitude with such accuracy, within a few yards of the current figure, 69.5 miles, that Newton is supposed to have used Picard's results to estimate the mass of the earth and verify the theory of gravitation. By similar observations, Picard reckoned the equatorial diameter of the earth at 7,801 miles, not far from our present computation of 7,913 miles. These findings made it possible for a ship at sea to determine its location with unprecedented precision. So the commercial expansion and industrial development of Europe urged on the scientific revolution and profited from it. At Picard's suggestion, Louis XIV invited to France the Italian astronomer Giovanni Domenico Cassini, who had already acquired European fame by discovering the spheroidal form of Jupiter and the periodic rotation of Jupiter and Mars. Arrived in Paris in 1669, he was received by the king as a prince of science. In 1672, he and Picard sent Jean Richet to Cayenne in South America to observe Mars at its maximum opposition to the sun and nearness to the Earth. Cassini noted the same opposition from Paris. The comparison of the simultaneous observations from these two separate points gave new and more precise values to the parallax of Mars and the sun and their distance from the Earth, and revealed vaster dimensions in the solar system than had been estimated before. As a pendulum was found to beat more slowly at Cayenne than a similar pendulum at Paris, the astronomers concluded that gravity was less intense near the equator than in higher latitudes, and this suggested that the Earth was not a perfect sphere. Cassini thought it was flattened at the equator. Newton thought it was flattened at the poles. Further research supported Newton. Meanwhile, Cassini discovered 4 new satellites of Saturn and the division, now known by his name, of Saturn's ring into 2. After Cassini's death in 1712, he was succeeded in the Paris Observatory by his son Jacques, who measured the arc of the meridian from Dunkirk to Perpignan and published the first tables of the satellites of Saturn. Christian Huygens, before joining the cosmopolitan assemblage of scientists in Paris, made at The Hague some important contributions to astronomy. With his brother Constantine, he developed a new method of grinding and polishing lenses. With these, he constructed telescopes of greater power and clarity than any known before. Thereby he discovered in 1655 the 6th satellite of Saturn and that planet's mysterious ring. A year later, he made the first delineation of the bright region, now bearing his name, in the Orion Nebula, and detected the multiple character of its nuclear star. The great rival to the Paris astronomers was the remarkable group that gathered mostly around Halley and Newton in England. James Gregory of Edinburgh lent distant aid by designing the first reflecting telescope in 1663, that is, one in which the rays of light from the object are concentrated by a curved mirror instead of a lens. Newton improved this in 1668. In 1675, John Flamsteed and others addressed to Charles II a memorial asking him to finance the building of a national observatory so that better methods of calculating longitude might guide the English shipping that was now plowing the seas. The king provided for the building, which was raised in the borough of Greenwich near southeast London. This came to be used as the point of zero longitude and standard time. Charles offered Flamsteed a small salary as director, but nothing to pay for assistants or instruments. Flamsteed, frail and sickly, gave his life to that observatory. He took pupils, bought instruments out of his personal funds, received others as gifts from friends, and set himself patiently to chart the sky as seen from Greenwich. Before he died in 1719, he had made the most extensive and accurate star catalogue yet known, considerably improving on that which Tycho Brahe had left to Kepler in 1601. Harassed by lack of aid, doing himself the paperwork usually left to assistants, Flamsteed angered Halley and Newton by delays in the calculation and announcement of his results. At last Halley published them without Flamsteed's permission, and the ailing astronomers shook the stars with his wrath. Nevertheless, Edmund Halley was the finest gentleman of them all. An enthusiastic schoolboy student of the sky, he published at 20 a paper on the planetary orbits. And in that same year, 1676, he set out to see how the heavens looked from the southern hemisphere of the Earth. On the island of St. Helena, he charted the behavior of 341 stars. On the eve of his 21st birthday, he made the first full observation of a transit of Mercury. Back in England, he was elected a Fellow of the Royal Society at 22. He recognized Newton's genius, financed the first edition of the costly Principia, and prefixed to it some complimentary verse in splendid Latin, ending in the line, "It is not allowed to any mortal to come closer to the gods." Halley edited the Greek text of the Conics of Apollonius of Perga and learned Arabic to translate Greek treatises preserved only in that language. He wrote his name in the sky by one of the most successful predictions in history. Borelli had paved the way by discovering the parabolic form of cometary paths in 1665. When a comet appeared in 1682, Halley found similarities in its course with comets recorded in 1456, 1531, and 1607. He noted that these manifestations had come at intervals of some 75 years, and he predicted a reappearance in 1758. He could not live to see the fulfillment of his prophecy, but when the comet returned, it received his name and added to the rising prestige of science. Until late in the 17th century, comets were considered to be direct acts of God, portending great calamities to mankind. The essays of Bayle and Fontenelle, and the prediction of Halley, laid this superstition. Halley identified another comet, seen in 1680, with one observed in the year of Christ's death. He traced its recurrence every 575 years, and from this periodicity he computed its orbit and speed around the sun. Commenting on these calculations, Newton concluded that the bodies of comets are solid, compact, fixed, and durable like the bodies of the planets, and are not vapors or exhalations of the earth, of the sun, and other planets. In 1691, Halley was refused the civilian chair of astronomy at Oxford on suspicion of being a materialist. In 1698, on a commission from William III, he sailed far into the South Atlantic, studied the variations of the compass, and charted stars as seen from the Antarctic. Compared with this expedition, said Voltaire, the voyage of the Argonauts was but the crossing of a bark from one side of a river to the other. In 1718, Halley pointed out that several of the supposedly fixed stars had altered their positions since Greek times, and that one of them, Sirius, had changed since Brahe. Allowing for errors of observation, he concluded that the stars vary their positions relative to one another over great periods of time, and these proper motions are now accepted as real. In 1721, he was appointed to succeed Flamsteed as Astronomer Royal, but Flamsteed had died so poor that his creditors seized his instruments, and Halley found his own work hampered by inadequate equipment as well as by his own declining energies. Nevertheless, he began at 64 to observe and record the phenomena of the moon through its complete cycle of 18 years. He died in 1742, aged 86, after wisely drinking a glass of wine against his doctor's orders. Life, like wine, should not be taken in excess. 4. The Earth. In love with science, Halley had ventured into the mists of meteorology with an essay in 1697 on trade winds, and a chart that for the first time mapped the movements of the air. He attributed these movements to differences in the temperature and pressure of the atmosphere. So the sun, moving apparently westward, carried heat with it, especially along the equatorial regions of the Earth. The air, rarefied by this heat, sucked in less rarefied air from the east, and created the prevailing equatorial winds that Columbus had relied on to sail from east to west. Francis Bacon had suggested a similar explanation. George Hadley was to develop it in 1735 by adding that the greater eastward speed of the Earth's rotation at the equator creates a contrary westward flow of air. The development of the barometer and the thermometer made meteorology a science. Guericke's barometer rightly forecast a severe storm in 1660. Various hygrometers were invented in the 16th century to measure humidity. The Accademia del Cimento used a graduated vessel that received the moisture dripping from the outside of an ice-filled metallic cone. Hooke attached a grain bristle, or beard, which swelled and bent with increasing moisture in the air, to an indicator needle that turned as the bristle swelled. Hooke invented also a wind gauge, a wheel barometer, and a weather clock. This last instrument, designed on a commission from the Royal Society in 1678, measured and recorded the velocity and direction of the wind, the pressure and humidity of the atmosphere, the temperature of the air, and the amount of rainfall. For literal good measure, it gave the time of day. Armed with improved instruments, weather stations in diverse cities began to record and compare their simultaneous observations, as between Paris and Stockholm in 1649. Grand Duke Ferdinand II of Tuscany, patron of the Cimento, sent barometers, thermometers, and hygrometers to chosen observers at Paris, Warsaw, Innsbruck, and elsewhere, with instructions for recording meteorological data daily and transmitting a copy to Florence for comparison. Leibniz persuaded the weather stations at Hanover and Kiel to keep daily records from 1679 to 1714. The ingenious and inconclusive Hooke opened 100 promising avenues of investigation, but he was too poor in funds or patience to follow them to famous ends. We find him everywhere in the history of British science in the second half of the 17th century. Son of a minister who died by suspending himself, he prefigured his vacillating diversity by painting pictures, playing the organ, and inventing 30 different ways of flying. At Oxford, he took to chemistry, serving as assistant to Robert Boyle. In 1662, he was appointed Curator of Experiments for the Royal Society. In 1665, he was Professor of Geometry in Gresham College. In 1666, after the Great Fire of London, he took to architecture and designed several major buildings: Montague House, the College of Physicians, and Bethlehem Hospital, or Bedlam. After long poring through microscopes, he published his chef-d'oeuvre, Micrographia, in 1665, containing a number of suggestive ideas in biology. He proposed a wave theory of light, helped Newton in optics, and anticipated both the law of inverse squares and the theory of gravitation. He discovered the fifth star in Orion and made the first attempts to determine by telescope the parallax of a fixed star. He propounded a kinetic theory of gases in 1678 and described a system of telegraphy in 1684. He was among the first to apply the spring to regulate watches. He laid down the principle of the sextant for measuring angular distances. He made a dozen scientific instruments. He was probably the most original mind in all that galaxy of geniuses that for a time made the Royal Society the pacemaker of European science. But his somber and nervous nature kept him from the acclaim that he deserved. Even in geology he had his moment of truth. He argued that fossils proved for the earth and for life an antiquity quite incompatible with the book of Genesis, and he foresaw that the chronology of terrestrial life would someday be calculated from the differing fossils of successive strata. Most 17th-century writers still accepted the biblical account of creation, and some of them struggled to reconcile Genesis with the sporadic discoveries of geology. In An Essay Towards a Natural History of the Earth in 1695, John Woodward, after long study of his large collection of fossils, restored Leonardo da Vinci's interpretation of them as the relics of plants or animals that had once lived on the earth. But even he thought that the distribution of fossils was the result of Noah's flood. An Anglican clergyman, Thomas Burnet, proposed in 1680 a reconciliation between Genesis and geology by stretching the days of the biblical creation myth into epochs. This subterfuge proved acceptable, but when Thomas, gathering courage, went on to explain the story of Adam's fall as an allegory, he found himself barred from ecclesiastical advancement. Athanasius Kircher was both a good Jesuit and a great scientist. We shall find him brilliant in a dozen fields. His Mundus Subterraneus, from 1665, charted ocean currents, suggested that underground streams were fed from the sea, and ascribed volcanic eruptions and hot springs to subterranean fires. This seemed to confirm the popular belief that hell was in the center of the earth. Pierre Perrault, in 1674, rejected the idea that springs and rivers have subterranean sources and upheld the now accepted view that they are the product of rain and snow. Martin Lister explained volcanic eruptions as due to the heating and consequent explosion of the sulfur and iron pyrites. And experiments showed that a mixture of iron filings, sulfur, and water buried in the earth became heated, cracked the earth above it, and burst into flames. The most prominent figure in the geology of this age was known to Denmark as Niels Stensen, and to the International of Science as Nicholas Steno. Born in Copenhagen, he studied medicine there and in Leiden, where he numbered Spinoza among his friends. Migrating to Italy, he accepted Catholicism and became court physician to Ferdinand II at Florence. In 1669, he published a small volume, De Solido Intra Solidum Naturaliter Contento, which one student has ranked as the most important geological document of that century. Its purpose was to confirm the new view of fossils, but as a prelude, Steno for the first time formulated principles to explain the evolution of the Earth's crust. Studying the geology of Tuscany, he found 6 successive strata. He analyzed their structure and contents, the formation of mountains and valleys, the causes of volcanoes and earthquakes, and the fossil evidence for formerly higher levels of rivers and the sea. The reputation earned by this book and by Steno's anatomical studies led King Christian IV to offer him the chair of anatomy in the University of Copenhagen. He accepted, but his zealous Catholicism caused some friction. He returned to Florence, passed from science to religion, and ended as Bishop of Tetopolis and Vicar Apostolic for North Europe. Meanwhile, geography was growing, usually as a byproduct of missionary, military, or commercial enterprise. The Jesuits were almost as devoted to science as to religion or politics. Many of them belonged to learned societies which welcomed their geographical and ethnographical reports. As missionaries, they ventured into Canada, Mexico, Brazil, Tibet, Mongolia, China. They gathered and remitted much useful knowledge and made the best maps of the areas they visited. In 1651, Martino Martini published his Atlas Sinensis, the fullest geographical description of China yet printed, and in 1667 Athanasius Kircher issued a magnificent China Illustrata. Louis XIV sent 6 Jesuit scientists equipped with the latest instruments to map China again. In 1718 they issued a vast map in 120 sheets, covering China, Manchuria, Mongolia, and Tibet. This remained for 2 centuries the basis of all later maps of those areas. The cartographical wonder of the age was the map, 24 feet in diameter, which Giovanni Cassini and his aides drew in ink on the floor of the Paris Observatory, circa 1690, showing the precise location in latitude and longitude of all important places on the earth. Some famous travelers belong to this period. We have already helped ourselves to Tavernier's 6 voyages through Europe into Asia from 1670, and Chardin's travels in Persia from 1686. In my 6 voyages, wrote Tavernier, and traveling by different roads, I had the leisure and opportunity to see all Turkey, all Persia, and all India. The last 3 times I went beyond Ganges to the island of Java, so that for the space of 40 years I have traveled above 60,000 leagues by land. Chardin, in one sentence, anticipated Montesquieu's spirit of laws. The climate of each particular race is always the primary cause of the inclinations and customs of its people. In 1670-71, François Bernier published an account of his travels and studies in India, and was accused of having shed his Christianity en route. William Dampier buccaneered in 100 lands and seas, wrote A New Voyage Round the World in 1697, and gave a cue to Defoe by telling how, on one of his later sallies, he piloted the vessel that rescued Alexander Selkirk from an otherwise uninhabited island, this in 1709. Geography played its part in the erosion of Christian theology. As accounts of other continents accumulated, the educated classes of Europe could not but marvel at the variety of religious beliefs on the earth, the similarity of religious myths, the confidence of each cult in the truth of its creed, and the moral level of Mohammedan or Buddhist societies that in some respects shamed the gory wars and murderous intolerance of peoples dowered with the Christian faith. Baron de Lauanton, traveling in Canada in 1683, reported that he had much difficulty in meeting criticisms of Christianity by Indian natives. Bayle again and again quoted the customs and ideas of the Chinese or the Japanese in criticizing European beliefs and ways. The relativity of morals became an axiom of 18th-century philosophy. One wit described the travels of Jacques Sedin, the hermaphrodite, who to his delight found a country where all the inhabitants were homosexuals, who looked upon Europe's heterosexuals as immoral and disgusting monstrosities. 5. Physics. Physics and chemistry conflicted less visibly than geography and biology with the ancient creed, for they dealt with solids, liquids, and gases that apparently had no connection with theology. But even in that material realm, the progress of science was enlarging the rule of law and weakening the faith in miracles. The study of physics rested on no philosophical interests, but on commercial and industrial needs. Navigators, having induced astronomers to chart the skies more accurately, now offered rewards for a clock that would aid in finding longitude despite the perturbations of the sea. Longitude at sea could be determined by comparing the moment of sunrise or meridian with the time shown at that instant by a clock set to keep Greenwich or Paris time. But unless the clock was accurate, the calculation would be dangerously wrong. In 1657, Huygens contrived a reliable clock by attaching a pendulum to a toothed escapement wheel, but such a clock was useless on a rolling and pitching ship. After many trials, Huygens constructed a successful marine clock by substituting for the pendulum a balance wheel worked by 2 springs. This was among the illuminating suggestions expounded by him in one of the classics of modern science, the Horologium Oscillatorium, the pendulum clock, published in Paris in 1673. 3 years later, Hooke invented the anchor escapement of clocks, applied spiral springs to the balance wheel of watches, and expounded the action of the springs on the principle ut tensio sic vis, as the tension so the force. This is still called Hooke's law. Pocket watches could now be made more competently and cheaply than before. In the Horologium and a special monograph, Huygens studied the law of centrifugal force. That every particle of a rotating body not lying in the axis of rotation is subject to a centrifugal force which increases with its distance from the axis and with the speed of rotation. He set a clay sphere rotating rapidly and found that it assumed the form of a spheroid flattened at both ends of the axis. On this centrifugal principle he explained the polar flattening of the planet Jupiter, and by analogy he concluded that the Earth too must be slightly flattened at the poles. Huygens's Tractatus de Motu Corporum et Percussione, from 1703, published 8 years after his death, continued the studies of Galileo, Descartes, and Wallace on the problems of impact. These presented intriguing mysteries, from the play of billiards to the collision of stars. How is force transmitted from a moving object to an object that it strikes? Huygens did not solve the mystery, but he stated some basic principles. 1. If upon a body at rest another body equal to it impinges, the latter will come to rest after the impact, while the body initially at rest will acquire the velocity of the impinging body. 2. If two equal bodies collide with unequal velocities, they will move after impact with interchanged velocities. 11. In the mutual impact of two bodies, the sum of the products of the masses into the squares of the relative velocities is the same before and after impact. These propositions, formulated by Huygens in 1669, gave partial expression to the most comprehensive principle of modern physics, the conservation of energy. They were, however, only ideally true, since they assumed complete elasticity in bodies. As no body in nature is perfectly elastic, the relative velocity of impinging objects is diminished according to the substance of which they are composed. Newton determined this rate of diminution for wood, cork, steel, and glass in his introductory scholium to Book I of his Principia in 1687. Another line of investigation flowed from the experiments of Torricelli and Pascal on atmospheric pressure. Pascal had announced in 1647 that any vessel, however large, can be made empty of all matter known in nature and perceptible to the senses. For hundreds of years, European philosophy had proclaimed that natura abhorrat vacuum. Even now, a Paris professor informed Pascal that the angels themselves could not produce a vacuum, and Descartes scornfully remarked that the only existing vacuum was in Pascal's head. But about 1650, Otto von Guericke constructed at Magdeburg an air pump which produced so nearly complete a vacuum that he astonished the dignitaries of his country and the luminaries of the scientific world with a famous experiment known as the Magdeburg Hemispheres in 1654. In the presence of the Emperor Ferdinand III and the Imperial Diet at Ratisbon, he brought two bronze hemispherical shells together in such a way that they were hermetically sealed, but not mechanically connected at their edges. He pumped nearly all the air from their united interiors. Then he showed that the combined strength of 16 horses, 8 pulling in one direction, 8 in the opposite direction, could not separate the two halves of the sphere. But when a stopcock in one hemisphere was opened, admitting air, the shells could be separated by hand. Guericke had a flair for making physics intelligible to emperors. By emptying a copper sphere of water and air, he caused it to collapse with a loud and startling noise. So he demonstrated the pressure of the atmosphere. He balanced two equal globes and made one full by pumping air from the other. So he proved that air has weight. He confessed that all vacuums were incomplete, but he showed that in his imperfect vacuums a flame would be extinguished, animals would suffocate, and a striking clock would make no sound. So he prepared for the discovery of oxygen and revealed air as the medium of sound. He used the suction of a vacuum to pump water and raise weights, and shared in preparing for the steam engine. Having become burgomaster of Magdeburg, he delayed publishing his discoveries till 1672. But he communicated them to Caspar Schott, Jesuit professor of physics at Würzburg, who printed an account of them in 1657. It was this publication that stimulated Boyle to the researches leading to the law of atmospheric pressure. Robert Boyle was a prime factor in the flowering of English science in the second half of the 17th century. His father, Richard Boyle, Earl of Cork, had acquired a large estate in Ireland, and Robert inherited most of this at the age of 17 in 1644. On frequent visits to London, he became acquainted with Wallace, Hooke, Wren, and other members of the Invisible College. Fascinated by their work and their aspirations, he moved to Oxford and built a laboratory there in 1654. He was a man of warm enthusiasms and of a piety that no science could destroy. He refused to communicate further, through Oldenburg, with Spinoza when he learned that the philosopher worshipped substance as God. But he placed much of his fortune at the service of science and helped many friends. Tall and lean, frail and often ill, he held death at a distance by resolute diet and regimen. He found in his laboratory that water of Lethe which causes me to forget everything but the joy of making experiments. Having read of Guerrica's air pump, Boyle devised, with Hooke's help in 1657, a pneumatic engine to study the properties of the atmosphere. With this and later pumps, he proved that the column of mercury in a barometer is supported by atmospheric pressure, and he measured roughly the density of the air. He advanced upon Galileo's alleged experiment at Pisa by showing that, even in an incomplete vacuum, a bunch of feathers fell as rapidly as a stone. He showed that light is not affected by a vacuum, and therefore does not, like sound, use air as its medium of transmission, and he confirmed Guerrica's demonstration that air is indispensable to life. When a mouse fainted in the vacuum chamber, he stopped the experiment and revived it by letting in air. We see the International of Science in action when we learn that Guerrica was stimulated by Boyle's work to contrive a better air pump and resume his scientific studies, and that Huygens, visiting Boyle in 1661, was led to make similar instruments and tests. Boyle went on to creative inquiries into refraction, crystals, specific gravities, hydrostatics, and heat. He crowned his contributions to physics by formulating the law that bears his name, that the pressure of air or any gas varies inversely as its volume, or that at a constant temperature the pressure of a gas multiplied by its volume is constant. He first announced this principle in 1662 and generously credited it to his pupil, Richard Townley. Hooke had reached the same formula in 1660 by independent experiments, but did not make it known till 1665. A French priest, Edme Mariotte, about the same time as Boyle, arrived at a similar conclusion. Air is compressed according to the weight acting upon it. He published this in 1676, and on the continent his name, rather than Boyle's, is attached to the law of atmospheric pressure. Whatever its parentage, it was one of the progenitors of the steam engine and the Industrial Revolution. Boyle and Hooke followed up Bacon's view that heat is a motion of expansion not uniformly of the whole body, but in the smaller parts of it. Describing heat as a property arising in a body from the motion or agitation of its parts, Hooke distinguished it from fire and flame, which he attributed to the action of air on heated bodies. All bodies, said Hooke, have some degree of heat in them, for the parts of all bodies, though never so solid, do yet vibrate. Cold is merely a negative conception. Mariotte amused his friends by showing that cold could burn. With a concave slab of ice, he focused sunlight upon gunpowder, causing it to explode. Spinoza's friend, Count Ehrenfried Walter von Tschirnhaus, melted porcelain and silver dollars by focusing upon them the light of the sun. In the Physics of Sound, two Englishmen, William Noble and Thomas Pigott, separately showed, circa 1673, that not only the whole but different parts of a string may vibrate with diverse overtones, in sympathy with a near and related string plucked, struck, or bowed. Descartes had suggested this to Mersenne, and Joseph Sauveur, working on this idea, arrived independently at results similar to those of the Englishman in 1700. We should note in passing that Sauveur, who first used the word acoustics, had been a deaf-mute from infancy. In 1711, John Shore invented the tuning fork. Attempts to find the velocity of sound were made in this period by Borelli, Viviani, Picard, Cassini, Huygens, Flamsteed, Boyle, Halley, and Newton. Boyle, reckoning it at 1,126 feet per second, came closest to our current estimate. William Derham pointed out in 1708 that this knowledge could be used to calculate the distance of a storm by observing the time interval between the lightning flash and the thunderclap. The second half of the 17th century was probably the most brilliant epoch in the history of the physics of light. First, what was light itself? Hooke, always ready to delve into difficulties, hazarded the view that light is nothing else but a peculiar motion of the parts of the luminous body. That is, light differs from heat only in the more rapid motion of the body's constituent particles. Second, how fast does it move? Scientists had heretofore assumed that the speed of light was infinite, and even the venturesome Hooke had regarded it as in any case too great for measurement. In 1675, Olaus Rømer, a Danish astronomer brought to Paris by Picard, proved the finite velocity of light by noting that the period of eclipse of Jupiter's innermost satellite varied according as the Earth was moving toward or away from that planet. By computations based on the time of the satellite's revolution and the diameter of the Earth's orbit, he showed that the variation in the observed time of the eclipse was due to the time taken by light from the satellite to traverse the orbit of the Earth. And on that slender basis he calculated the speed of light as some 120,000 miles per second. The current estimate is 186,000 miles. But how was light transmitted? Did it move in straight lines? If so, how did it get around corners? Francesco Grimaldi, Jesuit professor at Bologna, discovered and named in 1665 the phenomena of diffraction, that rays of light passing through a small opening into a dark room spread more widely on the opposite wall than straight lines from source to wall would warrant, and that rays of light are slightly deflected from a straight line when they pass by the edges of an opaque body. These and other findings led Grimaldi to accept Leonardo da Vinci's suggestion that light moves in expanding waves. Hooke agreed, but it was Huygens who established the wave theory still popular among physicists. In another classic of modern science, Traité de la Lumière in 1690, Huygens reported the conclusions he had reached from studies begun 12 years before. That light is transmitted by a hypothetical substance which he called ether, from the Greek word for the sky, and which he conceived as made up of small, hard, elastic bodies, transmitting light in successive spherical waves spreading out from the luminous source. On this theory he formulated laws of reflection, refraction, and double refraction. He ascribed to the enveloping motion of the waves the ability of light to move around corners and opaque objects. And he explained translucence by supposing the ether particles to be so minute that they can travel around and between the particles composing transparent liquids and solids. But he confessed himself unable to explain polarization. This was one of the reasons why Newton rejected the wave hypothesis and preferred the corpuscular theory of light. The 17th century made only modest advances in the study of electricity after the work of Gilbert and Kircher on magnetism and of Cabello on electrical repulsion. Halley studied the influence of terrestrial magnetism on compass needles and was the first to recognize a connection between the magnetism of the Earth and the aurora borealis in 1692. Guericke reported in 1672 some experiments in frictional electricity. A ball of sulfur, after being rotated against his hand, attracted paper, feathers, and other light objects, and carried them around with it in its rotation. He likened this to the action of the Earth carrying along with it the objects on or near its surface. He verified electrical repulsion by showing that a feather placed between the electrified ball and the floor jumped up and down from one to the other. He pioneered in studying conduction by proving that an electric charge could travel along a linen thread, and that bodies could become electrified by being brought near to the electrified ball. Francis Hauksbee of the Royal Society developed, between 1705 and 1709, a better method of generating electricity by rapidly rotating an exhausted glass ball and then applying it to his hand. The contacts gave off sparks an inch long, providing light enough for reading. Another Englishman, Wall, having produced similar sparks, likened their sound and light to thunder and lightning in 1708. Newton made the same comparison in 1716. Franklin confirmed the relation in 1749. So year by year, and mind by mind, the impenetrable immensity surrenders some teasing, luring fragment of its mystery. 6. Chemistry. This remarkable century saw the science of chemistry evolve from the experiments and vagaries of alchemy. Industry had long been accumulating chemical knowledge through such operations as smelting iron, tanning leather, mixing dyes, brewing beer. But the investigation of substances in their composition, combination, and transformation had been for the most part left to alchemists seeking gold, or to pharmacologists concocting drugs, or to philosophers, from Democritus to Descartes, puzzling over the constitution of matter. Some approach to chemistry had been made by Andreas Libavius in 1597 and by Jan van Helmont in 1640. But both of these men shared the alchemist's hope of transmuting base metal into gold. Boyle himself made experiments with this aim. In 1689 he secured repeal of an Old English statute against multiplying gold and silver, and at his death in 1691 he left to his executors a quantity of red earth with instructions for trying to turn it into gold. Now that the transmutation of metals is a cliché of chemistry, we can applaud the science in alchemy while condemning and concealing the itch for gold. The greatest blow to alchemy was the publication of Boyle's Skeptical Chemist in 1661, the prime classic in the history of chemistry. He apologized for suffering his treatise to pass abroad so maimed and imperfect, but with his many ailments he was never confident of much longer life. He was consoled to observe that of late chemistry begins, as indeed it deserves, to be cultivated by learned men who before despised it. He called his chemistry skeptical because he proposed to reject all mystical explanations and occult qualities as the sanctuary of ignorance, and was resolved to rely upon experiments rather than syllogisms. He abandoned the traditional division of matter into the four elements of air, fire, water, and earth. These, he argued, were compounds, not elements. The real elements were rather certain primitive and simple or perfectly unmingled bodies, which, not being made of any other bodies or of one another, are the ingredients of all compounds, and into which all compounds may be resolved. He did not mean that the elements were the ultimate constituents of matter. These minima naturalia, he thought, were tiny particles, invisible to the eye and differing in shape and size, like the atoms of Leucippus. From the diversity and motion of these particles and their union in corpuscles, all bodies and all their qualities and conditions, like color, magnetism, heat, and fire, arise by purely mechanical means and laws. Fire was as fascinating to scientists as to dreamers at the hearth. What made a substance burn? How explain those ever-changing tongues of flame, beautiful, imperious, and terrible? In 1669, a German chemist, Johann Joachim Becher, reduced all elements to two, water and earth. One form of the latter he called oily earth, which he believed present in all combustible bodies. This it was that burned. In the 18th century, Georg Stahl, following this false lead, was to set chemistry askew for decades with his similar theory of phlogiston. Boyle took another cue. Noting that various burning substances cease to burn in a vacuum, he concluded that there is in the air a little vital quintessence which serves to the refreshment and restoration of our vital spirits. His younger contemporary, John Mayo, also of the Royal Society, advanced in 1647 toward our current theory of fire by positing among the constituents of air a substance that unites with metals when they are calcined, or oxidized. And he believed that a similar substance, entering our bodies, changes Venus into arterial blood. 100 years had to pass before Scheele and Priestley would definitely discover oxygen. About 1670, a German alchemist, Hennig Brandt, discovered that he could obtain from human urine a chemical that glowed in the dark without preliminary exposure to light. A Dresden chemist, Kraft, exhibited the new product before Charles II at London in 1677. Boyle drew from the secretive Kraft only the admission that the luminous substance was somewhat that belonged to the body of man. The hint proved enough. Boyle soon obtained his own supply of phosphorus, and by a series of experiments he established all that is yet known about the glowing of that element. The new product cost its purchasers 6 guineas, or about $315 per ounce, despite the abundance of the source. 7. Technology. Until the 19th century, more stimulus was given by industry to science than by science to industry, and until the 20th century, inventions were made less often in the laboratory than in the shop or field. In the most important cases of all, the development of the steam engine, the two processes may have proceeded hand in hand. Hero of Alexandria, in or before the 3rd century A.D., made several steam engines, but so far as we know, these were used as toys or marvels to amuse the multitude, rather than as mechanisms replacing human energy. Early in the 16th century, Leonardo da Vinci described a gun which by steam pressure could propel an iron bolt 1,200 yards. but his scientific manuscripts remained unpublished till 1880. Some of Hero's Greek writings were translated into Latin in 1575 and into Italian in 1589. Jerome Cardan in 1550 and Giambattista della Porta in 1601 pointed out that a vacuum could be produced by the condensation of steam, and Porta described a machine for using the pressure of steam to raise a column of water. Similar applications of expanding steam were proposed by Salomon de Caux at Paris in 1615 and by Branca at Rome in 1629. And in 1630, David Ramsay obtained from Charles I of England a patent for machines to raise water from low pits by fire, to make any sort of mills to go on standing waters by continual motion, without help of wind, weight, or horse. In 1663, Edward Somerset, Marquess of Worcester, received from Parliament a 99-year monopoly on the most stupendous work in the whole world, a water-commanding engine that raised water to a height of 40 feet. By this mechanism he proposed to operate waterworks for a large part of London, but he died before he could put his plans into effect. About 1675, Samuel Morland, master mechanic to Charles II, invented the plunger pump, and in 1685 he published the first accurate description of the expansive power of steam. In 1680, Huygens made the first gas engine with cylinder and piston driven by the expansive force of exploding gunpowder. Huygens's French assistant, Denis Papin, went to England, worked with Boyle, and published in 1681 an account of a digester, a pressure cooker, to soften bones by water boiling in a closed vessel. To prevent explosion, he attached to the top of the vessel a tube that could be opened when the pressure reached a certain point. This first safety valve played a saving role in the development of the steam engine. Papin went on to show that the power of expanding steam could be piped pneumatically from one place to another. Moving to Marburg in Germany, he demonstrated in 1690 the first engine in which the condensation of steam, producing a vacuum, was used to drive a piston. He suggested the possibilities of this machine for throwing bombs, raising water from mines, and propelling ships by paddle wheels. And in 1707, precisely a century before Fulton's Clermont moved up the Hudson River, he used his steam engine to drive a paddle-wheel boat on the River Fulda at Kassel. This boat, however, was wrecked, and the German authorities, comfortable in the status quo and perhaps fearing the spread of unemployment, discouraged the development of mechanical power. A similar apparatus had been offered to the Navy Board in England about 1700 by Thomas Savery, but had been turned down with the alleged comment, "What have interloping people that have no concern with us to do to pretend to contrive or invent things for us?" Savery demonstrated his device on the Thames, but the Navy again rejected it. In 1698, Savery patented the first steam engine actually employed to pump water out of mines. In 1699, he was awarded a patent granting him for 14 years the sole exercise of a new invention for raising water and occasioning motion by the impellent force of fire, which will be of great use for draining mines, serving towns with water, and for the working of all sorts of mills. Savery's engines, however, proved costly and dangerous. They had gauge cocks but no safety valves. They were subject to boiler explosions, and though they were used in some mines to pump out water, the mine owners soon returned to the employment of horses. At this point in the story, we again meet Robert Hooke. This book is continued at this point on the other side of this cassette. Please reverse or turn the cassette over now. Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant. Part 2, continued. Cassette 7, Side 2. At this point in the story, we again meet Robert Hooke. About 1702, according to a reliable contemporary, he corresponded with a Dartmouth ironmonger and blacksmith, Thomas Newcomen, on the possibility of using the air pump principle to produce mechanical power. "Could you make a speedy vacuum under your second cylinder," he wrote, "your work is done." Apparently, Newcomen had been experimenting with a steam engine. Here science and industry visibly touched. Hooke was skeptical, let the matter drop, and again missed an opportunity. Newcomen joined with a plumber, John Cawley, to build in 1712 a steam engine, with rocking beam, piston, and safety valve, that could be trusted to do heavy work without danger of explosion, and with fully automatic control. Newcomen continued till his death in 1729 to improve his engine, but we may date from Savory's patent in 1699 and Newcomen's engine of 1712 the beginnings of the Industrial Revolution that in the next 2 centuries would change the face and air of the world. 8. Biology. The remarkable group of investigators that made the glory of the Royal Society extended its researches into the sciences of life. The omnipresent Hooke demonstrated experimentally what Sir Kenelm Digby, that errant mountebank, as Evelyn called him, had already pointed out, that plants need air for their life. He sowed lettuce seed in soil under the open sky, and at the same time similar seed in similar soil in a vacuum chamber. The first grew 1.5 inches in 8 days, the other not at all. Hooke identified the part of the air used up in combustion with the part used up in plant and animal respiration, and described this used part as nitrous in character, this in 1665. He showed that animals which had stopped breathing could be kept alive by blowing air into their lungs with bellows. He discovered the cellular structure of living tissue, and invented the term cell for its organic constituents. Through his microscope, the members of the society saw with delight the cells of cork, whereof, Hooke estimated, 1 cubic inch contained 1,200,000,000 cells. He studied the histology of insects and plants, and gave novel drawings of them in his Micrographia. Hooke was always on the verge of ranking with Galileo and Newton. Another member of the society, John Ray, shared in giving its modern form to the science of botany. He was the son of a blacksmith, but he made his way to Cambridge, became a Fellow of Trinity College, and was ordained an Anglican priest. Like Boyle, he gave his devotion to religion as well as to science. Because he would not sign the Act of Uniformity in 1662, pledging non-resistance to Charles II, he resigned his fellowship and set out with his pupil Francis Willoughby on a tour of Europe to gather data for a systematic description of the animal and plant kingdoms. Willoughby undertook the zoology, but died after completing the sections on birds and fishes. In 1670, Ray issued a Catalogus Plantarum Angliae, which became the frame of English botany. Helped by the improved terminology and classification established in 1678 by Joachim Jungius, Ray proposed a Methodus Plantarum Nova in 1682, which divided all flowering plants into dicotyledons and monocotyledons, according to their having 2 seed leaves or only 1. He completed his great task in one of the chefs-d'œuvre of modern science, the massive 3-volume Historia Generalis Plantarum, from 1682 to 1704, which described 18,625 species of plants. Ray was the first to use the word species in its biological sense, as a group of organisms derived from similar parents and capable of reproducing their kind. This definition, and the later classification by Linnaeus in 1751, set the stage for the controversy over the origin and mutability of species. Meanwhile, Ray edited Willoughby's manuscripts on ichthyology and ornithology, and added a Synopsis Methodica Animalium Quadrupedum in 1693, providing for modern zoology the first really scientific classification of animals. Order was Ray's first law. Even in antiquity, botanists had recognized that some plants might be termed female because they bore fruit, and others male because they did not, and Theophrastus, in the 3rd century before Christ, had observed that the female date palm produces fruit only if the dust of the male date palm has been shaken over it. But these ideas had been almost forgotten. In 1682, Nehemiah Grew, of the Royal Society, gave a new charm to flowers by definitely affirming the sexuality of plants. Studying plant tissues under the microscope, he noted the pores in the upper surface of leaves and suggested that leaves are organs of respiration. Flowers he described as organs of reproduction, the pistils as female, the stamens as male, the pollen as seed. He mistakenly assumed that all plants are hermaphrodites, uniting male and female structures in one organism. In 1691, Rudolf Camerarius, professor of botany at Tübingen, definitely proved the sexuality of plants by showing that they would bear no fruit after the removal of their anthers, the pollen-containing part of the stamens. On the same day, December 7, 1671, that the Royal Society of London received Greu's first essay, The Anatomy of Vegetables, begun, it received also a manuscript from Marcello Malpighi of Bologna. The Society published it in 1675 as Anatomes Plantarum Idea. The use of Latin was still facilitating the international of science. Malpighi divided with Greu the honor of establishing the histology of plants, but his major contribution was to zoology. In 1676, Mariotte, by chemically analyzing the residue of plants and the soil in which they had grown, showed that they absorbed nutritive elements in the water that they suck from the earth. Neither Mariotte nor Greu nor Malpighi recognized the power of plants to take nourishment from the air, but the processes of nutrition and reproduction, now discovered, were a vast advance upon Aristotle's vague explanation of plant growth by the expansive ambitions of the vegetable soul. An old and popular notion received in 1668 the first of several shocks when Francesco Redi of Arezzo published his Esperienze intorno alla generazione degli insetti, experiments tending to disprove abiogenesis, or the spontaneous generation of living organisms from non-living matter. Until the second half of the 17th century, it was almost universally believed, William Harvey an outstanding exception, that minute animals and plants could be generated in dirt or slime, and especially in decaying flesh. So Shakespeare spoke of the sun breeding maggots in dead dogs. Redi showed that maggots did not form on meat that was protected from insects, but did form on meat exposed. He formulated his conclusion in the phrase omne vivum ex ovo. Every living thing comes from an egg or a seed. When protozoa were discovered, the argument for abiogenesis was revived. Spallanzani answered it in 1767, and Pasteur again in 1861. The discovery of those single-celled organisms, which were later termed protozoa, was the major contribution of this age to zoology. Anton von Leeuwenhoek was a Dutchman of Delft, but he reported through the Royal Society at London his scientific results through 40 of his 91 years. Coming of a family of rich brewers, he was able to accept employments that offered him more leisure than pay, and he gave himself with fascinated pertinacity to studying the new world of life revealed by the microscope. He had 247 of these instruments, most of them made by himself, and his laboratory sparkled with 419 lenses, some of which may have been ground by Spinoza, who had been born in the same year, 1632, and the same land as he. Peter the Great, when in Delft in 1698, made it a point to peer through Leeuwenhoek's microscopes. When in 1675 the scientist turned one of these to the study of some rainwater that had fallen into a pot a few days before, he was astonished to see little animals appearing to me 10,000 times less than those represented by Monsieur Swammerdam, and by him called water fleas or water lice, which may be perceived in the water with the naked eye. And he proceeded to describe an organism that we now recognize as the bell animalcule, or vorticella. This was apparently the earliest description of a protozoon. In 1683, Leeuwenhoek discovered still tinier organisms, bacteria. He found them first on his own teeth, though my teeth, he protested, are kept usually very clean. And he startled some neighbors by examining their spittle and showing them, under the microscope, a great many living creatures therein. In 1677 he discovered spermatozoa in semen. He marveled at nature's profuse equipment for reproduction. In a small quantity of human semen he estimated 1,000 spermatozoa, and he calculated that in the milt of a single codfish there were 150 billion sperm, more than 10 times the number of inhabitants that the earth would contain if all the land were as thickly populated as the Netherlands. Jan Swammerdam was 5 years younger than Leeuwenhoek, but preceded him by 43 years to the grave. He was a man of nerves, passions, ailments, and fluctuating purposes, who stopped his scientific work at 36 and burned himself out at 43 in 1680. He was intended for the ministry, but abandoned theology for medicine. Having secured his medical degree, he devoted himself to anatomy. He became enamored of bees, and especially of their intestines. He spent his days in dissecting them, his nights in reporting and illustrating his findings. When he had finished his classic treatise on bees in 1673, he broke down physically. Soon thereafter he gave up science as too worldly a pursuit and returned to religion. 57 years after his death, his manuscripts were collected and published as Biblia Naturae, the Bible of Nature. This contained, in remarkably exact detail, the life history of a dozen typical insects, including the mayfly and the honeybee, and microscopic studies of the squid, the snail, the clam, and the frog. Here, too, were descriptions of the experiments by which Swammerdam proved that muscles in tissues cut off from an animal's body could be made to contract by stimulation of the connecting nerve. Like Redi, he rejected abiogenesis. He went further and showed that instead of decaying flesh-producing minute organisms, it is these that produce decay in organic matter. In his brief career, Swammerdam founded modern entomology and established himself as one of the most accurate observers in the history of science. His return from science to religion personified the hesitation of modern man between a search for truth that smiles at hope and a retreat to hopes that shy from truth. 9. Anatomy and Physiology. The human body, subjected to the microscope, gave up some of its intimate secrets to the advancing army of science. In 1651, Jean Pequet of Paris traced the course of the lacteal vessels. In 1653, Olaf Rudbeck of Uppsala discovered, and Thomas Bartholin of Copenhagen described, the lymphatic system, and in 1664 Swammerdam detected the lymphatic valves. In that year, his friend Reinier de Graaf demonstrated the function and operation of the pancreas and the bile. In 1661, Nicholas Steno, another friend, discovered the duct, still bearing his name, of the parotid gland, and a year later the lacrimal ducts of the eye. Graaf studied especially the anatomy of testicles and ovaries. In 1671 he gave the first account of those ovum-bearing sacs which Haller, in his honor, called the Graafian follicles. Bartholin left his card on two oval bodies adjoining the vagina, and William Cooper, physician not poet, found in 1702 and gave his name to the glands that discharge into the urethra. Franciscus Sylvius, beloved teacher of Graaf, Swammerdam, Steno, and Willis at Leiden, left his signature on a fissure of the brain in 1663. Thomas Willis, the founder of the Royal Society, published in 1664 a Cerebri Anatome, which was the most complete account yet given of the nervous system. His name is still borne by the Circle of Willis, a hexagonal network of arteries at the base of the brain. The outstanding anatomist of the age was Marcello Malpighi. Born near Bologna in 1628, he took his degree in medicine there. After some professorial years in Pisa and Messina, he returned to Bologna and taught medicine in the university for 25 years. After working on the microscopic anatomy of plants, he turned his lenses upon the silkworm and recorded his findings in a classic monograph. In this investigation, he nearly lost his eyesight. Nevertheless, in performing these researches, he wrote, so many marvels of nature were spread before my eyes that I experienced an internal pleasure that my pen could not describe. He must have felt like Keats, first looking into Chapman's Homer, when in 1661 he saw, in the lungs of the frog, how the blood passed from the arteries into the veins through vessels so fine that he called them capillaries. He found a network of such little hairs wherever arterial became venous blood. Now, for the first time, the circulatory system was demonstrated in its course. This was but a part, though the most important, of Malpighi's contributions to anatomy. He was the first to prove that the papillae of the tongue are organs of taste, the first to distinguish the red corpuscles in the blood, but he mistook them to be globules of fat, the first to give an accurate account of the nervous and circulatory systems in the embryo, the first to describe the histology of the cortex and the spinal cord, the first to make possible a practical theory of respiration by describing with precision the vesicular structure of the lungs. Justly his name is scattered over our flesh in the Malpighian tufts, or loops of capillaries, in the kidneys, in the Malpighian corpuscles of the spleen, in the Malpighian layer of the skin. Many of his revelations and interpretations were challenged by his contemporaries. He defended himself vigorously and won his battles at some cost to his nerves. As if laying these matters before the Supreme Court of Science in his age, he sent to the Royal Society at London an account of his labors, discoveries, and controversies. The Society published this as his autobiography. In 1691 he was appointed personal physician to Pope Innocent XII, but he died in 1694 of an apoplectic stroke. His detection of the capillaries is one of the landmarks in the history of anatomy. His work as a whole established the science of histology. As anatomical research progressed, it revealed so many similarities between human and animal organs that some students were led close to a theory of evolution. Edward Tyson, whose name is given to the sebaceous glands of the foreskin, published in 1699 Orangutan, Sive Homo Silvestris, describing the orangutan as a man of the woods. He compared the anatomy of man with that of the monkey and reckoned the chimpanzee to be intermediate between the two. Only the fear of a theological earthquake kept biology from anticipating Darwin in the 17th century. From anatomy and structure, the researchers passed to physiology and function. Till about 1660, respiration had been interpreted as a cooling process. Now the experimenters likened it to combustion. Hooke proved that the essence of respiration is the exposure of venous blood to fresh air in the lungs. Richard Lower, also of the Royal Society, showed in 1669 that venous blood could be changed to arterial by aeration, and that arterial blood became venous when persistently kept from contact with air. He suggested that the chief agent in aeration is a nitrous spirit in the atmosphere. Following these leads, Lower's friend John Mayo described this active factor as nitroaerial particles. In respiration, he believed the nitrous particles are absorbed from the air into the blood. Hence, air exhaled is lighter in weight and less in volume than the same air inhaled. Animal heat is due to the union of nitrous particles with combustible elements in the blood. Increased heat after exercise results from the extra intake of nitrous particles through increased respiration. These nitrous particles, said Mayo, play the leading role in the life of animals and plants. The interpretation of vital processes led to one of the most indestructible controversies in the history of modern science. As physiology delved more and more curiously into the human anatomy, one after another function of the body seemed to yield to a mechanical interpretation in terms of physics and chemistry. Respiration appeared to be a combination of expansion, aeration, and contraction. The functions of the saliva, the bile, and the pancreatic juice were obviously chemical, and John Alfonso Borelli apparently brought to completion in 1679 the mechanical analysis of muscular action. Steno, the fervent Catholic, adopted the mechanical view of physiological processes and dismissed as mere words meaning nothing such vague phrases as Galen's animal spirits. Descartes' conception of the body as a machine seemed now fully justified. Nevertheless, most scientists felt that these bodily mechanisms were merely the instruments of some vital principle beyond analysis in physico-chemical terms. Francis Glisson, a founder of the Royal Society, ascribed to all living substance a characteristic irritability, susceptibility to stimulation, which he thought to be absent from non-living matter. Just as Newton, after reducing the cosmos to mechanism, ascribed the initial impetus of the world machine to God, so Borelli, after giving a mechanical explanation of the muscular processes, posited within the human body a soul from which all animal motion took its origin. Claude Perrault, architect and physician, suggested in 1680 that physiological actions that now seem mechanical were formerly voluntary, guided by a soul, but became mechanical through frequent repetition, like the formation of habits. Perhaps even the heart had once been controlled by the will. Georg Stahl argued in 1702 that the chemical changes in living tissue are different from those seen in laboratories, for in living animals he believed the chemical changes are governed by an anima sensitiva, which pervades all parts of the body. The soul, said Stahl, directs every physiological function, even digestion and respiration. It builds each organ, indeed the whole body, as an instrument of desire. Diseases, he surmised, are processes by which the soul strives to remove something that hinders its operations. And he foreshadowed a 20th century psychosomatic theory by holding that disturbances of the sensitive soul can produce bodily ailments. In one form or another, vitalistic conceptions held the ascendancy in science till the second half of the 19th century. They yielded for a time to the rising prestige of mechanical physics, and they were revived with the charm of literature in Bergson's Creative Evolution in 1906. The debate will go on until the part understands the whole. 10. Medicine. The strongest stimulus to the biological sciences came from the needs of medicine. botany before Ray had been the handmaiden of pharmacy. Health was the summum bonum, and men, women, and children sought it through prayers, stars, kings, toads, and science. One physician, before prescribing, went to his closet to pray, says Aubrey, so that at last his knees were horny with orisons. Astrology still took a hand in medicine. The surgeon in ordinary of Louis XIV advised that the king be bled only in the first and last quarters of the moon, because at this time the humors have retired to the center of the body. Defoe thought that the money spent upon quacks would have paid off the national debt. Flamsteed, the astronomer royal, traveled miles to have his back stroked by the famous quack Valentine Greatrakes, who proposed so simply to cure scrofula. Perhaps Flamsteed was among the 100,000 whom Charles II touched for scrofula, the king's evil. In the 1 year 1682, the complacent ruler touched 8,500 sufferers. In 1684, the press to get to him was so great that 6 of the sick were trampled to death. William III refused to go on with the play. "It is a silly superstition," he exclaimed when a crowd besieged his palace. "Give the poor creatures some money and send them away." On another occasion, when he was importuned to lay his hand on a patient, he yielded, but said, "God give you better health and more sense." The people denounced him as an infidel. Defects of personal hygiene and public sanitation cooperated with the resilient ingenuity of disease. Prostitution spread syphilis in cities and camps. It was especially rife among actors and actresses, as we gather from a subtle story in Madame de Sévigné of a player who, being resolved to marry, though he labored under a certain dangerous disorder, one of his companions said to him, "Zounds, can't you wait till you are cured? You will be the ruin of us all." The French General Vendôme appeared at court without a nose, having sacrificed it to the spirochetes. Cancer was on its way. Madame de Motteville describes a cancer of the breast. Yellow fever was first described in 1694. Smallpox was especially widespread in England. No cure was yet known for it. Queen Mary died of it, and Marlborough's son. Epidemics, particularly of malaria, ran through whole countries. In 1657, reported Thomas Willis, almost all England was a hospital treating malarial fever. Plague devastated London in 1665, killed 100,000 in Vienna in 1679, and 83,000 in Prague in 1681. Occupational diseases increased with industry. Bernardino Ramazzini, professor of medicine at Padua, issued in 1700 a classic treatise, De Morbis Artificum, on the damage done to painters by the chemicals in their paint, to workers in colored glass from antimony, to masons and miners from tuberculosis, to potters from vertigo, to printers from eye troubles, to physicians from the mercury they applied. Amid ignorance and poverty, the science of medicine slowly advanced. The thirst for money hampered the profession. Some doctors who had made successful cures refused to reveal to other doctors the treatment they had used. The medical members of the Royal Society rose above this greed and zealously shared their discoveries with their fellows. There were now good medical schools, led by those at Leiden, Bologna, and Montpellier, and generally a degree from a recognized institution was required for the legal practice of medicine in Western Europe. The teachers of the art continued their division into 2 schools of treatment. Borelli defended iatrophysical therapy, proposing to deal with diseases as derangements of the body's mechanism. Sylvius, developing the arguments of Paracelsus and Helmont, advocated the iatrochemical method of using drugs to counteract disturbances in the humors of the body. Most of these, he thought, were due to hyperacidity. More fruitful than these general theories were discoveries in the causes of specific diseases. So Sylvius first described tubercules in the lungs and related these morbid growths to consumption. One of the most basic discoveries of this age was the work of that remarkable Jesuit, Athanasius Kircher of Fulda, mathematician, physicist, orientalist, musician, and physician, and apparently the first to use the microscope in investigating disease. With this aid, he found that the blood of plague victims contained numberless worms invisible to the naked eye. He saw similar animalcules in putrefying matter and described putrefaction and many diseases to their activity. He reported his findings in Scrutinium Pestis, Rome, 1658, which first stated in explicit terms what Fracastoro had only suggested in 1546. the doctrine that the transfer of noxious organisms from one person or animal to another is the cause of infectious disease. Medical treatment lagged behind medical research, for those who excelled in research tended to form a class distinct from those who practiced, and their communication was imperfect. Some medieval cures were still prescribed. Aubrey records an untimely success. A woman endeavored to poison her husband, who was a dropsical man, by boiling a toad in his pottage, which cured him, and this was the occasion of finding out the medicine. Some new drugs entered the pharmacopoeia in the second half of the 17th century. Ipecacuanha, cascara, peppermint. Dutch physicians, favoring Dutch commerce, prescribed tea as almost a panacea. Two Dutchmen were the greatest medical teachers of the age, Sylvius and Boerhaave, both at Leiden. Hermann Boerhaave taught chemistry, physics, and botany as well. Students came to him from all northern Europe, and he raised the status of clinical medicine by taking his maturer pupils with him on his daily rounds of the hospital beds, instructing them by direct observation and specific treatment of each individual case. His works were translated into all major European languages, even Turkish. His reputation reached to China itself. In England, clinical medicine had its finest exponent in Thomas Sydenham. After 2 stays at Oxford, separated by terms of service in the army, he settled in London as a general practitioner. With little theory and much experience, he came to his philosophy of disease, which he defined as an effort of nature striving with all her might to restore the health of the patient by eliminating morbid matter. He distinguished essential symptoms as those caused by the foreign substance, and accidental as those caused by the body's resistance to it. So fever is not an illness, but a device of the organism in its self-defense. The problem of the physician is to help this process of defense. Hence Sydenham praised Hippocrates, because the father of medicine required no more of art than to assist nature when she languished, and to check her when her efforts were too violent. For this sagacious observer found that nature alone terminates distemper, and works a cure with the assistance of a few simple medicines, and sometimes even without any medicines at all. Sydenham's distinction lay in recognizing that each major disease has many varieties. He studied each case with its clinical record in order to diagnose the special form of the disease involved, and he adjusted the treatment to the specific differences of the ailment. So he separated scarlatina from measles and gave it its current name. He was known to his profession as the English Hippocrates because he subordinated theory to observation, general ideas to particular cases, and drugs to natural cures. His Procesus Integri remained for a century the English practitioner's manual of therapy. Surgery continued to struggle for recognition as a reputable science. Its ablest representatives found themselves pressed on either side by the hostility of physicians and the envy of barbers, who still performed some minor operations, including dentistry. Guy Patin, dean of the Faculty of Medicine in the University of Paris, could not forgive surgeons for assuming the dress and manners of the medical profession, and he denounced all surgeons as a race of evil, extravagant coxcombs who wear mustaches and flourish razors. But in 1686, the surgeon Félix operated successfully upon Louis XIV's fistula. The king was so pleased that he gave Félix 15,000 louis d'or, a country estate, and a patent of nobility. This elevation raised the social status of surgeons in France. In 1699, surgery was decreed to be a liberal art, and its exponents began to assume a high rank in French society. Voltaire called surgery the most useful of all the arts, and the one in which the French excelled all other nations in the world. English surgery, however, had at least 2 credits in this age. In 1662, J.D. Major made the first successful intravenous injection in man, and in 1665-67, Richard Lower succeeded in transfusing blood from one animal into the veins of another. Pepys noted this latter event in his diary. From that private gossip sheet we gather that operations were usually performed with only feeble anesthetics or none. When Pepys was operated on for stone in his bladder, he received no chloroform and no antiseptics, but only a soothing draught. Satires of the physician continued as in every generation. People resented his fees, his pompous dress in gown, wig, and conical hat, his grandiloquent speech, and his sometimes mortal mistakes. Boyle said that many people feared the doctor more than the disease. Molière's caricatures of the great profession were for the most part the good-natured fun of a man who nevertheless took care to keep on amiable terms with his physician. After all darts had been thrown, it remained that the 17th century had seen a creditable advance in medical science through 100 discoveries in anatomy, physiology, and chemistry, that the international exchange of medical knowledge was increasing, that notable teachers were sending out able pupils to all parts of Western Europe, that surgery was improving its methods and status, that specialists were developing greater knowledge and skill, and that more measures were being taken to promote public health. Municipal governments legislated sanitation. In 1656, when plague appeared in Rome, Monsignor Gastaldi, papal commissioner of health, made mandatory the cleansing of streets and sewers, the regular inspection of aqueducts, the provision of public facilities for the disinfection of clothing, and the requirement of health certificates from all persons entering the city. As wealth rose, men built sturdier houses that could keep rats at a respectful distance, and so reduce the spread of plague. Better supplies of water, the first necessity of civilization, enabled the willing body to be clean. For more and more people it was becoming physically possible to be civilized. 11. Results. All in all, the 17th century was one of the peak periods in the history of science. See it in its arching gamut, from Bacon calling men to labor for the advancement of learning, and Descartes marrying algebra to geometry, through the improvement of telescopes, microscopes, barometers, thermometers, air pumps, and mathematics, through Kepler's planetary laws, Galileo's swelling firmament, Harvey's charting of the blood, Guerrica's obstinate hemispheres, Boyle's skeptical chemistry, Huygens's multifarious physics, Hooke's polymorphous tentatives, and Halley's cosmetary predictions, culminating in Leibniz's notational calculus and Newton's cosmic synthesis. What previous century had equaled that performance? The modern mind, said Alfred North Whitehead, has been living upon the accumulated capital of ideas provided for it by the genius of the 17th century in science, literature, and philosophy. The influence of science spread in widening arcs. It affected industry by supplying the physics and chemistry for new ventures in technology. In education, it compelled a lessening of emphasis on the humanities, on literature, history, and philosophy. For the development of industry, commerce, and navigation demanded practical knowledge and minds. Literature itself felt the new influence. The scientist's pursuit of order, precision, and clarity suggested similar virtues in poetry and prose, and accorded well with the classic style exemplified by Molière, Boileau, and Racine, by Addison, Swift, and Pope. The Royal Society, according to its historian, required of its members a close, naked, natural way of speaking, bringing all things as near to mathematical plainness as they can. The triumphs of mathematics and physics, giving period to comets and laws to stars, affected philosophy and religion. Descartes and Spinoza accepted geometry as the ideal of philosophy and exposition. There seemed no need henceforth to posit in the universe anything but matter and motion. Descartes saw all the world, except the human and divine mind, as a machine. Hobbes challenged the exception and formulated a materialism in which even religion would be a tool of the state for manipulating human machines. The new physics, chemistry, and astronomy seemed to show a universe operating according to invariable laws. This cosmos allowed no miracles, therefore answered no prayers, therefore needed no God. Perhaps he could be kept to give the world machine an inaugural push, but thereafter he might retire to be an Epicurean Lucretian deity, mindless of the world and men. Halley was said to have assured a friend of Berkeley that the doctrines of Christianity were now inconceivable. Boyle, however, saw in the revelations of science additional evidence of the existence of God. The world, he wrote, behaves as if there were diffused throughout the universe an intelligent being. And in a sentence recalling Pascal, he added, the soul of man is a nobler and more valuable being than the whole corporeal world. Dying, Boyle left a fund to finance lectures that would demonstrate the truth of Christianity against notorious infidels, viz., atheists, theists, pagans, Jews, and Mohammedans, to which he added a proviso that the lectures must not mention the controversies among Christians. Many scientists agreed with Boyle, and many believing Christians joined in praising science. In these last 100 years, said Dryden at the close of the century, almost a new nature has been revealed to us. More errors have been detected, more useful experiments have been made, More noble secrets in optics, medicine, anatomy, and astronomy have been discovered than in all these doting and credulous ages from Aristotle to us." This was a wild but significant exaggeration, revealing the conviction of the moderns that they had won the battle of the books with the ancients. In any case, men could not but see that the sciences were increasing human knowledge, while religions quarreled and statesmen warred. Science now rose to a new status of honor among human enterprises. Indeed, by the end of this epoch, it was already being hailed as the harbinger of Utopia and the savior of mankind. "The application of science to nature," said Fontenelle in 1702, "will constantly grow in scope and intensity, and we shall go on from one marvel to another. The day will come when man will be able to fly by fitting on wings to keep him in the air. The art will increase till one day we shall be able to fly to the moon." Everything was progressing except man. Chapter 19. Isaac Newton, 1642 to 1727. 1. The Mathematician. He was born in a small farm at Woolsthorpe, in the county of Lincoln, on December 25, 1642, Old Style, the year in which Galileo died. Cultural, like economic leadership, was passing from the south to the north. At birth he was so small that, his mother later told him, he might have been put into a quart mug, and so weak that no one thought he would live beyond a few days. As his father had died some months earlier, the boy was brought up by his mother and an uncle. At 12 he was sent to the public school at Grantham. He did not do well there. He was reported as idle and inattentive, neglecting prescribed studies for subjects that appealed to him, and giving much time to mechanical contrivances like sundials, water wheels, and homemade clocks. After 2 years at Grantham, he was taken from school to help his mother on the farm, but again he skimped his duties to read books and do mathematical problems. Another uncle, recognizing his ability, sent him back to school and arranged for Newton's admission to Trinity College, Cambridge, in 1661 as a subsizar, a student who earned his expenses by various services. He took his degree 4 years later and was soon thereafter elected a fellow of the college. He dealt chiefly with mathematics, optics, astronomy, and astrology. In this last study he maintained interest till late in his life. In 1669 his mathematics teacher, Isaac Barrow, resigned, and on Barrow's recommendation of him as an unparalleled genius, Newton was appointed to succeed him. He held this chair at Trinity for 34 years. He was not a successful teacher. So few went to hear him, his secretary recalled, and fewer that understood him, that oft-times he did in a manner for want of hearers read to the walls. On some occasions he had no auditors at all, and returned sadly to his room. There he built a laboratory, the only one then to be found in Cambridge. He made many experiments, mainly in alchemy, the transmuting of metals being his chief design, but also he was interested in the elixir of life and the philosopher's stone. He continued his alchemist studies from 1661 to 1692, and even while writing the Principia he left unpublished manuscripts on alchemy totaling 100,000 words or more, wholly devoid of value. Boyle and other members of the Royal Society were feverishly engaged in the same quest for manufacturing gold. Newton's aim was not clearly commercial. He never showed any eagerness for material gains. Probably he was seeking some law or process by which the elements could be interpreted as transmutable variations of one basic substance. We cannot be sure that he was wrong. Outside his rooms at Cambridge he had a small garden. There he took short walks, soon interrupted by some idea which he hurried to his desk to record. He sat little, but rather walked about his room so much that, said his secretary, you might have thought him among the Aristotelian sect of peripatetics. He ate sparingly, often skipped a meal, forgot that he had missed it, and grudged the time he had to give to eating and sleeping. He rarely went to dine in the hall, and then, if he had not been reminded, would go very carelessly, with shoes down at the heels, stockings untied, and his head scarcely combed. Many stories were told, and many were invented, about his absent-mindedness. On awakening from sleep, we are assured, he might sit on his bed for hours undressed, engrossed in thought. When he had visitors, he would sometimes disappear into another room, jot down ideas, and quite forget his company. During those 35 years at Cambridge, he was a monk of science. He drew up rules of philosophizing, that is, of scientific method and research. He rejected the rules which Descartes in his Discours had set up as a priori principles from which all major truths were to be derived by deduction. When Newton said, "I do not invent hypotheses," he meant that he offered no theories as to anything beyond observation of phenomena. So he would hazard no guess as to the nature of gravitation, but would only describe its behavior and formulate its laws. He did not pretend to avoid hypotheses as cues to experiments. On the contrary, his laboratory was devoted to testing 1,000 ideas and possibilities, and his record was littered with hypotheses tried and rejected. Nor did he repudiate deduction. He merely insisted that it should start from facts and lead to principles. His method was to conceive possible solutions of a problem, work out their mathematical implications, and test these by computation and experiment. The whole burden of natural philosophy, he wrote, seems to consist in this: from the phenomena of motions to investigate the forces of nature, and then from these forces to demonstrate the other phenomena. He was a compound of mathematics and imagination, and no one can understand him who does not possess both. Nevertheless, we proceed. His fame has two foci, calculus and gravitation. He began his work on the calculus in 1665 by finding the tangent and radius of curvature at any point on a curve. He called his method not calculus, but fluxions, and gave for this term an explanation upon which we cannot improve. Lines are described and thereby generated not by the apposition of parts, but by the continued motion of points. Superficies, or planes, by the motion of lines, solids by the motion of superficies, angles by the rotation of the sides, portions of time by continual flux, and so in other quantities. Therefore, considering that quantities, which increase in equal times and by increasing are generated, became greater or less according to the greater or less velocity with which they increase or are generated, I sought a method of determining quantities from the velocities of the motions or increments in which they are generated, and calling these velocities of the motions or increments fluxions, and the generated quantities fluents, I fell by degrees upon the method of fluxions in the years 1665 and 1666. Newton described his method in a letter to Barrow in 1669, and referred to it in a letter to John Collins in 1672. He probably used the method in reaching some of the results in his Principia of 1687, but his exposition there, probably for the convenience of his readers, followed accepted geometrical formulas. He contributed a statement of his fluxions procedure, but not over his own name, to Wallace's Algebra in 1693. Not till 1704, in an appendix to his Optics, did he publish the account just quoted. It was characteristic of Newton to delay publication of his theories. Perhaps he wished first to resolve the difficulties suggested by them, so he waited till 1676 to announce his binomial theorem, though he had probably formulated it in 1665. These deferments embroiled the mathematicians of Europe in a disgraceful controversy that for a generation disrupted the International of Science. This book is continued on Cassette 8, Side 1. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant, Part 2, continued, Cassette 8, Side 1. These deferments embroiled the mathematicians of Europe in a disgraceful controversy that for a generation disrupted the International of Science. For between Newton's communication of his fluxions to his friends in 1669 and the publishing of the new method in 1704, Leibniz developed a rival system at Mainz and Paris. In 1671 he sent to the Académie des Sciences a paper containing the germ of the differential calculus. On a visit to London, January to March 1673, Leibniz met Oldenburg. He had already corresponded with him and Boyle. Newton's friends later believed, historians now doubt, that Leibniz on this trip received some suggestion of Newton's fluxions. In June 1676, at the request of Oldenburg and Collins, Newton wrote a letter for transmission to Leibniz, explaining his method of analysis. In August, Leibniz replied to Oldenburg, including some examples of his own work in calculus. And in June 1677, in a further letter to Oldenburg, he described his form of differential calculus and his system of notation, which differed from Newton's. In the Acta Eruditorum for October 1684, he again expounded the differential calculus, and in 1686 he published his system of integral calculus. In the first edition of the Principia in 1687, Newton apparently accepted Leibniz's independent discovery of calculus. In letters which went between me and that most excellent geometer, G.W. Leibniz, 10 years ago, when I signified that I was in the knowledge of a method of determining maxima and minima, of drawing tangents and the like, that most distinguished man wrote back that he had also fallen upon a method of the same kind, and communicated his method, which hardly differed from mine except in his forms of words and symbols. This gentlemanly acknowledgment should have contracepted controversy. But in 1699, a Swiss mathematician, in a communication to the Royal Society, suggested that Leibniz had borrowed his calculus from Newton. In 1705, Leibniz, in an anonymous review of Newton's optics, implied that Newton's fluxions were an adaptation of the Leibnizian calculus. In 1712, the Royal Society appointed a committee to examine the documents involved. Before the year was out, the Society published a report, Commercium Epistolicum, asserting the priority of Newton, but leaving open the question of Leibniz's originality. In a letter of April 9, 1716, to an Italian priest in London, Leibniz protested that Newton's scholium had settled the question. Leibniz died November 14, 1716. Soon afterward, Newton denied that the scholium allowed him, Leibniz, the invention of the calculus differentialis, independently of my own. In the third edition of the Principia in 1726, the scholium was omitted. The dispute was hardly worthy of philosophers, since either claimant might have bowed to Fermat's priority. 2. The physicist. Mathematics, however wonderful, was only a tool for calculating quantities. It did not profess to understand or describe reality. When Newton turned from the tool to the ultimate quest, he addressed himself first to the mystery of light. His first lectures at Cambridge were on light, color, and vision. Characteristically, he did not publish his optics till 35 years later, in 1704. He had no itch to print. In 1666, he bought a prism at Sturbridge Fair and began optical experiments. From 1668 onward, he made a succession of telescopes. Hoping to avoid some defects persisting in the refracting telescope, he made with his own hands a reflecting telescope, on theorems set forth by Mersenne in 1639 and James Gregory in 1662, and presented it to the Royal Society at its request in 1671. On January 11, 1672, he was elected to membership in the Society. Even before making telescopes, he had reached in 1666 one of his basic discoveries, that white light, or sunlight, is not simple or homogeneous, but is a compound of red, orange, yellow, green, blue, indigo, and violet. When he passed a small ray of sunlight through a transparent prism, he found that the apparently monochrome light divided into all these colors of the rainbow, that each component color emerged from the prism at its own specific angle or degree or refraction, and that the colors arranged themselves in a row of bands forming a continuous spectrum, with red at one end and violet at the other. Later investigators showed that various substances, when made luminous by burning, gave different spectra. By comparing these spectra with one made by a given star, it became possible to analyze in some degree the star's chemical constituents. Still more delicate observations of a star's spectrum indicated its approximate rate of motion toward or from the Earth, and from these calculations the distance of the star was theoretically deduced. Newton's revelation of the composition of light and its refraction in the spectrum has therefore had almost cosmic consequences in astronomy. Hardly foreseeing these results, but feeling, as he wrote to Oldenburg, that he had made the oddest if not the most considerable detection which hath hitherto been made in the operations of nature, Newton sent to the Royal Society early in 1672 a paper entitled New Theory about Light and Colors. It was read to the members on February 8th and aroused a controversy that crossed the Channel to the continent. Hooke had described in his Micrographia in 1664 an experiment similar to Newton's with the prism. He had not deduced from it a successful theory of color, but he felt slighted by Newton's ignoring his priority, and he joined with other members of the Society in criticizing Newton's conclusions. The dispute lingered on for 3 years. "I am so persecuted," wrote the thin-skinned Newton, "with discussions arising out of my theory of light that I blamed my own imprudence for parting with so substantial a blessing as my quiet to run after a shadow." For a time he was inclined to resolutely bid adieu to philosophy eternally, except what I do for my own satisfaction. Another point of controversy with Hooke concerned the medium through which light is transmitted. Hooke had adopted Huygens's theory that light traveled on the waves of an ether. Newton argued that such a theory could not explain why light traveled in straight lines. He proposed instead a corpuscular theory. Light is due to the emission by a luminous body of innumerable tiny particles traveling in straight lines through empty space with a speed of 190,000 miles per second. He rejected ether as a medium of light, but later accepted it as a medium of gravitational force. Newton gathered his discussions of light into the Optics of 1704. Significantly, it was written in English. The Principia was in Latin, and was addressed to readers of quick wit and understanding not yet versed in optics. At the end of the book he listed 31 queries for further consideration. Query 1 suggested prophetically, "Do not bodies act upon light at a distance, and by their action bend its rays? And is not this action strongest at the least distance?" Compare this with page 88 of Einstein's Relativity, published in 1900. And query 30, "Why may not nature change bodies into light, and light into bodies?" 3. The Genealogy of Gravitation. The year 1666 was germinal for Newton. It saw the beginning of his work in optics, but also, he later recalled, "In May I had entrance into the inverse method of fluxions, and in the same year I began to think of gravity extending to the orbit of the moon, having thereby compared the force requisite to keep the moon in her orbit with the force of gravity at the surface of the earth, and found them to answer pretty nearly. In those years I was in the prime of my age." In 1666 the plague reached Cambridge, and for safety's sake Newton returned to his native Woolsthorpe. At this point we come upon a pretty story. Wrote Voltaire in his Philosophie de Newton in 1738. "One day in the year 1666, Newton then retired to the country, seeing some fruit fall from a tree, as I was told by his niece, Madame Conduit, fell into a profound meditation upon the cause which draws all bodies in a line which, if prolonged, would pass very nearly through the center of the earth." This is the oldest known mention of the apple story. It does not appear in Newton's early biographers, nor in his own account of how he came to the idea of universal gravitation. It is now generally regarded as a legend. More likely is another story in Voltaire, that when a stranger asked Newton how he had discovered the laws of gravitation, he replied, "By thinking of them without ceasing." It is fairly clear that by 1666 Newton had calculated the force of attraction holding the planets in their orbits as varying inversely with the square of their distance from the sun. But he could not as yet reconcile the theory with his mathematical reckonings. He laid it aside and published nothing about it for the next 18 years. The idea of interstellar gravitation was by no means original with Newton. Some 15th century astronomers thought that the heavens exert a force upon the earth like that of the magnet upon iron, and that since the earth is equally attracted from every direction, it remains suspended in the sum total of all these forces. Gilbert's De Magnete, from 1600, had set many minds thinking about the magnetic influences surrounding every body, and he himself had written, in a work that would be published in 1651, 48 years after his death, "The force which emanates from the moon reaches to the earth, and in like manner the magnetic virtue of the earth pervades the region of the moon. Both correspond and conspire by the joint action of both, according to a proportion and conformity of motions. But the earth has more effect in consequence of its superior mass. Ismailis Bouillard, in his Astronomia Philolaica from 1645, had held that the mutual attraction of the planets varies inversely as the square of the distance between them. Alfonso Borelli, in Theories of the Medicean Planets in 1666, held that every planet and satellite revolves round some principal globe of the universe as a fountain of virtue, or force, which so draws and holds them that they cannot by any means be separated from it, but are compelled to follow it wherever it goes, in constant and continuous revolutions. And he explained the orbits of these planets and satellites as the resultant of the centrifugal force of their revolution, as we find in a wheel or a stone whirled in a sling, countered by the centripetal attraction of their sun. Kepler considered gravity inherent in all celestial bodies, and for a while he reckoned its force as varying inversely with the square of the intervening distance. This would have clearly anticipated Newton, but later he rejected this formula and supposed the attraction to be diminished in direct proportion as the distance increased. These approaches to a gravitational theory were deflected by Descartes' hypothesis of vortices forming in a primeval mass and then determining the action and orbit of each part. Many of the alert inquirers in the Royal Society puzzled over the mathematics of gravitation. In 1674, Hooke, in An Attempt to Prove the Annual Motion of the Earth, anticipated by 11 years Newton's announcement of the gravitation theory. I shall explain a system of the world, differing in many particulars from any yet known, answering in all things to the common rules of mechanical motions. This depends upon three suppositions. First, that all celestial bodies whatsoever have an attractive or gravitating power towards their centers, whereby they attract not only their own parts and keep them from flying from them, but that they do also attract all other celestial bodies that are within the sphere of their activity. The second suggestion is this, that all bodies whatsoever that are put into direct and simple motion will so continue to move forward in a straight line till they are by some other effectual powers deflected. The third supposition is that these attractive powers are so much the more powerful in operating by how much nearer the body wrought upon is to their own centers. Hooke did not in this treatise reckon the attraction as varying inversely with the square of the distance, but if we may believe Aubrey, he communicated this principle to Newton, who had already arrived at it independently. In January 1684, Hooke propounded the formula of inverse squares to Wren and Halley, who themselves had already accepted it. They pointed out to Hooke that what was needed was no mere supposition, but a mathematical demonstration that the principle of gravitation would explain the paths of the planets. Wren offered to Hooke and Halley a reward of 40 shillings, or $100, if either would bring him within 2 months a mathematical proof of gravitation. So far as we know, none came. Sometime in August 1684, Halley went to Cambridge and asked Newton what would be the orbit of a planet if its attraction by the sun varied inversely as the square of the distance between them. Newton replied, an ellipse. As Kepler had concluded from his mathematical study of Tycho Brahe's observations that the planetary orbits are elliptical, astronomy seemed now confirmed by mathematics and vice versa. Newton added that he had worked out the calculations in detail in 1679, but had laid them aside, partly because they did not fully accord with the then current estimates of the Earth's diameter and the distance of the Earth from the Moon. More probably because he was not sure that he could treat the Sun, the planets, and the Moon as single points in measuring their attractive force. But in 1671, Picard announced his new measurements of the Earth's radius and a degree of longitude, which last he calculated at 69.1 English statute miles. And in 1672, Picard's mission to Cayenne enabled him to estimate the distance of the Sun from the Earth as 87 million miles. The present figure is 92 million. These new estimates harmonized well with Newton's mathematics of gravitation, and further calculations in 1685 convinced him that a sphere attracts bodies as though all its mass were gathered at its center. Now he felt more confidence in his hypothesis. He compared the rate of fall in a stone dropped to the Earth with the rate at which the Moon would fall toward the Earth if the gravitational pull of the Earth upon the Moon diminished with the square of the distance between them. He found that his results agreed with the latest astronomical data. He concluded that the force making the stone fall and the force drawing the moon toward the Earth, despite the moon's centrifugal impetus, were one and the same. His achievement lay in applying this conclusion to all bodies in space, in conceiving all the heavenly bodies as bound in a mesh of gravitational influences, and in showing how his mathematical and mechanical calculations tallied with the observations of the astronomers, and especially with Kepler's planetary laws. Newton worked out his calculations anew and communicated them to Halley in November 1684. Recognizing their importance, Halley urged him to submit them to the Royal Society. He complied by sending the Society a treatise, Propositiones de Motu, in February 1685, which summarized his views on motion and gravitation. In March 1686, he began a fuller exposition, and on April 28, 1686, he presented to the Society, in manuscript, Book I, De Motu Corporum, of Philosophiae Naturalis Principia Mathematica. Hooke at once pointed out that he had anticipated Newton in 1674. Newton answered in a letter to Halley that Hooke had taken the idea of inverse squares from Borelli and Bouillard. The dispute waxed to mutual irritation. Halley acted as peacemaker, and Newton soothed Hooke by inserting into his manuscript, under Proposition 4, a scholium in which he credited our friends Wren, Hooke, and Halley as having already inferred the law of inverse squares. But the dispute so irked him that when he announced to Halley on June 20th, 1687, that Book 2 was ready, he added, "The third I now design to suppress. Philosophy is such an impertinently litigious lady that a man had as good be engaged in lawsuits as have to do with her." Halley persuaded him to continue, and in September 1687 the entire work was published under the imprint of the Royal Society and its current president, Samuel Pepys. The Society being short of funds, Halley paid for the publication entirely out of his own pocket, though he was not a man of means. So at last, after 20 years of preparation, appeared the most important book of 17th-century science, rivaled in the magnitude of its effect upon the mind of literate Europe only by the De Revolutionibus Orbium Coelestium, from 1543, of Copernicus, and The Origin of Species, in 1859, of Darwin. These three books are the basic events in the history of modern Europe. 4. The Principia. The preface explained the title. Since the ancients, as we are told by Pappus, made great account of the science of mechanics in the investigation of natural things, and the moderns, laying aside substantial forms of the scholastics and occult qualities, have endeavored to subject the phenomena of nature to the laws of mathematics, I have in this treatise cultivated mathematics as far as it regards natural philosophy. Therefore, we offer this work as mathematical principles of philosophy, for all the difficulty of philosophy seems to consist in this: from the phenomena of motions to investigate the forces of nature, and then from these forces to demonstrate the other phenomena. The viewpoint is to be strictly mechanical. I wish we could derive the rest of the phenomena of nature by the same kind of reasoning from mechanical principles, for I am induced by many reasons to suspect that they may all depend upon certain forces by which the particles of bodies, by some causes hitherto unknown, are either mutually impelled towards each other and cohere in regular figures, or are repelled and recede from each other, which forces being unknown, philosophers have hitherto attempted the search of nature in vain. But I hope the principles here laid down will afford some light either to that or some truer method of philosophy. After laying down some definitions and axioms, Newton formulated 3 laws of motion. 1. Every body continues in its state of rest or of uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. 2. The change of motion is proportional to the motive force impressed and is made in the direction of the straight line in which that force is impressed. 3. To every action there is always opposed an equal reaction. Armed with these laws and the rule of inverse squares, Newton proceeded to formulate the principle of gravitation. Its current form, that every particle of matter attracts every other particle with a force varying directly as the product of their masses and inversely as the square of the distance between them, is nowhere found in these words in the Principia. But Newton expressed the idea in the general scholium that closes Book 2. Gravity operates according to the quantity of the solid matter which they, the sun and the planets, contain, and propagates its virtue on all sides, decreasing always as the inverse square of the distances. He applied this principle and his laws of motion to the planetary orbits and found that his mathematical calculations harmonized with the elliptical orbits deduced by Kepler. He argued that the planets are deflected from rectilinear motions and are kept in their orbits by a force tending toward the sun and varying inversely as the square of their distances from the center of the sun. On similar principles, he explained the attraction of Jupiter upon its satellites and of the Earth upon the moon. He showed that Descartes' theory of vortices as the first form of the cosmos could not be reconciled with Kepler's laws. He calculated the mass of each planet and figured the density of the Earth as between 5 and 6 times that of water. The current figure is 5.5. He accounted mathematically for the flattening of the Earth at the poles and ascribed the bulge of the Earth at the equator to the gravitational attraction of the sun. He worked out the mathematics of tides as due to the combined pull of the sun and the moon upon the seas, and by similar lunisolar action, he explained the precession of the equinoctial points. He reduced the trajectories of comets to regular orbits, and so confirmed Halley's prediction. By attributing gravitational attraction to all planets and stars, he pictured a universe mechanically far more complex than had been supposed. For now every planet or star was viewed as influenced by every other. But into this complex multitude of heavenly bodies, Newton placed law. The most distant star was subject to the same mechanics and mathematics as the smallest particles on the earth. Never had man's vision of law ventured so far or so boldly into space. The first edition of the Principia was soon sold out, but no second edition appeared till 1713. Copies became so scarce and hard to secure that one scientist transcribed the whole work with his own hand. It was recognized as an intellectual enterprise of the highest order, but some notes of criticism soured the praise. France, clinging to Descartes' vortices, rejected the Newtonian system until Voltaire gave it a worshipful exposition in 1738. Cassini and Fontenelle objected that gravitation was just one more occult force or quality. Newton propounded certain relationships among the heavenly bodies, but he had not revealed the nature of gravitation, which remained as mysterious as God. Leibniz argued that unless Newton could show the mechanism by which gravitation could act through apparently empty space upon objects millions of miles away, gravitation could not be accepted as anything more than a word. Even in England, the new theory was not readily received. Voltaire claimed that 40 years after its first publication, hardly 20 scientists could be found favorable to it. Whereas in France, critics complained that the theory was insufficiently mechanical as compared with Descartes' primeval whirlpools, in England, the objections were predominantly religious. George Berkeley, in Principles of Human Knowledge in 1710, regretted that Newton had thought of space, time, and motion as absolute, apparently eternal, and existing independently of divine support. Mechanism so pervaded the Newtonian system that there seemed no place in it for God. When Newton, after characteristic delays, agreed to prepare a second edition, he tried to appease his critics. He assured Leibniz and the French that he did not assume a force acting at a distance through empty space. He believed in an intervening medium of transmission, though he would not attempt to describe it, and he frankly confessed that he did not know the nature of gravitation. It was in this connection that he wrote in the second edition the oft-misunderstood words, non fingo hypotheses. Gravity, he added, must be caused by an agent acting constantly according to certain laws. But whether this agent be material or immaterial, I have left to the consideration of my readers. To further meet religious objections, he appended to the second edition a general scholium on the role of God in his system. He restricted his mechanistic explanations to the physical world. Even in that world he saw evidences of divine design. The great machine required some initial source of its motion, which must be God. Moreover, there were in the solar system certain irregularities of behavior, which God periodically corrected as they arose. To make room for such miraculous interpositions, Newton surrendered the principle of the conservation of energy. The world machine, he now supposed, lost energy in time and would run down if God did not intervene to restore its force. This most beautiful system of the sun, planets, and comets, he concluded, could only proceed from the counsel and dominion of an intelligent and powerful being. Finally, he moved toward a philosophy that could be interpreted in either a vitalistic or a mechanistic sense. And now we might add something concerning a certain most subtle spirit which pervades and hides in all gross bodies, by the force and action of which spirit the particles of bodies attract one another at near distances and cohere if contiguous, and electric bodies operate to greater distances, as well repelling as attracting the neighboring corpuscles. And light is emitted, reflected, refracted, inflected, and heats bodies. And all sensation is excited, and the members of animal bodies move at the command of the will, namely by the vibrations of this spirit, mutually propagated along the solid filaments of the nerves, from the outward organs of sense to the brain, and from the brain into the muscles. But these are things that cannot be explained in a few words, nor are we furnished with that sufficiency of experiments which is required to an accurate determination and demonstration of the laws by which this electric and elastic spirit operates. What was his actual religious faith? His professorship at Cambridge required allegiance to the established church, and he attended Anglican services regularly. But, says his secretary, as for his private prayers, I can say nothing of them. I am apt to believe his intense studies deprived him of the better part. Yet he studied the Bible as zealously as he studied the universe. An archbishop complimented him. You know more divinity than all of us put together. And Locke said of his knowledge of the Scriptures, I know few his equals. He left theological writings greater in bulk than all his scientific works. His studies led him to semi-Arian conclusions, much like those of Milton, that Christ, though the Son of God, was not equal in time or power with God the Father. For the rest, Newton was, or became, quite orthodox. He seems to have taken every word of the Bible as the word of God, and to have accepted the books of Daniel and Revelation as literal truth. The greatest scientist of his age was a mystic who lovingly copied out large passages from Jacob Boehme, who asked Locke to discuss with him the meaning of the white horse in the Apocalypse. He encouraged his friend John Craig to write Theologiae Christianae Principia Mathematica in 1699, which sought to prove mathematically the date of Christ's second coming and the ratio between the highest attainable earthly happiness and the believer's rewarding bliss in paradise. He wrote a commentary on the Apocalypse and argued that the Antichrist therein predicted was the Pope of Rome. Newton's mind was a mixture of Galileo's mechanics and Kepler's laws with Boehme's theology. We shall not soon see his like again. 5. Evening. He was in another sense an anomalous mixture, a man apparently absorbed in mathematical and mystical theory, and yet possessed of practical ability and common sense. In 1687 he was chosen by the University of Cambridge to go with others and protest to James II the king's attempt to have the university admit a Benedictine monk to a degree without taking the usual oaths impossible to a Catholic. The mission failed to dissuade the king, but the university must have approved Newton's conduct of it, for he was chosen member for Cambridge in the Parliament of 1689. He served till the dissolution in 1690, and was re-elected in 1701, but he took no memorable part in politics. His career was interrupted in 1692 by 2 years of physical and mental illness. He addressed to Pepys and Locke letters complaining of sleeplessness and melancholia, expressing fears of persecution, and mourning that he had lost the former consistency of his mind. On September 16, 1693, he wrote to Locke, Sir, being of opinion that you endeavored to embroil me with women and by other means, I was so much affected that when one told me you were sickly and would not live, I answered 'twere better if you were dead. I desire you to forgive me for this uncharitableness, for I am now satisfied that what you have done is just, and I beg your pardon for having hard thoughts of you for it, and for representing that you struck at the root of morality in a principle you laid down in your book of ideas, and designed to pursue in another book, and that I took you for a Hobbist. I beg your pardon also for saying or thinking that there was a design to sell me an office or to embroil me. I am your most humble and unfortunate servant, Isaac Newton. Pepys, in a letter of September 26, 1693, mentioned a discomposure in head or mind, evidenced by a message he had received from Newton. Huygens left at his death in 1695 a manuscript in which he noted, under the date of May 29, 1694, that Mr. Colin, a Scotchman, informed me that 18 months ago the illustrious geometer Isaac Newton had become insane, but had so far recovered his health that he began to understand the Principia. Huygens sent the report to Leibniz in a letter of June 8, 1694. The good Mr. Newton has had an attack of phrenitis which lasted 18 months, and of which they say his friends have cured him by means of remedies and keeping him shut up. Some have supposed that this nervous breakdown led Newton from science to the apocalypse, but we cannot say. It was said that he never again concentrated after the old fashion or did any fresh work. Yet he solved almost at once in 1696 a mathematical problem proposed by Johann Bernoulli to the acutest mathematicians in the world, and he did likewise with the problem set by Leibniz in 1716. His answer to Bernoulli was sent anonymously through the Royal Society, but Bernoulli at once guessed the author to be Newton, recognizing, he said, tanquam ex ungue leonum, the lion from his toenail. In 1700 he discovered the theory of the sextant. He let it remain unknown except by a letter to Halley, and it had to be reinvented in 1730. And he seems to have filled creditably the difficult positions to which he was presently appointed by the state. Locke, Pepys, and other friends had for some time negotiated to secure for Newton a governmental position that would get him away from the confinement of his room and laboratory at Cambridge. In 1695 they persuaded Lord Halifax to offer him the post of Warden of the Mint. The appointment was no sinecure and no act of charity. The government wished to use Newton's knowledge of chemistry and metallurgy in minting a new coinage. In 1695 he moved to London, where he lived with his niece, Catherine Barton, the mistress of Halifax. Voltaire felt that the charm of this niece led Halifax, as Chancellor of the Exchequer, to make Newton Master of the Mint in 1699. But this bit of gossip hardly explains why Newton continued to hold that office through his remaining 28 years, and to the general satisfaction. His old age should have been happy. He was honored as the greatest of living scientists. Not till our own time did any man of science enjoy such wide acclaim. He was elected President of the Royal Society in 1703, and annually thereafter till his death. In 1705 he was knighted by Queen Anne. When he rode in his carriage through the London streets, people gazed with awe upon his pink face, majestic and benevolent under a mass of white hair. And they could not always see that he had expanded out of proportion to his modest height. He enjoyed a good salary, £1,200 a year, and invested his savings so wisely that he left £32,000 when he died, though he had been generous in gifts and charity. He surmounted successfully the South Sea Company fiasco. However, he was moody, sometimes irritable, suspicious, secretive, always timid but proud. He loved privacy and did not make friends readily. In 1700 he proposed to a rich widow. Nothing came of it, and he never married. High-strung and morbidly sensitive, he bore criticism painfully, resented it sharply, and fought back stoutly in controversy. He was conscious of his own work and ability, but he lived modestly until his salary and his savings enabled him to have 6 servants and enjoy a high place in London society. In his 79th year he began to repay his debt to nature. Diseases that respect no genius afflicted him, stone in the bladder and urinary incontinence. At the age of 83 he suffered from gout, and at 84 from hemorrhoids. On March 19, 1727, the pains from the stone were so severe that he lost consciousness. He never regained it, but died the next day in his 85th year. He was buried in Westminster Abbey after a funeral led by statesmen, nobles, and philosophers, in a pall borne by dukes and earls. Poets swathed him in elegies, and Pope composed a famous epitaph. Nature and nature's laws lay hid in night. God said, "Let Newton be," and all was light. Voltaire, even in old age, was moved when he told how, in his English exile, he had seen a mathematician buried with the honors of a king. Newton's fame grew to almost absurd heights. Leibniz judged his rival's contributions to mathematics to be equal in value to all previous work in that science. Hume considered Newton the greatest and rarest genius that ever rose for the adornment and instruction of the species, and Voltaire modestly agreed. Lagrange called the Principia the greatest production of the human mind, and Laplace assured it for all time a preeminence above all other productions of the human intellect. Newton, he added, was the most fortunate of men, for there is only one universe and one ultimate principle in it, and Newton discovered that principle. Such judgments are precarious, for truth, even in science, wilts like a flower. If we rank the greatness of a man by the least subjective test, the spread and duration of his influence, Newton can be compared only with the founders of world religions and pivotal philosophies. For a time, his influence upon English mathematics was harmful, for his fluxions and their notation proved less convenient than the calculus and notation with which LEIBNIZ prevailed on the continent. For a century, his corpuscular theory of light seems to have impeded the progress of optics, though some students now find much help in Newton's view. In mechanics, his work has proved endlessly creative. All that has been accomplished in mechanics since his day, wrote Ernst Mach, has been a deductive, formal, and mathematical development on the basis of Newton's laws. Theologians at first feared the influence of the Principia on religion, but Bentley's Boyle lectures in 1692, encouraged by Newton, turned the new worldview to the support of faith by stressing the apparent unity, order, and grandeur of the universe as evidences of the wisdom, power, and majesty of God. However, the same Newtonian system was accepted by the Deists as strengthening their replacement of the Christian theology with a simple acceptance of one God, or even their identification of God with nature and her laws. Probably the final influence of Newton on religion was injurious. Despite his protests and his million words of theological writings, freethinkers supposed that he had conceived a self-subsistent world and had brought deity into it as a comforting afterthought. In France especially, Newton's cosmology, though presented deistically by Voltaire, encouraged the mechanistic atheism of many philosophes. Between the decline of the Cartesian cosmogony in France, circa 1740, and the rise of relativity theories and quantum mechanics in the 20th century, Newton's system of the world met no serious challenge, and seemed to be verified by every advance or discovery in physics or astronomy. So far as an outsider can understand such arcana, the principal dissents of contemporary physicists from Newton's mechanics are: 1. Newton took space and distance, time and motion as absolute, that is, not varying in quantity according to anything outside themselves. Einstein considered them relative, varying with the position and motion of the observer in space and time. 2. Newton's first law of motion apparently assumed that a body might continue in a state of rest or of uniform motion in a straight line. But rest is always relative, like the rest of a traveler in a speeding plane. All things move, and never in a straight line, for every line of motion or action is deflected by surrounding bodies, as Newton realized. 3. Newton thought of mass as a constant. Some contemporary physicists think of it as varying with the relative velocity of observer and object. 4. Force is now looked upon as a convenient but not necessary concept in science, which aims to content itself with describing sequences, relations, and results. We do not and need not, we are told, know what it is that passes from a moving object to an object that it strikes. We need only record the sequences and assume, never with absolute certainty, that these will be in the future what they have appeared to be in the past. Gravitation, in this view, is not a force, but a system of relationships among events in space and time. It is a consolation to learn that these and other emendations of Newton's mechanics are of importance only in fields, such as electromagnetic phenomena, where particles seem to move with a speed approaching the velocity of light. Elsewhere, the divergence between the old physics and the new may be safely ignored. Philosophers, cured of certainty by history, may still retain a humble skepticism about contemporary ideas, including their own. They will sense a fluent relativity in relativity formulas, and they will remind all delvers in atoms and stars of Newton's own final estimate of his epochal achievement. I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting himself in now and then finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me. Chapter 20. English Philosophy, 1648 to 1715. 1. Thomas Hobbes, 1588 to 1679. 1. Formative influences. He was born aforetime on April 5, 1588. His mother attributed his premature birth to her fright at the coming of the Spanish Armada and the threat of a large-scale invasion by murderous idolaters. To this unpremeditated expulsion into life the philosopher ascribed his timorous disposition, but he was the boldest heretic of his age. His father, an Anglican clergyman at Malmesbury in Wiltshire, may have transmitted some pugnacity to the son, for he engaged in a brawl at the door of his church and then disappeared, leaving his 3 children to be brought up by a brother. The brother prospered, and at 15 Thomas entered Magdalen College, Oxford, doubtless as timid as any youth venturing into caves dedicated to the idols of the tribe. He found little to his liking in the philosophy taught there. He consoled himself with extracurricular reading and gained a first-hand acquaintance with Greek and Latin classics. Graduating at 20, he had the good fortune to be employed as private tutor to William Cavendish, who became 2nd Earl of Devonshire. The protection given him by that family proved precious to him in the days of his heresies. With his pupil, he traveled on the continent in 1610. On his return, he served for a while as secretary to Francis Bacon. That stimulating experience may have shared in forming his thoroughly empirical philosophy. About this time, Aubrey tells us, Mr. Benjamin Johnson, poet laureate, was his loving and familiar friend. More learned than Hobbes and not yet tough. Soon he was back with the Cavendish family. He retained relations with it for 3 generations. And probably from these generous and well-entrenched patrons, he adopted the royalist and high church views that won pardon for his materialistic metaphysics and kept him from burning. His discovery of Euclid was a turning point in his mental biography. He was 40 years old when, in a private library, he saw the Elements open at Proposition 47 of Book 1. Reading it, he cried out, "By God, this is impossible!" The demonstration referred for its proof to an earlier proposition, and this to another, and so backward to the initial definitions and axioms. He was delighted with this logical architecture and fell in love with geometry. But, Aubrey adds, he was much addicted to music and practiced on the bass viol. In 1629, he published a translation of Thucydides with the professed aim of scaring England away from democracy. In that year he resumed his travels, now as tutor to his first pupil's son, the 3rd Earl of Devonshire. His visit to Galileo in 1636 may have strengthened his inclination to interpret the universe in mechanical terms. He returned to England in 1637. As the conflict between Parliament and Charles I progressed, Hobbes wrote an essay, The Elements of Law, Nature, and Politic, defending the absolute authority of the king as indispensable to social order and national unity. This was circulated in manuscript and might have led to the author's arrest had not Charles dissolved the Parliament. As the temper of the conflict rose, Hobbes thought it discreet to retire to the continent in 1640. He remained there, chiefly in Paris, for the next 11 years. In Paris he won the friendship of Mersenne and Gassendi and the hostility of Descartes. Mersenne invited him to submit comments on Descartes' meditations. He did, with some courtesy but too much point, and Descartes never forgave him. When civil war came to England in 1642, royalist émigrés formed a colony in France, and Hobbes may have taken from them some added rubbing of monarchist sentiment. For 2 years, from 1646 to 48, he was tutor in mathematics to the exiled Prince of Wales, the future Charles II. The outbreak of the Fronde in France, aiming like the revolt in England to limit royal power, confirmed his conviction that only an absolute monarchy could maintain stability and internal peace. He arrived very slowly at the definitive expression of his philosophy. This book is continued at this point on the other side of this cassette. Please reverse or turn the cassette over now. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant, Part 2, continued. Cassette 8, Side 2. He arrived very slowly at the definitive expression of his philosophy. He walked much and contemplated, says Aubrey, and he had in the head of his staff, or cane, a pen and inkhorn, carried always a notebook in his pocket, and as soon as a notion darted, he presently entered it into his book, or else he should perhaps have lost it. He issued a series of minor works, most of which are now negligible, but in 1651 he gathered his thoughts into a reckless masterpiece of thought and style. The Leviathan, or the Matter, Form, and Power of a Commonwealth, Ecclesiastical and Civil. This is one of the landmarks in the history of philosophy. We must tarry with it leisurely. 2. Logic and Psychology. The style is almost as good as Bacon's, not as rich in illuminating images, but every bit as pithy, idiomatic, forceful, and direct. with now and then a tang of pointed irony. There is no ornament here, no show of eloquence, only the clear expression of clear thought, with a stoic economy of verbal means. Words, said Hobbes, are wise men's counters, they do but reckon by them. But they are the money of fools that value them by the authority of an Aristotle, a Cicero, or a Thomas. With that new razor he cut down many a weed of pretentious and meaningless speech. When he came upon St. Thomas Aquinas's definition of eternity as nunc stans, or everlasting now, he shrugged it off as easy enough to say, but though I fain would, yet I never could conceive it. They that can are happier than I. Therefore Hobbes is a blunt nominalist. Class or abstract nouns like man or virtue are merely names for generalizing ideas. They do not represent objects. All objects are individual entities, individual virtuous actions, individual men. He defines his terms carefully, and on the first page of his book he defines Leviathan as a commonwealth or state. He found the word in Job, where God used it for an unspecified sea monster as an image of the divine power. Hobbes proposed to make the state a great organism that should absorb and direct all human activity, but before coming to his main thesis, he swept through logic and psychology with a merciless hand. He understood by philosophy what we should now call science, the knowledge of effects or of appearances acquired from the knowledge of their causes, and conversely of possible causes from their known effects. He followed Bacon in expecting from such a study great practical benefits to human life. But he ignored Bacon's call to inductive reasoning. He was all for true ratiocination, that is, deduction from experience. And in his admiration for mathematics he added that ratiocination is the same with addition and subtraction, that is, the combination or separation of images or ideas. He thought that what we lack is not experience, but proper reasoning about experience. If we could clear away the miasma of meaningless words from metaphysics, and the prejudices transmitted by custom, education, and partisan spirit, what a load of error would fall away. Reason, however, is fallible, and, except in mathematics, can never give us certainty. The knowledge of consequence, which I have said before is called science, is not absolute, but conditional. No man can know by discourse, or reasoning, that this or that is, has been, or will be, which is to know absolutely, but only that if this be, that is. If this has been, that has been. If this shall be, that shall be, which is to know conditionally. As that passage foresaw Hume's argument that we know only sequences, not causes, so Hobbes anticipated Locke's sensationist psychology. All knowledge begins with sensation. There is no conception in a man's mind which hath not at first, totally or by parts, been begotten upon the organs of sense. It is a frankly materialistic psychology. Nothing exists outside us or within us except matter and motion. All qualities called sensible, or sensory, light, color, form, hardness, softness, sound, odor, taste, heat, cold, are in the object that causeth them but so many several motions of the matter by which it presseth our organs diversely. Neither in us that are pressed are they anything else but divers motions, for motion produceth nothing but motion. Motion in the form of change is necessary to sensation. Semper idem sentire, idem est ac nihil sentire. Hobbes could be epigrammatic in Latin, too. Always to feel the same thing is the same as to feel nothing. So neither the white man nor the colored man is conscious of his own odor, since it is always under his nose. From sensation, Hobbes proceeds to derive imagination and memory through a peculiar application of what came to be Newton's first law of motion. That when a thing lies still, unless somewhat else stir it, it will lie still forever, is a truth that no man doubts of. But that when a thing is in motion, it will be eternally in motion, unless somewhat else stay it, though the reason be the same, namely that nothing can change itself, is not so easily assented to. When a body is once in motion, it moveth, unless something else hinder it, eternally, and whatsoever hindereth it cannot in an instant, but only in time and by degrees, quite extinguish it. And as we see in the water, though the wind cease, the waves give not over rolling for a long time after. So also it happeneth in that motion which is made in the internal parts of a man, then when he sees, dreams, etc. For after the object is removed, or the eye shut, we still retain an image of the thing seen, though more obscure than when we see it. And this is it the Latins call imagination. Imagination, therefore, is nothing but decaying sense. When we would express the decay, or signifying that the sense is fading, old, and past, it is called memory. Much memory, or memory of many things, is called experience. Ideas are imaginations produced by sensation or memory. Thought is a sequence of such imaginations. That sequence is determined not by a free will, but by mechanical laws governing the association of ideas. Not every thought to every thought succeeds indifferently, but as we have no imagination whereof we have not formerly had sense in whole or in parts, so we have no transition from one imagination to another whereof we never had the like before in our senses. The reason whereof is this: all fancies, imaginations, ideas, are motions within us, relics of those made in the sense, and those motions that immediately succeed one another in the sense continue also together after sense. But because in sense to one and the same thing perceived, sometimes one thing, sometimes another succeeds, it comes to pass in time that in the imaging of anything there is no certainty what we shall imagine next. Only this is certain: it shall be something that succeeded the same before at one time or another. Such a train of thoughts may be unguided, as in dreams, or regulated by some desire and design. In dreams, the images lying dormant in the brain are aroused by some agitation of the inward parts of man's body, for all parts of the body are connected in some way with certain parts of the brain. I believe there is a reciprocation of motion from the brain to the vital parts, and back from the vital parts to the brain, whereby not only imagination, or idea, begetteth motion in those parts, but also motion in those parts begetteth imagination, like to that by which it was begotten. Our dreams are the reverse of our waking imaginations, the motion when we are awake beginning at one end, and when we dream at another. The illogical sequence of images in dreams is due to the absence of any external sensation to check them, or of any purpose to guide them. There is no place in Hobbes's psychology for free will. The will itself is no separate faculty or entity, but merely the last desire or aversion in the process of deliberation. And deliberation is an alternation of desires or aversions, which ends when one impulse lasts long enough to flow into action. In deliberation, the last appetite or aversion immediately adhering to the action or the omission thereof is that we call the will. Appetite, fear, hope, or the rest of the passions are not called voluntary, for they proceed not from, but are the will, and the will is not voluntary. Because every act of man's will and every desire and inclination proceedeth from some cause, and that from another cause in a continual chain, whose first link is in the hand of God, the first of all causes, they proceed from necessity, so that to him that could see the connection of those causes, the necessity of all man's voluntary actions would appear manifest. Throughout the universe there is an unbroken chain of causes and effects. Nothing is contingent or miraculous or due to chance. The world is a machine of matter in motion according to law, and man himself is a similar machine. Sensations enter him as motions and beget images or ideas. Each idea is the beginning of a motion, and becomes an action if not impeded by another idea. Every idea, however abstract, moves the body in some degree, however unseen. The nervous system is a mechanism for transforming sensory motion into muscular motion. Spirits exist, but they are merely subtle forms of matter. The soul and the mind are not immaterial. They are names for the vital processes of the body and operations of the brain. Hobbes makes no attempt to explain why consciousness should have developed in such a mechanical process of sensation to idea to response, and by reducing all perceived qualities of objects to images in the mind, he comes close to the position that Berkeley would later take in refuting materialism, that all reality known to us is perception, mind. 3. Ethics and Politics. Like Descartes before him and Spinoza after him, Hobbes undertakes an analysis of the passions, for he finds in them the sources of all human actions. All three philosophers use the word passion broadly to mean any basic instinct, feeling, or emotion, chiefly appetite or desire, and aversion, love and hate, delight and fear. Behind all these are pleasure and pain, physiological processes raising or lowering the vitality of the organism. Appetite is the beginning of emotion toward something that promises pleasure. Love is such an appetite directed to one person. All impulses, as La Rochefoucauld would argue 14 years later, are forms of self-love and derive from the instinct of self-preservation. Pity is the imagination of future calamity to ourselves, aroused by perceiving another's calamity. Charity is the satisfied feeling of power in helping others. Gratitude sometimes includes a certain hostility. To have received from one to whom we think ourselves equal greater benefits than there is hope to requite disposeth to counterfeit love, but really secret hatred, and puts a man into the estate of a desperate debtor, that, in declining the sight of his creditor, tacitly wishes him there where he might never see him more. For benefits oblige, and obligation is thraldom. The basic aversion is fear, the basic appetite is for power. I put for a general inclination of all mankind a perpetual and restless desire of power after power, that ceaseth only in death. We desire riches and knowledge as means to power, and honors as evidence of power, and we desire power because we fear insecurity. Laughter is an expression of superiority and power. The passion of laughter is nothing else but sudden glory, or self-satisfaction, arising from a sudden conception of some eminency in ourselves by comparison with the infirmity of others, or with our own formerly. For men laugh at the follies of themselves past, when these come suddenly to remembrance, except they bring with them any present dishonor. Laughter is incident most to them that are conscious of the fewest abilities in themselves, who are forced to keep themselves in their own favor by observing the imperfections of other men. And therefore much laughter at the defects of others is a sign of pusillanimity. For of great minds one of the proper works is to help and free others from scorn, and compare themselves only with the most able. Good and bad are subjective terms, varying in content not only from place to place and from time to time, but from person to person. The object of any appetite or desire, a man calleth the good, the object of his hate or aversion, evil. For these words are ever used with relation to the person that useth them, there being nothing simply and absolutely so, nor any common rule of good and evil to be taken from the nature of the objects themselves. Strength of passions may be good and lead to greatness. He who has no great passion for power, riches, knowledge, or honor cannot possibly have a great fancy or much judgment. To have weak passions is dullness. To have passions abnormally strong is madness. To have no desires is to be dead. The felicity of this life consisteth not in the repose of a mind satisfied, for there is no such finis ultimus, or ultimate aim, nor summum bonum, or greatest good, as is spoken of in the books of the old moral philosophers. Felicity is a continual progress of the desire from one object to another, the obtaining of the former being still but the way to the latter. The government of men so constituted, so acquisitive and competitive, so hot with passions and prone to strife, is the most complex and arduous of all human tasks, and to those who undertake it we must allow every weapon of psychology and power. Though the human will is not free, society is justified in encouraging certain actions by calling them virtuous, and rewarding them, and in discouraging some actions by calling them wicked and punishing them. There is no contradiction here with determinism. These social approvals and condemnations are added, for the good of the group, to the motives influencing conduct. The world is governed by opinion. Government, religion, and the moral code are in large part the manipulation of opinion to reduce the necessity and area of force. Government is necessary not because man is naturally bad, for the desires and other passions are in themselves no sin, but because man is by nature more individualistic than social. Hobbes did not agree with Aristotle that man is a political animal, that is, a being equipped by nature for society. On the contrary, he conceived an original state of nature, and therefore the original nature of man, as a condition of competition and mutual aggression, checked only by fear, not yet by law. We can visualize that hypothetical condition, said Hobbes, by observing international relations in our own age. Nations are still for the most part in a state of nature, not yet subject to a superimposed law or power. In all times, kings and persons of sovereign authority, because of their independency, are in continual jealousies, and in the state and posture of gladiators, having their weapons pointed and their eyes fixed on one another, that is, their forts, garrisons, and guns on the frontiers of their kingdoms, and continual spies upon their neighbors, which is a posture of war. Where there is no common power, there is no law, no injustice, Force and fraud are in war the cardinal virtues. So, Hobbes believed, individuals and families, before the coming of social organization, had lived in a condition of perpetual war, actual or potential, every man against every man. War consisteth not in battle only, but in a tract of time wherein the will to contend by battle is sufficiently shown. He rejected the theory of Roman jurists and Christian philosophers that there is or ever was a law of nature, in the sense of laws of right and wrong based upon the nature of man as a reasonable animal. He admitted that man was occasionally rational, but saw him rather as a creature of passions, above all the will to power, using reason as a tool of desire and controlled only by fear of force. Primitive life, that is, life before social organization, was lawless, violent, fearful, nasty, brutish, and short. From this hypothetical state of nature, men, in Hobbes's vision, had emerged by an implicit agreement one with another to submit to a common power. This is the social contract theory made popular by Rousseau's treatise under that title in 1762, but already old and battered in Hobbes's day. Milton, in his tract on the tenure of kings and magistrates in 1649, had just interpreted the contract as an agreement between a king and his subjects, that they would obey him, and that he would properly fulfill the duties of his office. If he failed in this, said Milton, like Buchanan, Mariana, and others, the people would be justified in deposing him. Hobbes objected to this form of the theory on the ground that it established no authority empowered to enforce the contract, or to determine when it had been broken. He preferred to think of the social compact as made not between ruler and ruled, but among the ruled, who agreed to confer all their power and strength, or their right to the use of force upon one another, upon one man or upon one assembly of men. This done, the multitude so united in one person is called a commonwealth. This is the generation of the great Leviathan, or rather of that mortal God to which we owe, under the immortal God, our peace and defense. For by this authority, given him by every man in the commonwealth, he hath the use of so much power and strength conferred on him, that by terror thereof he is enabled to form the wills of them all, to the end he may use the strength and means of them all, as he shall think expedient, for their peace and common defense. And he that carrieth this person is called sovereign, and said to have sovereign power, and every one besides his subject. The theory rashly assumed, among the nasty and brutish savages aforementioned, a degree of order, rationality, and humility sufficient for an agreement to surrender their powers. Hobbes wisely allowed for alternative origins of the state. The attaining to the sovereign power is by two ways. One by natural force, as when a man maketh his children to submit themselves, and their children, to his government, as being able to destroy them if they refuse, or by war subdueth his enemies to his will. The other is when men agree among themselves to submit to some man or assembly of men voluntarily, on confidence to be protected by him against all others. This latter may be called a political commonwealth. However based, the sovereign, to be really sovereign, must have absolute power, for without it he cannot ensure individual security and public peace. To resist him is to violate the social contract which every person in the community has implicitly agreed to by accepting the protection of its head. The theoretical absolutism may admit of some actual limitations. A sovereign may be resisted if he orders a man to kill or maim himself, or to confess a crime, or if the ruler is no longer able to protect his subjects. The obligation of subjects to the sovereign is understood to last as long and no longer than the power lasteth by which he is able to protect them. Revolution is always a crime until it succeeds. It is always unlawful and unjust, for both law and justice are determined by the sovereign. But if a revolution establishes a stable and effective government, the subject is bound to obey the new power. The king does not rule by divine right, since his power is derived from the people, but his authority must not be limited by a popular assembly, or by law, or by the church. It should extend also to property. The sovereign should determine property rights, and may reappropriate private property for what he deems the public good. Absolutism is necessary, for when power is shared, as between king and parliament, there will soon be conflict, then civil war, then chaos, then insecurity of life and property. And since security and peace are the ultimate needs of a society, there should be no separation, but full unity and concentration of governmental powers. Where powers are divided, there is no sovereign, and where there is no sovereign, there will soon be no state. Consequently, the only logical form of government is monarchy. It should be hereditary, for the right to choose his successor is part of the sovereign's sovereignty. Again, the alternative is anarchy. Government by an assembly might serve, but only on condition that its power be absolute, not subject to the shifting desires of an uninformed populace. A democracy is no more than an aristocracy of orators. The people are so readily moved by demagogues that control must be exercised by the government over speech and press. There should be strict censorship of the publication, importation, and reading of books. There is to be no nonsense about individual liberty, private judgment, or conscience. Anything that threatens the sovereign authority and therefore the public peace should be contracepted at its source. How could a state be governed or protected in its foreign relations if every individual remained free to obey or not to obey the law according to his private opinion? 4. Religion and the state. The sovereign must also control the religion of his people, for this, when taken to heart, can be a disruptively explosive force. Hobbes offers a summary definition. Fear of power invisible, feigned by the mind or imagined from tales publicly allowed, is religion. Not allowed? Superstition. This reduces religion to fear, imagination, and pretense, but elsewhere Hobbes ascribes it to an anxious inquiry into the causes and beginnings of things and events. Ultimately, this pursuit of causes leads to the belief that there must be, as even the heathen philosophers confessed, one first mover, that is, a first and an eternal cause of all things, which is that which men mean by the name of God. Men naturally supposed that this first cause was like themselves, a person, soul, and will, only much more powerful. They attributed to this cause all events whose natural determinants they could not yet discern, and they saw in strange events portents and prophecies of the divine will. In these 4 things, opinion of ghosts, or spirits, ignorance of second causes, devotion towards what men fear, and taking of things casual for prognostications, consisteth the natural seat of religion, which, by reason of different fancies, judgments, and passions of several men, hath grown up into ceremonies so different, that those which are used by one man are for the most part ridiculous to another. Hobbes was a deist rather than an atheist. He acknowledged an intelligent supreme being, but added, "Men may naturally know that God is, though not what he is. We must not conceive of God as having figure, for all figure is finite, or as having parts, or as being in this or that place. For whatsoever is in place is bounded and finite, nor that he moves or rests, for these ascribe to him place, nor, except by metaphor, that he partakes of grief, repentance, anger, mercy, want, appetite, hope, or any desire." Hobbes concluded that the nature of God is incomprehensible. He would not describe God as incorporeal, for we cannot conceive anything to be without body. Probably every spirit is subtly corporeal. Having put religion and God in their place, Hobbes proposed to make use of them as instruments and servants of government. For this he claimed prestigious precedence. The first founders and legislators of commonwealths amongst the Gentiles, whose ends were only to keep the people in obedience and peace, have in all places taken care, first, to imprint in their minds a belief that those precepts which they gave concerning religion might not be thought to proceed from their own device, but from the dictates of some god or other spirit, or else that they themselves were of a higher nature than mere mortals, that their laws might be more easily received. So Numa Pompilius pretended to receive the ceremonies he instituted among the Romans from the nymph Egeria. And the first king and founder of the kingdom of Peru pretended himself and his wife to be the children of the sun. And Mahomet, to set up his new religion, pretended to have conferences with the Holy Ghost in the form of a dove. Secondly, they have had a care to make it believed that the same things were displeasing to the gods which were forbidden by the laws. Lest anyone conclude that Moses used similar devices in ascribing his laws to God, Hobbes adds, with a certain allergy to fire, that God himself, by supernatural revelation, planted religion among the Jews. But he feels himself justified, by historical examples, in recommending that religion be made an instrument of government, and that, in consequence, its doctrines and observances be dictated by the sovereign. If the Church were independent of the state, there would be 2 sovereigns, therefore no sovereign, and subjects would be torn between 2 masters. Seeing the ghostly, or spiritual power, challenges, or assumes, the right to declare what is sin, it challenges by consequence to declare what is law, sin being nothing but the transgression of the law. When these two powers, meaning church and state, oppose one another, the commonwealth cannot but be in great danger of civil war and dissolution. In such a conflict the church will have an advantage. For every man, if he be in his wits, will in all things yield that man an absolute obedience, by virtue of whose sentence he believes himself to be either saved or damned. When the spiritual power moves the subjects by the terror of punishment and hope of reward, of this supernatural sort, and by strange and hard words suffocates their understanding, it must needs thereby distract the people, and either overwhelm the commonwealth by oppression, or cast it into the fire of civil war. The only escape from such turmoil, Hobbes thinks, is to make the church subject to the state. As the Catholic Church had the opposite solution, Hobbes, in Part 4 of the Leviathan, attacks it as the ultimate and most powerful foe of his philosophy. He enters upon some higher criticism of the Bible, questions Moses' authorship of the Pentateuch, and dates the historical books much later than an orthodox tradition. He suggests that Christianity should require of its adherents only a faith in Jesus the Christ, and that for the rest it should allow public opinion to vary within the safe bounds of public order. To a creed so chastened he offers not only the support of the government, but the full force of the state to propagate it. He agrees with the Pope that only one religion should be tolerated in a state. He advises the citizens to accept the theology of their sovereign without critical hesitation, as a duty to morality and the state. For it is with the mysteries of our religion as with wholesome pills for the sick, which, swallowed whole, have the virtue to cure, but chewed are for the most part cast up again without effect. The most powerful assault that any Englishman had yet made upon Christianity ended with Christianity established as the inescapable law of an absolute state. 5. Baiting the bear. And thus, said the final paragraph of the Leviathan, I have brought to an end my discourse of civil and ecclesiastical government, occasioned by the disorders of the present time, without partiality and without other design than to set before men's eyes the mutual relation between protection and obedience. The impartiality was not widely recognized. The émigrés who gathered about Charles II in France welcomed Hobbes's defense of royalty, but condemned his materialism as indiscreet, if not blasphemous. And they regretted that their unmanageable philosopher had spent reams attacking the Catholic Church just when they were soliciting the aid of a Catholic king. The Anglican divines, who were among the refugees from the triumphant Puritans, raised such an outcry against the book that Hobbes was ordered to come no more to court. Finding himself now friendless and unprotected in France, Hobbes decided to make his peace with Cromwell and return to England. According to Bishop Burnet, he made some changes in the text of the Leviathan to gratify the Republicans. This is not certain. Certain it is, however, that the doctrine of revolution as unlawful in origin but sanctified by success fitted imperfectly, like patchwork, with the basic doctrine of absolute obedience to an absolute monarch. The final review and conclusion, which looks like an afterthought, explained the conditions under which a subject formerly loyal to a king might in time gracefully submit to the new regime that had deposed the king. The book was published in London in 1651 while Hobbes was still in Paris. At the end of that year, amid a severe winter, he crossed to England and found a familiar haven with the Earl of Devonshire, who had long since submitted to the revolutionary Parliament. Hobbes sent in his own submission. It was accepted, and the philosopher, supported by a small pension from the Earl, moved to a house in London, because in the countryside the want of learned conversation was a very great inconvenience. He was now 63 years old. Slowly, as his book found readers, a swarm of critics gathered around his head. One clergyman after another came to the defense of Christianity and asked who was this Malmesbury animal who set himself up against Aristotle, Oxford, Parliament, and God. Hobbes was timid, but he was a fighter. In 1655 he restated, in the Elements of Philosophy, his materialistic and deterministic views. John Bramhall, the learned Bishop of Derry, cast his hook for Hobbes in the Catching of the Leviathan in 1658, and aimed so well, according to another bishop, that the hook is still in Hobbes's nose. The attacks continued in almost every year till Hobbes's death. The Earl of Clarendon, after his fall from power as Chancellor, amused his exile by publishing a brief view and survey of the dangerous and pernicious errors in Church and State in Mr. Hobbes's book entitled Leviathan, this in 1676. Through 322 pages it followed the volumes systematically, answering argument with argument in lucid and majestic prose. Clarendon spoke as a man with long experience in political office, and smiled Hobbes's philosophy away as that of one who had no responsible posts to temper his theorems with practice. And he hoped that Mr. Hobbes might have a place in Parliament, and sit in council, and be present in courts of justice and other tribunals, whereby it is probable he would find that his solitary cogitations, how deep soever, and his too peremptory adhering to some philosophical notions, and even rules of geometry, have misled him in the investigation of policy. Not all the attacks were so even-tempered. In 1666, the House of Commons ordered one of its committees to receive information touching such books as tend to atheism, blasphemy, and profaneness, or against the essence and attributes of God, and in particular the book published in the name of White, a former Catholic priest who questioned the immortality of the soul, and the book of Hobbes called the Leviathan. There was a report, and surely true, says Aubrey, that in Parliament some of the bishops made a motion to have the good old gentleman burnt for a heretic. Hobbes destroyed such of his unpublished papers as might further embroil him, and wrote 3 dialogues arguing learnedly that no court in England could try him for heresy. The restored king came to his rescue. Shortly after reaching London, Charles II noticed Hobbes in the street, recognized him as his former tutor, and welcomed him to the court. The Restoration Court, already inclined to religious skepticism and defending royal absolutism against Parliament, found some congenial elements in Hobbes's philosophy, but his bald head, white hair, and Puritan-like garb invited taunting. Charles himself called him the Bear, and as Hobbes neared, said, "Here comes the bear to be baited." Nonetheless, the witty king relished Hobbes's ready repartees. He had the old man's portrait painted, placed it in his private chambers, and gave him a pension of £100 a year. Though this was irregularly paid, it sufficed, with £50 a year from the Cavendish family, to meet the philosopher's simple needs. Aubrey describes him as sickly in youth, but healthy and vigorous in old age. He played tennis till he was 75. When a tennis court was not available, he took a daily walk long and brisk enough to give him a great sweat, and then he gave the servants some money to rub him. He ate and drank moderately. After 70, no meat and no wine. He bragged that he had been in excess in his life 100 times, but Aubrey calculated that as this came to little more than once a year, it was not egregious. He never married. He appears to have had an illegitimate daughter for whom he made generous provision. He read little in those later years, and was wont to say that if he had read as much as other men, he should have known no more than they. At night, when he was abed, and the doors made fast, and was sure nobody heard him, he sang aloud, not that he had a very good voice, but for his health's sake. He did believe it did his lungs good, and conduced much to prolong his life. However, as early as 1650, he had a shaking palsy in his hands, which grew so bad that by 1666 his writing became almost illegible. He continued to write nevertheless. Reverting from philosophy to mathematics, he slipped incautiously into controversy with an expert, John Wallis, who made short work of the old man's claim to square the circle. In 1670, aged 82, he published Behemoth, a history of the Civil War. He wrote several replies to his critics, and lovingly translated the Leviathan into Latin. In 1675, he composed an autobiography in verse, and rendered all the Iliad and the Odyssey into English rhymes, because there is nothing else for me to do. In that year, aged 87, he returned from London to the country, and spent the remainder of his life at the Cavendish estate in Derbyshire. Meanwhile, his palsy increased, and he suffered from strangury, painful difficulty in urination. When the current Earl moved from Chatsworth to Hardwicke Hall, Hobbes insisted on going with him. The trip proved exhausting. A week later, his paralysis spread, putting an end to his speech. On December 4th, 1679, having received the sacrament as an obedient Anglican, he died, 4 months short of completing his 92nd year. 6. Results. Hobbes's psychology was a masterpiece of deduction from inadequate premises. Logical as it seems at first view, its joints creak with loose assumptions that further inquiry might have corrected. Determinism is logical, but it may be determined by the mold of our logic, formed by dealing with things rather than ideas. Hobbes found difficulty in conceiving anything to be incorporeal. It seems equally difficult to conceive thought or consciousness as corporeal. Yet these are the only realities directly known to us. Everything else is hypothesis. Hobbes passed from object to sensation to idea without shedding much light upon the mysterious process whereby the apparently corporeal object generates the apparently incorporeal thought. Mechanistic psychology falters in the face of consciousness. Nevertheless, it was in psychology that Hobbes contributed most to our legacy. He cleared the field of some metaphysical ghosts like the scholastic faculties, though these could be readily interpreted not as separate mental entities but as aspects of mental activity. He established the more evident principles of association, but underestimated the role of purpose and attention in determining the selection, sequence, and persistence of ideas. He gave a helpful description of deliberation and volition. His analysis in defense of the passions was a brilliant summary, and it paid to Spinoza the debt that it owed to Descartes. From these psychological pages, Locke developed his more careful and detailed Essay Concerning Human Understanding. It was in answering Hobbes, rather than Filmer, that Locke evolved his treatises on government. Hobbes's political philosophy reformulated Machiavelli in terms of Charles I. It stemmed from the successful absolutism of Henry VIII and Elizabeth in England, and of Henry IV and Richelieu in France. And doubtless it took some warmth from ducal friends and royal refugees. In immediate effect, it seemed justified by the happy restoration of a Stuart king still claiming unlimited authority and ending in erosive anarchy. But some able Englishmen felt that if the consent of nasty and brutish savages sufficed to create a government, the consent of men in a presumably more advanced condition might rightly check or topple it. So in the glorious revolution of 1688, the philosophy of absolutism fell before the reassertion of Parliament, and was soon replaced by the liberalism of Locke, preaching the limitation and separation of powers. After a 19th century of relative democracy growing in an England guarded by the Channel, and in an America protected by the seas, a modified absolutism returned in totalitarian states exercising governmental control over life, property, industry, religion, education, publication, and thought. Invention transcended mountains and moats, frontiers vanished, national isolation and security disappeared. The absolutist polity is a child of war, and democracy is a luxury of peace. We do not know if Hobbes's state of nature ever existed. Perhaps social organization antedated man. The tribe preceded the state, and custom is older, wider, deeper than law. The family is the biological ground of an altruism that enlarges the ego and its loyalties. Hobbes's ethic might have been kindlier if he had brought up a family. To let the state define morality, though this too has passed into the totalitarian regimes, is to destroy one of the forces improving the state. The moral sense sometimes enlarges its area of cooperation or devotion, and then prods the law to widen its protection accordingly. In a distant future it may be possible for a state to be Christian, as was once that of Ashoka, who was a Buddhist. Hobbes's strongest influence was his materialism. From intellectual groups, Hobbesism flowed into the professional and business classes. The irate Bentley reported in 1693 that the taverns and coffee-houses, nay, Westminster Hall, meaning Parliament, and the very churches were full of it. Many men in the government privately accepted it, but publicly covered it with a conspicuous respect for the established church as a beneficent form of social control that only reckless fools would destroy. In France, the materialistic philosophy affected Bayle's skepticism and came to bolder developments in La Métrie, d'Holbach, and Diderot. Bayle ranked Hobbes as one of the greatest geniuses of the 17th century. Honored or denounced, he was recognized as the most powerful philosopher that England had produced since Bacon, and as the first Englishman to present a formal treatise on political theory. One clear debt we owe him. He formulated his philosophy in logical order and lucid prose. Reading him and Bacon and Locke, or Fontenelle and Bayle and Voltaire, we perceive again what the Germans had made us forget, that obscurity need not be the distinguishing mark of a philosopher, and that every art should accept the moral obligation to be intelligible or silent. 2. Harrington's Utopia. While Hobbes defended an ailing monarchy, James Harrington proposed a democratic utopia. Now that exploration and commerce were opening up remote areas of the globe, and legends came to Europe with any cargo from overseas, it was a simple matter for imaginative wordsmen to voyage in fancy to some happy corner of the map, or, like Cyrano de Bergerac and Tommaso Campanella, to the moon or the sun, whose political and social customs would shame the tyranny and misery of men under civilization. The cult of antiquity by the Renaissance gave way to a futuristic romance of more or less perfect states in distant and uncorrupted lands. So in 1656 Harrington offered his Oceana to the coffee houses of London. Born among the gentry, he naturally moved toward a political philosophy favoring the minor landlords of England. After leaving Oxford, he traveled widely on the continent, admired the Dutch Republic, served in the Dutch army, visited Venice, was impressed by its republican institutions, saw the Pope, refused to kiss the papal toe, and, returning to England, had all his sins forgiven when he explained to Charles I that he could not think of kissing the foot of a foreign prince after having kissed the hand of England's king. When Charles was arrested, Harrington was appointed by Parliament to attend him. He loved the unhappy prisoner, but explained to him the desirability of a republic. He accompanied Charles to the end, was on the scaffold at the execution, and, we are told, nearly died of grief. Comforted by the birth of the English Republic, he set himself to expound his republican ideas in fictional form. But while Harrington wrote, Cromwell changed the new republic into a semi-monarchical protectorate, and when the Commonwealth of Oceania was passing through the press, the protector ordered it suppressed. Cromwell's favorite daughter, Mrs. Claypool, interceded for the book. Harrington dedicated it to her father, and it saw the light in 1656. Oceania is England, as the author hoped that Cromwell would remake it. This book is continued on Cassette 9, Side 1. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant. Part 2, continued. Cassette 9, Side 1. Oceania is England, as the author hoped that Cromwell would remake it. He lays down a principle which, 2 centuries later, was expanded into the economic interpretation of history. Political supremacy, says Harrington, naturally and rightly follows economic supremacy. Only in that accord can a state enjoy stability. Such as is the proportion of property in land, such is the nature of the empire, that is, the government. If one man, as in Turkey, owns all the land, the government will be an absolute monarchy. If a few own it, the government will be a mixed monarchy, supported and limited by an aristocracy. And if the whole people be landlords, or hold the lands so divided among them that no one man or number of men overbalance them, the empire, without the imposition of force, is a commonwealth. To Hobbes, who thought that all government rests on force, Harrington answered that armies had to be fed and armed, so power goes to those who can raise the money to feed and arm them. A change in the form or direction of the government is merely an adjustment to a change in the distribution of property. On this basis, Harrington explained the victory of the Long Parliament, as representing the gentry, over the king as representing the major landowners. To prevent the government from being an oligarchy of large estates, Harrington proposed an equal agrarian law, limiting any one person to land yielding no more than £2,000 a year. Actual democracy requires a wide distribution of property, and the best democracy will be one in which every landowner has a turn in government. In the true English Republic, the citizens will send landowners to serve in a popular assembly and a senate. The Senate alone will propose laws, the Assembly alone will pass or reject them. The senators will nominate candidates for public office. From that list, the citizens will elect the magistrates by secret ballot. Each year, 1/3 of the assemblymen, the senators, and the magistrates will be replaced by other men in a new election. By this rotation, all landowners will ultimately have a term in the government. Popular election will protect the community against lawyers serving private interests, and against the clergy, those declared and inveterate enemies of popular power. There will be universal education in national schools and colleges, and complete freedom of religion. The doctrine was very taking, reported Aubrey, and soon found enthusiastic supporters. Harrington gathered some of these, including Aubrey, in a Rota Club in 1659, which agitated for parliamentary enactment of his Rotarian Republic. He ascribed the current collapse of the Commonwealth to its failure to confiscate the large estates and redistribute the land in smaller parcels among the people. That failure left the nobles still powerful and the people still poor and powerless. On the principle that property dictates government, the restoration of an oligarchic monarchy was inevitable unless Parliament voted the agrarian law. But, says Aubrey, the greatest part of the parliamentmen perfectly hated this design of rotation by balloting, for they were cursed tyrants and in love with their power. They preferred to recall Charles II. As Harrington continued to propagate his plan even after the Restoration, the king had him committed to the Tower on a charge of conspiracy in 1661. When efforts were made to free him by habeas corpus, he was transported to closer confinement on an island off Plymouth. There he fell into spells of insanity. He was released, but he never regained his health. His Utopia was more practical than most, and much of it has been realized. Perhaps one weakness lay in its assumption that land is the only form of wealth. Harrington mentioned the power of money in commerce and industry, but did not foresee its rise to political power. He may have felt that even commercial and industrial wealth is ultimately subject to owners of the land. The gradual extension of the franchise and the secrecy of the ballot were in line with his hopes, and though Britain rejected rotation in office as an annual dismemberment of experience, the United States accepted it in the periodical election of a part of Congress. And Locke, Montesquieu, and America approved his separation of governmental powers. Let not dreamers despair. Time may surprise them with fulfillments and turn their poetry into prose. 3. The Deists. As the religious wars injured religious belief in France, so the Civil War in England shared in generating theological doubts. Memories of the Puritan regime made irreligion popular among the triumphant royalists and made atheism ribald and boisterous at the Restoration Court. The first Earl of Shaftesbury, the second Duke of Buckingham, and the second Earl of Rochester were suspected of atheism, so later were Halifax and Bolingbroke. The extension of geographical, historical, and scientific knowledge widened the skeptical current. Every day some traveler or chronicler told of great nations whose religion and morals were shockingly different from the Christian, but usually as virtuous and seldom as homicidal. The mechanical view of the world encouraged by the pious Descartes and the apocalyptic Newton seemed to be pushing providence out of sight. The discovery of law in nature was making miracles indigestible. The slow triumph of Copernicus and the dramatic prosecution of Galileo contributed to the erosion of belief. The brave attempt of many Christian theologians to demonstrate the creed by reason weakened the creed. No one, said Anthony Collins, doubted the existence of God until the Boyle lectures undertook to prove it. The refutations of atheism attested its spread. Sir William Temple wrote in 1672 of those who would pass for wits by saying things which, David tells us, the fool hath said in his heart. In the same year, Sir Charles Wolseley remarked that irreligion in its practice hath been the companion of every age, but its open and public defense seems to be peculiar to this. According to Archdeacon Samuel Parker in 1681, the ignorant and unlearned among ourselves are become the greatest pretenders to skepticism and infidelity. Atheism and irreligion are at length become as common as vice and debauchery. Plebeians and mechanics have philosophized themselves into principles of impiety, and read their lectures of atheism in the streets and highways, and they are able to demonstrate out of the Leviathan that there is no God. Among the educated classes, doubt sought a compromise in Unitarianism, natural religion, and deism. The Unitarians questioned the equality of Christ with the Father, but they usually accepted the divine authority of the Bible. The advocates of natural religion preferred a faith independent of Scripture and limited to beliefs which they thought universal, in God and immortality. The Deists, who made their chief stir in England, required only a belief in God, whom they sometimes depersonalized into a synonym for nature, or the prime pusher of the Cartesian or Newtonian world machine. The word deist first came into prominence in 1677 through Archdeacon Edward Stillingfleet's Letter to a Deist. But the deistic literature had begun with Lord Herbert of Cherbury's De Veritate in 1624. Lord Herbert's disciple, Charles Blount, carried on with Anima Mundi in 1679. All organized religion, ran the argument, was the creation of impostors seeking political power or material gain. Heaven and hell were among their clever inventions to control and milk the populace. The soul dies with the body. Men and beasts are so alike that some authors are of opinion that man is nothing but an ape cultivated. In Great is Diana of the Ephesians, or The Origin of Idolatry, in 1680, Blount made priests themselves the tools of privileged classes that fattened on the patient labor and credulity of the people. With impish subtlety, he translated Philostratus's Life of Apollonius of Tyana, indicated the similarities between the miracles ascribed to the pagan wonder-worker and those attributed to Christians, and gently suggested their equal incredibility. In A Summary Account of the Deists' Religion in 1686, Blount proposed a religion free from all cult and ritual, and consisting only of the worship of God by a moral life. In the Oracles of Reason in 1693, he pointed out that the Christian theology was at first based upon the erroneous expectation of an early end to the world. He ridiculed the biblical stories of creation, of Eve's birth from Adam's rib, of original sin, of the stopping of the sun by Joshua, as childish absurdities, and suggested that to believe our modern earth, a blind and sordid particle of the universe, inferior to each of the fixed stars as well in bulk as in dignity, to be the heart, the most noble and vital part of so vast a body, is irrational and repugnant to the nature of things. An anonymous work uncertainly ascribed to Blount, Miracles, No Violations of the Laws of Nature, from 1683, tried to explain many miracle stories as honest misconceptions, by simple minds, of natural causes and events. The Bible, it added, was written to excite pious affections, not to teach physics, and it should be interpreted accordingly. Whatever is against nature is against reason, and whatever is against reason is absurd and should be rejected. Blount himself did not worship reason to the end, if we may believe the report that he killed himself in 1693 because English law would not let him marry his deceased wife's sister. John Toland continued the campaign. Born in Ireland, he was brought up as a Roman Catholic, but was converted to Protestantism in his youth. He studied at Glasgow, Leiden, and Oxford. At 26, he issued anonymously Christianity Not Mysterious in 1696, which he described as a treatise showing that there is nothing in the gospel contrary to reason nor above it. Accepting Locke's recent essay concerning human understanding as having proved the sense origin of all knowledge, he drew from it a thoroughgoing rationalism. We hold that reason is the only foundation of all our certitude, and that nothing revealed is more exempted from its disquisitions than the ordinary phenomena of nature. To believe the divinity of Scripture, or the sense of any passage thereof, without rational proof and an evident consistency, is a blamable credulity, ordinarily grounded upon an ignorant and willful disposition, but more generally maintained out of a gainful prospect. This was a declaration of war, but as Toland proceeded, he unveiled an olive branch by arguing that the basic doctrines of Christianity, excepting transubstantiation, are quite reasonable. Nevertheless, his challenge was not ignored. The grand juries of Middlesex and Dublin joined hands across the Irish Sea to condemn the book. It was officially burned before the doors of the Irish Parliament, and Toland was sentenced to jail. He escaped to England, but unable to secure employment there, he migrated to the continent. For a time he found welcome with Electress Sophia of Hanover and her daughter Sophia Charlotte, Queen of Prussia. To the latter he addressed letters to Serena in 1704. One of these tried to trace the origin and growth of the belief in immortality. This was among the first attempts at a natural history of supernatural beliefs. Another letter disputed the view that matter is by itself inert and motionless. Motion, said Toland, is inherent in matter, and no body is in absolute rest. All objective phenomena are the motions of matter, including the actions of animals, and this might be true of man as well. Here, however, Toland checked himself. Such thoughts should not be publicly expressed, for the uneducated multitude must be left in undisturbed orthodoxy as a means of moral and social control. Free thinking should be the duty and the exclusive privilege of the educated minority. Among these there should be no censorship. Let all men freely speak what they think, without being ever branded or punished, but for wicked practices. The terms freethinker and pantheist were apparently coined by Toland. His essay Nazarenus in 1718 suggested that Christ had not intended to separate his followers from Judaism, and that the Jewish Christians who continued to observe the Mosaic law represented the true original plan of Christianity. A pamphlet, Pantheisticus, expounded the creed and ritual of an imaginary secret society. Perhaps Toland was a member of the Mother Grand Lodge of Freemasonry, which was established in London in 1717. The society described by Toland rejected all supernatural revelations, proposed a new religion agreeing with philosophy, identified God with the universe, and replaced the saints of the Christian calendar with the heroes of liberty and thought. The society allowed its members to conform to the popular worship, so long as, through their political influence, they could render fanaticism harmless. After a fitful and varied career, Toland retired to a life of poverty in England, kept from starvation by Lord Molesworth and the philosopher Shaftesbury. He bore up stoutly under the storm of refutations, 54 in 60 years, that fell upon his books. He claimed that philosophy had granted him perfect tranquility and had freed him from the terrors of death. Attacked by an incurable disease at the age of 52 in 1722, he composed his own proud epitaph. Here lies John Toland, who was born near Londonderry. He cultivated the various literatures and was acquainted with more than 10 languages. The champion of truth, the defender of liberty, he bound himself to no man. On no man did he fawn. Neither threats nor misfortunes deterred him from his appointed course, which he pursued to the very end, subordinating his own interest to the pursuit of the good. His soul is united with the Heavenly Father, from whom he first proceeded. Beyond all doubt he will live again unto all eternity, yet never will there be another Toland. For the rest, consult his writings. Anthony Collins took up the deist cause with more skill and modesty. He had the advantages of money, a house in the country, a house in the town. He could not be refuted by starvation. He was a man of fine manners and irreproachable character. Locke, who knew him well, wrote to him, "To love truth for truth's sake is the principal part of human perfection in this world, and the seed plot of all other virtues. And if I mistake not, you have as much of it as ever I met with in anybody." Collins's Discourse of Freethinking in 1713 was the ablest exposition that deism received in this age. He defined freethinking as the use of the understanding in endeavoring to find out the meaning of any proposition whatsoever, in considering the nature of the evidence for or against it, and in judging of it according to the seeming force or weakness of the evidence. There is no other way to discover the truth. The diversity of creeds and the contradictory interpretations of biblical passages compel us to accept the judgment of reason. To what other court can we turn, unless it be to the arbitrament of force? How, except by evidence and reasoning, can we decide which books of the Bible are to be accepted as authentic, and which should be set aside as apocryphal? Collins quotes a divine as estimating at 30,000 the number of different readings proposed by scholars for the text of the New Testament alone, and he refers to Richard Simon's textual criticism of the Scriptures. He tries to answer the objections that cautious men advanced against free thought, that most people have not the capacity to think both freely and harmlessly about fundamental problems, that such freedom would lead to endless divisions of opinion and sects, and therefore to disorders in society, that free thinking may conduce to atheism in religion and libertinism in morals. He gives ancient Greece and modern Turkey as examples of social order maintained despite freedom of opinion or diversity of faiths. He denies that free thinking makes for atheism. He quotes and supports Bacon's aphorism about a little thought inclining us to atheism and more thought turning us away from it. Ignorance, he adds with apparent sincerity, is the foundation of atheism and free thinking the cure for it. He lists free thinkers who were the most virtuous people in all ages: Socrates, Plato, Aristotle, Epicurus, Plutarch, Varro, Cato Censor, Cato of Utica, Cicero, Seneca, Solomon, the prophets, Origen, Erasmus, Montaigne, Bacon, Hobbes, Milton, Tillotson, Locke. Here and in Toland we have a model for Comte's calendar of positivist saints. And, Collins suggests, another list could be made of those foes of free thought who disgraced humanity with barbarous cruelties under the pretext of glorifying God. So many replies rained down upon him from pulpits and universities that Collins thought discretion required travel. His stay in Holland may have left upon him some influence from Spinoza and Bayle. Returning to England, he raised another storm with an Inquiry Concerning Human Liberty in 1715, which stated with clarity and force the case for determinism. Collins found himself a free-thinker slave to an unfree will. 9 years later, he set the theological air astir by a discourse on the grounds and reason of the Christian religion. He quoted the Apostles and Pascal as basing their demonstration of Christianity on Old Testament prophecies which the new dispensation had seemingly fulfilled, and he argued that these predictions had no reference to Christianity or Christ. 35 theologians answered him in 35 tracts. The controversy was still alive when Voltaire reached England in 1726. He enjoyed it mischievously and imported it into France, where it entered into the skeptical Enlightenment. The deistic movement was continued in England by William Whiston, Matthew Tyndall, Thomas Chubb, and Conyers Middleton, and passed down through Bolingbroke and the philosopher Shaftesbury to Gibbon and Hume. It became unpopular with the ruling classes when they suspected it of encouraging democratic ideas, but its immediate influence was felt in a temporary decline of religious belief. In 1711, an official report on the subject was drawn up for the Upper House of Convocation of the English clergy in the province of Canterbury. It described a wide spread of unbelief and profanity, denials of biblical inspiration, rejection of miracles as fables, ridicule of the doctrine of the Trinity, doubts of immortality, and much decrying of priests as impostors. By the beginning of the 18th century in England, religion had sunk to deism. It was in this crisis that some of the ablest minds in Britain rose vigorously to the defense of Christianity. 4. Defenders of the faith. Most of them were willing to meet their assailants on the grounds of reason, scholarship, and history. This in itself betrayed the spirit of the age. Charles Leslie led the defense with a short and easy method with the Deists in 1697, intended originally as a reply to Blunt. The evidences for the biblical narratives, he argued, were of the same nature and as convincing as for the careers of Alexander and Caesar. The miracles were attested by testimony as plentiful and reliable as that which is accepted as adequate in English courts. Priests could never have persuaded peoples of such miracles as the parting of the Red Sea unless many eyewitnesses had corroborated them. Leslie rounded out his argument by portraying Judaism as a primitive covenant superseded by the coming of Christ, Mohammedanism as an ungrateful imitation of Christianity by an ambitious impostor, and paganism as a mass of fables too childish for rational belief. Only the Christian religion met all the tests of evidence and reason. Samuel Clarke, who knew enough mathematics and physics to defend Newton against Leibniz, undertook to prove the Christian creed by demonstrations as rigorous as geometry. In his Boyle Lectures of 1704, he forged a chain of 12 propositions which, in his judgment, established the existence, omnipresence, omnipotence, omniscience, and benevolence of God. The chain of contingent or dependent beings and causes, he supposed, compels us to assume a necessary and independent being, who is the first cause of all causes. God must have intelligence, for there is intelligence in created beings, and the Creator must be more perfect than the creature. God must be free, for otherwise his intelligence would be a senseless slavery. This, of course, added nothing to ancient or medieval philosophy, but in the second series of his Boyle Lectures, Clarke proposed to prove the truth and certainty of the Christian revelation. Moral principles, he thought, are as absolute as the laws of nature. Man's depraved nature, however, can be led to obey these moral rules only through the inculcation of religious beliefs. Hence it was necessary that God give us the Bible and the doctrines of heaven and hell. History, with its usual humor, adds that Clarke was dismissed by Queen Anne as her chaplain because he was suspected of doubting the Trinity. In the next reign, according to the impish Voltaire, he was prevented from becoming Archbishop of Canterbury because a bishop informed Princess Caroline that Clarke was the most learned man in England, but had one defect: he was not a Christian. The still more learned Bentley had already demonstrated the folly and unreasonableness of atheism in the Boyle Lectures of 1692-93. 20 years later, he was aroused by Collins's book to issue some Remarks on a Late Discourse of Freethinking. This chiefly consisted of exposing errors in Collins's scholarship. The argument seemed overwhelming, and the Senate of Cambridge University gave Bentley a unanimous vote of thanks. Jonathan Swift, who was then serving the deist Bolingbroke, thought that Collins, for having revealed a secret that all gentlemen kept to themselves, deserved additional chastisement. This he administered in a tract called Mr. Collins's Discourse of Freethinking put into plain English for the use of the poor. He burlesqued Collins's arguments by humorous exaggerations. He added that since most men are fools, it would be disastrous to leave them free to think. The bulk of mankind is as well qualified for flying as for thinking, which is now a more hopeful statement than Swift intended it to be. He agreed with Hobbes that dictatorship, even in spiritualibus, is the sole alternative to anarchy. We have seen that the Irish Anglicans thought the gloomy dean would make an excellent prelate if he believed in God. The Cambridge Platonists defended Christianity with less wit and more sincerity. They went back to Plato and Plotinus to find a bridge between reason and God, and they illustrated their faith not so much by arguments as by the integrity and devotion of their lives. They had so strong a sense of divinity surrounding them that this seemed to them the most immediate testimony of reason. Hence their first leader, Benjamin Whichcote, claimed that reason is the voice of God. Henry More, the outstanding member of this once famous group, went beyond the philosophies of Europe to an almost Hindu sense of the vanity, the literal emptiness of sense knowledge, its incapacity to satisfy the longing of the solitary soul for some companionship and significance in the universe. The cosmic mechanism of Descartes gave him no comfort. He found more to his needs in the Neoplatonists, the Jewish mystics, and Jacob Boehme. He wondered whether the knowledge of things was really that supreme felicity of man, or something greater and more divine was, or, supposing it to be so, whether it was to be acquired by such an eagerness or intentness in the reading of authors or contemplating of things, or by the purging of the mind from all sorts of vices whatsoever. He resolved to cleanse himself of all self-seeking, all worldliness, all intellectual curiosity. When this inordinate desire after the knowledge of things was thus allayed in me, and I aspired after nothing but this soul purity and simplicity of mind, there shone in upon me daily a greater assurance than ever I could have expected, even of those things which before I had the greatest desire to know. Gradually, he tells us, he so purified himself in body and soul that his flesh, in the spring season, gave forth a sweet odor, and his urine had the fragrance of violets. So cleansed, he seemed to feel the reality of spirit in himself as the most convincing experience possible to man, and from this conviction he passed readily to the belief that the world was peopled by other spirits, of ascending grades, from the lowest to God himself. All motion in matter, he thought, is the operation of some species of spirit. Instead of the material plenum of Hobbes, More proposed a spiritual universe in which matter was merely the tool and vehicle of spirit. This animating anima occasionally expanded beyond its habitation. How else explain magnetism, electricity, and gravity? More went on to accept the reality of devils, witches, and ghosts. He was an amiable and unselfish soul, refusing the worldly preferments offered him and remaining on friendly terms with materialist Hobbes. Hobbes said that if he ever found his own opinions untenable, he would embrace the philosophy of Dr. More. Ralph Cudworth, the most learned of the Cambridge Platonists, undertook to prove Hobbes's opinions untenable. The true intellectual system of the universe, in 1678, challenged Hobbes to explain why, in addition to the various sensory and muscular motions to which he had reduced the operations of the mind, there is also in many cases an awareness of these motions. How can a materialist philosophy find room and function for consciousness? If all is matter in motion, why should not the nervous system, through sensation and response, as in reflexes, attend to everything and not be bothered with a superfluous consciousness? How can we deny reality, even primacy, to a consciousness without which no reality whatever could be known? Knowledge is no passive receptacle of sensations. It is the active transformation of sensations into ideas. Here in Cudworth we have, long in advance, the answer of Berkeley and Kant to Hobbes and Hume. Joseph Glanville, chaplain to Charles II, was not geographically one of the Cambridge Platonists, but he strongly agreed with them. In The Vanity of Dogmatizing in 1661, he turned the guilt of dogmatism upon science and philosophy, arguing that they had built up grandiose systems of doctrine upon insecure foundations. So the notion of cause, which Glanville supposed indispensable to science, is an unwarrantable assumption. We know sequences, relations, and occasions, but we have no idea of what it is in one thing that produces an effect in itself or another. Another premonition of Hume. Consider, says Glanville, how ignorant we are of the most basic things, the nature and origin of the soul and its relation to the body. How should a thought be united to a lump of clay? The freezing of the words in the air in northern climes is as inconceivable as this strange union. And to hang weights on the wings of the wind seems far more intelligible. Anticipating Bergson, Glanville charges the intellect with being a constitutional materialist, so used to dealing with matter that it loses capacity to think of other realities except by a return to material phantasms or images. How fallible our senses are! They make it appear that the earth is at rest in space, whereas the latest pundits assure us that it is dizzy with a variety of simultaneous motions. And even supposing that our senses have not deceived us, how often do we reason wrongly from correct premises? Our feelings time and again mislead us. We easily believe what we wish, and our mental environment often dominates our reasoning. Opinions have their climes and national diversities. They that never peeped beyond the common belief in which their easy understandings were at first indoctrinated are indubitably assured of the truth and comparative excellency of their receptions. The larger souls that have traveled the diverse climates of opinion, here is born a famous phrase, are more cautious in their resolves and more sparing to determine. Despite these warnings to science, Glanville was a zealous member of the Royal Society, defended it against charges of irreligion, applauded its achievements, and looked forward to a world of marvels to come from scientific research. I doubt not but posterity will find many things that are now but rumors verified into practical realities. It may be, some ages hence, a voyage to the southern unknown tracts, yea, possibly to the moon, will not be more strange than one to America. To them that come after us it may be as ordinary to buy a pair of wings to fly into remotest regions as now a pair of boots to ride a journey. And to confer at the distance of the Indies by sympathetic conveyances may be as usual to future times as to us in a literary correspondence. The restoration of gray hairs to juvenility and renewing the exhausted marrow may at length be effected without a miracle, and the turning of the now comparatively desert world into a paradise may not improbably be expected from late agriculture. We must add that Glanville, like Cudworth and Henry Moore, believed in witches. They argued that if there is a spiritual as well as a material world, there must be spirits as well as bodies in the universe. And judging from the parlous state of things, some of these spirits must be devilish. If pious people communicate with God or saints or angels, why should not wicked people communicate with Satan and his demons? The devil's last stratagem, said Glanville, is to spread the belief that he does not exist. Those that dare not bluntly say there is no God content themselves, for a fair step and introduction, to deny that there are spirits and witches. Satan had to be rescued for God's sake. 5. John Locke, 1632 to 1704. 1. Biography. The most influential philosopher of this age was born at Rington, near Bristol, in the same year as Spinoza. He grew up in an England that made a bloody revolution and killed its king. He became the voice of a peaceful revolution and an age of moderation and tolerance, and represented English compromise at its sanest and best. His father was a Puritan attorney who, at some sacrifice, supported the parliamentary cause and expounded to his son the doctrines of popular sovereignty and representative government. Locke remained faithful to these lessons and grateful for the paternal discipline that trained him to sobriety, simplicity, and industry. Lady Masham said of Locke's father that he used a conduct towards him when young that he, the son, often spoke of afterwards with great approbation. It was the being severe to him by keeping him in much awe and at a distance when he was a boy, but relaxing still by degrees of that severity as he grew up to be a man, till he being become capable of it, he lived perfectly with him as a friend. Locke bore no similar gratitude toward his teachers. At Westminster School he was choked with Latin, Greek, Hebrew, and Arabic, and was probably not allowed to witness the execution of Charles I in 1649 in nearby Whitehall Palace Yard. But that event left a mark on his philosophy. The turmoil of the Civil War delayed his entry into Christ College, Oxford, till he was 20 years old. There he studied Aristotle as dressed in Latin scholastic form. more Greek, some geometry and rhetoric, much logic and ethics, most of which he later disgorged as antiquated in substance and indigestible in form. After taking his master's degree in 1658, he remained at Oxford as a don, tutoring and lecturing. He had a love affair which for a time robbed me of the use of my reason. He regained his reason and lost the lady. Like nearly all the philosophers in this period, Malebranche, Bayle, Fontenelle, Hobbes, Spinoza, Leibniz, he never married. He was advised to enter the ministry, but he demurred at being lifted into a place which perhaps I cannot fill, and from whence there is no descending without tumbling. In 1661, his father died of tuberculosis, leaving him with a small fortune and weak lungs. He studied medicine, but did not take the medical degree till 1674. Meanwhile, he read Descartes and felt the fascination of philosophy when it spoke intelligibly. He helped Robert Boyle in laboratory experiments and acquired an admiration for scientific method. In 1667, he received an invitation to come and live at Exeter House as personal physician to Anthony Ashley Cooper, soon to be the first Earl of Shaftesbury, member of the Cabal Ministry under Charles II. From that time onward, though keeping Oxford as his legal home till 1683, Locke found himself in the stream of English politics, whose events and figures molded his thought. As physician, he saved Shaftesbury's life by a skillful operation for tumor in 1668. He helped to negotiate the marriage of the Earl's son, attended the daughter-in-law in her confinement, and directed the education of the grandson, his successor in philosophy. Mr. Locke, recalled this third Earl of Shaftesbury, grew so much in esteem with my grandfather that, as great a man as he experienced him in physic, he looked upon this as but his least part. He encouraged him to turn his thoughts another way, nor would he suffer him to practice physic except in his own family and as a kindness to some particular friend. He put him upon the study of the religious and civil affairs of the nation, with whatsoever related to the business of a minister of state, in which he was so successful that my grandfather began to use him as a friend and consult with him on all occasions of that kind. For 2 years, from 1673 to 75, Locke served as secretary to the Council of Trade and Plantations, colonies, of which Shaftesbury was president. He helped Shaftesbury to draft a constitution for Carolina, of which the Earl was a founder and a chief proprietor. These fundamental institutions were not generally carried out in the colony, but the freedom of conscience provided in them was largely accepted by the new settlement. When Shaftesbury fell from office in 1675, Locke traveled and studied in France. There he met François Bernier, who introduced him to the philosophy of Gassendi. Therein he found a reasoned rejection of innate ideas, the comparison of the unborn child's mind to a tabula rasa, or clean slate, and the key sentence that was to be later bandied across the Channel: "There is nothing in the mind except what was first in the senses." Locke returned to London and Shaftesbury in 1679, but as the Earl ventured closer and closer to revolution, Locke retired to Oxford in 1680 and resumed the life of a scholar. Shaftesbury's arrest, escape, and flight to Holland cast royal suspicion upon his friends. Spies were sent to Oxford to catch Locke in remarks that might serve as a basis for prosecuting him. Feeling insecure and foreseeing the accession of his enemy James II, Locke too sought refuge in Holland in 1683. The abortive revolution of the Duke of Monmouth in 1685 provoked James to demand from the Dutch government the extradition of 85 Englishmen on the charge that they had shared in the plot to overthrow the new king. Locke was named among them. He hid and took a false name. A year later, James sent him an offer of pardon, but Locke preferred to remain in Holland. Living in Utrecht, Amsterdam, and Rotterdam, he enjoyed the friendship not only of English refugees, but of Dutch scholars like Jean Leclerc and Philip van Limburg, both of them leaders in the liberal Arminian theology. In that environment, Locke found much encouragement for his ideas of popular sovereignty and religious freedom. There he wrote his Essay Concerning Human Understanding and the first drafts of his treatises on education and toleration. In 1687 he joined in the plot to replace James II with William III on the throne of England. When the expedition of the stadtholder succeeded in this enterprise, Locke sailed to England in 1689 on the same vessel that carried the future Queen Mary. Before leaving Holland, he wrote to Limburg in Latin a letter whose warmth of sentiment may correct the supposition that his habitual moderation stemmed from coldness of character. "In going away, I almost feel as though I were leaving my own country and my own kinsfolk. For everything that belongs to kinship, goodwill, love, kindness, everything that binds men together with ties stronger than that of blood, I have found among you in abundance. I leave behind me friends whom I can never forget, and I shall never cease to wish for an opportunity of coming back to enjoy once more the genuine fellowship of men who have been such friends that, while far away from my own connections, while suffering in every other way, I have never felt sick at heart. As for you, best, dearest, and most worthy of men, when I think of your learning, your wisdom, your kindness and candor and gentleness, I seem to have found in your friendship alone enough to make me always rejoice that I was forced to pass so many years amongst you. In an England governed by his friends, Locke passed through a succession of official employments. In 1690 he was a Commissioner of Appeals. In 1696 to 1700 he was a Commissioner of Trade and Plantations. He was intimate with John Somers, Attorney General, with Charles Montague, 1st Earl of Halifax, and with Isaac Newton, whom he aided in reforming the coinage. After 1691 he lived most of the time at Oates Manor in Essex with Sir Francis Masham and his wife, Lady Damaris Masham, a daughter of Ralph Cudworth. He remained in that quiet haven, writing and rewriting till his death. 2. Government and Property. When he came back from exile, he was already 56 years old. So far he had published only some minor articles and a French epitome of his essay in Leclerc's Bibliothèque Universelle in 1688. He was not yet known as a philosopher except to a few friends. Then, all in one annus mirabilis, he sent to the press 3 works that made him a major figure in European thought. In March 1689, his Epistola de Tolerantia appeared in Holland. It was translated into English in the fall, and it was followed in 1690 by a second letter concerning toleration. In February 1690 he issued his 2 treatises on government, the cornerstone of modern democratic theory in England and America, and a month later the Essay Concerning Human Understanding, the most influential book in modern psychology. Though this had been completed before he left Holland, he preceded it in print by the Treatises on Government because he was anxious to provide a philosophical basis for the glorious revolution of 1688-89. This purpose was frankly stated in the preface to the first treatise: to establish the throne of our great restorer, our present William III, to make good his title in the consent of the people, and to justify to the world the people of England, whose love of their just and natural rights, with their resolution to preserve them, saved the nation when it was on the brink of slavery and ruin. The first and lesser treatise undertook to answer the Patriarcha, or the natural power of kings asserted, which Sir Robert Filmer had written about 1642 to uphold the divine right of Charles I, but which had only recently, in 1680, reached print in the heyday of Charles II's triumphant absolutism. It was not the best of Sir Robert's writings. He published anonymously in 1648 The Anarchy of a Limited Mixed Monarchy, anticipating Hobbes's views. Though he suffered imprisonment for his defense of a losing cause, he defended it again in Observations upon Aristotle's Politics, published anonymously in 1652, a year before the author's death. Filmer presented government as an extension of the family. God conferred sovereignty over the first human family upon Adam, from whom it descended to the patriarchs. Those who, like Filmer's opponents, believe in the divine inspiration of the Bible must admit that the patriarchal family and the power of the patriarch were sanctioned by God. From the patriarchs this sovereignty passed to kings. The early kings were patriarchs, and their authority was a form and derivative of parental rule. Monarchy, therefore, goes back to Adam, and so to God. Its sovereignty, except when it commands an explicit violation of God's law, is divine and absolute, and rebellion against it is a sin as well as a crime. Against the theory that man is born free, Filmer points out that man is born subject to the customs and laws of the group, and to the natural and legal rights of parents over their children. Natural freedom is a romantic myth. It is also a myth that government was originally established by the consent and agreement of the people. Representative government is another myth. Actually, the representative is chosen by a small and active minority in each constituency. All government is of a majority by a minority. It is in the nature of government to be above the laws, for by definition a legislature is empowered to make and unmake laws. We do but flatter ourselves if we hope ever to be governed without an arbitrary power. If government is to depend upon the will of the governed, there will soon be no government, for every individual or group will claim the right to rebel according to conscience. That would be anarchy or mob rule, and there is no tyranny to be compared to the tyranny of the multitude. Locke felt that his first task as defender of the glorious revolution was to dispose of Filmer's arguments. He thought there was never so much glib nonsense put together in well-sounding English as in Sir Robert's discourses. I should not speak so plainly of a gentleman long since past answering, had not the pulpit of late years publicly owned his doctrine and made it the current divinity of the times. That is, had not the Anglican clergy upheld the divine right of kings even under Catholic James II. Locke proceeded with playful, sometimes ungracious sarcasm to question Filmer's derivation of royal authority from the supposed sovereignty of Adam and the patriarchs. We need not follow him in his long biblical refutation. Today we rationalize our political prejudices by other than scriptural means. Something of Filmer remains after Locke's rough handling of him, the attempt, however mistaken in detail, to illuminate the nature of government by seeking its origins in history, even in biology. Probably both Filmer and Locke underestimated the role of conquest and force in the establishment of states. In the second treatise of civil government, Locke turned to the task of finding for the rule of William III in England some more defensible basis than a divine right that would unfortunately return the power to James II. This book is continued at this point on the other side of this cassette. Please reverse or turn the cassette over now. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant, Part 2, continued. Cassette 9, Side 2. In the second treatise of civil government, Locke turned to the task of finding for the rule of William III in England some more defensible basis than a divine right that would unfortunately return the power to James II. In deriving William's title from the consent of the governed, he assumed more than he could historically prove. The people had not given their consent to William's conquest of England, and the aristocrats who had maneuvered it had thought not of securing popular consent, but only of avoiding public resistance. Nevertheless, in building a philosophical prop for William's power, Locke raised an impressive defense of popular sovereignty. While defending a monarch, he developed the theory of representative government, and while offering a rationale to the Whigs and the defenders of property, he formulated the gospel of political liberty. He ended, in English political philosophy, the ascendancy of Hobbes. He followed Hobbes in assuming a primitive state of nature before the rise of states. Like Hobbes and Filmer, he fashioned history to his purpose, but unlike Hobbes, he imagined that individuals in the state of nature were free and equal. He used this word as Jefferson was to use it in following him, to mean that no man had by nature more rights than any other. And he allows to man in the natural condition certain social instincts as a psychological preparation for society. Occasionally Locke makes some amiable assumptions. Every man being naturally free, and nothing being able to put him into subjection to any earthly power without his consent. The state of nature, in this theory, was not a Hobbesian war of each against all, for the law of nature supported the rights of men as reasoning animals. By reason, Locke supposed, men came to an agreement, made a social contract with one another, to surrender their individual rights of judging and punishing, not to a king, but to the community as a whole. Hence the community is the real sovereign. By its majority vote it selects a chief administrator to implement its will. He may be called king, but like any other citizen he is bound to obey the laws enacted by the community. If, like James II, he seeks to violate or circumvent them, the community has the right to withdraw from him the authority which it has conferred. Locke was really defending not William against James, but the now victorious Parliament against any king. The highest power in a state should be the legislature. It should be chosen by the unpurchased vote of the people, and the laws should punish severely any attempt to buy the vote of a citizen or a legislator. Locke did not foresee that his admired William III would be forced to buy the vote of MPs, and that powerful families would continue for yet 140 years to control and dispose of the vote of rotten boroughs. The functions of the legislature should be strictly separate from those of the executive, and each of these branches of the government should serve as a check upon the other. Government, said Locke, has no other end but the preservation of property. There had once been a primitive communism when food grew without planting and men could live without toil. But when labor began, communism ended, for a man naturally claimed as his separate property anything whose value had been created by his work. Labor, then, is the source of 99/100ths of all physical values. Here, quite without intending it, Locke offered one of its basic tenets to modern socialism. Civilization grows through labor, and therefore through the institution of property as the product of labor. Theoretically, no man should have more property than he can use. But the invention of money enabled him to sell such surplus product of his labor as he could not utilize, and in this way there developed a great inequality of possessions among men. We might have expected at this point some criticism of the concentration of wealth. Instead, Locke looked upon property, however unequally distributed, as natural and sacred. The continuance of social order and civilization requires that the protection of property shall be the paramount purpose of the state. The supreme power cannot take from any man part of his property without his consent. On this basis, Locke could not admit any revolution involving the expropriation of property, but as the prophet and voice of the glorious revolution, he could not deny the right to overthrow a government. The people are absolved from obedience when illegal attempts are made upon their liberties or properties, for the end of government is the good of mankind. And which is best for mankind? That the people should be always exposed to the boundless will of tyranny, or that the rulers should be sometimes liable to be opposed when they grow exorbitant in the use of their power, and employ it for the destruction and not the preservation of the properties of the people? Whereas some Huguenot and some Jesuit philosophers had sanctioned revolution to protect the one true religion, Locke sanctions it only to protect property. Secularization was changing the locus and definition of sanctity. Locke's influence on political thought remained supreme till Karl Marx. His philosophy of the state was so well suited to the Whig ascendancy and the English character that for a century its faults were ignored as trivial blemishes on a magnificent Magna Carta of the bourgeoisie. It provided a halo not only to 1689, but, by remarkable anticipation, to 1776 and 1789, that is, to the three stages in the revolt of business against birth, of money against land. Today, critics smile at Locke's derivation of government from the consent of free men in a state of nature, just as he smiled at Filmer's derivation of it from the patriarchs, Adam and God. Natural rights are suspect and theoretical. In a lawless society, the only natural right is superior might, as now among states. And in civilization, a right is a liberty desired by the individual and not injurious to the group. Rule by the majority may exist in small communities on less than vital concerns. Usually, rule is by an organized minority. Governments now recognize greater obligations than the protection of property. Nevertheless, the achievement of that second treatise remains immense. It broadened the victory of Parliament and the Whigs over the monarchy and the Tories into a theory of representative and responsible government that inspired one people after another in its climb to liberty. England rejected Locke's separation of powers and subordinated all government to the legislature, but his doctrine had aimed to check the executive, and that aim was completely achieved. Much of his trust in human reasonableness and decency, and his moderation in applying theory to practice, became standard procedure in English politics, making revolution imperceptible while real. From England, the ideas of Locke passed to France with Voltaire in 1729. They were taken up by Montesquieu on his visit to England in 1729-31. They found voice in Rousseau and others before and during the French Revolution, and appeared in full blast in the Constituent Assembly's Declaration of the Rights of Man in 1789. When the American colonists rebelled against the resurgent monarchy of George III, they adopted the ideas, the formulas, almost the words of Locke to express their Declaration of Independence. The rights that Locke had vindicated became the Bill of Rights in the first 10 amendments to the American Constitution. His separation of governmental powers, as extended to the judiciary by Montesquieu, became a living factor in the American form of government. His solicitude for property passed into American legislation. His essays on toleration influenced the Founding Fathers in separating church from state and decreeing religious liberty. Rarely in the history of political philosophy has one man had such lasting influence. 3. Mind and Matter. Locke's influence was as extensive and profound in psychology as in the theory of government. He had been writing the Essay Concerning Human Understanding since 1670. Characteristically, he sent it to the printer only after 20 years of revision. And then, for this masterpiece of psychological analysis, he received £30. He himself ascribed the inception of the essay to a conversation in London in 1670. 5 or 6 friends meeting at my chamber and discoursing on a subject very remote from this found themselves quickly at a stand by the difficulties that rose on every side. After we had a while puzzled ourselves, without coming any nearer a solution of those doubts, it came into my thoughts that we took a wrong course, and that before we set ourselves upon inquiries of that nature, it was necessary to examine our own abilities and see what objects our understandings were or were not fitted to deal with. This I proposed to the company, who all readily assented, and thereupon it was agreed that this should be our first inquiry. Some hasty and undigested thoughts, which I set down against our next meeting, gave the first entrance into this discourse. Apparently the stimulus to the essay was the contention of the Cambridge Platonists, who here followed the scholastic philosophers, that we derive our ideas of God and morality not from experience, but from introspection, and that these ideas are innate with us, part of our mental equipment, however unconscious, at our birth. This view, rather than Descartes' incidental statements on innate ideas, led Locke to consider whether there were any ideas whatever that were not the result of impressions from the external world. Locke came to the conclusion that all knowledge, including our ideas of God and right and wrong, is derived from our experience and is not part of the inborn structure of the mind. He knew that in arguing for this empirical position he would offend many of his contemporaries, who felt that morality required the support of religion, and that both morality and religion would be weakened if their basic ideas had any less noble origin than God himself. He asked his readers to be patient with him, and for his own part he approached the dangerous discussion in a spirit of modest uncertainty. "I pretend not to teach, but to inquire." He spoke quietly, moderately, leisurely, and he confessed that he was too lazy and too busy to be brief. But at least he would define his terms. He protests against the affected obscurity of some philosophers. The knowing precisely what our words stand for would in many cases end the dispute. It must be allowed that Locke's teaching in this particular is better than his practice. He defines understanding as the power of perception, but he uses perception to include 1. The perception of ideas in our minds, 2. The perception of the signification of signs, or words, and 3. The perception of the agreement or disagreement between ideas. But what is idea? Locke uses the term to mean 1. The impress of external objects upon our senses, what we should call sensation, or 2. The internal awareness of this impress, what we should call perception, or 3. The image or memory connected with the idea, what we should call idea, or 4. The notion that combines many individual images into a general or abstract or universal concept of a class of similar objects. Locke does not always make clear in which sense he uses this troublesome term. He begins by rejecting innate principles. It is an established opinion amongst some men that there are in the understanding certain innate principles, some primary notions stamped upon the mind of man, which the soul receives in its very first being and brings into the world with it. He proposes to show the falseness of this supposition. He does not deny innate tendencies, what were later called tropisms, reflexes, or instincts, but these, in his view, are physiological habits, not ideas. Following Hobbes, he describes such processes as trains of motion in the animal spirits, which, once set going, continue in the steps they have been used to, which, by often treading, are worn into a smooth path, and the motion in it becomes easy, and, as it were, natural, or inborn. He is inclined to reduce the associations of ideas to such physiological paths. Descartes had supposed that the idea of God is innate in us. Locke denies this. Some tribes have been found without it, and those that profess it have such different conceptions and images of the deity that it is wiser to reject the notion of innateness and rest our belief in God upon the visible marks of extraordinary wisdom and power in all the works of creation, that is, upon experience. Likewise, there are no innate practical principles, no inborn conceptions of right and wrong. History shows so great, sometimes so contradictory a variety of moral judgments that they cannot be a part of man's natural inheritance. They are a social inheritance, differing from place to place and from time to time. Having disposed of innate ideas, Locke proceeds to inquire how ideas are generated. Let us then suppose the mind at birth to be, as we say, white paper, void of all characters, without any ideas. How comes it to be furnished? To this we answer in one word, from experience. In that all our knowledge is founded, and from that it ultimately derives itself. All ideas are derived either from sensation or from reflection on the products of sensation. Sensations themselves are physical. Their mental result is perception, which is the first faculty of the mind. Locke saw no reason to doubt that we can have true or valid knowledge of the external world, but he accepted the long-established distinction between the primary and secondary qualities of objects perceived. Primary qualities are such as are utterly inseparable from the body, in what state soever it be. Solidity, extension, figure, number, and motion or rest. Secondary qualities are nothing in the objects themselves but powers to produce various sensations in us by their primary qualities. So colors, sounds, tastes, and odors are secondary qualities produced in us by the bulk, figure, texture, or motion of objects. The objects themselves have no color, weight, taste, smell, sound, or warmth. This distinction, as old as Albertus Magnus and Thomas Aquinas, had been accepted by Descartes, Galileo, Hobbes, Boyle, and Newton. Locke's exposition and emphasis gave it new and wider currency. Theoretically, the external world was now imagined by science as a colorless and silent neutrality, whose flowers and fruit had lost all fragrance and flavor. Poetry may have been depressed by this conception into the prosy verse of the Augustan age, the early 18th century in England, but it ultimately discovered that qualities felt are as real as the objects themselves, and Romanticism revenged itself on Classicism by making feelings the supreme quality. The analysis of an object into qualities led to the question, what is the substance in which the primary qualities seem to inhere? Locke confessed that we know nothing of that mysterious substratum except its qualities. Take those away, and the substance, the underlying ground of the qualities, loses all meaning, apparently all existence. Berkeley entered here. If we know only the qualities of objects, and know these only as ideas, then all reality is perception, and Locke, the great champion of empiricism, of experience as the source of all knowledge, becomes an idealist, reducing matter to idea. Moreover, the mind is as supposititious as substance, body, or matter. In a remarkable passage, Locke overleaps Berkeley and anticipates Hume. The same thing happens concerning the operations of the mind, viz., thinking, reasoning, fearing, etc., which we, concluding not to subsist of themselves, nor apprehending how they can belong to body or be produced by it, are apt to think the actions of some other substance, which we call spirit, whereby yet it is evident that, having no other idea or notion of matter but something wherein those many sensible qualities which affect our senses do subsist, so by supposing a substance wherein thinking, knowing, doubting, and a power of moving, etc., do subsist, we have as clear a notion of spirit as we have of body, the one being supposed to be, without knowing what it is, the substratum to those simple ideas we have derived from without, and the other supposed, with a like ignorance of what it is, to be the substratum to those operations we experiment, or experience, in ourselves within. Adding, then, that our idea of substance is equally obscure, or none at all, in both worlds, and that it is but a supposed I know not what to support those ideas we call accidents, Locke concludes that in both cases we are warranted in believing in a substance, though we cannot know it, in a matter behind and emitting the sensory qualities, and in a mind behind and possessing the ideas, a spiritual agent performing the various operations of perceiving, thinking, feeling, and willing. Whatever the mind is, its operations are all of one kind, the play of ideas. Locke rejects the scholastic notion of faculties in the mind, such as thought, feeling, and will. Thought is the combination of ideas, feeling is the physiological reverberation of an idea, will is an idea flowing into action, as all ideas tend to do unless checked by another idea. But how can an idea become an action? How can a spiritual process become a physiological process and a physical motion? Locke reluctantly accepts the dualism of corporeal body and incorporeal mind, but in an imprudent moment he suggests that mind might be a form of matter. This is a locus classicus in Locke. Possibly we shall never be able to know whether any mere material being thinks or no, it being impossible for us, by the contemplation of our own ideas, without revelation, to discover whether omnipotency has not given to some systems of matter, fitly disposed, a power to perceive and think, or else joined and fixed to matter, so disposed, a thinking immaterial substance. It being, in respect of our notions, not much more remote from our comprehension to conceive that God can, if he pleases, superadd to matter a faculty of thinking, than that he should add to it another substance with a faculty of thinking. He that considers how hardly sensation is, in our thoughts, reconcilable to extended matter, or existence to anything that has no extension at all, will confess that he is very far from certainly knowing what his soul is. He who will give himself leave to consider freely will scarce find his reason able to determine him fixedly for or against the soul's materiality. Though Hobbes had already leaped upon the materialistic horn of the dilemma, the suggestion of its possible truth was, in the intellectual context of Locke's time, so offensive to orthodoxy that 100 defenders of religion attacked him as playing recklessly into the hands of the atheists. They paid little attention to his passing obeisance to revelation, or to his earlier statement that the more probable opinion is that consciousness is annexed to, and the affection of, one individual immaterial substance. Perhaps they foresaw how Lemaitre, D'Holbach, Diderot, and other materialists would see in Locke's suggestion a secret inclination to their view. Bishop Stillingfleet accused him of precisely such a tendency, and warned him that it endangered the whole Christian theology. Forgetting his usual caution, Locke warmly reasserted the possibility of the material hypothesis in a controversy that lasted, with Stillingfleet and others, till 1697. Despite its critics, its occasional contradictions, obscurities, and other faults, the essay gathered prestige and influence with every year. 4 editions of it were called for in the 14 years between its publication and Locke's death. A French edition appeared in 1700 and was greeted with enthusiastic admiration. It became a topic in English drawing rooms. Tristram Shandy assured his hearers that a reference to the essay would enable anyone to cut no contemptible figure in a metaphysical circle. The influence of the essay on Berkeley and Hume was so great that we might date from it the turn of British philosophy from metaphysics to epistemology. Perhaps Pope had Locke in mind when he wrote that the proper study of mankind is man. A French edition appeared in 1700 and was greeted with enthusiastic hyperboles. After so many speculative gentlemen had formed the romance of the soul, wrote Voltaire, one truly wise man appeared who has, in the most modest manner imaginable, given us its real history. Mr. Locke has laid open to man the anatomy of the soul, just as some learned anatomist would have done that of the body. And again, Locke alone has developed the human understanding in a book where there is nothing but truths, a book made perfect by the fact that these truths are stated clearly. The essay became the psychological Bible of the French Enlightenment. Condillac adopted and extended Locke's sensationism, and thought nothing had been done in psychology between Aristotle and Locke, a manifest injustice to the scholastics and Hobbes. D'Alembert, in the Discours préliminaire of the Encyclopédie, credited Locke with having created scientific philosophy, as Newton, he supposed, had created scientific physics. Despite its professions of orthodoxy, the essay made for a rationalistic empiricism that soon discarded the soul as a needless hypothesis, and passed on to apply the same reasoning to God. 4. Religion and toleration. Locke himself had no sympathy with such extremes. Whatever his private doubts, he felt, like an English gentleman, that good manners and morals required public support of the Christian Church. If philosophy should take from the people their faith in a divine justice, standing behind the apparent injustices and sufferings of life, what could it offer to sustain the hopes and courage of men? A slow progress toward a democratic utopia? But in that utopia would not the natural greed and inequality of men forge new means for the use and abuse of the simple or the weak by the clever or the strong? His first concern was to lay down the measures and boundaries between faith and reason, and this he aimed to do in Chapter 18 of Book 4 of the essay. I find every sect, as far as reason will help them, make use of it gladly, and where it fails them they cry out, it is a matter of faith and above reason. Whatever God hath revealed is certainly true, but only reasoning on the available evidence can tell us whether a Scripture is the Word of God, and no proposition can be received for divine revelation if it be contrary to our clear intuitive knowledge. When a matter can be decided by such direct observation, Our knowledge is above any supposed revelation, for it is clearer than any certainty we can have that the revelation in question is really divine. However, there being many things wherein we have very imperfect notions, or none at all, and other things of whose past, present, or future existence, by the natural use of our faculties, we can have no knowledge at all, these, as being above reason, are, when revealed, the proper matter of faith. Locke concludes, nothing that is contrary to and inconsistent with the clear and self-evident dictates of reason has a right to be urged or asserted as a matter of faith wherein reason hath nothing to do. One unerring mark of the love of truth is not entertaining any proposition with greater assurance than the proofs it is built upon will warrant. Reason must be our last judge and guide in everything. So in 1695 Locke published The Reasonableness of Christianity as delivered in the Scriptures. He read the New Testament again as one might read a new book, putting aside, as he thought, all dogmas and commentaries. He was overwhelmed by the lovable nobility of Christ and the beauty of nearly all his teaching as the best and brightest hope of mankind. If anything could be a divine revelation, this narrative and doctrine seemed divine. Locke proposed to accept it as divine, but also to prove it, in all its essentials, to be in the profoundest agreement with reason. But those essentials, it seemed to him, were far more modest and simple than the complex theology of the 39 Articles, the Westminster Confession, or the Athanasian Creed. He quoted passage after passage from the New Testament requiring of a Christian only the belief in God and in Christ as his divine messenger or Messiah. Here, said Locke, is a plain and intelligible religion, fit for any man and independent of all learning and theology. As to the existence of God, he felt that the works of nature and every part of them sufficiently evidence a deity. From his own existence he argued to a first cause, and since he found perception and knowledge in himself, he concluded that such attributes must also belong to God. God is eternal mind. When Locke's critics complained that he had left out such vital doctrines as the immortality of the soul and everlasting punishments and rewards, he replied that in accepting Christ he accepted Christ's teachings, in which those doctrines were included. So Locke came out by the same door wherein he went. However, he insisted that all forms of Christianity except Catholicism should enjoy full liberty in England. He had written an essay on toleration as early as 1666. When he moved to Holland in 1683, he found much more freedom of worship than in England, and while he was there he must have noted Bayle's powerful defense of toleration in 1686. Moved by the persecution and migration of the Huguenots in 1685, he wrote a letter to his friend Limborch, who urged its publication. It was printed in Latin in 1689 as Epistola de Tolerantia, and appeared in an English translation before the year was out. An Oxford don denounced it. Locke, now in England, defended it in a second and third letter concerning toleration in 1690 and 1692. The Toleration Act of 1689 fell far short of his proposals. It excluded Catholics, Unitarians, Jews, and pagans, and barred dissenters from public affairs. Locke also made exceptions. He would not tolerate atheists because he thought their word could not be trusted since they feared no God, or any religion that did physical harm as by human sacrifice, or any religion demanding allegiance to a foreign power. He gave Mohammedanism as an example, but was understood to mean Catholicism too. He explicitly called for toleration of Presbyterians, Independents, Anabaptists, Arminians, and Quakers. He did not dare include Unitarians, though the first Shaftesbury, dying in Amsterdam in 1683, said he had imbibed Arianism and Socinianism, or Unitarianism, from his secretary Locke. The law, said Locke, should concern itself only with the preservation of social order. It has a right to suppress expressions destructive of the state, but it has no jurisdiction over men's souls. No church should have the power to compel adherence. How ridiculous to punish persons in Denmark for not being Lutherans, in Geneva for not being Calvinists, in Vienna for not being Catholics. After all, which individual or group can have the full truth about human life and destiny? Locke noted that most of the religions demanded toleration when they were weak, but refused it when they were strong. Persecution, he felt, comes from lust for power, and from jealousy masquerading as religious zeal. Persecution creates hypocrites, toleration promotes knowledge and truth. And how can a Christian persecute, being pledged to charity? Locke continued his campaign for toleration till the close of his life. He was engaged in writing a fourth letter on the subject when his time ran out. Death came to him in 1704 while he sat quietly listening to Lady Masham reading Psalms. Even before his death he had reached in philosophy a reputation surpassed only by Newton's in science. Men already spoke of him as the philosopher. While he ended in almost orthodox piety, his books, unable to change with age, passed through editions and translations into the thought of educated Europe. The Western Enlightenment, said Spengler, is of English origin. The rationalism of the continent comes wholly from Locke. Of course, not wholly, but of whom else would one now risk such hyperbole? 6. Shaftesbury, 1671 to 1713. His pupil, Anthony Ashley Cooper, 3rd Earl of Shaftesbury, was a credit to Locke the educator. Not that Locke was responsible for Shaftesbury's style. The explorative psychologist wrote a pedestrian prose, simple and usually clear, this side the stake, but seldom beautiful. Shaftesbury, a man of wealth and leisure, wrote with confident urbanity, tolerant humor, and almost Gallic grace, the English seigneur condescending to be a philosopher. We must stay with him a while, for he almost founded aesthetics in modern philosophy, and by rescuing feeling and sympathy from the cold hands of Hobbes and Locke, fed the stream of sentiment that culminated in Rousseau. Under Locke's supervision, and on Locke's scheme of teaching a language by conversation, Elizabeth Birch, skilled in Greek and Latin, enabled Anthony to read both these languages with ease by the age of 11. Then off to Winchester School, then 3 years of travel, during which he learned French and French ways and acquired such a flair for art as must have seemed unseemly in an English lord. He served for a year in Parliament, long enough to note the injustice and corruption of both parties. But London smoke so aggravated his asthma that he retreated to Holland, where he found the intellectual air vibrant with Spinoza and Bayle. Having succeeded to the earldom in 1699, he spent the remainder of his life at his country estate. 4 years before his death he married, and was astonished to find himself as happy as before. In 1711 he published his collected essays under the omnibus title Characteristics of Men, Manners, Opinions, and Times. In 1713, only 42 years old, he died. It was not to be expected that a man who had inherited such a fortune on the earth should bother much about heaven. He deprecated the enthusiasm, by which his time meant fanaticism, of those Englishmen who thought that they exhaled divine revelations. Any form of violent emotion or speech was, in his judgment, a mark of ill breeding, but he thought it wiser to smile at such people than to persecute them. Indeed, wit and humor, which he made the subject of an originative essay, appeared to him the best approach to everything, even to theology. He agreed with Bayle that atheists could be decent citizens, and that they had done less harm to religion and morality than the brutality of faiths wielding power. He protested against the adoration and love of a God whose character it is to be captious and of high resentment, subject to wrath and anger, furious and revengeful, encouraging deceit and treachery amongst men, favorable to a few and cruel to the rest. He wondered what effect such a conception of the deity had had upon human character and conduct. He thought it abject and cowardly to be virtuous from hope of heaven or fear of hell. Virtue is real only when practiced for its own sake. However, man being what he is, it is necessary to inculcate belief in such future punishments and rewards. 'Tis real humanity and kindness to hide strong truths from tender eyes. It may be necessary for wise men to speak in parables. So Shaftesbury defended an established church and tried to reconcile evil and theism with an optimistic philosophy that reduced evil to a human prejudice. Nevertheless, Alexander Pope thought that the characteristics had done more harm to reveal religion in England than all the works of explicit infidels. Shaftesbury agreed with Aristotle and Locke that happiness is the rightful aim of human actions. He defined philosophy as the study of happiness. But he opposed the reduction of all human motives to egoism or self-interest. According to that analysis, recently expounded by Hobbes and La Rochefoucauld, civility, hospitality, humanity towards strangers or people in distress is only a more deliberate selfishness. An honest heart is only a more cunning one, and honesty and good nature a better regulated self-love. The love of kindred, children, and posterity is purely love of self and one's own immediate blood. Magnanimity and courage no doubt are modifications of this universal self-love. Against this view, Shaftesbury alleged the double equipment of human nature with instincts for personal gain and instincts for living in a group. He believed that society and the state had originated not in a social contract, but in the herding principle and associating inclination, so natural and strong in most men. There are natural affections founded in love, complacency, goodwill, and sympathy with the kind. To have these natural and good affections in full strength is to have the chief means of self-enjoyment. To want them is certain misery and ill. To be good is to have one's inclinations consistently directed toward the good of the group. The larger the group that inspires these feelings, the better the man. The consciousness of such social sympathy is the moral sense. This is innate, not in its specific commands, which vary from group to group, but in its instinctive ground, the sense of right and wrong being as natural to us as natural affection itself, and being a first principle in our constitution. Shaftesbury passed from ethics to aesthetics by identifying them. The good and the beautiful are one. Morality is the taste of beauty and the relish of what is decent. So we speak of some unsocial acts as ugly, for we feel that they offend that harmony of the part with the whole which is both goodness and beauty. A man can make his life a work of art, of unity and harmony, by developing an aesthetic sense in which morality will be an element. A man of thorough good breeding, our aristocrat believed, does this, and is by training incapable of doing a rude or brutal action. His formed good taste will guide him in conduct as in art. Truth, too, is a kind of beauty, a harmony of the parts of knowledge with the whole. Hence Shaftesbury took readily the side of classicism in art. Form, unity, and harmony seemed to him the essentials of excellence in poetry, architecture, and sculpture. And in painting, color is less basic and noble than line. He was the first modern who made beauty a fundamental problem in philosophy. He began the discussion that at the end of the 18th century culminated in Lord Kames and Burke. This was one line of Shaftesbury's influence. There were many others. His emphasis on feeling affected the Romantic movement, especially in Germany through Lessing, Schiller, Goethe, and Herder, who called him Europe's amiable Plato. In France, this influence appeared in Diderot as well as in Rousseau. His interpretation of religion as theoretically weak but morally indispensable touched Kant's practical nerve. His stress on sympathy as the basis of morals reappeared in Hume and Adam Smith. His ideas on art shared in forming Winckelmann's classical ecstasy. Beginning as a pupil of the intellectual and not too aesthetic Locke, he became, perhaps by the natural resistance of every generation to its generators, the philosopher of feeling, sentiment, and beauty. Lover of the classic style in art, he became a source of the Romantic revival on the continent, though in England poetry and architecture followed his classic bent. And he had the distinction of making philosophy shine with a grace of style reminiscent of Plato, and then rivaled only by Berkeley. 7. George Berkeley, 1685 to 1753. He was born at Dysart Castle in County Kilkenny. At 15, he entered Trinity College, Dublin. At 20, he formed a club to study the new philosophy, which meant Locke. At 21, he entered into his commonplace book the idea which he hoped would crush materialism forever, that nothing exists except by being perceived, that therefore mind is the only reality, and matter is a myth. As the doctrine of matter, or corporeal substance, has been the main pillar and support of skepticism, so likewise upon the same faith have been raised all the impious schemes of atheism and irreligion. How great a friend material substance hath been to atheists in all ages were needless to relate. All their monstrous systems have so visible and necessary a dependence on it, that when this cornerstone is once removed, the whole fabric cannot choose but fall to the ground, insomuch that it is no longer worth while to bestow a particular consideration on the absurdities of every wretched sect of atheists. So in the next 7 years, and before completing his 29th birthday, Berkeley issued his most important works: an essay towards a new theory of vision in 1709, a treatise concerning the principles of human knowledge in 1710, and 3 dialogues between Hylas and Philonous, in opposition to skeptics and atheists, in 1713. The first was a brilliant contribution to psychology and optics. The others profoundly stirred the waters of modern philosophy. The essay on vision stemmed from a passage in Locke which told how William Molyneux, a tutor in Trinity College, Dublin, had posed a problem to him. Would a man born blind be able, on recovering his sight, to distinguish by sight alone a sphere from a cube, if both of these were of like material and size? Molyneux and Locke had concurred in the negative. Berkeley agreed with them and added his own analysis. Sight gives us no perception of the distance, size, relative positions, or movements of objects, except after correction by the sense of touch. Through repeated experiences, this correction becomes almost instantaneous, and sight then gives us such a judgment of the shape, distance, place, and motion of objects seen as we should have if we touched them. A man born blind, being made to see, would at first have no idea of distance by sight. The sun and stars, the remotest objects as well as the nearer, would all seem to be in his eye, or rather in his mind. The objects intromitted by sight would seem to him, as in truth they are, no other than a new set of thoughts or sensations, each whereof is as near to him as the perception of pain or pleasure, or the most inward passions of the soul. For our judging objects perceived by sight to be at any distance, or without the mind, is entirely the effect of experience. Space, then, is a mental construct. It is a system of relationships built up in the course of experience to coordinate our perceptions of sight and touch. Operations reported by the Royal Society in 1709 and 1728 confirmed this view. When a congenitally blind person was surgically given sight, he was at first so far from making any judgment about distances that he thought all objects whatever touched his eyes. He knew not the shape of anything, nor any one thing from another, however different in shape or magnitude. The Principles of Human Knowledge was a remarkable product for a lad of 25. Again, Berkeley took a leap out of Locke's essay. If all knowledge comes from the senses, nothing has reality for us unless we perceive or have perceived it. Esse est percipi. To be is to be perceived. Locke had supposed that perceptions were caused by external objects pressing upon our sense organs. How do you know, asked Berkeley, that such objects exist? Have we not in our dreams ideas as vivid as in our waking hours? Locke tried to save the independent reality of objects by distinguishing between their primary and secondary qualities. The latter were subjective, in the mind. The others, extension, solidity, figure, number, motion, rest, were objective. They subsisted in some mysterious substratum of which Locke confessed himself ignorant, but which he and the world identified with matter. Berkeley now announced that the primary qualities are as subjective as the secondary, that we know the extension, solidity, figure, number, motion, and rest of objects only through perception, that therefore these primary qualities too are subjective, are ideas. The world is for us just a bundle of perceptions. It is the mind that frames all that variety of bodies which compose the visible world, any one whereof does not exist longer than it is perceived. Take away from matter the primary as well as the secondary qualities, and matter becomes a meaningless nonentity. The materialist is left mouthing nothings. Berkeley was well aware that others besides materialists would protest against this sleight-of-hand evaporation of the external world. He was not at a loss when asked if the furniture in our rooms ceases to exist when no one is there to perceive it. He did not deny the reality of an external world, an external source for our perceptions. He merely denied the materiality of that world. External objects may continue to exist when we do not perceive them, but that is only because they exist as percepts in the mind of God. And in truth, he went on, our sensations are caused not by external matter, but by the divine power acting upon our senses. Only spirit can act upon spirit. God is the sole source of our sensations and ideas. Berkeley's contemporaries thought this was all an Irish lark. Lord Chesterfield wrote to his son that Dr. Berkeley, a very worthy, ingenious, and learned man, has written a book to prove that there is no such thing as matter, and that nothing exists but an idea. His arguments are, strictly speaking, unanswerable. But yet I am so far from being convinced by them that I am determined to go on to eat and drink and walk and ride in order to keep that matter, which I so mistakenly imagine my body at present to consist of, in as good plight as possible. And all the world knows what pains Dr. Johnson took to answer Dr. Berkeley. After we came out of church, says Boswell, we stood talking for some time together of Bishop Berkeley's ingenious sophistry to prove the non-existence of matter, and that everything in the universe is merely ideal. I observed that though we are satisfied his doctrine is not true, it is impossible to refute it. I shall never forget the alacrity with which Johnson answered, striking his foot with mighty force against a large stone, till he rebounded from it, I refute it thus. Berkeley, of course, could only have pointed out to the great Cham that all that he knew of the stone, including the pain in his toe, was subjective. A bundle of perceptions called a stone, mingling with a bundle of auditory sensations called Boswell and a bundle of indoctrinated ideas called philosophy, had generated a response resulting in another bundle of sensations. Hume agreed with Boswell and Chesterfield. Berkeley's arguments admit of no answer and produce no conviction. Hume found Berkeley's puzzle fascinating, but drew from it a devastating conclusion. This book is continued on Cassette 10, Side 1. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant, Part 2, continued, Cassette 10, Side 1. Hume found Berkeley's puzzle fascinating, but drew from it a devastating conclusion. He admitted that matter vanishes when we divest it of all the qualities which our perceptions ascribe to it, but he suggested that the same could be said of mind. We have seen Locke's preview of this point, but Berkeley foresaw it too. In the third of the dialogues, he makes Hylas challenge Philonous. You acknowledge you have, properly speaking, no idea of your own soul. You admit, nevertheless, that there is a spiritual substance, although you have no idea of it, while you deny there can be such a thing as material substance because you have no notion or idea of it. Is this fair dealing? To me it seems that according to your own way of thinking, and in consequence of your own principles, it should follow that you are only a system of floating ideas, without any substance to support them. Words are not to be used without a meaning, and as there is no more meaning in spiritual substance than in material substance, the one is to be exploded as well as the other. Philonous, lover of mind, answers Hylas, Mr. Matter, How often must I repeat that I know or am conscious of my own being, and that I myself am not my ideas, but somewhat else, a thinking, active principle that perceives, knows, wills, and operates about ideas? I know that I, one and the same self, perceive both colors and sounds, that a color cannot perceive a sound, nor a sound a color, that I am therefore one individual principle, distinct from color and sound. Hume was not convinced by this reply. He concluded that Berkeley willy-nilly had destroyed both matter and soul, and that the writings of the brilliant bishop, who had longed to defend religion, form the best lessons of skepticism which are to be found either among the ancient or modern philosophers, Bayle not excepted. 40 years remained to Berkeley after publishing his 3 treatises. In 1724 he was appointed Dean of Derry. In 1728, on a promise of funds from the government, he sailed to found a college in Bermuda for the reformation of manners among the English in our western plantations and the propagation of the gospel among the American savages. Having reached Newport, Rhode Island, he waited for the promised £20,000, none of which ever came. While there he composed Alciphron, or The Minute Philosopher, in 1732, to put an end to all religious doubt. He left his mark upon the mind of Jonathan Edwards and wrote a famous line, "Westward the course of empire takes its way." After 3 years of vain expectations, he returned to England. In 1734 he was appointed Bishop of Cloyne. We have seen how Swift's Vanessa made him one of her executors and left him half her property. In 1744 he issued a strange treatise, Cyrus, the Virtues of Tar Water, to which he had been introduced by the aforesaid savages, and which he now recommended as a cure for smallpox. He died at Oxford in 1753, aged 68. No man ever surpassed him in proving the unreality of the real. In his effort to restore religious belief and to exorcise the Hobbesian materialism that was infecting England, he turned philosophy outside in, and made all the choir of heaven and furniture of the earth, all those bodies which compose the mighty frame of the world, to exist for man as merely ideas in his mind. It was a risky enterprise, and Berkeley would have shuddered to see Hume and Kant draw from his pious principles a critique of reason that left no basic dogma undislodged in the ancient and beloved edifice of the Christian faith. We admire the subtlety of his web-weaving, and concede that no one since Plato had written nonsense so charmingly. We shall find his influence everywhere in Britain and Germany in the 18th century, less in France, but rising again in the epistemological abracadabra of 19th century Kantians. Even today, European philosophy has not yet quite made up its mind that the external world exists. Until it reconciles itself to the extreme probability thereof and faces the problems of life and death, the world will pass it by. All in all, this was the finest epoch in the history of English philosophy. The bell that Francis Bacon had rung to call the wits together had been heard after the subsiding fury of the Civil War. Hobbes was the bridge over that mindless void, Newton was the lever by which mechanics moved theology, Locke was the peak from which the problems of modern philosophy came clearly into view. From that English quartet, soon abetted by the canny, uncanny Hume, came a powerful influence into France and Germany. The French thinkers of this period were not so profound or original as the English, but more brilliant, partly because they were Gauls, partly because a more stringent censorship compelled them to spend their substance upon form and dispense their wisdom in wit. Then, in 1726, Voltaire came to England. When he returned, he carried Newton, Locke, Bacon, Hobbes, and other contraband in his bags. And France for half a century thereafter used English science and philosophy as weapons to écraser l'enfant of superstition, obscurantism, and ignorance. An English midwife served at the accouchement of the French Enlightenment. Chapter 21. Faith and Reason in France, 1648 to 1715. 1. The Vicissitudes of Cartesianism. The Dictionary of the French Academy in 1694 defined philosopher as one who devotes himself to research work in connection with the various sciences, and who seeks from their effects to trace their causes and principles. A name also applied to one who lives a quiet and secluded life remote from the stir and troubles of the world. It is occasionally used to denote someone of undisciplined mind who regards himself as above the responsibilities and duties of civil life. From the first part of this definition, it is clear that philosophy and science were not yet distinguished. Science, as natural philosophy, would remain a branch of philosophy till the 19th century. From the final portion of the definition, we gather that the 40 immortals under Louis XIV sniffed a revolutionary odor in the philosophic air, as if the harbingers of the Enlightenment had already spoken their prologue. Between three horns of the definition, the intellectual legacy of René Descartes meandered through renown to repudiation. The legacy itself had three horns. One sounded the trumpet of doubt as the prelude to all philosophy. Another announced the universal mechanism of the external world. The third played the welcome tunes of the traditional creed and drew God, free will, and immortality out of the vortices of the world. Descartes had begun with doubt and ended with piety, and his heirs could take him at either end. The ladies of the early salons, the femmes savantes, satirized by Molière in 1672, found some exciting respite from the rosary and the whirlpools of the new cosmology. Madame de Sévigné reported the Cartesian philosophy as an after-dinner topic in her circle. She and Mesdames de Grignon, de Sablé, and de Lafayette were all Cartesiennes. Fragrant women attended the lectures given in Paris by followers of Descartes. Great nobles took up the philosophic mode. Cartesian discourses were pronounced each week in the chateau of the Duc de Ligne, and in the Paris palace of the Prince de Condé, and in the most magnificent hôtel of the capital. Religious orders, Oratorians, Benedictines, Augustinians, taught the new philosophy in their schools. It became the fashion to praise reason in science and human affairs, while carefully subordinating it in religion to divine revelation as interpreted by the Catholic Church. The Jansenists and Port-Royal accepted Cartesianism as an elegant reconciliation of religion and philosophy. But their most brilliant convert, Blaise Pascal, denounced Cartesianism as the vestibule of atheism. "I cannot pardon Descartes," he said. "He would have been glad in all his philosophy to dispense with God. But he could not avoid allowing him a fillip, a snap of the finger released from the thumb, to put the world in motion. After that he had no use for God." On this point the Jesuits agreed with Pascal. After 1650 they rejected Cartesianism as a subtle, even if unintended, corrosive of religious faith. The Sorbonne wished to proscribe Descartes. Boileau defended him. Ninon de L'Enclos and others persuaded Molière to write a satire on the Sorbonne. The Sorbonne deferred its censure. The learned Huet, after long accepting Cartesianism, turned against it as blowing hot and cold for and against Christianity. Theologians were increasingly alarmed by the difficulty of reconciling transubstantiation with Descartes' view of matter as pure extension. In 1665, Louis XIV forbade the teaching of the ambivalent philosophy in the Collège Royal, and in 1671 he extended the prohibition to the University of Paris. In 1687, Bossuet joined in the attack. These condemnations revived interest in Cartesianism and drew attention to its skeptical overture, the Discours de la Méthode. The initial doubt of that essay spread subterraneanly. Its orthodox appendages withered away. In the 18th century, hardly anything remained of the once victorious system, except its attempt to reduce the external world to a mechanism obeying the laws of physics and chemistry. Every new discovery of science seemed to support this Cartesian mechanism and to discredit the Cartesian theology. The God of Abraham, Isaac, and Jacob found no place in Descartes' picture of the cosmos. Nor was Christ there. All that remained was a Dieu fainéant who gave the world an initial push and then retired from the scene except as a guarantor of Descartes' intuitions. This was not the majestic and awful God of the Old Testament, nor the merciful Father of the New. He was the God of deism, impersonal, functionless, negligible, subject to invariable laws. Who would think of praying to such an Epicurean futility? Already in 1669 and 1678, the books of Guillaume Lamy, professor on the medical faculty at the University of Paris, expounded a completely mechanistic psychology anticipating Condillac's Traité des Sensations in 1754, and a materialistic philosophy anticipating La Maîtrise l'Homme-Machine in 1748. And amid the fracas, Cyrano de Bergerac made his scandalous voyages to the moon and the sun. 2. Cyrano de Bergerac, 1619 to 1655. For most of us he is the lover travestied by Rostand, and losing every race to Venus by a nose. The real Cyrano was not quite frustrated. He played vivaciously with life and love, and frittered away his time to the top of his bent. To the usual education of a well-born lad he added, with Molière, eager attendance on the lectures of Pierre Gassendi, the amiable priest who liked Epicurus the materialist and Lucretius the atheist. Cyrano became an esprit especially for, a libertin in both senses, as freethinker and loose liver. He joined in Paris a company of sacrilegious roisterers, earned repute as a duellist, served in the army, was for a while incapacitated by his wounds, and retired from active venery to philosophy. He wrote the first French philosophical play, and opened the road to Swift by making fun of mankind via travels to unfrequented parts of the cosmos. He laughed at the venerable St. Augustine, that grand personage who assures us, though his mind was illuminated by the Holy Ghost, that in his time the earth was as flat as an oven, and that it floated on the water like half an orange. Cyrano tried his pen in almost every literary form, seldom seriously, but usually finding the nerve. His comedy, Le Pédant Joué, seemed to Molière good enough for poaching a scene or two. His tragedy, L'amour d'Agrippine, was acted once in 1640, was immediately proscribed by the authorities, and had to wait till 1960 to reach the boards again. But it was published in 1654, and soon the wild young men of Paris were shouting the atheistic lines of its Séjan. What then, are these gods? The offspring of our fears, pretty nothings that we adore without knowing why. Gods whom man has made, and who never made man. And on immortality. 1 hour after death our vanished soul will be that which it was an hour before life. Soon after this play was printed, Cyrano was struck on the head by a falling beam and died of the blow, aged 36. He left a manuscript which was published in 2 parts. Histoire comique des états et empires de la Lune in 1657, and Histoire comique des états et empires du Soleil in 1662. They were a comic kind of science fiction based upon the Cartesian cosmology and deriving the planets from vortices formed by the revolutionary agitation of primeval matter. Cyrano suggested that the planets had once blazed like the sun, but in the compass of time suffered so great a loss of light and heat by the continual emission of the corpuscles causing such phenomena that they have become cold, dark, and almost powerless pulps. We find even that sunspots increase in size from day to day. Now who knows if these are not a crust forming on the sun's surface from its mass that cools in proportion as light is lost, and if the sun will not become an opaque globe like the earth? Propelled by rockets, Cyrano leaves the earth and swiftly reaches the moon. He notes that through 3/4 of the way he feels the earth drawing him backward, then through the final quarter he feels the attraction of the moon. This, I told myself, was because the mass of the moon was less than that of the earth, hence the sphere of its action was correspondingly less in space. Landing dazed, he finds himself in a Garden of Eden. He falls into an argument with Elijah about original sin, and is expelled from the garden into the primitive wastelands of the satellite. There he encounters a tribe of animals 12 cubits long, fashioned like men but walking on all fours. One of these, having served in Athens as the demon of Socrates, speaks philosophic Greek. He informs Cyrano that walking on all fours is the natural and healthy way, that these lunar gentlemen have 100 senses, not 5 or 6, and perceive countless realities hidden from mankind. Fontenelle, Voltaire, and Diderot will play with this speculation. Cyrano's fancy runs wild. The lunars feed only on vapors pressed from foods, not on foods themselves. Hence they are saved the nuisance and noises of digestion, the indignities and anachronisms of elimination. The lunar laws are made by the young, who are revered by the old. Celibacy and chastity are condemned. Suicide, cremation, and large noses are praised. The aforesaid demon of Socrates explains that the world was not created, but is eternal, that creation out of nothing, taught by the scholastics, is inconceivable, that the eternity of the universe is no more difficult to accept than the eternity of God. Indeed, the hypothesis of a God is quite unnecessary, since the world is a self-propelled and self-perpetuating machine. Cyrano argues that there must be a God, for he has with his own eyes seen miraculous cures. The demon laughs these away as due to suggestion or imagination. Orthodoxy is revenged by a powerful Ethiopian who grasps Cyrano in one arm, the demon in the other, carries the demon to hell, and en route deposits Cyrano in Italy, where all the neighborhood dogs howl at him because he smells of the moon. Jonathan Swift was attracted too. 3. Malebranche, 1638 to 1715. Against the infidel progeny of Gassendi and Descartes, the faith found powerful defenders not only in Pascal, Bossuet, and Fénelon, but in one of the subtlest metaphysicians of modern times. Nicolas de Malebranche was an almost exact contemporary of Louis XIV, born a month before him, dying a month after him. There was no further resemblance. Nicolas was gentle of spirit and pure of life. As his father was secretary to Louis XIII, and his uncle was Viceroy of Canada, he had every advantage of birth and rearing except health. His body was feeble and deformed, and only a frugal regimen in the routine and peace of monastic life can explain his 77 years. At 22 he joined the Congregation of the Oratory, a religious order dedicated to meditation and preaching. At 26 he was ordained priest. In that same year he came upon Descartes' Traité de l'Homme. He was transported by both its argument and its style. He became a Cartesian with a sublime faith in reason, and he at once resolved to prove by reason the Catholic creed in which he had rooted his life and his hopes. This was a brave move away from Pascal back to St. Thomas Aquinas. It showed the splendid confidence of youth, but it exposed the citadel of faith to the inroads of reason. After 10 years of study and writing, Malebranche issued in 4 volumes in 1674 one of the classics of French philosophy, De la Recherche de la Vérité, The Search for Truth. Here, as by all the philosophers of France, the moral obligation to be intelligible was accepted, and philosophy became literature. Descartes had not only begun his lucubrations with the self, but had set such a gulf between the body physical and mechanical and the mind spiritual and free, that no interaction between them could be conceived. And yet that interaction seemed indisputable. An idea could move an arm or an army, and a drug could muddle the mind. Half the puzzling of Descartes' successors was devoted to bridging the gap between flesh and thought. A Flemish philosopher, Arnold Gerlings, prepared for Malebranche and for SPINOZA and LEIBNIZ by denying the interaction. The material body does not act upon the immaterial mind, or vice versa. When either seems to act upon the other, it is only because God has created reality in two distinct streams of events, the one physical, the other mental. Their synchronism is like that of two clocks, set to the same second and speed and striking the same hours simultaneously, but operating quite independently of each other, except that both have one source, the intelligence that set and started them. So God is the sole source of both the physical and mental series of causes and effects. The mental state is the occasion, not the cause of the apparently resultant physical motion, and the physical motion, event or sensation, is merely the occasion of the mental state that it seems to cause. In each case, God alone is the cause. At this point, Görlings, fearful of determinism, broke into his system by allowing that in conscious actions the human will, cooperating with God, can be a real cause of physical results. Malebranche made this hesitant occasionalism complete. God is always the cause of both the physical act and the mental state. Their interaction is illusory. Neither ever acts upon the other. God alone drives back the air which he himself has made me breathe. It is not I who breathe. I breathe despite myself. It is not I who speak to you. I merely wish to speak to you. God, the total energy of the universe, is the only power. Whatever moves or thinks does so because the divine power acts through the physical and mental processes. Motion is God acting in material forms. Thought is God thinking in us. In this apparently deterministic philosophy there are countless difficulties which in later treatises Malebranche tried to resolve. He struggled to harmonize some degree of free will in man with the universal agency of God, and to reconcile evil and suffering and multitudinous deviltry with the sole and omnipresent causality of an omnipotent and omniscient benevolence. We shall not follow him into these labyrinths. But in the course of his wandering he leaves a helpful thread of psychology. Sensations, he thinks, are in the body, not in the mind. The mind has ideas and knows objects only as bundles of ideas, of structure, size, color, odor, solidity, sound, temperature, taste. These idea complexes are built up not merely from the object. Most of the qualities here named are not in the object, and many of our judgments about the object, that it is large, small, bright, dim, heavy, light, hot, cold, quickly moving or slow, describe the position, condition, and attitude of the observer rather than the attributes of the thing observed. We do not know things. We know only our prejudiced and transformed perceptions and ideas. All this a generation before Locke and Berkeley. Despite his spiritualistic background, Malebranche, after Descartes and Hobbes, gives physiological explanations of habit, memory, and association of ideas. Habit is a readiness with which the animal spirits, as the result of similar experiences or actions often repeated, flow in certain grooves or channels of the body. Memory is the reactivation of associations created in experience. Ideas tend to be associated according to their past sequence or contiguity. Strength of character, power of will, are the force of animal spirits flowing along the fibers of the brain, deepening the grooves of association and the vividness of imagination. Pious though Malebranche was, there were many elements in his philosophy that disturbed that alert watchman of orthodoxy, Benigne Bossuet. In a clever move to divert the passionate pen of Antoine Arnauld from the logic of Jansenism to the succor of the proper faith, he persuaded him to comb Malebranche for hidden heresies. The philosopher defended himself in a series of treatises as eloquent and incredible as the first, and the controversy continued from 1683 to 1697. Bossuet brought Fénelon's light artillery to the attack. Madame de Sévigné, seeing that mice were devouring her crops and caterpillars her trees, complained that she found little consolation in Malebranche's view of evil as a necessary element in the best of all possible worlds. To offset these critics, Malebranche had many fervent friends. Young men and old women found in his doctrine of God as the only agent in all actions a mystic pleasure of surrender and divine union. Frenchmen and foreigners wore a path to his cell. One Englishman said that he came to France to see only two celebrities, Louis XIV and Malebranche. Berkeley came, all reverence, and engaged the old priest in a long discussion. Soon afterward, Malebranche, 77, weakened. He grew thinner every day until his mind had hardly any body left to serve as occasion for his thought. On October 13, 1715, he passed away in his sleep. His fame faded rapidly after his death, for his religious philosophy was not in tune with the skepticism and revelry of the Regency, and still less with the ensuing tendency of the philosophe to replace divine providence with a world machine. But his influence appeared in Leibniz's attempt to show that the actual was the best possible world. In Berkeley's view that things exist only in our perception or in God's, in Hume's destructive analysis of cause as an occult quality, in Kant's emphasis on the subjective elements in the formation of knowledge, even in the determinism of the Enlightenment. For to say that God is the only cause of all motions, volitions, and ideas is not far different from saying that every change in matter or mind is the inevitable result of the total forces operating in the universe at that moment. In Malebranche's ecstasy he had approached, though he denied it, a determinism that made man an automaton. Above all, the system of occasionalism served as a halfway house between Descartes and Spinoza. Descartes saw mechanism in matter, but liberty in mind. Malebranche saw God as sole cause in every action of every mind. Spinoza, quite as God-intoxicated as the monk, agreed with him that the mental and physical series were parallel products of one creative force. Unwittingly, the pious Oratorian, seeing God everywhere, had taught even to the faithful a pantheism that needed only the phrase Deus sive natura, God or nature, to become the philosophy of Spinoza and of the Enlightenment. 4. Pierre Bayle, 1647 to 1706. The father of the Enlightenment was the son of a Huguenot minister serving the town of Carla in the Countship of Foix, under the Pyrenees. Pierre lived there his first 22 years, imbibing Greek, Latin, and Calvinism. He was a sensitive, impressionable youth. Sent to the Jesuit college at Toulouse in 1669 to get the best classical education within his family's reach and means, he fell in love with his teachers and was soon converted to Catholicism, so fervently that he tried to convert his father and brother. They bore with him patiently, and 17 months later he returned to the parental faith. But now, as a relapsed heretic, he was subject to prosecution by the Roman Church. To protect him, the father sent him to the Calvinist University of Geneva in 1670, hoping that Pierre would enter the Protestant ministry. There, however, Bayle discovered the works of Descartes and began to doubt all forms of Christianity. His schooling completed, he lived as a tutor in Geneva, Rouen, and Paris, and rose to a professorship in philosophy at a Huguenot seminary in Sedan in 1675. In 1681, the seminary was closed by order of Louis XIV as part of his war of attrition against the Edict of Nantes. Bayle found refuge in Rotterdam and a berth as professor of history and philosophy in the École Illustre, the municipal academy. He was among the first of many intellectual émigrés who in this age made the Dutch Republic a citadel of independent thought. His salary was small, but he was content to live simply so long as he had access to books. He never married, preferring a library to a wife. He was not unmindful of feminine graces and charms, and would have been grateful for the tender solicitude of a good woman, but he suffered all his life from headaches and an associated megrim, or melancholia, and doubtless he hesitated to bind another spirit to his ills. He had his cynical moments, however, for when a French Jesuit, Father Maimbourg, in a history of Calvinism, argued that Catholic priests had accepted conversion to Protestantism in order to marry, Bayle asked how could this be, for what greater cross is there than marriage? He reviewed Maimbourg's book in a volume of letters that appeared in 1682. He wondered whether any man strongly attached to a special faith could write impartial or truthful history. How could one trust a historian who, like Maimbourg, called Louis XIV's treatment of the Huguenots before 1682 just, gentle, and charitable? Turning to Louis himself, Bayle, writing from a Holland so recently and flagrantly assailed by France, asked, what right had any king to force his own religion upon his subjects? If he had such a right, then the Roman emperors were justified in persecuting Christianity. Conscience, Bayle thought, should be the only ruler over a man's beliefs. Maimbourg answered conclusively by procuring from Louis XIV an order that any copy of Bayle's book found in France should be publicly burned by the common hangman. In that same year, 1682, Bayle issued his first major work, Pensées diverses sur la comète, miscellaneous thoughts on the comet that had crossed the sky in December 1680. All Europe had been frightened by that star, whose tail of fire seemed to herald the conflagration of the world. Only if we put ourselves back into the fears of that age, when Catholic and Protestant alike interpreted such phenomena as divine warnings, and believed that any moment would bring upon a sinful earth the thunderbolts of God, can we understand the terror with which that flaming apparition had been viewed, or appreciate the courage and wisdom of Bayle's comments. Even the learned Milton had recently told how the comet from its horrid hair shakes pestilence and war. Basing his discussion upon the recent studies of astronomers, but Halley's comet of 1682 had not yet appeared, Bayle assured his readers that comets move through the heavens according to fixed laws and have nothing to do with the misery or happiness of mankind. He mourned the pertinacity of superstition. He who would find all the causes of popular errors will never be finished. He rejected all miracles except those of the New Testament. Without this exception, his book could not have been printed in Holland. In sound philosophy, nature is nothing else than God himself acting by certain laws which he has established by his own free will, so that the works of nature are not less the effect of the power of God than miracles, and suppose as great a power as miracles, it being altogether as difficult to form a man by natural laws of generation as to raise him from the dead. Bayle passed boldly to one of the most difficult problems of history. Is a natural ethic possible? Can a moral code be maintained without the aid of supernatural belief? Did atheism lead to corrupt morals? If that were so, said Bayle, one would have to conclude from the crime, corruption, and immorality prevalent in Europe that most Christians are secret atheists. Jews, Mohammedans, Christians, and infidels differ in creeds, but not in deeds. Apparently religious belief, and ideas in general, have little influence upon conduct. This flows from desires and passions usually stronger than beliefs. What influence had the precepts of Christ upon the European conception of courage and honor, which praised most the man who promptly and violently avenged insults and injuries, who excelled in war, inventing an infinity of machines to make sieges more murderous and frightful? It is from us that infidels learn to use better arms. Bayle concluded that a society of atheists would have no worse morals than a society of Christians. What keeps most of us in order is not the distant and uncertain terror of hell, so much as the fear of the policeman and the law, of social condemnation and disgrace, of the hangman. Take away these secular deterrents, and you would have chaos. Keep them, and a society of atheists would be possible. Indeed, it might contain many men of high honor and women of chastity. We hear of such exemplary atheists in antiquity, like Epicurus and both Pliny's, and in modern times like Michel de l'Hôpital and Spinoza. Whether the morals of the average man would be worse than they are if religion did not supplement law is a question that Bayle leaves untouched. This tract on the comet was published anonymously. Bayle took the same precaution when he inaugurated one of the major periodicals of the time, Nouvelles de la République des Lettres. Its first number, running to 104 pages, appeared in Amsterdam in March 1684. The magazine proposed to keep its readers informed on all significant developments in literature, science, philosophy, scholarship, exploration, and historiography. So far as we know, Bayle himself wrote all the contents, month after month, for 3 years. We may imagine the industry this entailed. His reviews of books soon became a power in the literary world. In 1685 he took courage and acknowledged his authorship. 2 years later his health broke down, and he surrendered the editorship to other hands. Meanwhile, the persecution of Huguenots in France found 4 victims in Bayle's family. As a direct or indirect result of the Dragonades, his mother died in 1681, his father in 1685. In that year his brother was imprisoned and died of the cruelties inflicted upon him. 6 days later, on October 18th, the Edict of Nantes was revoked. Bayle was shocked by these developments. Like Voltaire, he had no weapon but his pen. In 1686 he challenged the persecutors with one of the classics in the literature of toleration. He called it Philosophical Commentary on These Words of Jesus Christ. Compel them to come in. The persecutors had claimed to find a divine warrant for their procedure in the parable told by Christ of the man who, when the guests whom he had invited to a feast failed to come, said to his servant, "Go out quickly into the streets and lanes of the city, and bring in hither the poor and the maimed and the halt and the blind. Compel them to come in, that my house may be filled." Bayle had no trouble in showing that these words had nothing to do with compelling unity of religious faith. On the contrary, the attempts to enforce unity of belief had bloodied half of Europe, and the diversity of religions in a state prevented any one creed from being strong enough to persecute. Besides, which of us can be so sure that he has the truth as to warrant injuring another for differing from him? Bayle condemned persecution by Protestants as well as by Catholics, and of non-Christians by Christians in general. Unlike Locke, he proposed to extend freedom of worship or non-worship to Jews, Mohammedans, and freethinkers. Forgetting his claim that atheists were as likely as Christians to be good citizens, he advised against tolerating sects that had no belief in providence and a punishing deity. These, undeterred from perjury by fear of God, would make difficult the enforcement of the law. For the rest, only intolerance should be exempt from toleration. Should a Protestant state tolerate the rise of a Catholicism that defended intolerance on the ground that it alone had the true faith? Bayle thought that in such cases Catholics should be deprived of the power of doing mischief. Yet I should never be for leaving them exposed to personal insult, or for disturbing their enjoyment of property or the exercise of their religion, or allow any injustice in their appeals to law. The Protestants were no better pleased than the Catholics by this program of toleration. Pierre Bayle, who had been Bayle's friend and professorial associate in Sedan, and was now pastor of a Calvinist congregation in Rotterdam, attacked Bayle in a tract on the rights of the two sovereigns in the matter of religion, the conscience and the prince, in 1687. Jurieu proposed to destroy the dogma of the indifference of religions and of universal tolerance against a book entitled A Philosophical Commentary. He agreed with the popes that rulers had full right to destroy a false religion, and he was especially shocked by the idea of tolerating Jews, Mohammedans, Socinians, and pagans. In 1691, Jurieu appealed to the burgomasters of Rotterdam to dismiss Bayle from his professorship. They refused, but in 1693 an election changed the official personnel. Jurieu renewed his campaign, charging Bayle with atheism, and Bayle was dismissed. "God preserve us from the Protestant Inquisition," said the philosopher. "Another 5 or 6 years, and it will have become so terrible that people will be longing to have the Roman back again." Soon recovering his perspective and good humor, Bayle adjusted himself to the situation. It was sufficient consolation that now he could devote all his working hours to the epical dictionnaire that he had already begun. He accustomed himself to live on his savings and a few honorariums from his publishers. He received offers of patronage from the French ambassador in Holland and from 3 English earls. He courteously declined, and even refused the Earl of Shrewsbury's proffered gift of 200 guineas for the dedication of the dictionary. He had friends, but few distractions. Public amusements, games, country jaunts, and other recreations were none of my business. I waste no time on them, nor in any domestic cares, nor soliciting for any preferment. I find sweetness and repose in the studies in which I have engaged myself, and which are my delight. Canem mihi et musis. I will sing to myself and the muses. So he remained quietly in his room, working 14 hours a day, adding page after page to the strange volumes that were to become a fountainhead of the Enlightenment. The 2 massive folios, totaling 2,600 pages, appeared at Rotterdam in 1697. He called them Dictionnaire historique et critique. Not a vocabulary of words, but a critical consideration of persons, places, and ideas in history, geography, mythology, theology, morals, literature, and philosophy. "Iacta est alea," he cried as he dispatched the final proof sheets to the printer. "The die is cast." It was a heavy gamble with life and liberty, for it contained more heresies than any other book of its century, perhaps more than its grandchild, the Encyclopédie from 1751 of Diderot and d'Alembert. Bayle had begun with the limited aim of correcting the errors and supplying the omissions in the Grand Dictionnaire Historique that Louis Maurery had published in 1671 from the viewpoint of Catholic orthodoxy. But his aim widened as he progressed. He never pretended to encyclopedic coverage. Where he had nothing to say, he said nothing. So there were no articles on Cicero, Bacon, Montaigne, Galileo, Horace, Nero, Thomas More. Science and art were largely ignored. On the other hand, there were articles on such recondite notables as Akiva, Uriel Acosta, and Isaac Abravanel. Space was allotted not according to historical importance, but according to Bayle's interest. So Erasmus, who had been allotted 1 page in Morerie, received 15 in Bayle, and Abélard 18. The arrangement was alphabetical but semi-Talmudic. The main facts were stated in the text, but in many cases Bayle appended in smaller type a note, in which he let himself go into a miscellany of proofs and discussions, even sometimes a train of philosophical reflections. It was in this fine print that he draped his heresies from the common view. In the margins he indicated his sources. Altogether these display a range of reading and learning hardly possible in one lifetime. Some notes contained risque anecdotes. Bayle hoped these would help his sales, but doubtless in his baccalaureal solitude he enjoyed them for their own sake. Readers took gratefully to his racy, rambling, saucy style, his sly exposure of weaknesses in current creeds, and his tongue-in-cheek professions of Calvinist orthodoxy. The original issue of 1,000 copies was sold out in 4 months. Bayle's method was to collate authorities, ferret out the facts, expound rival and contradictory opinions, follow reason to its conclusions, and then, if these wounded orthodoxy, reject them piously in favor of Scripture and faith. Jurieu angrily asked, "Can a word in passing in favor of faith over reason oblige men to renounce the objections that Bayle has called invincible?" Otherwise, there is little order in his Dictionnaire. Some of its major discussions emerge under trivial topics or misleading heads. I cannot meditate with much regularity on one subject. I am too fond of change. I often wander from the subject and jump into places of which it might be difficult to guess the way out. Usually the argument was courteous, modest, and undogmatic, and good-humored. Now and then, however, Bayle sharpened his tongue, and the article on St. Augustine did not spare the great Calvinist for his long deferment of chastity, his gloomy theology, and his religious intolerance. Bayle professed to accept the Bible as the Word of God, but he slyly pointed out that we would never believe some of its miracle stories had they not had so distinguished an author. He put pagan legends, that is, Hercules swallowed by a whale, beside similar tales in the Bible, and let the reader puzzle why one story should be rejected and the other received. In the most famous of his articles, he recounted the massacres, treacheries, and adulteries of King David, and left the reader to wonder why such a crowned scoundrel should be honored by Christians as the ancestor of Christ. He found it easier to swallow both Jonah and the whale than the fall of Eve and Adam. How could an omnipotent deity create them, foreseeing that they would taint the whole human race with original sin and curse it with 1,000,000 miseries? If man is the creature of one principle perfectly good, most holy, and omnipotent, can he be exposed to diseases, to heat and cold, hunger and thirst, pain and grief? Can he have so many bad inclinations? Can he commit so many crimes? Can perfect holiness produce a criminal creature? Can perfect goodness produce an unhappy creature? Would not omnipotence, joined with infinite goodness, furnish his own work plentifully with good things, and secure it from everything that might be offensive or vexatious? The God of Genesis was either a cruel deity or one of limited power. So Bayle expounded with much sympathy and force the Manichaean conception of 2 gods, one good, the other evil, fighting to control the world and man. As the Papists and the Protestants agree that very few people escape damnation, it would seem that the devil is winning the battle against Christ. Moreover, his victories are everlasting, for the theologians assure us there is no escape from hell. Since there is or will be more souls in hell than in heaven, and those in hell eternally curse the name of God, there will be more creatures who will hate God than those who will love him. Bayle maliciously concluded that we must not engage with the Manichaeans until we have first laid down the doctrine of the exaltation of faith and the abasing of reason. The article on Pyrrho expressed doubts about the Trinity, for things which do not differ from a third do not differ from each other. And as to transubstantiation, the modes of a substance, and therefore the appearances of bread and wine, cannot subsist without the substance which they modify. As to all men inheriting the guilt of Adam and Eve, A creature which does not exist cannot be an accomplice of an ill action. But all these doubts were placed by him in other mouths than his own, and were repudiated by him in the name of faith. Bayle quoted as most falsely said by impious men that religion is a mere human invention set up by sovereigns to keep their subjects within the bounds of obedience. In the article on Spinoza, he went out of his way to condemn the Jewish pantheist as an atheist. Yet he must have found something fascinating in him, for this is the longest article in the dictionary. Bayle pretended to reassure the theologians by telling them that the doubts expressed in this book would never destroy religion, because these matters were beyond the understanding of the people. Faguet thought Bayle unquestionably an atheist, but it would be fairer to call him a skeptic, and to remember that he was skeptical of skepticism too. This book is continued at this point on the other side of this cassette. Please reverse or turn the cassette over now. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant. Part 2, continued, Cassette 10, Side 2. Faguet thought Bayle unquestionably an atheist, but it would be fairer to call him a skeptic, and to remember that he was skeptical of skepticism too. Since secondary sense qualities are largely subjective, the objective world is quite different from what it appears to us. The absolute nature of things is unknown to us. We know only some relations they have to one another. Amid 2,600 pages of reasoning, he confessed the weakness of reason. It, too, like the senses upon which it depends, may deceive us, for it is often clouded by passion, and it is desire and passion rather than reason that determine our conduct. Reason can teach us to doubt, but it rarely moves us to act. The reasons for doubting are doubtful themselves. One must therefore doubt whether he ought to doubt. What chaos! What torment for the mind! Our reason is the way to wander, since, when it displays itself with the greatest subtlety, it throws us into such an abyss. Human reason is a principle of destruction, and not of edification. It is only fit to start doubts and to turn itself all manner of ways to perpetuate a dispute. Consequently, Bayle counseled philosophers not to set a high value on philosophy, and he advised reformers not to expect much of reforms. Since human nature is apparently the same in all centuries, it will continue, through greed, pugnacity, and erotic appetite, to produce the problems that disorder societies and cause the infantile mortality of utopias. Men do not learn from history. Every generation shows the same passions, delusions, and crimes. Therefore, democracy is all the more a mistake in proportion as it is real. To allow the busy, ill-informed, and impulsive multitude to choose rulers and policies would be the suicide of a state. Some kind of monarchy is necessary, even under democratic forms. Progress, too, is a delusion. We mistake movement for advance, but probably it is mere oscillation. The best we can hope for is a government that, though manned by corrupt and imperfect men, will provide enough law and order to enable us to cultivate our gardens in security and pursue our studies or hobbies in peace. No such peace was left to Bayle in the 9 years that remained to him. As his readers passed from his large to his fine print, a wave of resentment rose. A consistory of the Walloon Church in Rotterdam summoned Bayle, a member of the congregation, to appear before it and answer charges that his dictionary contained indecent expressions and questions, a great many obscene quotations, offensive remarks on atheism and Epicurus, and especially objectionable articles on David, Pyrrho, and the Manichees. Bayle promised that he would meditate further on the doctrine of the Manichees, and if he found any replies, or if the ministers of the consistory would furnish him with some, he would be glad to put them in the best form possible. For the second edition of the dictionary in 1702, he rewrote and softened the article on David. Jurieu, unmollified, renewed the assault, and published in 1706 a blast entitled The Philosopher of Rotterdam Accused, Attacked, and Convicted. After that second edition, Bayle's health failed. Like Spinoza, he suffered from tuberculosis. In those later years he coughed almost constantly, fell into repeated fevers, and grew despondent with headaches. Convinced that his disease was incurable, he resigned himself to death, retired more and more to the confinement of his room, and worked day and night on the reply that he was making to his critics. On December 27, 1706, he sent his final sheets to the printer. The next morning his friends found him dead in his bed. His influence pervaded the 18th century. His dictionary, repeatedly reissued, became a secret delight to thousands of rebel minds. By 1750, 9 editions had appeared in French, 3 in English, 1 in German. In Rotterdam, his admirers wished to raise a statue to him alongside that of Erasmus, and they induced the publishers to reprint the original article on David. Within a decade of his death, students stood in line at the Mazarin Library in Paris, waiting their turn to read the Dictionnaire. A survey of private libraries in France found it in more of them than any other work. Almost every thinker of consequence felt his influence. Most of Leibniz's Theodicy was explicitly an attempt to answer Bayle. Lessing's mental emancipation and his defense of tolerance stemmed from Bayle. Frederick the Great probably derived his skepticism originally from Bayle rather than from Voltaire. He called the dictionary the Breviary of Good Sense, had 4 sets of it in his library, and supervised the publication of a cheaper and abbreviated 2-volume edition to attract a wider range of readers. Shaftesbury and Locke were touched by Bayle more lightly. Both of them knew him in Holland, and Locke's Epistola de Tolerantia in 1689 walked in the footsteps of Bayle's Commentaire from 1686. But of course the greatest influence of Bayle was on the philosophes of the Enlightenment. They were weaned on the Dictionnaire. It was probably from Bayle that Montesquieu and Voltaire took the device of invoking Asiatic comparisons and criticisms of European institutions. The Encyclopédie of 1751 was not, as Faguet judged, merely a revised, corrected, and slightly augmented edition of Bayle's dictionary, but much of its standpoint and many of its guiding ideas came from those 2 volumes, and its article on toleration perhaps too generously referred the reader to Bayle's Commentaire as exhausting the subject. Diderot acknowledged his indebtedness with his usual candor, and hailed Bayle as the most redoubtable exponent of skepticism in either ancient or modern times. Voltaire was Bayle reborn with better lungs, more energy, years, wealth, and wit. The Dictionnaire philosophique has been rightly called an echo of Bayle's. The delicious monkey of Ferney often differed from Bayle. For example, Voltaire thought that religion had helped to foster morality, and that if Bayle had had 500 or 600 peasants to govern, he would not have hesitated to announce to them a God who punishes and rewards. But he reckoned Bayle as the greatest dialectician who has ever written. Altogether, the philosophy of France in the 18th century was Bayle in an explosive proliferation. With Hobbes, Spinoza, Bayle, and Fontenelle, the 17th century opened, between Christianity and philosophy, the long and bitter war that would culminate in the fall of the Bastille and the feast of the goddess of reason. 5. Fontenelle, 1657 to 1757. In the first 40 of his 100 years, Bernard Le Bovier de Fontenelle waged the philosophic war, independently of Bayle, sometimes before him, and he continued the war, un poco adagio, for half a century after Bayle's death. He was one of the phenomena of longevity, bridging the gap between Bossuet and Diderot, and carrying into the intellectual turmoil of the 18th century the milder and more cautious skepticism of the 17th. He was born at Rouen, February 11, 1657, so frail that he was baptized at once in fear that he would die before the day was out. He remained frail through all his circuit. His lungs were bad, and he spat blood if he exerted himself even to play billiards. But by measuring out his forces sparingly, avoiding marriage, starving his passions, and indulging his sleep, he outlived all his contemporaries, and remembered Molière while he spoke to Voltaire. He had some impetus to letters as the nephew of Corneille. He, too, dreamed dramas, but the plays and operas that he composed, his eclogues, love poems, and bergeries, lacked passion and died of the cold. French literature was losing art and gaining ideas, and Fontenelle found himself only when he discovered that science could be a more astonishing revelation than the apocalypse, and that philosophy was a ruthful battle transcending all wars. Not that he was a warrior. He was too genial for strife, too much a man of the world to lose his temper in debate, and too conscious of the relativity of truth to tie his thought to an absolute. And yet he sowed dragon's teeth. Where he walked in feigned discourse with his imaginary marquise, the army of the Enlightenment would rise with the dashing light horse of Voltaire, the heavy infantry of D'Holbach, the sappers of the Encyclopédie, and the artillery of Diderot. His first sally into philosophy was a 15-page essay, L'Origine des Fables, in effect a sociological inquiry into the origin of gods. We can hardly believe his biographer that this was composed at the age of 23, though prudently left in manuscript till the censorship was relaxed in 1724. It is almost completely modern in spirit, tracing myths not to priestly invention but to primitive imagination, above all, to the readiness of simple minds to personify processes. So a river flowed because a god poured out its water. All natural operations were the actions of deities. Men beheld many wonders beyond their own power, to hurl thunderbolts, raise the winds and the waves. Men imagined beings more powerful than themselves, capable of producing these effects. These superior beings had to have human form, for what other form could be imagined? So the gods were human, but endowed with superior power. Primitive men could conceive no quality more admirable than physical force. They had not yet conceived, had not yet words for, wisdom and justice. Half a century before Rousseau, Fontenelle rejected Rousseau's idealization of the savage. Primitive men were stupid and barbarous. But, he added, all men are so much alike that there is no race whose follies should not make us tremble. He took care to add that his naturalistic interpretation of the gods did not apply to the Christian or Jewish deity. Putting that little essay aside for safer times, Fontenelle took a leaf and a title from Lucian, and published in January 1683 a little book called Dialogue des Morts. These imaginary conversations between dead celebrities proved so popular that a second edition was called for in March, and a third soon afterward. Bayle praised it enthusiastically in his Nouvelle. Before the year ran out, it was translated into Italian and English, and Fontenelle, at 26, reached European fame. The dialogue form was handy in a world infested with censors. Almost any notion could be expressed by one of the speakers, refuted by another, and disclaimed by the author. Fontenelle, however, was in a mood for humor rather than heresy. The ideas he discussed were moderate and left no mitres crushed. So Milo, the vegetarian athlete of Crotona, plumes himself with having carried an ox on his shoulders at the Olympic Games. Smindaride, from neighboring Sybaris, taunts him with developing his muscles at the expense of his mind. But the Sybarite confesses that the Epicurean life is also vain, since it dulls pleasure with frequency and multiplies the sources and degrees of pain. Homer compliments Aesop on teaching truth with fables, but warns him that truth is the last thing desired by mankind. The spirit of man is extremely sympathetic to falsehood. Truth must borrow the figure of the false to be agreeably received by the human mind. If, said Fontenelle, I had all truth in my hands, I would be careful not to open them. But probably that would be out of sympathy for mankind, as well as from reckless love of the pursuit. In the most delightful of the dialogues, Montaigne meets Socrates, doubtless in hell, and discusses the idea of progress. Montaigne. Is this you, divine Socrates? What a joy it is to see you. I've just entered this region, and ever since I've been looking for you. At last, after filling my book with your name and praise, I can talk with you. Socrates. I am happy to see a dead man who appears to have been a philosopher, but since you have come so recently from up there, let me ask you the news. How goes the world? Hasn't it changed a great deal? Montaigne. Oh, much indeed. You wouldn't recognize it. Socrates. I'm delighted to hear it. I've never doubted that it must become better or wiser than in my time. Montaigne. What are you saying? It is crazier and more corrupt than ever. That is the change I wanted to discuss with you. And I've been waiting to hear from you an account of the age in which you lived, and in which so much honesty and justice reigned. Socrates. And I, on the contrary, have been waiting to learn about the marvels of the age in which you have just lived. What? Men have not yet corrected the follies of antiquity? I hoped that things would take a turn toward reason, and that men would profit from the experience of so many years. Montaigne. Men profit from experience? They are like birds that repeatedly let themselves be caught in the same nets that have already taken 100,000 birds of the same species. Everyone enters new into life, and the mistakes of the parents are lost on the children. Men of all centuries have the same inclinations, over which reason has no power. Hence, wherever there are men, there are follies, even the same follies. Socrates. You idealized antiquity because you were angry at your own time. When we were alive, we esteemed our ancestors more than they deserved, and now our posterity exalts us beyond our merits. But our ancestors, ourselves, and our posterity are quite equal. Montaigne. But aren't some ages more virtuous and others more wicked? Socrates. Not necessarily. Clothes change, but that is not to say that the figure of the body changes too. Politeness or grossness, knowledge or ignorance, are but the outside of man, and all that changes. But the heart changes not at all. And all of man is in the heart. Among the vast multitude of foolish men born in 100 years, nature may have scattered here and there 2 or 3 dozen reasonable men. Some years after this pessimistic conclusion, Fontenelle took a slightly more optimistic view in a Digression sur les anciens et les modernes in January 1688. There he drew a helpful distinction. In poetry and art there had been no visible progress, for these depend upon feeling and imagination, which hardly change from generation to generation. But in science and learning, which depend upon the slow accumulation of knowledge, we may expect to surpass antiquity. Each nation, Fontenelle suggested, goes through stages like an individual. In infancy it devotes itself to meeting its physical wants. In youth it adds imagination, poetry, and art. In maturity it may reach science and philosophy. Fontenelle thought that he saw truths growing through the gradual elimination of erroneous views. We are under an obligation to the ancients for having exhausted almost all the false theories that could be formed, which is to forget that for every truth there is an indefinite number of possible errors. He supposed that Descartes had found a new and better mode of reasoning, the mathematical. Now he hoped science would grow by leaps. When we behold the progress the sciences have made during the last 100 years, in spite of prejudices, obstacles, and the small number of scientific men, we might almost be tempted to let our hopes for the future rise too high. We shall see new sciences springing out of nothingness, while ours are still in the cradle. So Fontenelle formulated a theory of progress, le progrès des choses. And like Condorcet, a century later, he conceived it as having no assignable limit in the future. Here already was the indefinite perfectibility of mankind. The idea of progress was now fully launched and sailed on through the 18th century to become one of the fairest vehicles of modern thought. Meanwhile, Fontenelle, whose brilliant fancy was ever straining at the leash of caution, had come close to the Bastille. About 1685 he published a brief Relation de l'île de Bornéo, an imaginary voyage so realistically described, anticipating the verisimilitude of Defoe and Swift, that Bayle printed it as an actual history in his Nouvelle. But the conflict which it described between Enigu and Murillo was an evident satire on the theological strife between Geneva and Rome. When the French authorities saw through the anagrams, the arrest of Fontenelle seemed inevitable, for the skit appeared on the very heels of the revocation of the Edict of Nantes. He hurriedly issued a poem lauding the triumph of religion under Louis the Great. His apology was accepted, and thereafter Fontenelle saw to it that his philosophy should be unintelligible to governments. He returned to science and made himself its missionary to French society. He was too fond of ease to engage directly in experiment or research, but he understood the sciences well and presented them to his growing audiences in small doses coated with literary art. To popularize the Copernican astronomy, he composed Entretien sur la pluralité des mondes in 1686, Conversations on the Plurality of Worlds. Though 143 years had passed since the appearance of Copernicus's De Revolutionibus Orbium Coelestium, very few people in France, even among college graduates, accepted the heliocentric theory. Galileo had been condemned by the Church in 1633 for assuming that the hypothesis was a fact, and Descartes had not dared to publish his treatise Le Monde, in which the Copernican view had been taken for granted. Fontenelle approached the subject with disarming gallantry. He imagined himself discussing it with the pretty marquise. Her figure, unseen but not unfelt, moved through the discourse alluringly. For when beauty has a title, it can dim the stars. The 6 conversations were soirs, evenings. The scene was the garden of the marquise's chateau near Rouen. The purpose was to get the people of France, or at least the ladies of the salons, to understand the rotation and revolution of the earth and the Cartesian theory of vortices. As an added lure, Fontenelle raised the question whether the moon and the planets were inhabited. He was inclined to think so, but remembering that some readers might be disturbed by the notion that there were in the world men and women not descended from Adam and Eve, he prudently explained that these lunar or planetary populations were not really human. However, he suggested that they might have other senses, perhaps finer senses, than ours. If so, they would see objects differently than we do. Would truth then be relative? This would upset everything, even more than Copernicus had done. Fontenelle saved the situation by pointing out the beauty and order of the cosmos, comparing it to a watch, and deducing from the cosmic mechanisms a divine artificer of supreme intelligence. As the desire to teach is among our strongest itches, Fontenelle again risked the Bastille by issuing anonymously, in December 1688, the boldest of his little treatises, L'Histoire des Oracles. He confessed to having taken his material from the De Oraculis of a Dutch scholar, Van Dahl, but he transformed it by the clarity and gaiety of his style. "Il nous enjole à la vérité," said a reader. "He cajoles us to the truth." So he compared mathematicians with lovers. Grant a mathematician the least principle, and he will draw from it a consequence which you must also grant him, and from this consequence another. Theologians had accepted some pagan oracles as authentic, but had ascribed their occasional accuracy to satanic inspiration, and they had held it a proof of the Church's divine origin that these oracles had ceased to operate after the coming of Christ. But Fontenelle showed that they had continued as late as the 5th century A.D. He exonerated Satan as their deus ex machina. The oracles were tricks of pagan priests moving in the temples to work apparent miracles, or to appropriate the food offered by worshippers to the gods. He pretended that he spoke only of pagan oracles, and explicitly accepted Christian oracles and priests from his analysis. This essay and the Origine des Fables were not only subtle blows struck for enlightenment, they were examples of a new historical approach to theological questions, to explain the human sources of transmundane beliefs and thereby naturalize the supernatural. L'Histoire des Oracles was the last of Fontenelle's sapping operations. In 1691 he was elected to the French Academy over the opposition of Racine and Boileau. In 1697 he became, and for 42 years he remained, perpetual secretary of the Académie des Sciences. He wrote its history and composed gracious and illuminating éloges of members who had died. These constitute a lucid record and exposition of French science through almost half a century. From such séances of the sciences, Fontenelle could pass with equal pleasure to the salons, first that of Madame de Lambert, and then Madame de Tencins, then Madame de Geoffrins. He was always welcome, not merely because of his fame as a writer, but because his courtesy never lapsed. He dispensed truth with discretion, he refused to sour conversation with controversy, and his wit had no sting. No man of his time was more open-minded and free from prejudice. Madame de Tencins, who had been a firefly of passion, foolishly accused him of having another brain where his heart should have been, and the young god-killers who were growing up around him could no more understand his moderation than he could relish their dogmatism and violence. "I'm frightened by the certainties that reign around me." He did not see an unmixed evil in the decay of his hearing as he grew old. About the age of 50, he apparently decided to give thereafter none but platonic services to the ladies. But his gallantry never faltered. At 90, being introduced to a young and pretty woman, he remarked, "Ah, if I were only 80 now." Nearly 98, he opened a New Year's ball by dancing with the 1.5-year-old daughter of Helvétius. When Madame Grimaud, almost as old as he, said wonderingly, "Well, here we are, both still alive," he put a finger to his lips and whispered, "Hush, madam, death has forgotten us." It found him at last, January 9th, 1757, and took him quietly, after he had been ill but a day. He explained to his friends that he was suffering from being. Je souffre d'être. He may have felt that he had carried longevity to excess. He fell short by 33 days of rounding out a century. He had been born before Louis XIV had begun to govern. He had grown up amid the triumphs of Bossuet, the Revocation, and the Dragonnades. He had lived to see the Encyclopédie, and to hear Voltaire summon the philosophers to war upon l'infâme. Chapter 22. Spinoza, 1632 to 1677. 1. The Young Heretic. This strange and lovable character, who made the boldest attempt in modern history to find a philosophy that could take the place of a lost religious faith, was born in Amsterdam on November 24, 1632. His ancestors can be traced to the town of Espinosa, near Burgos, in the Spanish province of Leon. They were Jews who, as conversos to Christianity, included scholars, priests, and Cardinal Diego de Espinosa, one-time Grand Inquisitor. Part of the family, presumably to escape the Spanish Inquisition, migrated to Portugal. After a period of residence there, at Vidigueira, near Beja, the grandfather and father of the philosopher moved to Nantes in France, and thence, in 1593, to Amsterdam. They were among the first Jews who settled in that city, eager to enjoy the religious freedom guaranteed in 1579 by the Union of Utrecht. By 1628, the grandfather was regarded as head of the Sephardic community in Amsterdam. At various times, the father was warden of the Jewish school there and president of the organized charities of the Portuguese synagogue. The mother, Hanna Deborah de Espinosa, came to Amsterdam from Lisbon. She died when Baruch was 6 years old, leaving him a consumptive heredity. He was brought up by the father and a third wife. As Baruch was Hebrew for blessed, the boy was later named Benedictus in official and Latin documents. In the synagogue school, Baruch was given a predominantly religious education based upon the Old Testament and the Talmud. There was also some study of Hebrew philosophers, especially Abraham ibn Ezra, Moses ben Maimon, and Hasdai Crescas, with perhaps some dippings into the Kabbalah. Among his teachers were two men of prominence and ability in the community, Saul Mortera and Manasseh ben Israel. Outside of school, Baruch received in Spanish considerable instruction in secular subjects, since his father wished to prepare him for a business career. In addition to Spanish and Hebrew, he learned Portuguese, Dutch, and Latin, with later a touch of Italian and French. He developed a fondness for mathematics and made geometry the ideal of his philosophical method and thought. It was natural that a youth of exceptionally active mind should raise some questions about the doctrines transmitted to him in the synagogue school. Perhaps even there he had heard of Hebrew heresies. Ibn Ezra had long ago pointed out the difficulties involved in ascribing to Moses the later parts of the Pentateuch. Maimonides had proposed allegorical interpretations of some otherwise indigestible passages in the Bible, and had suggested some doubts about personal immortality and about creation as against the eternity of the world. Crescas had ascribed extension to God, and had rejected all attempts to prove by reason the freedom of the will, the survival of the soul, and even the existence of God. In addition to these predominantly Orthodox Jews, Spinoza must have read Levi ben Gerson, who had reduced biblical miracles to natural causes and had subordinated faith to reason, saying, "The Torah cannot prevent us from considering to be true that which our reason urges us to believe." And only recently, in this Amsterdam community, Uriel Acosta had challenged the belief in immortality and, humiliated by excommunication, had shot himself in 1647. The vague recollection of that tragedy must have deepened the turmoil in Spinoza's mind when he felt slipping from him the upholding theology of his people and his family. In 1654 his father died. A daughter claimed the whole estate. Spinoza contested her claim in court, won his case, and then turned over to her all of the legacy but a bed. Now dependent upon himself, he earned his bread by grinding and polishing lenses for spectacles, microscopes, and telescopes. In addition to tutoring some private pupils, he became an instructor in the Latin school of Franz van den Ende, ex-Jesuit, freethinker, dramatist, and revolutionary. There Spinoza improved his Latin. Perhaps he was stimulated by van den Ende to study Descartes, Bacon, and Hobbes. He may now have dipped into the Summa Theologiae of Thomas Aquinas. He seems to have fallen in love with the headmaster's daughter. She preferred a more affluent suitor, and Spinoza, so far as we know, made no further move toward marriage. Meanwhile, he had begun to lose his faith. Probably before reaching the age of 20, he had ventured, with all the pain and trepidation that such moltings bring to sensitive spirits, upon some exciting ideas. That matter may be the body of God, that angels may be phantoms of the imagination, that the Bible said nothing of immortality, that the soul is identical with life. He might have kept these proud heresies to himself had his father lived, and even after his father's death he might have remained silent, had not some friends importuned him with questions. After much hesitation he confessed to them the tremors of his faith. They reported him to the synagogue. It has often been pointed out, but must always be borne in mind, that the leaders of the Jewish community in Amsterdam were in a difficult position in dealing with heresies that attacked the fundamentals of the Christian as well as the Jewish creed. The Jews enjoyed in the Dutch Republic a religious toleration denied them elsewhere in Christendom, but that could be withdrawn if they tolerated among themselves ideas that might unsettle the religious basis of morality and social order. According to the biography of Spinoza, written in the year of his death by a French refugee in Holland, Jean-Maximilien Lucas, the students who reported Baruch's doubts falsely added the charge that he had expressed scorn of the Jewish people for thinking itself especially chosen by God, and for believing that God was the author of the Mosaic Code. We do not know how far we can trust this account. In any case, the Jewish leaders must have resented any disruption of the faith that had been a tower of strength and a well of comfort to the Jews through centuries of bitter suffering. The rabbis summoned Spinoza and chided him for disappointing the bright hopes that his teachers had held for his future in the community. One of these teachers, Manasseh ben Israel, was absent in London. Another, Saul Mortera, pleaded with the youth to abandon his heresies. In fairness to the rabbis, we must note that Lucas, though strongly sympathetic with Spinoza, records that when Mortera recalled the loving care he had given to the education of his favorite pupil, Baruch answered that in return for the trouble Mortera had taken in teaching him the Hebrew language, he, Spinoza, would now be glad to teach his instructor how to excommunicate. This seems quite out of character with all else that we hear of Spinoza, but we must not let our affections select the evidence. And, to vary a remark of Cicero's, there is hardly anything so foolish but we can find it in the lives of the philosophers. We are told that the synagogue leaders offered Spinoza an annual pension of 1,000 gulden if he would promise to take no hostile step against Judaism, and would show himself from time to time in the synagogue. The rabbis appear to have invoked against him at first only the lesser excommunication, which merely excluded him for 30 days from intercourse with the Jewish community. We are told that he accepted this sentence with a light heart, saying, "Good, they are forcing me to do nothing that I would not have done of my own free will." Probably he was already living outside the Jewish quarter of the city. A fanatic tried to assassinate him, but the weapon only tore Spinoza's coat. On July 24, 1656, the religious and secular authorities of the Jewish community solemnly pronounced from the pulpit of the Portuguese synagogue the full excommunication of Baruch de Spinoza, with all the customary curses and prohibitions. No one was to speak or write to him, or do him any service, or read his writings, or come within the space of 4 cubits distance from him. Mortera went before the Amsterdam officials, notified them of the charges and the excommunication, and asked that Spinoza be expelled from the city. They sentenced Spinoza to an exile of some months. He went to the nearby village of Ouderkerk, but soon returned to Amsterdam. His knowledge of Hebrew won him several friends in a little circle of students led by Lodewijk Meyer and Simon de Vries. Meyer had degrees in philosophy and medicine. In 1666 he published Philosophiae Sacrae Scripturae Interpres, which subordinated the Bible to reason. It may have reflected or influenced the views of Spinoza. De Vries, a prosperous merchant, was so fond of Spinoza that he wished to give him 2,000 florins. Spinoza refused to take them. When de Vries neared death in 1667, he proposed, being unmarried, to make Spinoza his heir. Spinoza persuaded him to leave the entire estate to a brother. The gratified brother offered him an annuity of 500 florins. Spinoza accepted 300. Another Amsterdam friend, Johann Baumeister, wrote to Spinoza, "Love me, for I love you with all my heart." Next to philosophy, friendship was the chief support of Spinoza's life. In one of his letters he wrote, "Of all the things that are beyond my power, I value nothing more highly than to be allowed the honor of entering into bonds of friendship with people who sincerely love truth. For of things beyond our power, I believe there is nothing in the world which we can love with tranquillity except such men." He was not quite a recluse, nor an ascetic. He approved good food and drink, the enjoyment of beauty and growing plants, the hearing of music, visits to the theater. It was on such a visit that the attempt had been made to kill him. He had still to fear attack. On his signet ring was one word, caute, carefully. But far more than amusements, more even than friendship, he loved privacy and study and the peace of a simple life. According to Bayle, it was because the visits of his friends too much interrupted his speculations that Spinoza in 1660 left Amsterdam to live in the quiet village of Rheinsberg, town on the Rhine, 6 miles from Leyden. The Collegians, a Mennonite sect resembling the Quakers, made their headquarters there, and Spinoza found welcome in one of their families. In that modest dwelling, now preserved as the Spinoza Huis, the philosopher wrote several minor works and Book I of the Ethics. He composed in 1662 a short treatise on God, man, and his well-being, but this was largely a reflection of Descartes. More interesting is the fragment De Intellectus Emendatione, on the improvement of the intellect, which was set aside unfinished in that same year. Within its 40 pages, we get a preview of Spinoza's philosophy. We feel the loneliness of the outcast in its first sentences. After experience had taught me that all things that frequently take place in ordinary life are vain and futile, when I saw that all the things I feared, and which feared me, had nothing good or bad in them, save in so far as the mind was affected by them, I determined at last to inquire whether there might be anything which might be truly good and able to communicate its goodness, and by which the mind might be affected to the exclusion of all other things. He felt that riches could not do this, nor fame, honor, nor the pleasures of the flesh, libido. Turmoil and grief are too often mingled with these delights. Only the love towards a thing eternal and infinite feeds the mind with pleasure, free from all pain. This could have been written by Thomas à Kempis or Jacob Boehme, and indeed there always remained in Spinoza a note and mood of mysticism that may have come to him from the Kabbalah and now found nourishment in his solitude. The eternal and infinite good which he had in mind could be termed God, but only in Spinoza's later definition of God as one with nature and its creative powers and its laws. The greatest good, says the Emendatione, is the knowledge of the union which the mind has with the whole of nature. The more the mind understands the order of nature, the more easily it will be able to liberate itself from useless things. Here is Spinoza's first phrasing of the intellectual love of God, the reconciliation of the individual with the nature of things and the laws of the universe. This eloquent little treatise states also the aim of Spinoza's thinking and his understanding of science and philosophy. I wish to direct all sciences in one direction or to one end, namely, to attain the greatest possible human perfection, and thus everything in the sciences that does not promote this endeavor must be rejected as useless. Here is quite a different strain from that which we heard in Francis Bacon. The progress of the sciences is a delusion if they merely increase man's power over things without improving his character and desires. That is why the chef-d'oeuvre of modern philosophy will be called ethics, despite its long metaphysical prelude, and why so much of it will analyze the bondage of man to desire and his liberation through reason. 2. Theology and Politics. The circle of gentlemen students whom Spinoza had left behind in Amsterdam heard that he had begun, for a pupil in Rheinsberg, a geometrical version of Descartes' Principia Philosophiae. They importuned him to complete it and send it to them. He did, and they financed its publication in 1663 as Renati Descartes Principia Philosophiae More Geometrico Demonstrata. We need note only 3 things about it: that it expressed Descartes' views, for example on free will, not Spinoza's; that it was the only book of Spinoza's printed in his lifetime over his own name; and that in an appended fragment, Cogitata Metaphysica, he suggested that time was not an objective reality, but a mode of thinking. This is one of several Kantian elements in Spinoza's philosophy. In Rheinsberg he made some new friends. The great anatomist Steno became acquainted with him there. Henry Oldenburg of the Royal Society came to Leyden in 1661, went out of his way to visit Spinoza, and was deeply impressed. Returning to London, he began a long correspondence with the unprinted but already famous philosopher. Another Rheinsberg friend, Adrian Courbach, was summoned before an Amsterdam court in 1668, charged with intemperate opposition to the prevailing theology. One magistrate sought to implicate Spinoza as the source of Courbach's heresies. Courbach denied this, and Spinoza was spared. But the young heretic was sentenced to 10 years in prison, where he died after he had served 15 months of his term. We can understand why Spinoza did not rush into print. In June 1663 he moved to Voorburg, near The Hague. For 6 years he lived in the home of an artist, still polishing lenses and composing the Ethics. The desperate defensive war of the United Provinces against Louis XIV frightened the Dutch government into tighter restrictions on the expression of ideas. Nevertheless, Spinoza published anonymously in 1670 a treatise on theology and politics that became a milestone in biblical criticism. The title page of this Tractatus Theologico-Politicus stated the purpose: to set forth that freedom of thought and speech not only may, without prejudice to piety and the public peace, be granted, but that also it may not, without danger to piety and the public peace, be withheld. Spinoza disclaimed atheism, supported the fundamentals of religious belief, but undertook to show the human fallibility of those scriptures upon which the Calvinist clergy based their theology and intolerance. The clergy in Holland were using their influence and their biblical texts to oppose the party led by the De Witts, which favored liberal thought and negotiations for peace, and Spinoza was warmly devoted to that party and to Jan de Witt. As I marked the fierce controversies of philosophers raging in church and state, the source of bitter hatred and dissension, I determined to examine the Bible afresh in a careful, impartial, and unfettered spirit, making no assumptions concerning it and attributing to it no doctrines which I do not find clearly therein set down. With these precautions I constructed a method of scriptural interpretation. He noted and illustrated the difficulty of understanding the Hebrew of the Old Testament. The Masoretic text, which filled in the vowels and accents omitted by the original writers, was partly guesswork and could hardly give us an indisputable prototype. He profited much in the earlier chapters of this treatise from Maimonides' Guide to the Perplexed. He followed Abraham ibn Ezra and others in questioning the Mosaic authorship of the Pentateuch. He denied that Joshua had composed the book of Joshua. He ascribed the historical books of the Old Testament to the priest-scribe Ezra of the 5th century B.C. The book of Job, he thought, was a Gentile production translated into Hebrew. Not all these conclusions have been accepted by later research, but they were a brave advance toward understanding the composition of the Bible, and they preceded by 8 years the more scholarly Critique du Vieux Testament from 1678 of Richard Simon. Spinoza pointed out that in several instances the same story or passage was repeated in different places in the Bible, sometimes in the same words, sometimes in divergent versions. The one case suggesting common borrowing from an earlier manuscript, the other raising the question as to which account was the Word of God. There were chronological impossibilities and contradictions. In his epistle to the Romans, chapter 3, verses 20 to 28, Paul taught that man can be saved only by faith, not by works. The epistle of the Apostle James, chapter 2, verse 24, taught precisely the opposite, which was God's view and word. Such diverse texts, the philosopher pointed out, have generated bitterest, even murderous quarrels among theologians, not the good conduct that a religion should inspire. Were the Old Testament prophets the voice of God? Evidently they were not ahead of the knowledge shared by the educated classes of their time. Joshua, for example, took it for granted that the sun, until he stopped it, revolved around the earth. The prophets excelled not in learning, but in intensity of imagination, enthusiasm, and feeling. They were great poets and orators. They may have been divinely inspired, but if so, it was by a process that Spinoza confessed himself unable to understand. Perhaps they dreamed that they saw God, and they may have believed in the reality of their dream. So we read of Abimelech that God said unto him in a dream, Genesis chapter 20, verse 6. The divine element in the prophets was not their prophecies, but their virtuous lives, and the theme of their preaching was that religion lies in good conduct, not in sedulous ritual. Were the miracles recorded in the Bible real interruptions of the normal course of nature? Did the sins of men bring down fire and flood, and did the prayers of men give fertility to the earth? Such stories, Spinoza suggested, were used by the scriptural authors to reach the understanding of simple men and move them to virtue or devotion. We must not take them literally. When, therefore, the Bible says that the earth is barren because of men's sins, or that the blind were healed by faith, we ought to take no more notice than when it says that God is angry at men's sins, that he is sad, that he repents of the good he has promised or done, or that on seeing a sign he remembers something he had promised. These and similar expressions are either thrown out poetically or related according to the opinions and prejudices of the writer. We may be absolutely certain that every event which is truly described in Scripture necessarily happened, like everything else, according to natural law. And if anything is there set down which can be proved in set terms to contravene the order of nature, or not to be deducible therefrom, we must believe it to have been foisted into the sacred writings by irreligious hands. For whatsoever is contrary to nature is contrary to reason, and whatsoever is contrary to reason is absurd. This was The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant, Part 2, continued, Cassette 11, Side 1. In what sense, then, is the Bible the Word of God? Only in this, that it contains a moral code that can form men to virtue. It contains also many things that have led or been adapted to human deviltry. For the generality of men, too obsessed with daily cares to have leisure or capacity for intellectual development, the biblical stories can be a beneficent aid to morality. But the emphasis of religious teaching should always be upon conduct rather than creed. It is a sufficient creed to believe in a God, that is, a supreme being who loves justice and charity, and whose proper worship consists in the practice of justice and love towards one's neighbor. No other doctrine is necessary. Aside from that doctrine, thought should be free. The Bible was not intended to be a textbook of science or philosophy. These are revealed to us in nature, and this natural revelation is the truest and most universal voice of God. Between faith or theology and philosophy there is no connection or affinity. Philosophy has no end in view save truth. Faith looks for nothing but obedience and piety. Faith, therefore, allows the greatest latitude in philosophical speculation, allowing us without blame to think what we like about anything, and only condemning as heretics and schismatics those who teach opinions that tend to produce hatred, anger, and strife. So Spinoza, in his own optimistic variation, renewed Pomponazzi's distinction between two truths, the theological and the philosophical, each of which, though contradictory, may be allowed to the same person in the one case as a citizen, in the other as a philosopher. Spinoza would allow to secular officials the right to compel obedience to the laws. The state, like the individual, has the right of self-preservation. But, he adds, with religion the case is widely different. Since it consists not so much in outward action as in simplicity and truth of character, it stands outside the sphere of law and public authority. Simplicity and truth of character are not produced by the constraint of laws, nor by the authority of the state. No one the whole world over can be forced or legislated into a state of blessedness. The means required for such a consummation are faithful and brotherly admonition, sound education, and, above all, free use of the individual judgment. It is in every man's power to wield the supreme right and authority of free judgment and to explain and interpret religion for himself. The public practice of religion should be subject to state control, for though religion may be a vital force in molding morality, the state must remain supreme in all matters affecting public conduct. Spinoza was as firm an Erastian as Hobbes, and followed him in subordinating the church to the state, but he cautioned his readers, "I speak here only of the outward observances, not of the inward worship." And, probably having Louis XIV in mind, he rose to hot indignation in denouncing the use of religion by the state for purposes contrary to what he conceives as basic religion, justice and benevolence. If in despotic statecraft the supreme and essential mystery be to hoodwink the subjects and to mask the fear which keeps them down with the specious garb of religion, so that men may fight as bravely for slavery as for safety, and count it not shame but highest honor to risk their blood and their lives for the vain glory of a tyrant. Yet in a free state no more mischievous expedient could be planned or attempted. It is wholly repugnant to the general freedom when law enters the domain of speculative thought, and opinions are put on trial and condemned on the same footing as crimes, while those who defend and follow them are sacrificed not to public safety, but to their opponents' hatred and cruelty. If deeds alone could be made the ground of criminal charges, and words were always allowed to pass free, seditions would be divested of every semblance of justification, and would be separated from mere controversy by a hard and fast line. In examining the Scriptures, Spinoza faced the fundamental issue between Christians and Jews. Had Christianity been unfaithful to Christ in rejecting the Mosaic law? In his opinion, that law was intended for the Jews in their own state, and not for other nations, not even for the Jews themselves when living in an alien society. Only the moral laws in the Mosaic Code, like the Ten Commandments, have eternal and universal validity. Some passages in Spinoza's discussion of Judaism reveal a strong resentment of his excommunication and an anxiety to justify his rejection of the synagogue's teachings. But he joined the Jews in hoping for their early restoration to an autonomous Israel. I would go so far as to believe that they may even raise up their state anew, and God may elect them a second time. He made several approaches to Christianity. He apparently read the New Testament with increasing admiration for Christ. He rejected the notion of Christ's physical resurrection from the dead, but he found himself in such sympathy with the preaching of Jesus that he conceded to him a special revelation from God. A man who can by pure intuition comprehend ideas which are neither contained in nor deducible from the foundation of our natural knowledge must necessarily possess a mind far superior to those of his fellow men, nor do I believe that any have been so endowed save Christ. To him the ordinances of God leading to salvation were revealed directly without words or visions, so that God manifested himself to the apostles through the mind of Christ, as he formerly did to Moses through the supernatural voice. In this sense, the voice of Christ, like the voice which Moses heard, may be called the voice of God, and it may be said that the wisdom of God, wisdom more than human, took upon itself in Christ human nature, and that Christ was the way of salvation. I must at this juncture declare that those doctrines which certain churches put forward concerning Christ I neither affirm nor deny, for I freely confess that I do not understand them. Christ communed with God, mind to mind. Thus we may conclude that no one except Christ received the revelation of God without the aid of imagination, whether in words or vision. This olive branch offered to the Christian leaders could not conceal from them that the Tractatus Theologico-Politicus was one of the boldest pronouncements yet made in the conflict between religion and philosophy. Hardly had it appeared when the Church Council of Amsterdam, on June 30th, 1670, protested to the Grand Pensionary of Holland that so heretical a volume should be allowed to circulate in a Christian state. A synod at The Hague petitioned him to ban and confiscate such soul-destroying books. Lay critics joined in the attack upon Spinoza. One called him Satan incarnate. Jean Leclerc described him as the most famous atheist of our time. Lambert van Veldhuizen accused him of craftily introducing atheism, destroying all worship and religion from the very foundation. Luckily for Spinoza, the Grand Pensionary, Jan de Witt, was one of his admirers, who had already conferred upon him a small pension. As long as de Witt lived and ruled, Spinoza could rely on his protection. That was to be for only 2 years. 3. The Philosopher. In May 1670, shortly after the publication of the Tractatus, Spinoza moved to The Hague, perhaps to be nearer to de Witt and other influential friends. For a year he stayed in the house of the widow van Velen. Then he passed to the home of Hendrik van der Speyk on the Pavilionsgracht. This building was bought in 1927 by an international committee and is preserved as the Domus Spinozana. There he remained to the end of his life. He occupied one room on the top floor and slept in a bed that during the day could be folded into the wall. He was sometimes 3 whole months without stepping out of doors, Bayle tells. Perhaps his consumptive lungs made him fearful of the winter damp. But he had many visitors, and, again according to Bayle, he occasionally visited persons of importance to discourse of state affairs, which he understood well. He continued to polish lenses. Christian Huygens commented on their excellence. He kept an account of his expenditures. We learn therefrom that he lived on 4.5 sous per day. His friends insisted on helping him, for they must have seen that his confinement to the house and the dust from his lens polishing were aggravating his constitutional ailment. The protection that he received from Jan de Witt ended when a mob assassinated both the de Witt brothers in the streets of The Hague on August 20th, 1672. Hearing of the murder, Spinoza wished to go out and denounce the crowd to its face as ultimi barbarorum, the lowest barbarians, but his host locked the door and prevented him from leaving the house. Jan de Witt's will left Spinoza an annuity of 200 francs. After the death of de Witt, the civil power fell to Prince William Henry, who needed the support of the Calvinist clergy. When a second edition of the Tractatus Theologico-Politicus appeared in 1674, the Prince and the Council of Holland issued a decree prohibiting the sale of the book. And in 1675 the Calvinist consistory of The Hague published a proclamation bidding all citizens to report at once any attempt to print any writing by Spinoza. Between 1650 and 1680 there were some 50 edicts by church authorities against the reading or circulation of the philosopher's works. Perhaps such prohibitions shared in spreading his fame into Germany, England, and France. On February 16, 1673, Johann Fabricius, professor of the University of Heidelberg, wrote to the very acute and renowned philosopher Benedictus de Spinoza, in the name of the liberal elector of the Palatinate, Prince Charles Louis. His Serene Highness has commanded me to write to you and ask whether you are willing to accept an ordinary professorship of philosophy in his illustrious university. You will be paid the annual salary which the ordinary professors enjoy today. You will not find elsewhere a prince more favorable to distinguished geniuses, among whom he reckons you. You will have the utmost freedom of philosophizing, which he believes you will not misuse to disturb the publicly established religion. Spinoza replied on March 30th, Most Honorable Sir, if I had ever experienced a wish to take on a professorship in any faculty, I could have desired no other than that which is offered me through you by His Serene Highness the Elector Palatine. Since, however, it was never my intention to give public instruction, I cannot be induced to embrace this glorious opportunity. For first, I think that if I want to find time for instructing youth, then I must desist from developing my philosophy. Secondly, I do not know within what limits that freedom of philosophizing ought to be confined in order to avoid the appearance of wishing to disturb the publicly established religion. For schisms arise not so much from an ardent love of religion as from men's various dispositions or the love of contradiction. I have already experienced these things while leading a private and solitary life. Much more, then, are they to be feared after I shall have risen to this degree of dignity. Thus you see, most honored sir, that I am not holding back in the hope of some better fortune, but from love of peace. Spinoza was fortunate in his refusal, for in the following year Turenne devastated the Palatinate, and the university was closed. In May 1673, amid the invasion of the United Provinces by a French army, an invitation came to Spinoza from a colonel in that army to visit the great Condé at Utrecht. Spinoza consulted the Dutch authorities, who may have seen in the invitation an opportunity to open negotiations for a desperately needed truce. Both sides gave him safe conducts, and the philosopher made his way to Utrecht. Meanwhile, Condé had been sent elsewhere by Louis XIV. He sent word, according to Locke, asking Spinoza to wait for him. But after several weeks another message said that he was indefinitely delayed. It was apparently at this time that Maréchal de Luxembourg advised Spinoza to dedicate a book to Louis, assuring him of a liberal response from the king. Nothing came of the proposal. Spinoza returned to The Hague to find that many citizens suspected him of treason. A hostile crowd gathered about his house, shouting insults and throwing stones. "Do not be troubled," he told his landlord. "I am innocent, and there are many in high places who well know why I went to Utrecht. As soon as you hear any disturbance at your door, I will go out to the people, even if they should treat me as they treated the good De Witt. I am an honest Republican, and the welfare of the Republic is my aim." His host would not let him go, and the crowd dispersed. He was now 41. A portrait in the Domus Spinozana at The Hague shows him as a fine type of Sephardic Jew, with flowing black hair, heavy eyebrows, black, bright, and slightly somber eyes, a long, straight nose, altogether a rather handsome face, if only in comparison with Halse's Descartes. He was extremely neat in his appearance, reported Locke, and never left his house without wearing clothes that distinguished the gentleman from the pedant. His manners were grave but amiable. Oldenburg noted his solid learning combined with humanity and refinement. Those who have been acquainted with Spinoza, wrote Bayle, all say that he was sociable, affable, honest, friendly, and a good moral man. To his neighbors he spoke no heresy. On the contrary, he encouraged them to continue their church attendance, and occasionally he accompanied them to hear a sermon. More than any other modern philosopher, he achieved a tranquility born of self-control. He rarely replied to criticism. He dealt with ideas rather than personalities. Despite his determinism, his uprooting from his people, and his illness, he was far from being a pessimist. "Act well," he said, "and rejoice." To know the worst and believe the best might have been the motto of his thought. Friends and admirers made a path to his door. Walter von Tschirnhaus persuaded him to let him see the manuscript of the Ethics. "I beg you," wrote the mathematician physicist, "to help me with your usual courtesy wherever I do not rightly grasp your meaning." Probably through this eager student, Leibniz won access to Spinoza in 1676, and presumably to the still unpublished masterpiece. The surviving members of Dr. Meyer's circle in Amsterdam came to see him, or were among his correspondents. His letters to and from European scholars shed unexpected light upon the intellectual climate of the time. Hugo Boxall repeatedly urged him to admit the reality of ghosts. In 1675, the anatomist Steno sent from Florence a touching appeal for Spinoza's conversion to Catholicism. "If you wish, I shall willingly take upon myself the task of showing you wherein your teachings are behind ours, although I should wish that you would offer to God a refutation of your own errors, in order that, if your first writings have turned aside 1,000 souls from the true knowledge of God, the recantation of them, reinforced by your own example, may lead back to him 1,000,000 with you as with another Augustine. I pray with all my heart that this grace may be yours. Farewell." The fascination of Catholicism captured also Albert Berg, son of Spinoza's friend Conrad Berg, Treasurer General of the United Provinces. Albert, like Steno, had become a convert while traveling in Italy. In September 1675, he wrote to Spinoza not so much soliciting as challenging him to accept the Roman Catholic faith. "How do you know that your philosophy is the best among all those which have ever been taught in the world, or are actually taught now, or ever will be taught in the future? Have you examined all those philosophies, ancient as well as modern, which are taught here and in India and everywhere throughout the world? And even if you have duly examined them, how do you know that you have chosen the best? If, however, you do not believe in Christ, you are more wretched than I can say, but the remedy is easy. Return from your sins and realize the fatal arrogance of your wretched and insane reasoning. Will you, you wretched little man, vile worm of the earth, dare in your unspeakable blasphemy to put yourself above the incarnate infinite wisdom? From your principles you will not explain thoroughly even one of those things which are accomplished in witchcraft, nor will you be able to explain any of the stupendous phenomena among those who are possessed by demons, of all of which I have myself seen various instances and have heard most certain evidence." Spinoza, in part, replied in December 1675, "What I could scarcely believe when it was related me by others, I at last understand from your letter. That is, that not only have you become a member of the Roman Church, but that you are a very keen champion of it, and have already learned to curse and rage petulantly against your opponents. I had not intended to reply to your letter, but certain friends who with me had formed great hopes for you from your natural talent earnestly prayed me not to fail in the duty of a friend, and to think rather of what you recently were than of what you are now. I have been induced by these arguments to write to you these words, earnestly begging you to be kind enough to read them with a calm mind. I will not here recount the vices of priests and popes to turn you away from them as the opponents of the Roman Church are wont to do, for they usually publish these things from ill-feeling, and in order to annoy rather than instruct. Indeed, I will admit that there are found more men of great learning and of an upright life in the Roman than in any other Christian church. For since there are more members of this church, there will also be found in it more men of every condition. In every church there are many very honest men who worship God with justice and charity, for justice and charity are the surest sign of the true Catholic faith, and wherever these are found, there Christ really is, and where they are lacking, there Christ also is not. For by the Spirit of Christ alone can we be led to the love of justice and charity. If you had been willing duly to ponder these facts within yourself, you would not have been lost, nor would you have caused bitter sorrow to your parents. You ask me how I know that my philosophy is the best among all those which have ever been taught in the world, or are taught now, or will be taught in the future. This, indeed, I can ask you with far better right, for I do not presume that I have found the best philosophy, but I know that I think it the true one. But you who presume that you have at last found the best religion, or rather the best men, to whom you have given over your credulity, how do you know that they are the best among all those who have taught other religions, or are teaching them now, or will teach them in the future? Have you examined all those religions, both ancient and modern, which are taught here and in India and everywhere throughout the world? And even if you have duly examined them, how do you know that you have chosen the best? Do you regard it as arrogance and pride because I use my reason and acquiesce in that true word of God which is in the mind and can never be depraved or corrupted? Away with this deadly superstition. Acknowledge the reason which God has given you, and cultivate it, if you would not be numbered among the brutes. If you will examine the histories of the Church, of which I see you are most ignorant, in order to see how false are many of the pontifical traditions, and by what arts the Roman pontiffs, 600 years after the birth of Christ, obtained sovereignty over the Church, I doubt not that you will at last come to your senses. That this may be so, I wish you from my heart. Farewell. Berg joined the Franciscan order and died in a monastery in Rome. Most of Spinoza's extant correspondence was with Oldenburg. We are surprised to find that much of it deals with science, that Spinoza carried on experiments in physics and chemistry, and that his letters are illustrated with many diagrams. This correspondence was interrupted in 1665. Oldenburg was arrested in 1667 and was held in the Tower of London on suspicion of dealing with a foreign power. On his release he turned to religion, and when he resumed correspondence with Spinoza in 1675, he joined in the effort to win him back to some form of orthodox Christianity. He begged him to take the story of Christ's resurrection not allegorically, but literally. The whole Christian religion and its truth, he thought, rests on this article of the resurrection, and if it is taken away, the mission of Christ and his heavenly teaching collapse. He finally gave up Spinoza as a lost soul, and discontinued the correspondence in 1677. All through the years from 1662, Spinoza had been working on the Ethics. As early as April 1662, he wrote to Oldenburg that he was thinking of publishing it, but I am naturally afraid lest the theologians take offense and with their usual hatred attack me, who utterly loathe quarrels. Oldenburg urged him to publish, however much the theological quacks may growl, but Spinoza still hesitated. He allowed some friends to read parts of the manuscript, and probably profited from their comments, for he repeatedly revised the treatise. The clamor aroused by the Tractatus Theologico-Politicus justified his caution. The murder of the De Witts and the suspicions directed against him after his visit to the French army further troubled him, and it was not till 1675 that he made another move to put the Ethics into print. He reported the results to Oldenburg. At the time when I received your letter of 22nd July, I was setting out for Amsterdam with the intention of getting printed the work about which I have written to you. While I was engaged in this matter, a rumor was spread everywhere that a book of mine about God was in the press, and that in it I endeavored to show that there is no God. This rumor was believed by many. Therefore, certain theologians seized the opportunity of bringing complaints against me before the prince and the magistrates. When I heard all this, I decided to postpone the publication I was preparing. He put the manuscript away and turned to writing a treatise on the state, Tractatus Politicus, but death came upon him before he could finish it. On February 6, 1677, Georg Hermann Schuler, a young physician, wrote to Leibniz, I fear that Mr. Benedictus Spinoza will soon leave us, as the consumption seems to grow worse every day. 2 weeks later, while the rest of the household were absent, the philosopher entered upon his final suffering. Schuler alone, not Meyer as formerly supposed, was with him at the time. Spinoza left instructions that his modest belongings be sold to pay his debts, and that such manuscripts as he had not burned be published anonymously. He died on February 20th, 1677, without any religious ministrations. He was buried in a cemetery of the new church of The Hague, near the tomb of Jan de Witt. The manuscripts, chiefly the Ethics, the Tractatus Politicus, and the treatise on the improvement of the intellect, were prepared for the press by Meyer, Schuler, and others, and were printed at Amsterdam toward the end of 1677. And so we come at last to the book into which Spinoza had poured his life and solitary soul. 4. God. He called it Ethica Ordine Geometrico Demonstrata, first because he thought of all philosophy as a preparation for right conduct and wise living, and second because, like Descartes, he envied the intellectual asceticism and logical sequence of geometry. He hoped to build, on the model of Euclid, a structure of reasoning in which every step would follow logically from preceding proofs, and these would at last be irrefutably derived from axioms universally received. He knew that this was an ideal, and he could hardly have supposed it proof against error, for he had by a similar method expounded the Cartesian philosophy, with which he did not agree. At least the geometrical scheme would make for clarity. It would check the confusion of reason by passion and the concealment of sophistry with eloquence. He proposed to discuss the behavior of men, and even the nature of God, as calmly and objectively as if he were dealing with circles, triangles, and squares. His procedure was not faultless, but it led him to rear an edifice of reason imposing in its architectural grandeur and unity. The method is deductive, and would have been frowned upon by Francis Bacon, but it claimed to be in harmony with all experience. Spinoza began with definitions, mostly taken from medieval philosophy. The words he used have changed their meaning since his day, and now some of them obscure his thought. The third definition is fundamental. I understand substance to be that which is in itself and is conceived through itself. I mean that the conception of which does not depend upon the conception of another thing from which it must be formed. He does not mean substance in the modern sense of material constituents. Our use of the word to mean essence or basic significance comes closer to his intent. If we take literally his Latin term substantia, it indicates that which stands under, underlies, supports. In his correspondence, he speaks of substance or being. That is, he identifies substance with existence or reality. Hence he can say that existence appertains to the nature of substance, that in substance, essence and existence are one. We may conclude that in Spinoza, substance means the essential reality underlying all things. This reality is perceived by us in two forms, as extension or matter, and as thought or mind. These two are attributes of substance, not as qualities residing in it, but as the same reality perceived externally by our senses as matter, and internally by our consciousness as thought. Spinoza is a complete monist. These two aspects of reality, matter and thought, are not distinct and separate entities. They are two sides, the outside and the inside, of one reality. So are body and mind, so is physiological action and the corresponding mental state. Strictly speaking, Spinoza, so far from being a materialist, is an idealist. He defines an attribute as that which the intellect apprehends of substance as constituting its essence. He admits, long before Berkeley was born, that we know reality, whether as matter or as thought, only through perception or idea. He believes that reality expresses itself in endless aspects through an infinite number of attributes, of which we imperfect organisms perceive only two. So far, then, substance or reality is that which appears to us as matter or mind. Substance and its attributes are one. Reality is a union of matter and mind, and these are distinct only in our manner of perceiving substance. To put it not quite Spinozistically, matter is reality externally perceived. Mind is reality internally perceived. If we could perceive all things in the same double way, externally and internally, as we perceive ourselves, we should, Spinoza believes, find that all things are in some manner animate, omnia quomodo animata. There is some form or degree of mind or life in everything. Substance is always active, matter is always in motion. Mind is always perceiving or feeling or thinking or desiring or imagining or remembering, awake or in sleep. The world is in every part of it alive. God, in Spinoza, is identical with substance. He is the reality underlying and uniting matter and mind. God is not identical with matter, therefore Spinoza is not a materialist, but matter is an inherent and essential attribute or aspect of God. Here one of Spinoza's youthful heresies reappears. God is not identical with mind, therefore Spinoza is not a spiritualist, but mind is an inherent and essential attribute or aspect of God. God and substance are identical with nature and the totality of all being. Therefore Spinoza is a pantheist. Nature has two aspects. As the power of motion in bodies and as the power of generation, growth, and feeling in organisms, it is natura naturans, nature creating or giving birth. As the sum of all individual things, of all bodies, plants, animals, and men, it is natura naturata, generated or created nature. These individual entities in generated nature are called by Spinoza modi, modes, transient modifications and embodiments of substance, reality, matter-mind, God. They are part of substance, but in our perception we distinguish them as passing, fleeting forms of an eternal whole. This stone, this tree, this man, this planet, this star, all this marvelous kaleidoscope of appearing and dissolving individual forms, constitute that temporal order which, On the Improvement of the Intellect, Spinoza contrasted with the eternal order that in a stricter sense is the underlying reality and God. By series of causes and real entities, I do not understand a series of individual mutable things, but the series of fixed and eternal things. For it would be impossible for human weakness to follow up the series of individual mutable things, every stone, every flower, every man. Their existence has no connection with their essence. They may exist, but need not, or is not an eternal truth. This essence is only to be sought from fixed and eternal things, and from the laws inscribed in those things as in their true codes, according to which all individual things are made and arranged. Nay, these individual and mutable things depend so intimately and essentially, so to speak, on these fixed ones, that without them they can neither exist nor be conceived. So a single specific triangle is a mode. It may, but need not exist. But if it does, it will have to obey the laws, and will have the powers of the triangle in general. A specific man is a mode. He may or may not exist, but if he does, he will share in the essence and power of matter-mind, and will have to obey the laws that govern the operations of bodies and thoughts. These powers and laws constitute the order of nature as natura naturans. They constitute, in theological terms, the will of God. The modes of matter in their totality are the body of God. The modes of mind in their totality are the mind of God. Substance or reality in all its modes and attributes is God. Whatever is in God. Spinoza agrees with the scholastic philosophers that in God essence and existence are one. His existence is involved in our conception of his essence, for he conceives God as all existence itself. He agrees with the scholastics that God is causa sui, self-caused, for there is nothing outside him. He agrees with the scholastics that we can know the existence of God, but not his real nature in all his attributes. He agrees with St. Thomas Aquinas that to apply the masculine pronouns to God is absurd, but convenient. He agrees with Maimonides that most of the qualities we ascribe to God are conceived by weak analogy with human qualities. God is described as the lawgiver or prince, and styled just, merciful, etc., merely in concession to popular understanding and the imperfection of popular knowledge. God is free from passions, nor is he affected with any emotion of joy or sorrow. Those who confuse divine with human nature easily attribute human passions to God, especially if they do not know how passions are produced in the mind. God is not a person, for that means a particular and finite mind, but God is the total of all the mind, all the animation, sensitivity, and thought, as well as of all the matter in existence. The human mind is part of a certain infinite intellect, as in the Aristotelian Alexandrian tradition. But if intellect and will appertain to the eternal essence of God, something far else must be understood by these two attributes than what is commonly understood by men. The actual intellect, together with will, desire, love, etc., must be referred to the natura naturata, not to the natura naturans. That is, individual minds with their desires, emotions, and volitions are modes or modifications, contained in God as the totality of things, but not pertaining to him as the law and life of the world. There is will in God, but only in the sense of the laws operating everywhere. His will is law. God is not a bearded patriarch sitting on a cloud and ruling the universe. He is the indwelling, not the transient, cause of all things. There is no creation except in the sense that the infinite reality, matter-mind, is ever taking new individual forms or modes. God is not in any one place, but is everywhere according to his essence. Indeed, the word cause is out of place here. God is the universal cause, not in the sense of a cause preceding its effect, but only in the sense that the behavior of anything follows necessarily from its nature. God is the cause of all events in the same way that the nature of a triangle is the cause of its properties and behavior. God is free only in the sense that he is not subject to any external cause or force, and is determined only by his own essence or nature. But he does not act from freedom of will, All his actions are determined by his essence, which is the same as to say that all events are determined by the inherent nature and properties of things. There is no design in nature in the sense that God desires some end. He has no desires or designs, except as the totality contains all the desires and designs of all modes and therefore of all organisms. In nature there are only effects following inevitably from antecedent causes and inherent properties. There are no miracles, for the will of God and the fixed and unchanged order of nature are one. Any break in the chain of natural events would be a self-contradiction. Man is only a small part of the universe. Nature is neutral as between man and other forms. We must not apply to nature or to God such words as good or evil, beautiful or ugly. These are subjective terms, as much so as hot or cold. They are determined by the contribution of the external world to our advantage or displeasure. The perfection of things is to be judged by their nature and power alone, nor are they more or less perfect because they delight or offend the human senses, or because they are beneficial or prejudicial to human nature. If, therefore, anything in nature seems to us ridiculous, absurd, or evil, it is because we know only in part, and are almost entirely ignorant of, the order and interdependence of nature as a whole, and also because we want everything to be arranged according to the dictates of our human reason. In reality, that which reason considers evil is not evil in respect to the order and laws of nature as a whole, but only in respect to the laws of our reason. Likewise, there is no beauty or ugliness in nature. Beauty is not so much a quality of the object beheld as an effect in him who beholds it. If our sight were longer or shorter, if our constitutions were different, what we now think beautiful, we should think ugly. The most beautiful hand, seen through the microscope, will appear horrible. I do not attribute to nature either beauty or deformity, order or confusion. Only in relation to our imagination can things be called beautiful or ugly, well-formed or confused. Order is objective only in the sense that all things cohere in one system of law, but in that order a destructive storm is as natural as the splendor of a sunset or the sublimity of the sea. Are we justified on the basis of this theology in calling Spinoza an atheist? We have seen that he was not a materialist, for he did not identify God with matter. He says quite clearly that those who think that the Tractatus, meaning the Tractatus Theologico-Politicus, rests on the identification of God with nature, taking nature in the sense of a certain mass of corporeal matter, are entirely wrong. He conceived God as mind as well as matter, and he did not reduce mind to matter. He acknowledged that mind is the only reality directly known. He thought that something akin to mind is mingled with all matter. In this respect he was a panpsychist. He was a pantheist, seeing God in all things and all things in God. Bayle, Hume, and others considered him an atheist, and this term might seem justified by Spinoza's denial of feeling, desire, or purpose in God. He himself, however, objected to the opinion which the common people have of me, who do not cease to accuse me falsely of atheism. Apparently he felt that his ascription of mind and intelligence to God absolved him from the charge of atheism, and it must be admitted that he spoke repeatedly of his God in terms of religious reverence, often in terms quite consonant with the conception of God in Maimonides or Aquinas. Novalis would call Spinoza der Gott betrunkene Mensch, the God-intoxicated man. Actually, he was intoxicated with the whole order of nature, which in its eternal consistency and movement seemed to him admirable and sublime. And in Book 1 of the Ethics he wrote both a system of theology and the metaphysics of science. In the world of law he felt a divine revelation greater than any book, however noble and beautiful. The scientist who studies that law, even in its pettiest and most prosaic detail, is deciphering that revelation, for the more we understand individual objects, the more we understand God. This sentence struck Goethe as one of the profoundest in all literature. It seemed to Spinoza that he had honestly accepted and met the challenge implicit in Copernicus, to reconceive deity in terms worthy of the universe now progressively revealed. In Spinoza, science and religion are no longer in conflict. They are one. 5. Mind. Next to the nature and operation of the cosmos, the greatest puzzle in philosophy and science is the nature and operation of the mind. If it is difficult to reconcile an omnipotent benevolence with the neutrality of nature and the fatality of suffering, it seems just as hard to understand how an apparently external and material object in space can generate an apparently immaterial and spaceless idea, or how an idea in the mind can become emotion in the body, or how idea can contemplate idea in the mystery of consciousness. Spinoza tries to avoid some of these problems by rejecting Descartes' assumption that body and mind are two different substances. Body and mind, he believes, are one and the same reality, perceived under two different aspects or attributes, just as extension and thought are one in God. There is then no problem of how body acts upon mind or vice versa. Every action is the simultaneous and unified operation of both body and mind. Spinoza defines mind as the idea of the body. That is, it is the psychological, not necessarily the conscious, correlate or accompaniment of a physiological process. The mind is the body felt from within. The body is the mind seen from without. A mental state is the inside or internal aspect of bodily action. An act of will is the mental accompaniment of a bodily desire that is moving into physical expression. There is no action of the will upon the body. There is a single action of the psychophysical, mental, material organism. The will is not the cause, it is the consciousness of the action. The decision of the mind and the desire and determination of the body are one and the same thing, which, when considered under the attribute of thought, we call a decision, and which, when considered under the attribute of extension and deduced from the laws of motion and rest, is called a determination, meaning a finished action. Hence, the order of the actions and passions, or movements, of our body are simultaneous in nature with the order and passions of the mind. In all cases of the supposed interaction of mind and body, the actual process is not the interplay of two distinct realities, substances, or agents, but the single action of one substance, which, seen from the outside, we call body, and which, seen from within, we call mind. To every process in the body there is a corresponding process in the mind. Nothing can happen in the body which is not perceived by the mind. But this mental correlate need not be a thought, it may be a feeling, and it need not be conscious, so a sleepwalker performs any number of actions while he is unconscious. This theory has been called psychophysical parallelism. However, it supposes parallel processes not in two different entities, but in one psychophysical unity doubly seen. On this basis, Spinoza proceeds to a mechanistic description of the knowledge process. Probably following Hobbes, he defines sensation, memory, and imagination in physical terms. He takes it as evident that most knowledge originates in impressions made upon us by external objects. But he admits to the idealist that the human mind perceives no external body as actually existing save through ideas of modifications in its body. Perception and reason, two forms of knowledge, are derived from sensation. But a third and higher form, intuitive knowledge, is derived, Spinoza thinks, not from sensation, but from a clear, distinct, immediate, and comprehensive awareness of an idea or event as part of a universal system of law. Anticipating Locke and Hume, Spinoza rejects the notion that the mind is an agent or entity possessing ideas. Mind is a general or abstract term for the succession of perceptions, memories, imaginations, feelings, and other mental states. The idea of the mind and the mind itself, at any moment, are one and the same thing. Nor are there any distinct faculties, such as intellect or will. These also are abstract terms for the sum of cognitions or volitions. Intellect or will have reference in the same manner to this or that idea, or to this or that volition, as stoniness to this or that stone, or man to Peter or Paul. Neither do idea and volition differ. A volition or act of will is merely an idea that has affirmed itself. That is, has lasted long enough to complete itself in an action, as ideas, if unimpeded, automatically do. The decision of the mind is nothing but the affirmation which the idea necessarily involves insofar as it is an idea. Will and intellect are one and the same thing. From another standpoint, what we call will is simply the sum and play of desires. This book is continued at this point on the other side of this cassette. Please reverse or turn the cassette over now. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant. Part 2, continued. Cassette 11, Side 2. From another standpoint, what we call will is simply the sum and play of desires. By desire, I understand all the efforts, impulses, appetites, and volitions of a man, which not infrequently are so opposed to one another that he is drawn hither and thither, and knows not where to turn. Deliberation is the alternating domination of body and thought by conflicting desires. It ends when one desire proves powerful enough to maintain its corresponding mental state long enough to pass into action. Obviously, says Spinoza, there is no free will. The will at any moment is just the strongest desire. We are free insofar as we are allowed to express our nature or our desires without external hindrance. We are not free to choose our own nature or our desires. We are our desires. There is in no mind absolute or free will, but the mind is determined for willing this or that by a cause which is determined in its turn by another cause, and this again by another, and so on to infinity. Men think themselves free because they are conscious of their volitions and desires, but are ignorant of the causes by which they are led to wish and desire. It is as if a stone flung through space should think it is moving and falling of its own will. Possibly the Calvinist fatalism in the climate of opinion that Descartes and Spinoza lived in as residents of Holland may have shared with the Galilean mechanics — Newton's Principia had not yet appeared — in molding the mechanistic theory in Descartes and the determinist psychology in Spinoza. Determinism is predestinarianism without theology. It substitutes the primeval vortex or nebula for God. Spinoza followed the logic of mechanism to its bitter end. He did not, like Descartes, confine it to bodies and animals. He applied it to minds as well, as he had to, since to him mind and body were one. He concluded that the body is a machine, but he denied that determinism makes morality useless or insincere. The exhortations of the moralist, the ideals of the philosophers, the stigma of public condemnation, and the penalties of the courts are still valuable and necessary. They enter into the heritage and experience of the growing individual, and therefore into the factors that form his desires and determine his will. 6. Man. Into this apparently static philosophy, Spinoza inserts two dynamic elements. First and generally, that matter and mind are everywhere united, that all things are animated, that they have in them something akin to what in ourselves we call mind or will. Second, and specifically, that this vital element includes in everything a conatus sese preservandi, an effort at self-preservation. Everything, insofar as it is in itself, endeavors to preserve its own being, and the power or endeavor of anything to persist in its own being is nothing else than the essence of that thing. Like the scholastic philosophers who said that esse est agere, to be is to act, and that God is actus purus, or pure activity, like Schopenhauer, who saw in will the essence of all things, like those modern physicists who reduce matter to energy, Spinoza defines the essence of each being through its powers of action. The power of God is the same as his essence. In this aspect, God is energy, and energy might be named, in addition to matter and mind, as a third attribute which we perceive as constituting the essence of substance or reality. Spinoza follows Hobbes in ranking entities according to their capacity for action and effectiveness. The perfection of things is estimated solely from their nature and power. But in Spinoza, perfect means per factum, or complete. Consequently, he defines virtue as a power of acting or doing. By virtue and power, or potentia, I understand the same thing. But we shall see that this potency means power over ourselves, perhaps even more than power over others. The more each one seeks what is useful to him, that is, the more he endeavors and is able to preserve his being, the more he is endowed with virtue. The endeavor to preserve oneself is the only basis of virtue. In Spinoza, virtue is biological, almost Darwinian. It is any quality that makes for survival. In this sense, at least, virtue is its own reward. It is to be desired for its own sake, nor is there anything more excellent or more useful to us, for the sake of which virtue ought to be desired. As the endeavor for self-preservation, the struggle for existence, is the active essence of anything, all motives derive from it and are ultimately self-seeking. Since reason postulates nothing against nature, it postulates, therefore, that each man should love himself and seek what is useful to him, what is truly useful to him, and desire whatever leads man truly to a greater state of perfection, or completion, and finally, that each one should endeavor to preserve his being as far as in him lies. These desires need not be conscious. They may be unconscious appetites lodged in our flesh. Taken altogether, they constitute the essence of man. We judge all things in terms of our desires. We do not strive for, wish, seek, or desire anything because we think it to be good. We judge a thing to be good because we desire it. By good, I understand that which we certainly know to be useful to us. Here is Bentham's utilitarianism in one sentence. All our desires aim at pleasure or the avoidance of pain. Pleasure is man's transition from a lesser state of perfection, or completion, fulfillment. Pleasure accompanies any experience or feeling that enhances the bodily mental processes of activity and self-advancement. Joy consists in this, that one's power is increased. Any feeling that depresses our vitality is a weakness rather than a virtue. The healthy man will soon slough off the feelings of sadness, repentance, humility, and pity. However, he will be readier than the weak man to render aid, for generosity is the superabundance of confident strength. Any pleasure is legitimate if it does not hinder a greater or more lasting pleasure. Spinoza, like Epicurus, recommends intellectual pleasures as the best, but he has a good word for a great variety of pleasures. There cannot be too much merriment. Nothing save gloomy superstition prohibits laughter. To make use of things, and take delight in them as much as possible, not indeed to satiety, for that is not delight, is the part of a wise man. To feed himself with moderate pleasant food and drink, and to take pleasure with perfumes, plants, dress, music, sports, and theaters. The trouble with the conception of pleasure as the realization of desires is that desires may conflict. Only in the wise man do they fall into a harmonious hierarchy. A desire is usually the conscious correlate of an appetite which is rooted in the body, and so much of the appetite may remain unconscious that we have only confused and inadequate ideas of its causes and results. Such confused desires Spinoza calls affectus, which may be translated by emotions. He defines these as modifications of the body by which the power of action in the body is increased or diminished, and at the same time the ideas of these modifications. A definition vaguely recognizing the role of internal, or endocrine, secretions in emotion, and remarkably anticipating the theory of C.G. Lange and William James, that the bodily expression of an emotion is the direct and instinctive result of the cause, and that the conscious feeling is an accompaniment or result, not a cause, of the bodily expression and response. Spinoza proposed to study the emotions, love, hate, anger, fear, etc., and the power of reason over them in the same manner as if I were dealing with lines, planes, and bodies. Not to praise or denounce them, but to understand them. For the more an emotion becomes known to us, the more it is within our power, and the less the mind is passive to it. The resulting analysis of the emotions owed something to Descartes, perhaps more to Hobbes, but it so improved upon them that when Johannes Müller, in his epical Physiology des Menschen, in 1840, came to treat of the emotions, he wrote, "With regard to the relations of the passions to one another, apart from their physiological conditions, it is impossible to give any better account than that which Spinoza has laid down with unsurpassed mastery." And he proceeded to quote extensively from the Ethics. An emotion becomes a passion when, through our confused and inadequate ideas of its origin and significance, its external cause dictates our feeling and response, as in hatred, anger, or fear. The mind is more or less subject to passions according as it has more or less adequate ideas. A man with poor powers of perception and thought is especially subject to passion. It is such a life that Spinoza describes in his classic Book 4 of Human Bondage. Such a man, however violent his action may be, is really passive, is swept along by an external stimulus instead of holding his hand and taking thought. We are driven about by external causes in many ways, and like waves driven by contrary winds, we waver and are unconscious of the issues and our fate. Can we free ourselves from this bondage and become in some measure the masters of our lives? 7. Reason. Never completely, for we remain part of nature, subject, as Napoleon was to say, to the nature of things. And since the emotions are our motive force, and reason can be only a light and not a fire, an emotion can neither be hindered nor removed save by a contrary and stronger emotion. Hence, society rightly seeks to moderate our passions by appealing to our love of praise and rewards, our fear of blame and punishment. And society rightly labors to instill in us a sense of right and wrong as another check to passion. Conscience, of course, is a social product, not an innate endowment or divine gift. But to use the imaginary rewards and punishments of a life after death as stimulants to morality is an encouragement to superstition and quite unworthy of a mature society. Virtue should be, and is, its own reward, if we define it like men as ability, intelligence, and strength, and not like cowards as obedience, humility, and fear. Spinoza resented the Christian view of life as a vale of tears and of death as a door to heaven or hell. This, he felt, casts a pall over human affairs, clouding with the notion of sin the legitimate aspirations and enjoyments of men. To be daily thinking of death is an insult to life. A free man thinks of nothing less than of death, and his wisdom is a meditation not on death, but on life. Nevertheless, Spinoza seems at times to flutter around the idea of immortality. His theory of mind and body as two aspects of the same reality committed him in logic to view their death as simultaneous. He affirms this quite clearly. The present existence of the mind and its power of imagining are taken away as soon as the mind ceases to affirm the present existence of the body. And again, the mind can imagine nothing, nor can it recollect anything that is past except while the body exists. In Book 5, some hazy distinctions appear. If we look at the common opinion of men, we shall see that they are indeed conscious of the eternity of their minds, but they confound this with duration, and attribute it to imagination and memory, which they believe remain after death. Insofar as the mind is a series of temporal ideas, memories, and imaginations connected with a particular body, it ceases to exist when that body dies. This is the mortal duration of the mind. But insofar as the human mind conceives things in their eternal relationships as part of the universal and unchanging system of natural law, it sees things as in God. It becomes to that extent part of the divine eternal mind, and is eternal. Things are conceived as actual in two ways by us, either insofar as we conceive them to exist with relation to certain time and space, or insofar as we conceive them to be contained in God, the eternal order and laws, and to follow from the necessity of the divine nature, those laws. But those things which are conceived in the second manner as true or real, we conceive under a certain species of eternity, sub quadam specie eternitatis, in their eternal aspect. And their ideas involve the eternal and infinite essence of God. When we see things in that timeless way, we see them as God sees them. Our minds to that extent become part of the divine mind and share eternity. We attribute to the human mind no duration which can be defined by time, but as there is nevertheless something else which is conceived under a certain eternal necessity through the essence of God, this something will be necessarily the eternal part which appertains to the mind. We are certain that the mind is eternal insofar as it conceives things under the species of eternity. Let us suppose that in contemplating the majestic sequence of apparent cause and effect according to apparently everlasting laws, Spinoza felt that through divine philosophy he had escaped, like some sinless Buddha, from the chain of time and had shared in the viewpoint and tranquility of an eternal mind. Despite this seeming reach for the moon, Spinoza devoted most of his concluding Book 5, of Human Liberty, to formulating a natural ethic, a fount and system of morals independent of survival after death, though fondly using religious terms. One sentence reveals his starting point. An emotion which is a passion ceases to be a passion as soon as we form a clear and distinct idea of it. That is, an emotion aroused in us by external events can be reduced from passion to controlled feeling by letting our knowledge play upon it until its cause and nature become clear, and its result in action can, through remembered experience, be foreseen. One method of clearing up an emotional state is to see the events that begot it as part of a chain of natural causes and necessary effects. Insofar as the mind understands all things as necessary, it has more power over the emotions and is less passive to them, less given to passions. No one becomes passionate at what he considers natural and necessary. Anger at an insult can be cooled by viewing the offender as the product of circumstances outreaching his control. Grief over the passing of aged parents can be moderated by realizing the naturalness of death. The endeavor to understand is the first and only basis of virtue, in Spinoza's sense of this word, for it reduces our subjection to external factors and increases our power to control and preserve ourselves. Knowledge is power, but the best and most useful form of that power is power over ourselves. So Spinoza works his Euclidean way to the life of reason. Recalling his three kinds of knowledge, he describes merely sensory knowledge as leaving us too open to domination by external influences. Rational knowledge, reached by reasoning, as gradually freeing us from bondage to the passions by letting us see the impersonal and determined causes of events, and intuitive knowledge, direct awareness of the cosmic order, as making us feel ourselves part of that order and one with God. We should expect and bear both faces of fortune with an equal mind, for all things follow by the eternal decree of God in the same way as it follows from the essence of a triangle that its 3 angles will make 2 right angles. This escape from thoughtless passion is the only true freedom, and he who achieves it, as the Stoics used to say, can be free in almost any condition in any state. The greatest gift that knowledge can give us is to see ourselves as reason sees us. On this naturalistic basis, Spinoza arrives at some ethical conclusions surprisingly like Christ's. He who rightly knows that all things follow from the necessity of divine nature and come to pass according to eternal, natural, and regular laws, will find nothing at all that is worthy of hatred, laughter, or contempt, nor will he deplore anyone, but as far as human virtue can go, he will endeavor to act well and rejoice. Those who cavil at men and prefer rather to reprobate vices than to inculcate virtues are a nuisance both to themselves and to others. A strong man hates no one, is enraged with no one, envies no one, is indignant with no one, and is in no wise proud. He who lives under the guidance of reason endeavors as much as possible to repay hatred, rage, contempt, etc., with love and nobleness. He who wishes to avenge injuries by reciprocal hatred will live in misery. Hatred is increased by reciprocated hatred, and on the contrary can be demolished by love. Men under the guidance of reason desire nothing for themselves which they do not also desire for the rest of mankind. Does this control of emotion by reason contradict, as some have thought, Spinoza's admission that only an emotion can overcome an emotion? It would, unless the following of reason could itself be raised to an emotional level and warmth. A true knowledge of good and evil cannot restrain any emotion insofar as the knowledge is true, but only insofar as it is considered as an emotion. This need, and perhaps a desire to kindle reason with phrases hallowed by piety and time, led Spinoza to the final and culminating thought of his work, that the life of reason must be inspired and ennobled by the intellectual love of God. Since God, in Spinoza, is the basic reality and invariable law of the cosmos itself, this amor intellectualis Dei is not the abject propitiation of some nebular sultan, but the wise and willing adjustment of our ideas and conduct to the nature of things and the order of the world. Reverence for the will of God and an understanding acceptance of the laws of nature are one and the same thing. Just as the mathematician finds a certain awe and ecstasy in viewing the world as subject to mathematical regularities, so the philosopher may take the deepest pleasure in contemplating the grandeur of a universe moving imperturbably in the rhythm of universal law. Since love is pleasure accompanied by the idea of an external cause, the pleasure we derive from viewing and adapting ourselves to the cosmic order rises to the emotion of love toward the God who is the order and life of the whole. Then love toward a being eternal and infinite fills the mind completely with joy. This contemplation of the world as a necessary result of its own nature, of the nature of God, is the ultimate source of content in the mind of the sage. It brings him the peace of understanding, of limitations recognized, of truth accepted and loved. The highest good, summum bonum, of the mind is the knowledge of God, and the highest virtue of the mind is to know God. Thus Spinoza mated the mathematician and the mystic in his soul. He still refused to see in his God a spirit capable of returning man's love, or of rewarding litanies with miracles, but he applied to his deity the tender terms that for thousands of years had inspired and comforted the simplest devotees and the profoundest mystics of Buddhism, Judaism, Christianity, and Islam. Cold in the solitude of his philosophic empyrean, Longing to find something in the universe to receive his adoration and his confidence, the gentle heretic who had viewed the cosmos as a geometrical diagram ended by seeing and losing all things in God, by becoming, to the confusion of posterity, the God-intoxicated atheist. The compulsion to find meaning in the universe made the exile from every faith conclude his seeking with the vision of an omnipresent divinity, and an exalting sense that, if only for a moment, he had touched eternity. 8. The State. Perhaps when Spinoza had finished the Ethics, he felt that, like most Christian saints, he had formulated a philosophy for the use and salvation of the individual, rather than for the guidance of citizens in a state. So, toward 1675, he set himself to consider man as a political animal, and to apply reason to the problems of society. He began his fragmentary Tractatus Politicus with the same resolve that he had made in analyzing the passions: to be as objective as a geometer or a physicist. That I might investigate the subject matter of this science with the same freedom of spirit as we generally use in mathematics, I have labored carefully not to mock, lament, or execrate human actions, but to understand them, and to this end I have looked upon passions, such as love, hatred, anger, envy, ambition, pity, and the other perturbations of the mind, not in the light of vices of human nature, but as properties just as pertinent to it as are heat, cold, storm, thunder, and the like to the nature of the atmosphere. Since human nature is the material of politics, Spinoza felt that a study of the state should begin by considering the basic character of man. We might understand this better if we could imagine man before social organization modified his conduct by force, morality, and law. And if we would remember that underneath his general and reluctant submission to these socializing influences, he is still agitated by the lawless impulses that in the state of nature were restrained only by fear of hostile power. Spinoza follows Hobbes and many others in supposing that men once existed in such a condition, and his picture of this hypothetical savage is almost as dark as in the Leviathan. In that garden of evil, the might of the individual was the only right. Nothing was a crime because there was no law, and nothing was just or unjust, right or wrong, because there was no moral code. Consequently, the law and ordinance of nature forbids nothing and is not opposed to strife, hatred, anger, treachery, or in general anything that appetite suggests. By natural right, then, that is, by the operations of nature as distinct from the rules and laws of society, every man is entitled to whatever he is strong enough to get and to hold, and this is still assumed between species and between states. Hence man has a natural right to use animals for his service or his food. Spinoza moderates this savage picture by suggesting that man, even in his first appearance on the earth, may have already been living in social groups. Since fear of solitude exists in all men, because no one in solitude is strong enough to defend himself and procure the necessaries of life, it follows that men by nature tend towards social organization. Men, then, have social as well as individualistic instincts, and society and the state have some roots in the nature of man. However, and whenever it came about, men and families united in groups, and the natural right or might of the individual was now limited by the right or might of the community. Doubtless, men accepted these restrictions reluctantly, but they accepted them when they learned that social organization was their most powerful tool for individual survival and development. So the definition of virtue as any quality that makes for survival, as the endeavor to preserve oneself, has to be enlarged to include any quality that makes for the survival of the group. Social organization, the state despite its restraints, civilization despite its artifices, these are the greatest inventions that man has made for his preservation and development. Therefore, Spinoza anticipates Voltaire's answer to Rousseau. Let satirists laugh to their heart's content at human affairs. Let theologians revile them. Let the melancholy praise as much as they can the rude and barbarous isolated life. Let them despise men and admire the brutes. Despite all this, men will find that they can prepare with mutual aid far more easily what they need. A man who is guided by reason is freer in a state where he lives according to common law than in solitude, where he is subject to no law. And Spinoza rejects also the other end of the lawless dream, the utopia of the philosophical anarchists. Reason can indeed do much to restrain and moderate the passions, but we saw that the road which reason herself points out is very steep, so that such as persuade themselves that the multitude can ever be induced to live according to the bare dictates of reason must be dreaming of the poetic golden age or of some stage play. The purpose and function of the state should be to enable its members to live the life of reason. The last end of the state is not to dominate men or to restrain them by fear. Rather, it is to set free each man from fear, that he may live and act with full security and without injury to himself or his neighbor. The end of the state is not to make rational beings into brute beasts and machines, as in war. It is to enable their bodies and their minds to function safely. It is to lead men to live by and to exercise a true reason. The end of the state is really liberty. Consequently, Spinoza renews his plea for freedom of speech, or at least of thought. But yielding, like Hobbes, to fear of theological fanaticism and strife, he proposes not merely to subject the Church to state control, but to have the state determine what religious doctrines shall be taught to the people. Quandoque dormitat Homerus. He proceeds to discuss the traditional forms of government. As became a Dutch patriot resenting the invasion of Holland by Louis XIV, he had no admiration for monarchy, and he sharply counters Hobbes's absolutism. Experience is supposed to teach that it makes for peace and concord when all authority is conferred upon one man. For no political order has stood so long without notable change as that of the Turks, while none have been so short-lived, nay, so vexed by seditions as popular or democratic states. But if slavery, barbarism, and desolation are to be called peace, then peace is the worst misfortune that can befall a state. Slavery, not peace, comes from the giving of all power to one man. For peace consists not in the absence of war, but in a union and harmony of men's souls. Aristocracy, as government by the best, would be fine if the best were not subject to class spirit, violent faction, and individual or family greed. If patricians were free from all passion and guided by mere zeal for the public welfare, no dominion could be compared with aristocracy. But experience itself teaches us only too well that things pass in quite a contrary manner. And so Spinoza, in his dying days, began to outline his hopes for democracy. He who had loved the mob-murdered De Witt had no delusions about the multitude. Those who have had experience of how changeful the temper of the people is are almost in despair. For the populace is governed not by reason but by emotion. It is headlong in everything and easily corrupted by avarice and luxury. Yet I believe democracy to be of all forms of government the most natural and the most consonant with individual liberty. In it no one transfers his natural right so absolutely that he has no further voice in affairs. He only hands it over to the majority. Spinoza proposed to admit to the suffrage all males except minors, criminals, and slaves. He excluded women because he judged them by their nature and their burdens to be less fit than men for deliberation and government. He thought that ruling officials would be encouraged to good behavior and peaceful policies if the militia should be composed of the citizens only, and none of them exempted, for an armed man is more independent than a man unarmed. The care of the poor, he felt, was an obligation incumbent on the society as a whole, and there should be but a single tax. The fields and the whole soil, and if it can be managed, the houses, should be public property, that is, the property of him who holds the right of the commonwealth, and let him lease them at a yearly rent to the citizens. With this exception, let them all be free and exempt from every kind of taxation in time of peace. Then, just as he was entering upon the most precious part of his treatise, death took the pen from his hand. 9. The Chain of Influence. In the great chain of ideas that binds the history of philosophy into one noble groping of baffled human thought, we can see Spinoza's system forming in 20 centuries behind him, and sharing in shaping the modern world. First, of course, he was a Jew. Excommunicated though he was, he could not shed that intensive heritage, nor forget his years of poring over the Old Testament and the Talmud and the Jewish philosophers. Recall again the heresies that must have startled his attention in Ibn Ezra, Maimonides, Hasdai Crescus, Levi ben Gerson, and Uriel Acosta. His training in the Talmud must have helped to sharpen that logical sense which made the ethics a classic temple of reason. Some begin their philosophy from created things, he said, and some from the human mind. I begin from God. That was the Jewish way. From the philosophers traditionally most admired, he took little, though in his distinction between the world of passing things and the divine world of eternal laws, we may find another form of Plato's division between individual entities and their archetypes in the mind of God. Spinoza's analysis of the virtues has been traced to Aristotle's Nicomachean Ethics. But the authority of Plato, Aristotle, and Socrates, he told a friend, has not much weight with me. Like Bacon and Hobbes, he preferred Democritus, Epicurus, and Lucretius. His ethical idea may echo the Stoics. We hear in it some tones of Marcus Aurelius, but it was fully consistent with Epicurus. He owed more to the scholastic philosophers than he realized, for they came to him through the medium of Descartes. They too, like Thomas Aquinas in the great Summa, had attempted a geometrical exposition of philosophy. They gave him such terms as substantia, natura naturans, attributum, essentia, summum bonum, and many more. Their identification of existence and essence in God became his identification of existence and essence in substance. He extended to man their merger of intellect and will in God. Perhaps, as Bayle thought, Spinoza read Bruno. He accepted Giordano's distinction between natura naturans and natura naturata. He may have taken term and idea from Bruno's conato de conservarsi. He may have found in the Italian the unity of body and mind, of matter and spirit, of world and God, and the conception of the highest knowledge as that which sees all things in God, though the German mystics must have spread that view even into commercial Amsterdam. More immediately, Descartes inspired him with philosophical ideals and repelled him with theological platitudes. He was inspired by Descartes' ambition to make philosophy march with Euclid in form and clarity. He probably followed Descartes in drawing up rules to guide his life and work. He adopted too readily Descartes' notion that an idea must be true if it is clear and distinct. He accepted and universalized the Cartesian view of the world as a mechanism of cause and effect reaching from some primeval vortex right up to the pineal gland. He acknowledged his indebtedness to Descartes' analysis of the passions. The Leviathan of Hobbes, in Latin translation, obviously evoked much welcome in Spinoza's thought. Here the conception of mechanism was worked out without mercy or fear. The mind, which in Descartes was distinct from the body and was endowed with freedom and immortality, became, in Hobbes and Spinoza, subject to universal law and capable of only an impersonal immortality or none at all. Spinoza found in the Leviathan an acceptable analysis of sensation, perception, memory, and idea, and an unsentimental analysis of human nature. From the common starting point of a state of nature and a social compact, the two thinkers came to contrary conclusions. Hobbes from his royalist circles to monarchy, Spinoza from his Dutch patriotism to democracy. Perhaps it was through Hobbes that the gentle Jew was led to Machiavelli. He refers to him as that most acute Florentine, and again as that most ingenious, foreseeing man. But he escaped the confusion of right with might, recognizing that this is forgivable only among individuals in the state of nature and among states before the establishment of effective international law. All these influences were tempered and molded by Spinoza into a structure of thought, awe-inspiring in its apparent logic, harmony, and unity. There were cracks in the temple, as friends and enemies pointed out. Oldenburg ably criticized the opening axioms and propositions of the ethics, and Uberweg subjected them to a Germanically meticulous analysis. The logic was brilliant, but perilously deductive. Though based upon personal experience, it was an artistry of thought resting upon internal consistency rather than objective fact. Spinoza's trust in his reasoning, though what other guide could he have, was his sole immodesty. He expressed his confidence that man can understand God, or essential reality and universal law. He repeatedly avowed his conviction that he had proved his doctrines beyond all question or obscurity, and sometimes he spoke with an assurance unbecoming in a spray of foam analyzing the sea. What if all logic is an intellectual convenience, a heuristic tool of the seeking mind, rather than the structure of the world? So the inescapable logic of determinism reduces consciousness, as Huxley confessed, to an epiphenomenon, an apparently superfluous appendage of psychophysical processes which, by the mechanics of cause and effect, would go on just as well without it. And yet nothing seems more real, nothing more impressive, than consciousness. After logic has had its say, the mystery, tam grande secretum, remains. These difficulties may have shared in the unpopularity of Spinoza's philosophy in the first century after his death, but resentment was more violently directed against his critique of the Bible, prophecies, and miracles, and his conception of God as lovable but impersonal and deaf. The Jews thought of their son as a traitor to his people. The Christians cursed him as a very Satan among philosophers, an antichrist who sought to rob the world of all meaning, mercy, and hope. Even the heretics condemned him. Bayle was repelled by Spinoza's view that all things and all men are modes of the one and only substance, cause, or God. Then, said Bayle, God is the real agent of all actions, the real cause of all evil, all crimes and wars. And when a Turk slays a Hungarian, it is God slaying himself. This, Bayle protested, forgetting the subjectivity of evil, was a most absurd and monstrous hypothesis. Leibniz was for a decade, from 1676 to 1686, strongly influenced by Spinoza. The doctrine of monads as centers of psychic force may owe something to omnia quodammodo animata. At one time, Leibniz declared that only one feature of Spinoza's philosophy offended him, the rejection of final causes or providential design in the cosmic process. When the outcry against Spinoza's atheism became universal, Leibniz joined in it as part of his own conatus sese preservandi. Spinoza had a modest, almost a concealed share in generating the French Enlightenment. The leaders of that combustion used Spinoza's biblical criticism as a weapon in their war against the Church, and they admired his determinism, his naturalistic ethic, his rejection of design in nature. But they were baffled by the religious terminology and apparent mysticism of the ethics. We can imagine the reaction of Voltaire or Diderot, of Helvetius or d'Holbach, to such statements as, "The mental intellectual love towards God is the very love of God with which God loves himself." The German spirit was more responsive to this side of Spinoza's thought. According to a conversation in 1780 reported by Friedrich Jacobi, Lessing not only confessed that he had been a Spinozist through all his mature life, but affirmed that there is no other philosophy than Spinoza's. It was precisely the pantheistic identification of nature and God that thrilled the Germany of the Romantic movement after the Aufklärung under Frederick the Great had run its course. Jacobi, champion of the new Gefühlsphilosophy, was among the first defenders of Spinoza in 1785. It was another German romantic, Novalis, who called Spinoza der Gottbetrunkene Mensch. Herder thought that he had found in the Ethics the reconciliation of religion and philosophy, and Schleiermacher, the liberal theologian, wrote of the holy and excommunicated Spinoza. The young Goethe was converted, he tells us, at his first reading of the Ethics. Henceforth Spinozism pervaded his non-sexual poetry and prose. It was partly by breathing the calm air of the Ethics that he grew out of the wild romanticism of Goetz von Berlichingen and Die Leiden des jungen Werthers to the Olympian poise of his later life. Kant interrupted this stream of influence for a while, but Hegel professed that to be a philosopher one must first be a Spinozist. And he rephrased Spinoza's God as absolute reason. Probably something of Spinoza's conatus sese preservandi entered into Schopenhauer's will to live and Nietzsche's will to power. England for a century knew Spinoza chiefly through hearsay and denounced him as a distant and terrible ogre. Stillingfleet in 1677 referred to him vaguely as a late author who I hear is mightily in vogue among many who cry up anything on the atheistical side. A Scottish professor, George Sinclair, in 1685, wrote of a monstrous rabble of men who, following the Hobbesian and Spinozian principle, slight religion and undervalue the Scripture. Sir John Evelyn, about 1690, spoke of the Tractatus Theologico Politicus as that infamous book, a wretched obstacle to the searchers of holy truth. Berkeley, in 1732, while ranking Spinoza among weak and wicked writers, thought him the great leader of our modern infidels. As late as 1739, the agnostic Hume shuddered cautiously at the hideous hypothesis of that famous atheist, the universally infamous Spinoza. Not till the Romantic movement at the turn of the 18th into the 19th century did Spinoza really reach the English mind. Then he, more than any other philosopher, inspired the youthful metaphysics of Wordsworth, Coleridge, Shelley, and Byron. Shelley quoted the Tractatus Theologico Politicus in the original notes to Queen Mab, and began a translation of it, for which Byron pledged a preface. A fragment of this version came into the hands of an English critic, who, taking it for a work by Shelley himself, called it a schoolboy speculation too crude for publication entire. George Eliot translated the Ethics with virile resolution, and James Froude and Matthew Arnold acknowledged the influence of Spinoza on their mental development. Of all the intellectual products of man, religion and philosophy seem to endure the longest. Pericles is famous because he lived in the days of Socrates. We love Spinoza especially among the philosophers because he was also a saint, because he lived as well as wrote philosophy. The virtues praised by the great religions were honored and embodied in the outcast who could find a home in none of the religions, since none would let him conceive God in terms that science could accept. Looking back upon that dedicated life and concentrated thought, we feel in them an element of nobility that encourages us to think well of mankind. Let us admit half of the terrible picture that Swift drew of humanity. Let us agree that in every generation of man's history and almost everywhere we find superstition, hypocrisy, corruption, cruelty, crime, and war. In the balance against them we place the long roster of poets, composers, artists, scientists, philosophers, and saints. That same species upon which poor Swift revenged the frustrations of his flesh wrote the plays of Shakespeare, the music of Bach and Handel, the Odes of Keats, the Republic of Plato, the Principia of Newton, and the Ethics of Spinoza. It built the Parthenon and painted the ceiling of the Sistine Chapel. It conceived and cherished, even if it crucified, Christ. Man did all this. Let him never despair. Chapter 23. Leibniz, 1646 to 1716. 1. The Philosophy of Law. A chasm of character and thought separates Spinoza from Leibniz, the solitary Jew, cast out by Judaism, not accepting Christianity, living in poverty in an attic room, finishing only 2 books, slowly evolving a boldly original philosophy that would alienate all the religions, and dying of consumption at 44. The German man of the world, busy with statesmen and courts, traveling through nearly all of Western Europe, spreading his feelers into Russia and China, accepting both Protestantism and Catholicism, welcoming and using a dozen systems of thought, writing 100 treatises, embracing God and the world with desperate optimism, living out his 70 years and 10, and resembling his predecessor only in the loneliness of his funeral. Here in one generation are the antipodes of modern philosophy. But before we come to this protean mosaic of a man, let us acknowledge some minor credits to German thought. Samuel von Pufendorf began his trajectory in 1632, in the same year as Spinoza and Locke. After studying at Leipzig and Jena, he went to Copenhagen as tutor in the family of a Swedish diplomat, was arrested with him when Sweden declared war upon Denmark, and tempered the tedium of imprisonment by constructing a system of international law. Released, he moved to Leiden, where he published the results as Elementa Jurisprudentiae Universalis in 1661, which so pleased Charles Louis of the Palatinate, the same who later invited Spinoza, that the Elector called him to Heidelberg and created for him a professorship in natural and international law, the first such chair in history. There Pufendorf composed a study of the German realm, De Statu Imperii Germanici Liber Unus in 1667, which shocked Leopold I by attacking the Holy Roman Empire and its emperors. Pufendorf migrated to Sweden and the University of Lund in 1670, where he published his chef-d'œuvre, De Lure Naturae et Gentium, in 1672. Attempting to mediate between Hobbes and Grotius, Pufendorf identified the law of nature not with the war of each against all, but with the dictates of right reason. He extended natural rights, rights belonging to all rational beings, to Jews and Turks, and argued that international law should not hold only among Christian states, but equally in their relations with infidels. He preceded Jean-Jacques Rousseau by almost a century in declaring that the will of the state is and should be the sum of the wills of its constituent individuals. But he thought slavery desirable as a way of reducing the number of beggars, tramps, and thieves. Some Swedish pastors thought these theories made too little account of God and the Bible in political philosophy. They urged that Pufendorf be returned to Germany. But Charles XI called him to Stockholm and made him historiographer royal. This book is continued on Cassette 12, Side 1. The Story of Civilization. Volume 8, The Age of Louis XIV, by Will and Ariel Durant. Part 2, continued. Cassette 12, Side 1. Some Swedish pastors thought these theories made too little account of God and the Bible in political philosophy. They urged that Pufendorf be returned to Germany. But Charles XI called him to Stockholm and made him historiographer royal. The professor repaid him by writing a biography of the king and a history of Sweden. In 1687, perhaps with an eye to travel, Pufendorf dedicated to the great elector of Brandenburg a treatise on the relation of the Christian religion to civil life, De Habitu Christianae Religionis ad Vitam Civilem, defending toleration. He soon accepted a call to Berlin, became historiographer to Frederick William, was made a baron, and died in 1694. His writings remained for half a century the dominant works in political and legal philosophy in Protestant Europe, and their realistic analysis of social relations helped events to deflate the theory of the divine right of kings. The decline in the theological interpretation of human affairs was accentuated by the careers of Balthasar Bekker and Christian Thomasius. Bekker was a Dutch pastor ministering to a flock in Friesland. Having spoiled his faith with Descartes, he proposed to apply reason to Scripture. He interpreted biblical devils as popular delusions or metaphors. He traced the pre-Christian history of the idea of Satan, held it an interpolation into Christianity, concluded that the devil was a myth, and blasted him out of existence in a Dutch manifesto, The Bedeviled World, in 1691. The Church severely censured Bekker, feeling that fear of the devil is the beginning of wisdom. The devil suffered some loss in prestige, but not in devotees. Thomasius carried on the battle. While continuing to accept the Scriptures as a guide to religion and salvation, he aspired to follow the rule of reason, to believe only up to the evidence, and to encourage religious toleration. As professor of natural law at Leipzig from 1684 to 1690, he offended the faculty and the ministry by the originality of his views, methods, and language. He countered the superstitions of his time with lusty German laughter. He agreed with Bekker in exorcising the devil from religion. He denounced the belief in witchcraft as shameful ignorance, and the persecution of witches as criminal brutality. Through his influence, trials for sorcery were ended in Germany. To make matters worse, he lectured his students in German instead of Latin, taking half the dignity out of pedagogy. In 1688, he began to publish a periodical review of books and ideas. We should have called it the first serious journal in German, but it took its erudition with a light heart, coated scholarship with humor, and called itself Jocose and Earnest, Rational and Silly Thoughts on All Kinds of Pleasant and Useful Books and Questions. His defense of the Pietists against the Orthodox clergy and of intermarriage between Lutherans and Calvinists so alarmed the authorities that they forbade him to write or lecture, and finally ordered his arrest in 1690. He escaped to Berlin. The Elector Frederick III gave him a professorship at Halle. He took part in organizing the university there, and soon made it the liveliest intellectual center in Germany. In 1709, Leipzig invited him to return. He refused and remained at Halle 34 years, to the end of his life. He inaugurated the Aufklärung, which produced Lessing and Frederick the Great. Some of the enthusiasts pushed their revolt to the extremes of atheism. Matthias Knudsen of Holstein discarded all supernatural belief. In super deum negamus, above all we deny God. He proposed to replace Christianity, its churches, and its priests with a positivist religion of humanity in full anticipation of Auguste Comte, and to base morality solely on the naturalistic education of conscience, this in 1674. He claimed 700 followers. This was probably an exaggeration, but we observe that between 1662 and 1713, at least 22 works were published in Germany aiming to spread or refute atheism. Leibniz deplored the apparent triumph of freethinkers. In our day, he wrote toward 1700, many people have scant respect for revelation or miracles. And he added in 1715, natural religion is growing very much weaker. Many hold that souls are corporeal, others that God himself is corporeal. Mr. Locke and his followers are doubtful whether souls are not material and naturally perishable. Leibniz was not too firm in his own faith, but as a man of the world and its courts, he wondered where the rising nationalism would end, and what it would do to churches, morals, and thrones. Could the rationalists be answered in their own terms, and the faith of the fathers be rescued for the health of the children? 2. Wanderjahre. Gottfried Wilhelm Leibniz was 2 years old when the 30 Years' War ended. He grew up in one of the most barren and unhappy periods of German history. But he had every educational opportunity then available, for his father was professor of moral philosophy at the University of Leipzig. Gottfried was a wunderkind, eager for knowledge and in love with books. The paternal library was opened to him with the invitation, Tolle, lege, take and read. He began Latin at 8, Greek at 12. He devoured history. He became a polymath, learned in many fields. At 15, he entered the university, where the stimulating Thomasius was one of his teachers. At 20, he applied for the doctor's degree in law. Leipzig refused it because of his youth, but he received it soon afterward from Nuremberg's university at Altdorf. His doctoral dissertation there made such an impression that he was at once offered a professorship. He declined, saying that he had different things in view. Very few of the major philosophers have held university chairs. Economically secure, intellectually free, he now dipped into all the movements and philosophies that were agitating Renaissance Germany. He had studied the scholastic systems at Leipzig. He kept their terminology and many of their ideas, like the ontological proof for the existence of God. He imbibed the full Cartesian tradition, but salted it with Gassendi's objections and atomism. He passed on to Hobbes, praised him as subtilissimus, and flirted with materialism. Living for a time, from 1666 to 67 in Nuremberg, he sampled the mysticism of the Rosicrucians, Fraternitas Rosae Crucis, that brotherhood of the Rosy Cross which alchemists, physicians, and clergymen had founded about 1654. He became its secretary and delved into alchemy, very much as his future rival Newton was doing at Cambridge. He left no idea untouched or unborrowed. Before he was 22, he had written several treatises, small in scope, but swelling with confidence. One of these, A New Method of Teaching and Learning Law, attracted the attention of a diplomat then staying in Nuremberg, Johann von Boineberg, who advised the young author to dedicate it to the Archbishop-Elector of Mainz and arranged to have it presented in person. The plan worked, and in 1667 Leibniz entered the service of the elector, first as assistant in revising the laws, then as counselor. He remained at Mainz for 5 years. He became familiar with Catholic clergymen, theology, and ritual, and began to dream of reuniting the sundered Christian creeds. The elector, however, was more interested in Louis XIV than in Luther, for the insatiable king was spreading his armies into the Low Countries and Lorraine, too close to Germany, and was obviously anxious to swallow the Rhine. How could he be stopped? Leibniz had a plan for that, indeed 2 plans, brilliant enough for a lad of 24. The first was to unite the Western German states in a Rheinbund for mutual defense in 1670. The second was to deflect Louis from Germany by persuading him to seize Egypt from the Turks. Relations between France and Turkey were at that time strained. If Louis, anticipating Napoleon by 128 years, were to send an expedition to conquer Egypt, he would capture control of the commerce, including Dutch commerce, that went from Europe through Egypt to the east. He would keep the soil of France free of war. He would end the Ottoman threat to Christendom. He would be the honored savior instead of the dreaded scourge of Europe. Boineberg so wrote to Louis, enclosing an outline of the plan from Leibniz's pen. Simon Arnaud de Pomponne, the French foreign minister, invited Leibniz in February 1672 to come and offer the plan to the king. In March, the 26-year-old statesman set out for Paris. The generals foiled him and themselves. By the time Leibniz reached Paris, Louis had mended his quarrel with Turkey and had decided to attack Holland. On April 6th, he declared war. Pomponne informed Leibniz that crusades were out of fashion, and he refused to let him see the king. Still hoping, the philosopher drew up for the French government a memorial, of which he sent a summary, the Concilium Egyptiacum, to Boineberg. If the proposal had been carried out to success, France, rather than England, might have captured India and the rule of the seas. Louis's decision, said Admiral Mahan, which killed Colbert and ruined the prosperity of France, was felt in its consequences from generation to generation. Boineberg died before the concilium reached him, and Leibniz mourned the loss of an unselfish friend. Partly for this reason he did not return to Mainz. Moreover, he had been caught in the intellectual currents of Paris and found them more stimulating than those that surrounded even the liberal and enlightened elector. Now he met Antoine Arnaud of Port-Royal, and Malebranche, and Christian Huygens, and Bossuet. Huygens drew him into higher mathematics, and Leibniz began those infinitesimal calculations that were to lead him to the calculus. In January 1673, on a mission from the Elector of Mainz to Charles II, he crossed the Channel to England. In London he made the acquaintance of Oldenburg and Boyle, and felt the zest of awakening science. Returning to Paris in March, he gave more and more of his time to mathematics. He contrived a computing machine that improved upon Pascal's by performing multiplication and division as well as addition and subtraction. In April he was elected, in absence, a member of the Royal Society. By 1675 he had discovered the differential calculus, by 1676 the infinitesimal calculus, and he had formulated his successful notation. No one any longer charges Leibniz with having plagiarized his calculus from Newton's. Newton had apparently made his discovery in 1666, but he did not publish it till 1692. Leibniz published his differential calculus in 1684, his integral calculus in 1686. There remains no doubt that Newton was first in the discovery, that Leibniz reached his own discovery independently, that he antedated Newton in publishing the discovery, and that Leibniz's system of notation proved superior to Newton's. The Archbishop of Mainz died in March 1673, leaving Leibniz without official employment. Soon he signed an agreement to serve Duke John Frederick of Brunswick-Lüneburg as curator of the ducal library at Hanover. Still fascinated by Paris, Leibniz remained there till 1676, then traveled leisurely to Hanover via London, Amsterdam, and The Hague. At Amsterdam he talked with Spinoza's disciples, and at The Hague with the philosopher himself. Spinoza hesitated to confide in him, for Leibniz was proposing to reconcile Catholicism and Protestantism, which might then join in suppressing freedom of thought. Leibniz overcame these suspicions, and Spinoza allowed him to read, even to copy passages from, the manuscript Ethica. The two men had several long conversations. Leibniz had much trouble after Spinoza's death in concealing how deeply he had been influenced by the saintly Jew. He reached Hanover toward the end of 1676 and remained in the employ of successive Brunswick princes through the remaining 40 years of his life. He had hoped to be accepted as a counselor of state, but the dukes assigned him to care for their libraries and write the history of their house. He performed these tasks intermittently well. His voluminous history, Annales Brunswiccenses, was weighted and illuminated with original documents assiduously obtained. His genealogical researches in Italy established the common origin of the Este and Brunswick dynasties. And though the subject of his book was uncomfortably confining for so ambitious a genius, he lived to see the Brunswick family inherit England. He tried hard to be a German patriot. He pleaded with the Germans to use their vernacular in law, but he wrote his treatises in Latin or French and was a shining exemplar of the good European and the cosmopolitan mind. He warned the German princes that their divisive jealousies and their deliberate weakening of the imperial power condemned Germany to be the victim of better centralized states and the battleground of repeated wars between France, England, and Spain. His secret hope was to serve the emperor and the empire rather than the princes of the separate states. He had 100 plans for political, economic, religious, and educational reform, and he agreed with Voltaire that it was easier to reform a state by converting its ruler than by slowly educating the masses, who are too harassed with board and bed to have much time for thought. In 1680, when the imperial librarian died, Leibniz offered himself for the post, but he added that he would not want it unless it carried with it membership in the emperor's privy council. His application was rejected. Returning to Hanover, he found some solace in the friendship of the Electress Sophia, and later of her daughter Sophia Charlotte, who gave him entree to the Prussian court, helped him to found the Berlin Academy in 1700, and inspired him to write his Théodicée. For the rest, he ennobled his modest position by corresponding with the leading thinkers of Europe, by making major contributions to philosophy, and by advancing a brave plan for the religious reunification of Christendom. 3. Leibniz and Christianity. Was he himself a Christian? Outwardly, yes, of course. A man with his zeal to pass from philosophy to statesmanship had to robe himself in the theology of his time and place. "I have endeavored in all things," said his preface to the Theodicy, "to consider the need for edification." The writings that he published during his life were exemplary in their faith. They defended the Trinity, miracles, divine grace, free will, immortality, and they attacked the freethinkers of the age as undermining the moral bases of social order. However, he went to church little and for many years did not communicate. The simple people of Hanover nicknamed him Löwenix, that is, glaubt nichts, believes nothing. Some students have credited him with two opposed philosophies, one for public consumption and the comforting of princesses, the other a clear-cut affirmation of all the principles of Spinozism. Leibniz fell into Spinozism whenever he allowed himself to be logical. In his published works, accordingly, he took care to be illogical. His efforts to reconcile Catholicism and Protestantism subjected him to the charge of indifferentism. His passion for unity and compromise dominated his theology. While avoiding preachers, he labored to bring them together. Because he saw deeply, he minimized surface diversities. If Christianity was a form of government, its creedal varieties seemed to him not instruments of piety and goodwill, but obstacles to order and peace. In 1677, the Emperor Leopold I sent Christopher Rojas de Spinola, titular Bishop of Tina in Croatia, to the court of Hanover to suggest to the Duke, John Frederick, himself a convert to Catholicism, that he join in a campaign to reunite Protestants with Rome. Probably the plan had political fringes. The elector at the time desired the support of the emperor, and Leopold hoped for a stronger German unity and spirit against the Turks. For a while, Spinola commuted between Vienna and Hanover, and the affair progressed. When Bossuet in 1682 formulated the Gallican Declarations by which the French clergy defied the Pope, Leibniz may have been led to hope that France would join with Germany in a Catholicism sufficiently independent of the papacy to soften Protestant hostility to the ancient creed. In 1683, as the Turks were marching to the siege of Vienna, Spinola assembled at Hanover a conference of Protestant and Catholic theologians, and submitted to them rules for the ecclesiastical union of all Christians. It was probably for this meeting that Leibniz anonymously composed the strangest of the many documents that were found among his papers after his death. It was called Systema Theologicum, and purported to be such a statement of Catholic doctrine as any Protestant of good will might accept. In 1819, a Catholic editor published it as evidence that Leibniz had been secretly converted. More likely, it was a diplomatic effort to reduce the theological gap between the two communions, but the editor was justified in considering the paper overwhelmingly Catholic. It began with brief impartiality. After invoking the divine aid by long and earnest prayer, putting aside, so far as is humanly possible, all party spirit, looking at the religious controversies as though I had come from another planet, a humble learner, unacquainted with any of the various communions, bound by no obligations, I have, after due consideration, arrived at the conclusions hereinafter set forth. I have deemed it incumbent upon me to embrace them because Holy Writ, immemorial religious tradition, the dictates of reason, and the sure testimony of the facts seem to me to concur in establishing them in the mind of any unprejudiced human being. Thereupon followed a profession of faith in God, creation, original sin, purgatory, transubstantiation, monastic vows, invocation of saints, use of incense, religious images, ecclesiastical vestments, and the subordination of the state to the Church. This generosity to Catholicism might cast doubt on the document, but its authenticity as a work of Leibniz is generally accepted today. Perhaps he hoped, by so supporting the Catholic view, to prepare for himself a commodious berth at the court of the Catholic Emperor in Vienna, and, like any good skeptic, Leibniz admired the sight, sound, and smell of Catholic ritual. Thus the strains of music, the sweet concord of voices, the poetry of the hymns, the beauty of the liturgy, the blaze of lights, the fragrant perfumes, the rich vestments, the sacred vessels adorned with precious stones, the costly offerings, the statues and the pictures that awaken holy thoughts, the glorious creations of artistic genius, the stately splendor of public procession, the rich draperies adorning the streets, the music of bells, in a word, all the gifts and marks of honor which the pious instincts of the people prompt them to pour forth with lavish hand, do not, I trow, excite in God's mind the disdain which the stark simplicity of some of our contemporaries would have us believe they do. That, at all events, is what reason and experience alike confirm. All these arguments failed to move the Protestants. Louis XIV disrupted the decor by revoking the Edict of Nantes and making brutal war upon French Protestants. Leibniz set aside his agape for more gracious times. In 1687, to consult scattered archives for his Annals of the House of Brunswick, he set out on 3 years of travel through Germany, Austria, and Italy. In Rome, on the assumption that he would accept conversion, the authorities offered him the curatorship of the Vatican Library. He declined. He made a brave attempt to obtain cancellation of the ecclesiastical decrees against Copernicus and Galileo. After his return to Hanover, he began, in 1691, 3 years of correspondence with Bossuet in the hope of reviving the movement for the reunion of Christendom. Could not the Roman Church call a really ecumenical council, one including Protestant as well as Catholic leaders, to reconsider and revoke the Council of Trent's harsh branding of Protestants as heretics? The bishop, who had just bombarded these heretics with his Variation des Églises Protestantes from 1688, replied uncompromisingly, if the Protestants wish to re-enter the sacred fold, let them accept conversion and end the debate. Leibniz begged him to reconsider. Bossuet held out hope. "I enter into the scheme. You shall shortly hear what I think." In 1691, Leibniz wrote to Madame Brinon with his usual optimism. "The Emperor is favorably disposed. Pope Innocent XI and a number of cardinals, generals of monastic orders, and many grave theologians, having carefully considered the matter, have expressed themselves in the most encouraging terms. It is no exaggeration to say that if the King of France and the prelates who have his ear in this matter were to take concerted action, the thing would not be merely feasible, it would be as good as done." When Bossuet's answer came, it was crushing. The decisions of the Council of Trent were irrevocable. They had rightly held the Protestants to be heretics. The Church is infallible. No conference between Catholic and Protestant leaders could reach any constructive result unless the Protestants would agree in advance to adopt the decisions of the Church on the matters at issue. Leibniz replied that the Church had often changed her views and teaching, had contradicted herself, and had condemned and excommunicated persons without just cause. He declared that he washed his hands of all responsibility for whatever further ills the existing schism may have in store for the Christian Church. He turned to the apparently more hopeful task of reconciling the Lutheran and Calvinist branches of Protestantism, but here he met with an intransigence as hard and proud as Bossuet's. At last he privately called down a plague upon all the rival theologies, and proclaimed that there were only two kinds of books with any value: those reporting scientific demonstrations or experiments, and those containing history, politics, or geography. Outwardly and laxly, he remained a Lutheran to the end of his life. 4. Locke reviewed. Half of Leibniz's product was an argumentum ad hominem, undertaken more or less incidentally as a discussion of some other writer's ideas. His greatest book, which grew to 590 pages, began in 1696 as a 7-page review of Locke's Essay Concerning Human Understanding from 1690, known then to Leibniz only from an abstract in Leclerc's Bibliothèque Universelle. When the essay appeared in a French translation in 1700, Leibniz reviewed it again for a German magazine. He was quick to recognize the importance of Locke's analysis and generously praised its style. In 1703, he set himself to comment on it chapter by chapter. It is these comments that constitute Leibniz's new essays on human understanding. When he learned of Locke's death in 1704, he left the commentary unfinished. It was not published till 1765, too late to interfere with the pervasive influence of Locke upon Voltaire and other luminaries of the French Enlightenment, but in time to share in molding Kant's epical Critique of Pure Reason. It is among the most important productions in the history of psychology. In form, it is a dialogue between Philalethees, or lover of truth, representing Locke, and Theophilus, or lover of God, representing Leibniz. The dialogue is vigorously sustained and still makes good reading for any person of keen mind and endless leisure. The preface shows Leibniz in his most courteous mood, professing modestly to win readers by attaching his discourse to the Essay on the Understanding by a distinguished Englishman, one of the most beautiful and esteemed works of this period. The question to be discussed is stated with laudable clarity. To know whether the soul in itself is entirely empty as the tablets upon which as yet nothing has been written, tabula rasa, according to Aristotle and the author of the essay, and whether all that is traced thereon comes solely from the senses and experience, or whether the soul contains originally the principles of many ideas and doctrines which external objects merely call up on occasion, as I believe with Plato. The mind, in Leibniz's view, is not a passive receptacle of experience. It is a complex organ that by its structure and functions transforms the data of sensation, just as the digestive tract is no empty sac, but a system of organs for the digestion of food and its transformation into the needs and organs of the body. In a famous epigram, Leibniz summarized and amended Locke. Nothing is in the mind that has not been in the senses, except the mind itself. Locke, as Leibniz noted, had recognized that ideas could come from introspective reflection, as well as from external sensation, but had ascribed to a sensory origin all elements entering into reflection. Leibniz, on the contrary, argued that the mind of itself supplies certain principles or categories of thought, such as being, substance, unity, identity, cause, perception, reason, and many other notions which the senses cannot give. and that these tools of understanding, these organs of mental digestion, are innate, not in the sense that we are conscious of them at birth, or always conscious of them when we use them, but in the sense that they are part of the native structure or natural aptitudes of the mind. Locke felt that these supposedly inborn principles were gradually developed by the interplay, in thought, of ideas originally sensory. But without such principles, Leibniz urged, there would be no ideas, only a disorderly succession of sensations. Just as, without the action and digestive juices of the stomach, food would not feed us and would not be food. In this measure, he boldly added, all ideas are innate, that is, the result of the transforming action of the mind upon sensations. But he admitted that the innate principles are at birth confused and indistinct, and become clear only through experience and use. The inherent principles in Leibniz's judgment include all necessary truths, such as are found in pure mathematics. For it is the mind, not sensation, that supplies the principle of necessity. Everything sensory is individual and contingent, and gives us, at best, repeated sequence, but not necessary sequence or cause. Locke had conceded this. Leibniz considered innate all our instincts, our preference of pleasure to pain, and all the laws of reason, though these become clear only with experience. Among the innate laws of thought, two are especially basic: the principle of contradiction, that contradictory statements cannot be true at the same time. If A is a circle, it is not a square. And the principle of sufficient reason, that nothing happens without a reason why it should be so rather than otherwise. Human intelligence, Leibniz thought, differs from animal knowledge by deducing general ideas from particular experiences through the use of innate principles of reason. Brutes are pure empirics, guiding themselves solely by examples. So far as we can judge of them, they never attain to the formation of necessary propositions. The principle of sufficient reason suffices to demonstrate the being of a god, and all the other parts of metaphysics or natural theology. In this sense, our idea of God is innate, though in some minds or tribes the idea may be unconscious or confused. And we may say the same of the idea of immortality. The moral sense is innate, not in its specific content or judgments, which may vary in time and place, but as consciousness of a difference between right and wrong. This consciousness is universal. In Leibniz's psychology, the mind is active not only as entering by its structure and functioning into the making of every idea, but also in the incessant continuance of its activity. Using the word think in Descartes' broad sense as including all mental operations, Leibniz agreed with the Cartesians that the mind is always thinking, whether awake, unconscious, or asleep. A state without thought in the soul and an absolute repose in the body appear to me equally contrary to nature and without example in the world. Some mental operations are subconscious. It is a great error to believe that there is no perception in the soul besides those of which it is conscious. It is with such propositions in Leibniz that modern psychology began its efforts to delve into what some students call unconscious mind, and what esprit fort consider to be merely cerebral or other bodily processes that do not evoke consciousness. Leibniz has much to say about the relation between body and soul, but there he leaves psychology, soars into metaphysics, and asks us to see all the world as psychophysical monads, like ourselves. 5. Monads. When he was in Vienna in 1714, he met Eugene of Savoy, who, with Marlborough, had saved Europe from subjection to Louis XIV. The prince asked the philosopher for a brief statement of his philosophy in a form intelligible to a general. Leibniz responded by composing a compact treatise of 90 paragraphs, which he left among his papers at his death. A German translation was published in 1720, but the original French text was not printed till 1839, and then it was the editor who christened it La Monadologie. Leibniz could have taken the term monad from Giordano Bruno, or from Franz, son of the chemist J.B. von Helmont, who used the word to describe the minute seeds which alone were directly created by God and which developed into all the forms of matter and life. An English physician, Francis Glisson, had attributed not only force, but instinct and ideas to all substances in 1672. A similar theory had germinated in Leibniz's roving and receptive mind since 1686. He may have been influenced by the recent work of microscopists, who had shown such throbbing life in the smallest cells. Leibniz concluded that there is a world of created beings, living things, animals, souls, in the least part of matter. Every portion of matter may be conceived as a pond full of fishes, and every drop of blood in one of these microscopic fishes is another pond full of fishes, and so on ad infinitum. He was moved, as Pascal had been appalled, by the indefinite divisibility of every extended thing. This endless divisibility, Leibniz suggested, is a puzzle arising from our conception of reality as matter, therefore as extended, therefore as divisible ad nauseam. If we consider the ultimate reality as energy and conceive the world as composed of centers of force, the mystery of divisibility vanishes because force, like thought, does not imply extension. So he rejected the atoms of Democritus as the ultimate components of the universe and replaced them with monads, unextended units of force. He defined substance not as matter but as energy. Up to this point, Leibniz's conception was quite in accord with 20th century physics. Matter is everywhere instinct with motion, activity, and life. Every monad feels or perceives. It has inchoate or incipient mind in the sense that it is susceptible and responds to external changes. We shall understand the monads better if we think of them in imitation of the notion that we have of souls. As each soul is a simple, separate person, a solitary ego, solus contra mundum, fighting its way by its own internal will against everything outside it, so each monad is essentially alone, a separate, independent center of force against all other centers of force. Reality is a universe of individual powers, unified and harmonized only through the laws of the whole, or God. As every soul is different from all others, so every monad unique. In the entire cosmos there are no two beings completely alike, for their differences constitute their individuality. Two things having all the same qualities would be indistinguishable, identical, one, the law of indiscernibles. As each soul feels or perceives the reality surrounding it, and ever less clearly the reality progressively distant from it, but feels all reality in some degree, so each monad feels, however confusedly and unconsciously, the whole universe. In this way it is a mirror more or less obscurely reflecting and representing the world. And as no individual mind can really look into another mind, so no single monad can see into another. It has no window or other opening for such direct communication, and therefore it cannot directly produce any change in any other monad. The monads do change, for change is essential to their life, but the changes come from their own inner striving. For just as each self is desire and will, so each monad contains, is an inner purpose and will, an effort to develop. This is the entelechy that Aristotle spoke of as the core of every life. In this sense, as Schopenhauer was to say, force and will are two forms or degrees of the same fundamental reality. There is an immanent teleology in nature. There is in everything a seeking, an appetition, a guiding, molding purpose, even though that purpose, that will, acts within the limits and by means of mechanical law. Just as, in ourselves, the bodily movement is the visible and mechanical expression of an internal will or desire, so in the monads the mechanical process that we see from without is only the outer form and shell of an inner force. That which is exhibited mechanically or by extension in matter is concentrated dynamically and monadically in the entelechy, or inner striving, itself. In our confused perception, we identify external things with matter because we see their outer mechanism only. We do not, as in introspection, see the inner and formative vitality. In this philosophy, the passive and helpless atoms of the materialists give place to monads, or units, that are living centers of individuality and force. The world ceases to be a dead machine and becomes the stage of diverse and palpitating life. In that diversity, the most important feature is the degree in which the mind of each monad is conscious. All monads have mind in the sense of sensitivity and response, but not all mind is conscious. Even we marvelous human beings go through many mental processes without consciousness, as in dreams, or as when, in our intense attention to certain aspects of a situation, we are not aware that we are perceiving many other elements in the scene, elements which may nevertheless be deposited in memory, enter into our dreams, or emerge from hidden corners of the mind into later consciousness. Or as when, conscious of the roar and hiss of the surf, we do not realize that each wave, and each particle of each wave, is beating upon our ears to produce 1,000 individual impressions that become our hearing of the sea. So the simplest monads feel and perceive everything about them, but so confusedly that they have no consciousness. In plants, the feelings become clearer and more specialized and lead to more specific responses. In the monad that is the soul of an animal, the echoing perceptions become memories, whose interplay begets consciousness. Man is a colony of monads, or cells, each with its own hunger, needs, and purposes. But these particles become a unified community of living organisms under the direction of a dominating monad, which is man's entelechy soul. When this soul is raised to the level of reason, it is reckoned as mind, and rises in rank in the measure of its perceiving necessary relations and eternal truths. When it perceives the order and mind of the universe, it becomes the mirror of God. God, the prime monad, is pure and fully conscious mind, free from mechanism and body. The most difficult aspect of this philosophy is Leibniz's theory of pre-established harmony. What is the relation between the inner life of a monad and its outward manifestation, or material shell? And how shall we explain the apparent interaction of physical body and spiritual mind in man? Descartes had delegated this problem helplessly to the pineal gland. Spinoza had answered it by denying any separation or interaction of matter and mind, since these were, in his view, merely the outside and inside aspects of one process and reality. Leibniz restored the problem by thinking of the two aspects as separate and distinct. He denied their interaction, but ascribed the simultaneity of the physical and the mental processes as due to a continuous collusion marvelously prearranged by God. The soul follows its own laws, and the body its own likewise, and they accord by virtue of the harmony pre-established among all substances, since they are all representations of one and the same universe. Bodies act as though, per impossibile, there were no souls, and souls act as if there were no bodies, and both act as if each influenced the other. I am asked how it happens that God is not content to produce all the thoughts and modifications of the soul without these useless bodies, which the soul, it is said, can neither move nor know. The answer is easy. It is that it was God's will that there should be a greater rather than a lesser number of substances, and he found it good that these modifications should correspond to something outside. Suspecting that this debonair exploitation of deity as a substitute for thought might not win universal applause, Leibniz embellished it with the occasionalism and timepieces of Gehlenx. Body and mind, each operating independently of the other and yet in puzzling harmony, are like two clocks so skillfully constructed, wound, and set that they tick off the seconds and strike the hours in perfect agreement, without any interaction or mutual influence. So the physical and psychical processes, though quite independent and never acting upon each other, accord through a harmony pre-established by a divine anticipatory artifice. Let us assume that what Leibniz had in view, but did not care to say, was that the apparently separate but synchronous processes of mechanism and life, of action and thought, are one and the same process, seen externally as matter, internally as mind. But to have said this would have been to repeat Spinoza, and share his fate. 6. Was God just? This need to put theological clothing upon philosophical nudities led Leibniz to write the book that drew the ire and wit of Voltaire, and almost lost a really profound thinker in the caricature of Professor Pangloss defending the best of all possible worlds. The only complete philosophical work published by Leibniz in his lifetime was called Essai de Théodicée sur la bonté de Dieu, la liberté de l'homme et l'origine du mal, in 1710. Almost as comforting a promissory note as Descartes' Principles of First Philosophy, in which are demonstrated the existence of God and the immortality of the soul, from 1641. Theodicy, of course, meant the justice or justification of God. This book, like the others, had an occasional origin. In an article, Hieronymus Rorarius, in the Dictionnaire historique et critique, Bayle, while expressing great admiration for Leibniz, questioned the philosopher's view that faith can be reconciled with reason, or man's freedom with God's omnipotence, or earthly evil with divine goodness and power. We had better, said Bayle, give up the idea of proving religious creeds. It merely brings the difficulties into clearer light. Leibniz replied in an essay in 1698, contributed to Jacques Banage's journal, Histoire des ouvrages des savants. In the second edition of his dictionary, Bayle added to the article, on Rorarius, a substantial note again hailing Leibniz as that great philosopher, but pointing out further obscurities, especially in the theory of pre-established harmony. Leibniz sent in 1702 his rejoinder directly to Bayle, but did not print it. In that same year he wrote again to the Rotterdam scholar, complimenting him on his striking reflections and boundless researches. Few episodes in the history of philosophy are so pleasant as the mutual courtesy in this exchange of ideas. Sophia Charlotte, Queen of Prussia, expressed her desire to know Leibniz's answers to Bayle's doubts. He was preparing such a statement when news came to him that Bayle had died. He revised and extended his replies and published them as the Théodicée. He was now 64 years old, felt the nearness of the great perhaps, and may have longed to believe in the justice of God to man. How had it come about that a world created by an omnipotent and benevolent deity had been sullied with such martial massacres, political corruption, human cruelty and suffering, earthquakes, famines, poverty, and disease? The preliminary dissertation on the confronting of faith with reason described reason and the Bible as being both of them divine revelations, and therefore unlikely to contradict each other. Bayle had wondered how a good God, presumably foreseeing all the fruit thereof, could have allowed the temptation of Eve. Leibniz answered that to make man capable of morality, God had to give him free will, and therefore freedom to sin. It is true that free will seems incompatible with both science and theology. Science sees everywhere the rule of invariable law, and human freedom seems lost in God's foreknowledge and predestination of all events. But, said Leibniz, we are obstinately and directly conscious that we are free. Though we cannot prove this freedom, we must accept it as a prerequisite to any sense of moral responsibility, and as the only alternative to viewing man as a ridiculously helpless physiological machine. As to the existence of God, Leibniz is content with traditional scholastic arguments. We conceive a perfect being, and since existence is a necessary element in perfection, a perfect being must exist. There must be a necessary and uncaused being behind all proximate causes and contingent events. It is inconceivable that the grandeur and order of nature should have any other source than a supreme intelligence. The Creator must contain in himself, in an infinite degree, the power, knowledge, and will discoverable in his creatures. Divine design and cosmic mechanism are not contradictory. Providence uses mechanism its wonders to perform, and God can interrupt the world machine now and then to work a miracle or two. Of course, the soul is immortal. Death, like birth, is only a change of form in an assemblage of monads. The inherent soul and energy remain. Soul, except in God, is always attached to body and body to soul, but there will be a resurrection of the body as well as of the soul. Leibniz is here a good Catholic. Below man, the immortality of the soul is impersonal, merely a redistribution of energy. Only the rational soul of man will enjoy a conscious immortality. Good and evil are human terms, defined according to our pleasure and pain. These terms cannot be applied to the universe without presuming for man an omniscience possible only to God. This book is continued at this point on the other side of this cassette. Please reverse or turn the cassette over now. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant, Part 2, continued, Cassette 12, Side 2. Good and evil are human terms, defined according to our pleasure and pain. These terms cannot be applied to the universe without presuming for man an omniscience possible only to God. Imperfection in the part may be required for a greater perfection in the whole. So sin is an evil, but is a result of free will, which is a good. And even the sin of Adam and Eve was in some sense a felix culpa, a happy fault, since it resulted in the coming of Christ. There is in the universe no chaos, no confusion, save in appearance. The afflictions of men contribute to the greater good of those who suffer them. Even Holding to the established doctrine that the number of men damned eternally will be incomparably greater than that of the saved, we must say that the evil could not but seem to be almost as nothing in comparison with the good, when one contemplates the true vastness of the city of God. Since the proportion of that part of the universe which we know is almost lost in nothing compared with that which is unknown, it may be that all evils are almost nothingness in comparison with the good things which are in the universe. One need not even agree that there is more evil than good in the human kind. For it is possible, and even a very reasonable thing, that the glory and perfection of the blessed may be incomparably greater than the misery and imperfection of the damned. Imperfect as it may seem to our selfish sight, this world is the best that God could have created so long as he left men human and free. If a better world had been possible, we may be sure God would have created it. It follows from the supreme perfection of God that in producing the universe he chose the best possible plan, containing the greatest variety, together with the greatest order, the best arranged situation, place, and time, the greatest effect produced by the simplest means, the most power, the most knowledge, the most happiness and goodness in created things of which the universe admitted. For as all possible things have a claim to existence in the understanding of God in proportion to their perfections, the result of all these claims must be the most perfect actual world which is possible. We cannot recommend any further reading of Leibniz's Theodicy today, except to those who would appreciate to the full the bitter laughter of Candide. 7. Paralipomena. Nevertheless, the Theodicee became the most widely read of all Leibniz's books, and succeeding generations knew him as the best of all possible worlds man. If we must regret the edifying absurdity of that performance, our respect for the author revives when we contemplate the prodigious variety of his intellectual interests. Though science was but one corner of his thought, he was fascinated by it. If he had to live another life, he told Bayle, he would have been a biologist. He was one of the profoundest mathematicians of an age rich in mathematicians. He bettered Descartes' formula for measuring force. His conception of matter as energy seemed to his time a bravura of metaphysics, but it is now a commonplace of physics. He described matter as our confused perception of the operations of force. Like our contemporary theorists, he rejected the absolute motion assumed by Newton. Motion, said Leibniz, is simply change in the relative position of bodies, and thus is nothing absolute, but consists in a relation. Anticipating Kant, he interpreted space and time not as objective realities, but as perceptual relations. Space as perceived coexistence, time as perceived succession, views adopted in relativity theories today. In his final year, 1715, Leibniz entered into a long correspondence with Samuel Clarke about gravitation. This seemed to him another occult quality, acting at enormous distances through an apparent void. It would be, he objected, a perpetual miracle. No greater, replied Clarke, than pre-established harmony. Leibniz feared that Newton's theory of the cosmic mechanism would make many atheists. On the contrary, said Clarke, the majestic order revealed by Newton would strengthen the belief in God. The aftermath justified Leibniz. In biology, Leibniz vaguely visioned evolution. Like many thinkers before and after him, he saw a law of continuity running through the organic world. But he extended the concept to the supposedly inorganic world as well. Everything is a point or stage in an endless series, and is connected with everything else through an infinite number of intermediate forms. There is, so to speak, an infinitesimal calculus running through reality. Nothing is accomplished all at once, and it is one of my great maxims that nature makes no leaps. This law of continuity declares that we pass from the small to the great, and the reverse, through the medium, in degree as well as in parts. This is now questioned by many physicists. Men are linked with animals, these with plants, and these again with fossils, which in their turn are connected with those bodies which sense and imagination represent to us as completely dead and inorganic. In this majestic continuity, all antitheses dissolve through a great chain of being and hardly perceptible differences, from the simplest matter to the most complex, from the lowliest animalcule to the greatest ruler, genius, or saint. Leibniz's mind seemed to span the whole continuity that he described. He was au courant with every science. He knew the history of nations and of philosophy. He touched the worldly affairs of a dozen states. He was at home with atoms and with God. In 1693 he published a paper on the beginnings of the earth, quietly ignoring Genesis, and he developed his geological ideas in a treatise, Protogaea, which was published in 1749 after his death. Our planet, he thought, had once been an incandescent globe. It gradually cooled, contracted, and formed a crust. As it cooled, the vapor surrounding it condensed into water and oceans, which became salty by dissolving minerals in the crust. Subsequent geological changes were due either to the action of water flooding the surface, leaving sedimentary formations, or to the explosion of subterranean gases, leaving igneous rocks. The same treatise gave an excellent explanation of fossils and advanced toward a theory of evolution. It seemed to him worthy of belief that in the course of vast changes in the crust of the earth, even the species of animals have many times been transformed. He thought it probable that the earliest animals were marine forms, and that the amphibia and land animals were descended from these. Like some optimists of the 19th century, he saw in this evolutionary transformism one basis for faith in a perpetual and unrestricted progress of the universe. Progress will never come to an end. From biology, Leibniz jumped to Roman law, and from this to Chinese philosophy. His Novissima Sinaica from 1697, the latest news from China, eagerly took up the reports that missionaries and merchants were sending from the Middle Kingdom. He held it probable that in philosophy, mathematics, and medicine the Chinese had made discoveries which might be of great help to Western civilization, and he urged cultural links with Russia partly as a means of opening cultural communication with the East. He corresponded with scholars, scientists, and statesmen in 20 countries and 3 languages. He wrote some 300 letters every year. 15,000 of them have been preserved. Voltaire's correspondence rivals this in quantity, but yields to it in intellectual diversity. Leibniz suggested an international culture bourse, or exchange, through which men of learning could compare notes and ideas. He planned an international language, Characteristica Universalis, in which each idea in philosophy and science would have its symbol or character, so that thinkers could manipulate notions by this ars combinatoria, just as mathematicians used signs for quantities. So he came close to founding mathematical or symbolic logic. By a kind of noble futility, he distributed himself into so many areas that he left hardly anything but fragments behind him. Our eager polymath found no time for marriage. At last, aged 50, he proposed, but, says Fontenelle, the lady asked for time to take the matter into consideration, and as Leibniz thus obtained leisure to consider the matter again, he never married. After his travels and his flights into diplomacy, he treasured the privacy of his study, and he who had touched half the world with the tentacles of his mind now kept his friends at a distance as enemies to his work. He lost himself in reading and writing, often through the night, seldom taking note of Sundays or holidays. He had no servant. He sent out for his meal and ate it alone in his room. If he stirred out, it was to make researches or pursue his schemes for the advancement of learning, science, or amity. He dreamed of establishing academies in the great capitals, and succeeded in one. The Berlin Academy was founded in 1700 on his initiative, and elected him its first president. He met Peter the Great at Torgau in 1712, and again at Carlsbad and Pyrmont. He proposed a similar academy for St. Petersburg. The Tsar loaded him with gifts and adopted his suggestion for governing Russia through administrative colleges. But Leibniz did not live to see the Academy of St. Petersburg take form in 1724. In 1712, we find him in Vienna, itching for an imperial post and pregnant with another academy. He submitted to Charles VI the plan for an institution that would promote not only science, but education, agriculture, and industry. He offered his services to direct it. The emperor raised him to the ranks of the nobility and made him an imperial counselor in 1712. His long absences from Hanover angered the new elector George. Leibniz's salary was for a period discontinued, and he was warned that it was time, after a quarter-century of interruptions, that he should finish his history of the House of Brunswick. When Queen Anne died, George left Hanover to take the throne of England. 3 days after this departure, Leibniz arrived from Vienna in 1714. He had hoped to be taken to London and enjoy there some loftier office and emoluments. He sent conciliatory letters to the new king, but George I answered that until the annals were complete, Leibniz had better remain in Hanover. Besides, England had not forgiven him for disputing with Newton the parentage of calculus. Disappointed and lonely, he struggled for 2 years more to believe in the good intentions of the universe. the man who was remembered in the 18th century as the apostle of optimism, died in pain of gout and stone at Hanover on November 14, 1716. His death was not noticed by the Berlin Academy, nor by the German courtiers in London, nor by any friends at home, for these had been alienated by his absences and his privacy. No clergyman came to administer religious rites to the philosopher who had defended religion against philosophy. One man alone, his former secretary, attended the funeral. A Scotsman then in Hanover wrote that Leibniz was buried more like a robber than what he really was, the ornament of his country. We must not spend space marking the flaws in this polymorphous multitude of ideas. Time has long since performed these unpleasant obsequies. Critics have charged Leibniz with ubiquitous borrowing. They have found his psychology in Plato, his theodicy in the scholastics, his monads in Bruno, his metaphysics, ethics, and mind and body relation in Spinoza. But who can say anything on these problems but what has been said 100 times before? It is easier to be original and foolish than to be original and wise. There are 1,000 possible errors for every truth, and mankind, with all its efforts, has not yet exhausted the possibilities. There is much nonsense in Leibniz, but we cannot quite decide whether it was honest nonsense or protective discoloration. So he tells us that when God created the world, he saw in a flash, in its most minute detail, everything that was to happen in history. I always begin as a philosopher, he said, but I always end up as a theologian. That is, he felt that philosophy missed its aim if it did not lead to virtue and piety. His long and genial debate with Locke gave him one of his many claims to significant thought. He may have exaggerated the innateness of innate ideas, but he admitted that they were capacities, instincts, or aptitudes rather than ideas, and he succeeded in showing that Locke's sensationism had oversimplified the process of knowledge, and that mind is by its nature, if only crudely at birth, an organ for the active reception, manipulation, and transformation of sensations. Here, as in his views of space and time, Leibniz stands high as a precursor of Kant. The doctrine of monads is shot through with difficulties. If they are not extended, how can any number of them produce extension? If they perceive the universe, how can they be immune to external influence? But it was an illuminating attempt to bridge the chasm between mind and matter by making matter mental rather than mind material. Of course, Leibniz failed to reconcile mechanism and design in nature, or mechanism in the body with freedom in the will, and his reseparation of mind and body, after Spinoza had united them in one two-sided process, was a step backward in philosophy. His pretense that this was the best of all possible worlds was the gallant or hopeful effort of a courtier to comfort a queen. The most learned of philosophers, a whole academy in himself, Frederick the Great called him, wrote theology as if nothing had happened in the history of thought since St. Augustine. But with all his shortcomings, his achievements in science and philosophy were immense. Patriot and yet good European, he restored Germany to a high place in the development of Western civilization. Of all who made Germany illustrious, wrote Frederick II, those rendering the greatest service to the human spirit were Thomasius and Leibniz. His influence diminished as his theology lost face before the moral consciousness of mankind. Within a generation after his death, his philosophy was given a systematic reformulation by Christian von Wolff, and in the modified form it became the dominant fashion of thought in the German universities. Outside Germany, his influence was slight. Though most of his writings were in French, they were too fragmentary to exert any consistent or concentrated force. No collected edition appeared till 1768, and even then some important but heterodox items were excluded, and had to wait till 1901 to venture into print. His calculus notation was destined to victory, but for half a century his rivals, Newton and Locke, carried everything before them and became the idols of the French Enlightenment. Yet even amid that ecstasy of reason, Buffon ranked Leibniz as the greatest genius of his age. The outstanding German thinker of the 20th century, Oswald Spengler, considered Leibniz without doubt the greatest intellect in Western philosophy. To round out these superlatives, we may add that all in all the 17th century was the most productive in the history of modern thought. Bacon, Descartes, Hobbes, Spinoza, Locke, Bayle, Leibniz. Here was a majestic sequence of men warm with the wine of reason, joyfully confident, most of them, that they could understand the universe, even to forming clear and distinct ideas about God, and leading, all but the last, to that heady enlightenment which was to convulse both religion and government in the French Revolution. Leibniz foresaw that terminus, and while he continued to the end to defend freedom of speech, he urged freethinkers to consider the effect of their spoken or written words upon the morals and spirit of the people. About 1700, in the Nouveau Essai, he uttered a remarkable warning. If fairness wishes to spare persons, freethinkers, piety demands the representation, where it is fitting, of the bad effects of their dogmas when they are contrary to belief in the providence of a perfectly wise, good, and just God, and contrary to that immortality of souls which renders them susceptible to the effects of his justice, not to speak of other opinions dangerous as regards morality and the police. I know that excellent and well-meaning men maintain that these theoretic opinions have less influence upon practice than is thought, and I also know that there are persons of an excellent disposition whom these opinions will never make do anything unworthy of themselves. It may be said that Epicurus and Spinoza, for example, have led a life wholly exemplary. But these reasons cease most frequently in their disciples or imitators, who, believing themselves released from the troublesome fear of an overseeing providence and of a menacing future, give loose reins to their brutish passions, and turn their minds to the seduction and corruption of others. And if they are ambitious, and of a disposition somewhat harsh, they will be capable, for their pleasure or advancement, of setting on fire the four corners of the earth. I have known this from the character of some whom death has swept away. I find also that similar opinions, insinuating themselves little by little into the minds of men of high life who rule others, and upon whom affairs depend, and slipping into the books of fashion, dispose all things to the general revolution with which Europe is threatened. There is a spirit of sincere concern in these lines, and we must respect the counsel of caution that they express. And yet, even after the Enlightenment had crumbled creeds, and the French Revolution had set on fire the four corners of the earth, and the September massacres had transiently sated the thirst of the gods, a major historian could look back to this first age of modern science and philosophy and see its adventurers not as destroyers of civilization, but as liberators of mankind. Said Lecky, "It was thus that the great teachers of the 17th century disciplined the minds of men for impartial inquiry, and having broken the spell that so long had bound them, produced a passionate love of truth which has revolutionized all departments of knowledge. It is to the impulse which was then communicated that may be traced a great critical movement which has renovated all history, all science, all theology, which has penetrated into the obscurest recesses, destroying old prejudices, dispelling illusions, rearranging our knowledge, and altering the whole scope and character of our sympathies. But all this would have been impossible but for the diffusion of a rationalistic spirit." So, for good or ill, the 17th century laid the foundations of modern thought. The Renaissance was tied to classical antiquity and to Catholic ritual and art. The Reformation was bound to primitive Christianity and a medieval creed. Now this rich and fateful era, from Galileo to Newton, from Descartes to Bayle, from Bacon to Locke, turned its face toward an uncharted future that promised all the dangers of liberty. It deserved, perhaps even more than the 18th century, the name Age of Reason. For though its thinkers were still the voices of a small minority, they displayed a wiser moderation, a deeper sounding of the limits and difficulties of reason and freedom than the unmoored protagonists of the French Enlightenment. In any case, the greatest drama in modern history had played its second act and moved on to its fulfillment. Book 5. France against Europe, 1683 to 1715. Chapter 24. The last chapter. The Sun Sets. 1. Madame de Maintenon. After the death of Marie-Thérèse on July 30th, 1683, the uncrowned Queen of France was the widow Scarron, the Marquise de Maintenon, governess of the king's bastards, soon, about January 1684, his morganatic wife, and henceforth the strongest personal influence in the reign. It is difficult today to know her real character, and historians still debate it. She had many enemies who resented her rise in power. Some of them wrote history and handed her down to us as a selfish, scheming villain. However, when she might have replaced Madame de Montespan as royal mistress, with all the influence that this would bring, she refused, and instead persuaded the king to return to the bed of the Queen in August 1680. The Queen was then 42, 3 years younger than La Maintenon, and there was no reason to expect her early death. At this point, apparently, the Marquise preferred virtue to power. When death took the Queen, the governess still refused to become a mistress. She played for higher stakes, risking her present place. If her virtue was ambition, it was no more sullied by it than the modesty of a prudent maiden, who has only her charms to bargain for her life and thinks a night's lodging less security than a wedding ring. When Louis married Maintenon, she was 48 years old. Mignard pictured her as an amiable matron long past the age of physical allure. At best, she was sincerely pious. At worst, she took a brave gamble and won. Placed now in an apartment near the king's, she lived in the Palace of Versailles with an almost bourgeois simplicity. Court life was irksome to her, and she had no pleasure in ostentation. She did not accumulate wealth. Even at the crest of her curve, she owned little more than the chateau of Maintenon, which she left unfurnished and unused. In their later years, Louis is reported to have said to her, "But, madam, you have nothing, and if I die you will be destitute. Tell me what I can do for you." She asked some modest favors for her relatives and considerable sums for her pet enterprise, the college, that in 1686 she established at Saint-Cyr for girls of good family but straitened means. It was not her vanity, but the king's, that conscripted labor and money for the abortive aqueduct that took her name. In many ways she was a good wife. Her constant occupation through a busy day was to serve as a buffer between the king and the world, to maintain peace amid the ambitions and intrigues of courtiers, to humor a swarm of place-seekers, to serve as a kindly aunt to her husband's grandchildren, to meet his masculine needs, to comfort him in his failures and defeats, to amuse the man most difficult to amuse in all his kingdom, and to bring an atmosphere of domestic calm into a life that in almost every hour had to make decisions affecting 1,000,000 lives. Among her private papers found after her death was this prayer, apparently composed soon after her marriage. "Lord God, thou hast placed me where I am, and I submit myself to thy providence without reserve. Grant me grace that as a Christian I may support its sorrows, sanctify its pleasures, seek in everything thy glory, and help the salvation of the king. Prevent me from giving way to the agitations of a restless mind. Thy will, O God, not mine, be done. For the sole happiness in this world and the next is to submit to it without reserve. Fill me with this wisdom, and all other spiritual gifts necessary to the high place to which thou hast called me. Make fruitful the talents thou hast been pleased to give me. Thou who holdest in thy hands the hearts of kings, open that of the king, that I may set therein the good that thou desirest. Enable me to please, console, encourage, and even, if it be necessary to thy glory, to sadden him. Let me hide none of the things he might learn from me which others have not the courage to tell him. Let me save myself together with him. Let me love him in thee and for thee. And let him love me in the same way. Grant that we may walk together in thy paths without reproach till the day of thy coming." This is beautiful as any letter of Héloïse to Abélard, and we hope more authentic. Such a prayer can give strength regardless of any external response. Perhaps there is a secret will to power in the desire to reform and guide others, but Maintenon's remaining years proved the sincerity as well as the narrowness of her piety. She found a king, said Saint-Simon, who believed himself an apostle because he had all his life persecuted Jansenism. This indicated to her with what grain she could sow the field most profitably. Did she encourage the persecution of the Huguenots? Saint-Simon thought so, but later investigation tends to clear her of this inhumanity, in which Louvois, her constant enemy, was the protagonist. Lord Acton, a Catholic historian seldom pro-Catholic, judged her the most cultivated, thoughtful, and observant of women. She had been a Protestant, and retained for a long time the zeal of a convert. She was strongly opposed to Jansenists, and was much in the confidence of the best men among the clergy. It is universally believed that she promoted persecution and urged the king to revoke the Edict of Nantes. Her letters are produced in evidence, but her letters have been tampered with by an editor who was a forger and a falsifier. Like Fénelon, Madame de Sévigné, and nearly all Catholics at the time, she approved the revocation, but she used her influence, often successfully, says the Protestant Michelet, to check the cruelty of the persecution. Lest a romantic tendency to idealize woman should color the picture with roses, let us look at the Marquise through other prejudices. Saint-Simon's ducal pride could never forgive the rise of the lowly bourgeoise to be mistress of France. The distress and poverty in which she had so long lived had narrowed her mind and abased her heart and her sentiments. Her feelings and her thoughts were so circumscribed that she was in truth always less even than Madame Scarron. Nothing was more repellent than this meanness, meaning low origin, joined to a situation so radiant. Even so, the Duke found some virtues amid her faults. Madame de Maintenon was a woman of much wit, which the good company in which she had at first been merely suffered, but in which she soon shone, had much polished and ornamented with knowledge of the world, and which gallantry had rendered of the most agreeable kind. The various positions she held had rendered her flattering, insinuating, complacent, always seeking to please. The need she had of intrigues, those she had seen of all kinds, and been mixed up in for herself and for others, had given her the taste, the ability, and the habit of them. Incomparable grace, an easy manner, and yet measured and respectful, which, in consequence of her long obscurity, had become natural to her, marvelously aided her talents, with language gentle, exact, well expressed, and naturally eloquent and brief. Her best time, for she was 3 or 4 years older than the king, had been the dainty phrase period, the superfine gallantry days. She put on afterwards an air of importance, but this gradually gave place to one of devoutness that she wore admirably. She was not absolutely false by disposition, but necessity had made her so, and her natural flightiness made her appear twice as false as she was. Macaulay, from the pathos of distance, took a more chivalrous view. Perhaps he felt that much could be forgiven in a woman who was both eloquent and brief. When she attracted the notice of her sovereign, she could no longer boast of youth or beauty, but she possessed in an extraordinary degree those more lasting charms which men of sense prize most highly in a female companion. A just understanding, an inexhaustible yet never redundant flow of rational, gentle, and sprightly conversation, a temper of which the serenity was never for a moment ruffled, a tact which surpassed the tact of her sex as much as the tact of her sex surpasses the tact of ours. Such were the qualities which made the widow of a buffoon first the confidential friend, then the spouse of the proudest and most powerful of European kings. Finally, see her through the eyes of Henri Martin, a French historian of inadequately recognized excellence. There was a harmony of mind and manners between them, the Marquise and the king, which was destined to increase with age, and her regular, gentle, and serious beauty, heightened by rare natural dignity, was essentially fitted to please Louis. She loved consideration as he loved glory. Like him, reserved, circumspect, and yet full of attraction and grace, she had the same charm of conversation, and sustained this charm longer by the resources of a richer imagination and a more varied education. Like him, she had the individuality of vigorous and self-seeking organizations, yet she was capable of lasting and solid, if not ardent, affections. She was at once less passionate and more constant than the king, who was to be, in friendship as in love, truly constant to her alone. But she had never known what it was to sacrifice to her feelings either her interests or her repose. Contrary to Louis XIV, she was devoted in small things, and devoid of generosity in great ones. Her calm, reflective, reasoning character, incapable of impulse and of illusion, aided her to defend a virtue often besieged. In any case, there must have been many admirable qualities in a woman whom so masterful a king could choose as his wife, and whom he trusted with cognizance of the most intimate affairs of state. Usually he met his ministers in her private room, in her presence and hearing, and though she maintained a discreet distance and silence, busying herself with her needlework, Louis sometimes turned to her and asked her judgment, which he valued so highly that he called her votre solidité. Skeptics called her Madame de Maintenon, Madame Now, presuming that she would soon be joined or displaced by rivals. On the contrary, the king remained her loving husband till his death. Her influence grew with every year, and was as beneficent as her piety would permit. She tried to moderate the king's extravagance and to divert him from war, hence the hostility of Louvois. She secured royal support for charities, hospitals, convents, help for bankrupt nobles, dowries for demoiselles. None but good Catholics could win her recommendation for office. She had vines or drapes drawn over the more vital nudities in the art that decorated Versailles. She changed Saint-Cyr from a college to a convent in 1693, whose doors were henceforth closed to the world. She herself became almost a nun in a palace. With her shut-in life, spending hours in solitude, she seemed to have one foot in a nunnery. The king began by laughing at her piety. He ended by imitating it this side of humility. The priests about him rejoiced to see the regularity with which he performed the rituals of devotion, but she understood him well. The king, she said, never misses a station of the cross or a penance, but he cannot understand the necessity of humbling himself and acquiring the true spirit of repentance. Pope Alexander VIII, however, was satisfied and congratulated Madame upon reforming the once anti-papal Gallican. perhaps the decline of his physical energy after 1684, and his sufferings from an anal fistula furthered the king's piety by reminding him of his mortality. On November 18, 1686, he submitted to a painful operation which he bore with class-conscious courage. For a time, the anti-French coalition rejoiced in the rumor that he was dying. He survived, and when he went to Notre Dame on January 30, 1687, to thank God for his cure, all Catholic France hailed his recovery with festive joy. From that time, said Voltaire, the king no longer went to the theatre. The gaiety and dignity that had characterized the earlier half of his reign gave way to a seriousness that sometimes neared austerity, but permitted occasional excesses of bed and board. Prompted by fatigue, seconded by Maintenon, he reduced the parade and ceremony of the court and retired to a more private life, content with the domesticity to which his wife had accustomed him. He was still extravagant in his expenditures on palaces and gardens, still as proud as his sceptre and as sensual as his jowls. In March 1686 he allowed an obsequious courtier, François d'Aubusson, later Duc de la Feuillade, to erect on the Place des Victoires a statue dedicated to him as the immortal man. We must add, however, that when d'Aubusson wished to provide a votive lamp to be kept lighted before the statue night and day, the king forbade this premature assumption of divinity. An inner circle of devout aristocrats, led by the Duke and Duchess of Chevreuse, the Duchesses of Beauvilliers and Mortemart, and the three daughters of Colbert, formed around the king and his wife a cordon sanitaire of devots, many of them sincerely religious, and some of them adopting the mystic quietism of Madame Guyon. The world-famous hymn Adeste Fideles was composed by an unknown French poet about this time. The remainder of the court joined only outwardly in the new mood of the king. It abandoned its frivolity, went more frequently to mass and communion, less and less to the opera and the theatre, which now rapidly declined from their heyday under Lully and Molière. Hunts, costly banquets and balls, and card-playing for high stakes went on, but in an atmosphere of moderation touched with reminiscent gloom. The roisterers and freethinkers of Paris hid their heads, waiting for revenge under an impatiently expectant regency, but the people of France rejoiced in the saintliness of their ruler, and silently bore, in death and taxes, the swelling levies of war. 2. The Grand Alliance, 1689 to 1697. Taxes rose even as prosperity declined. Colbert's massive system of state-regulated commerce and industry had begun to collapse before his death in 1683. Partly it died through the drain of men from farms and factories to camps and battlefields. Chiefly it died through self-strangulation. Governmental regulations stifled the growth that might have come under less supervision and restraint, more liberty to breathe, to experiment, and to err. Enterprise found itself bound by a maze of orders and penalties. The complex mechanism of economic activity, moved by the toilsome hunger of the many and the inventive greed of the few, groaned and stumbled under a mountain of rules and threatened to halt. So soon as 1685, we hear the cry of laissez-faire, 65 years before Quesnay and Turgot, 91 before Adam Smith. The supreme secret, said one of Louis XIV's intendants, is to allow complete freedom of trade. Never had manufacturers and commerce so wasted away in this realm as since we have taken it into our heads to build them up by the decrees of the state. Other factors contributed to decay. Huguenots fleeing from persecution took with them their economic skills and sometimes their savings too. Commerce suffered from the king's desire to conquer rather than to trade. Exports were balked by foreign tariffs, retaliating against French import dues. The English and the Dutch proved to be better seamen and colonizers than the proud and impatient Gauls. The Compagnie des Indes failed. Taxes discouraged agriculture, and a dishonest currency confused and palsied finance. The ministers who served Louis after the death of Colbert could not compare in ability with those whom the king had inherited from Richelieu and Mazarin. Colbert's son, Jean-Baptiste, the Marquis de Seignelay, received the ministries of commerce and marine. Claude Lepelletier took charge of finance, but was soon succeeded by Louis Philippot, Seigneur de Pontchartrain. Louvois remained minister of war. The new men were awed by Louis XIV's accumulated glory and authority. They feared to make decisions, and the machine of state waited upon the burdened mind of the king. Only Louvois had a will of his own, and it was all for war, against the Huguenots, against the Netherlands, against any prince or people that stood in the path of expanding France. For Louvois had built the finest army in Europe. He had trained it to discipline and bravery, and equipped it with the latest weapons, and had taught it the gentle art of the bayonet. How could such a force be fed or keep its morale unless it fought and won? France looked upon that army with pride. All the rest of Europe heard of it with anger and dread. When in May 1685 Louis claimed part of the Elector Palatine's estate as the inheritance of the dead Elector's sister Charlotte Elizabeth, now Duchesse d'Orléans, the princes of the empire wondered what demands would come next from the aggressive king. The tension rose when Louis in effect bound Cologne, Hildesheim, and Münster to France by securing the election of his nominees as their episcopal princes in 1686. On July 6th, the Catholic Emperor Leopold I and the Catholic Elector Maximilian II Emmanuel of Bavaria joined the Protestant Great Elector of Brandenburg, the Protestant King Charles XI of Sweden, and the Protestant Stadtholder William III of the United Provinces, in forming the League of Augsburg for defense against any attack upon their territories or their powers. The Emperor was still busy with the retreating Turks, but their defeat at the Second Mohács in 1687 and at Belgrade in 1688 freed the imperial troops for action on the empire's western front. The King of France now made the pivotal mistake of his military career. The Stadtholder had expected him to renew the assault upon Holland. Instead, Louis decided to invade Germany before the imperial forces could be assembled on his frontier. On September 22, 1688, he dispatched his main divisions toward the Rhine with a characteristic speech to the 27-year-old Dauphin. "My son, in sending you to command my armies, I give you opportunities of making your merit known. Show it to all Europe, so that when I come to die, no one will perceive that the king is dead." On September 25th, the French army swept into Germany. Within a month it took Kaiserslautern, Neustadt, Worms, Bingen, Mainz, and Heidelberg. On October 29th, the strategic forces of Philipsburg fell. On November 4th, the triumphant Dauphin advanced to attack Mannheim. Perhaps it was these victories that began the downfall of the king, for they committed him to a long war with a swelling host of foes. They freed Holland from fear of an early invasion. They induced the States General of the United Provinces to give its consent and support to the conquest of England by William III. As soon as he had certified his power, William turned England from a dependency into an enemy of France, and pleaded with his new subjects to take their part in defending the political and religious liberty of Europe. Parliament hesitated. It suspected that William's main interest was to save Holland, and Holland was England's greatest commercial competitor. But again the victories of France strengthened William's plea. Louvois had urged Louis to let him devastate the Palatinate in order to deprive the oncoming enemy of any local means of subsistence. Louis reluctantly agreed. In March 1689, the French army sacked and burned Heidelberg and Mannheim, then Speyer, Worms, Oppenheim, parts of the Archbishopric of Trier, and the Margraviate of Baden. Nearly all the German Rhineland was ruined. Voltaire described the atrocity with the conscience of a good European. It was in the heart of winter. The French generals could not but obey, and accordingly they announced to the citizens of those flourishing and well-ordered towns, to the inhabitants of the villages, and to the masters of more than 50 castles, that they would have to leave their homes, which were to be destroyed by fire and sword. Men, women, old people, and children departed in haste. Some went wandering about the countryside, others sought refuge in neighboring territory, while the soldiery burnt and sacked the country. They began with Mannheim and Heidelberg, the seats of the electors. Their palaces, as well as the houses of the common citizens, were destroyed. For the second time, this beautiful country was ravaged by Louis XIV. But the flames of the 2 towns and 20 villages which Turenne had burned in the 1674 devastation of the Palatinate were but sparks compared with this conflagration. From all Germany, the Netherlands, and England, a cry rose for vengeance against the King of France. German pamphleteers denounced the French soldiers as Huns, dead to any human feelings. They described Louis as a monster, a blasphemer, a barbarian worse than any Turk. German historians taunted the French people with having received their civilization from the Franks, that is, Germans, and their universities from the Holy Roman Emperors, that is, Germans. Pierre Jurieu, Huguenot exile in Holland, had already published there a powerful diatribe, The Size of a France Enslaved, branding Louis as a bigoted tyrant and calling upon the French people to depose him and establish a constitutional monarchy. The French press replied with appeals to the citizens to hurl back these insults into the faces of the enemy and come to the rescue of their brave, beleaguered, beloved king. On May 12, 1689, England joined the Empire, Spain, the United Provinces, Denmark, and Savoy in the First Grand Alliance, which pledged itself to defend each of its members against external aggression. The war was now of Europe against France. Louis responded by raising his armies to 450,000 men, his navy to 100,000 personnel. Europe had never seen such armed hosts before. The king melted down his silverware to help taxation pay the cost of these multitudes. He ordered all private individuals and many churches to do the same, and he allowed Pontchartrain to remint and depreciate the currency by 10%. The minister created new offices, restored old ones that had lapsed, and sold them to place-seekers infatuated with titles. "Every time your majesty creates an office," he said to Louis, "God creates a fool to purchase it." Seignelay advised the king to order his fleet to cut off Ireland from England. It might have been done, for on June 30th, 1690, Admiral de Tourville, with 75 ships, defeated a combined Dutch and English fleet at Beachy Head off the East Sussex coast. But Louis sent only 2,000 men to support James II in Ireland. A larger force might have won the Battle of the Boyne on July 1st, 1690, and might have kept England and its Dutch king too busy in Ireland to fight on the continent. William III, by the victory, was free to go to Holland in 1691 and lead English and Dutch troops against the French. In 1692, Louis attempted an invasion of England. A fleet from Toulon was ordered to sail north and join a fleet under Tourville at Brest. Together they were to beat down any English resistance and carry 30,000 troops across the Channel. The squadron from Toulon, checked by a storm at Gibraltar, failed to reach Tourville and had to fight unaided the united Dutch and English fleets. He was defeated in a decisive engagement off La Hogue, near Cherbourg, on May 19, 1692, and the invasion was turned back. After this victory, England remained mistress of the seas, free to capture from France one after another of her colonies. The Channel protected England till our time. On land, the French continued their victories, though at enormous cost in materials and men. In April 1691, proud to anesthesia under the eyes of their king, they besieged and took strategic Mons. Louvois died on July 7th, but Louis was not quite displeased at being freed from his aggressive minister of war. He proposed henceforth to guide all military policy himself. He observed an old French custom when he gave Louvois' post to Louvois' son, the amiable and tractable 24-year-old Marquis de Barbezieux. In June 1692, Louis led his troops in person to the capture of Namur. Then, leaving the command to the Duke de Luxembourg, he returned. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant, Part 2, continued, Cassette 13, Side 1. A year later, the same French army, under the same general, defeated William at Neerwinden, near Brussels. Here, too, the slaughter was immense, 20,000 of the Allies, 8,000 of the French. No matter how often William was beaten, he soon appeared with a new army and fresh funds. In August 1694, he recaptured Namur, and France discovered that after 5 years of bloodshed, it had failed to conquer even the Spanish Netherlands. Other French armies won victories in Italy and Spain, but found it hard to hold their gains against foes and supplies rising replenished on every side. In July 1694, an English fleet sailed to attack Brest. Some friends in England, including, it was said, Marlborough himself, had betrayed the plan to James II. So forewarned, the French lined the coast at Brest with guns, and the English were repulsed with heavy losses. In January 1695, the Maréchal de Luxembourg died, and Louis was left with only second-rate generals. Though its soil had been hardly touched by the Allies, France was feeling the burden of a new kind of war, in which no hired mercenaries fought the battles, but whole nations were conscripted for competitive massacre. Even while they acclaimed their generals, their heroes, and their victories, the French people, taxed as never before, were nearing exhaustion in body and spirit. In 1694, famine was added to destitution. In one diocese alone, there were 450 deaths from starvation. The national economy verged on collapse. Transportation was in chaos, for the repair of bridges and roads had almost stopped during the war. Internal trade was choked by tolls exacted at 100 places on rivers or land. Foreign commerce, already hampered by import and export dues, was made almost impossible by enemy fleets and privateers. Those who had lived by coastal fishing or trade were ruined. Hundreds of towns were depleted of their resources by their support of troops quartered upon them. Poverty, famine, disease, and war reduced the population of France from some 23 million in 1670 to some 19 million in 1700. The province of Touraine lost a fourth of its people. Its capital, Tours, had only 33,000 left of the 80,000 who had peopled it under Colbert. Hear the reports of intendants from various parts of France toward the end of the 17th century. This town, formerly rich and flourishing, is today without any industry. There were formerly manufactures in this province, but today they have been abandoned. The inhabitants formerly obtained much more from the soil than they do at present. Agriculture was infinitely more flourishing 20 years ago. Population and production have diminished by 1/5 these last 30 years. In 1694, Fénelon, soon to be Archbishop of Cambrai, addressed to Louis XIV an anonymous letter which is one of the high-water marks of the French spirit. Sire, he who takes the liberty to write you this letter has no worldly interest. He writes through neither disappointment nor ambition, nor through desire to mingle in great affairs. He loves you without being known to you. He sees God in your person. There is no evil that he would not gladly suffer to make you recognize the truths necessary to your salvation. If he speaks strongly to you, do not be surprised. It is only because truth is free and strong. You are not used to hearing it. People accustomed to be flattered mistake for resentment, bitterness, or excess that which is only pure truth. It would be treason to the truth not to show it to you. God is witness that he who now speaks to you does so with a heart full of zeal, of respect, of fidelity, and devotion for everything that concerns your real interest. For some 30 years past, your chief ministers have overturned all the ancient maxims of state to raise your authority to the utmost, because it was in their hands. No one spoke any more of the state and its laws. They only spoke of the king and his good pleasure. They have extended your revenues and your expenditure without limit. They have raised you to the skies in order, they say, to efface the grandeur of all your predecessors combined, but actually they have impoverished all France to establish at the court a monstrous and incurable luxury. They have wished to elevate you upon the ruin of every class in the state, as if you could be great while ruining all the subjects upon whom your greatness depends. True, you have been jealous of authority, but in reality each minister has been master within the scope of his administration. They have been hard, haughty, unjust, violent, and of bad faith. In domestic and foreign affairs they have known no rule but to threaten, remove, or destroy everything that opposed them. They have accustomed you constantly to receive extreme praises verging upon idolatry, which, for your own honor, you should have rejected with indignation. They have made your name hateful, and the whole French nation unbearable to neighboring peoples. They have retained none of our old allies because they wanted only slaves. They have been the cause, through 20 years of bloody wars whose only motives were glory and vengeance. All the frontiers that have been extended by war have been unjustly acquired. You have always wished to dictate peace, to impose conditions, instead of arranging them with moderation. That is why no peace has endured. Your enemies, shamefully struck down, have only one thought: to stand up again and unite themselves against you. Is it surprising? You have not even stayed within the limits of the peace terms that you so proudly dictated. In time of peace you have made war and immense conquests. Such conduct has aroused and united all Europe against you. Meanwhile your people, whom you should have loved as your children, and who have till now been so devoted to you, are dying of hunger. The cultivation of the earth is almost abandoned. The towns and the countryside are depopulated. All industry languishes, and no longer supports the workers. All commerce is destroyed. You have consumed half the wealth and vitality of the nation to make and defend vain conquests abroad. All France is now but a vast hospital, desolate and without provisions. The magistrates are worn out and despised. Popular uprisings, so long unknown, increase in frequency. Paris itself, so near you, is not exempt. Its officials must tolerate the insolence of rebels and spread money to appease them. You are reduced to the sad and disgraceful extremity of letting sedition go unpunished and therefore grow, or to slaughter without pity people whom you have driven to despair by snatching from them, through taxes for war, the bread that they toil to earn by the sweat of their brows. For a long time now the arm of God has been raised above you, but he is slow to strike because he pities a prince who all his life has been surrounded by sycophants, and because also your enemies are his. You do not love God, you only fear him, and with a slavish fear. Your only religion consists in superstitions, in petty superficial observances. You love only your glory and your gain. You bring back everything to yourself as if you were the God of the earth, and everything else were made to be sacrificed to you. On the contrary, God has put you in this world only for your people. We have hoped, sire, that your counsel would draw you away from the wrong road, but it has neither the courage nor the strength. At least Madame de Maintenon and Monsieur le Duc de Beauvilliers might use the confidence you place in them to undeceive you. But their weakness and timidity are a disgrace and scandal before the world. You ask, perhaps, sire, what it is they should do. This: they should show you that you must humble yourself under the powerful hand of God if you do not wish him to humble you, that you must ask for peace and expiate by that humiliation all the glory which you have made your idol, that to save the state you must as soon as possible restore to your enemies all that you cannot with justice retain. Sire, he who tells you these truths, far from opposing your interests, would give his life to see you such as God wishes you to be, and he will not cease to pray for you. Fénelon did not dare send this letter directly to the king. He had it delivered to Madame de Maintenon, perhaps hoping that, though she might not show it to Louis, she would be moved by it as reflecting the mood of the people to use her influence for peace. She turned it over to Archbishop de Noailles with this comment: "It is well written, but such truths only irritate or discourage the king. We must lead him gently in the way he should go." She had written in 1692, "The king knows the sufferings of his people, and he seeks all means of relieving them." Doubtless she knew what reply he would have made to Fénelon, that the maxims of Christianity could not be used in dealing with states, that a generation of Frenchmen might justly be sacrificed if thereby the future of France could be ensured by natural and more defensible boundaries, and that an attempt to secure peace from the united and vengeful allies would open France to invasion and dismemberment. Caught in the conflict between the religion of brotherhood and the philosophy of war, Maintenon went more and more frequently to Saint-Cyr and sought in the fellowship of the young nuns the happiness that she had not found in power. Toward the close of the war, Pierre le Paysan, Sieur de Bois-Guilbert, lieutenant general of the region around Rouen, brought to Pontchartrain a plan to mitigate the economic chaos and public destitution. "Listen to me patiently," he urged the finance minister. "You will at first take me for a fool. Then you will see that I deserve attention. Finally, you will be satisfied with my ideas." Pontchartrain laughed at him and sent him away. The angry magistrate published his rejected manuscript as Le Détail de la France in 1697. It denounced the multiplicity of taxes, which fell heavily upon the poor, lightly upon the rich. It condemned the Church for absorbing so much land and wealth. It excoriated the financiers whose sticky fingers clung to the taxes they collected for the king. The argument was weakened by exaggerations, careless statistics, and erroneous views of French economic history before Colbert, but it was sharpened by insights that a government accustomed to regulate everything was not equipped to understand. Bois-Guilbert was among the first to reject the mercantilist delusion that the precious metals are in themselves wealth, and that the purpose of trade is to accumulate gold. Wealth, he held, is an abundance of goods and of power to produce them. The ultimate wealth is land. The farmer is the base of the economy, and his ruin involves the ruin of all. Ultimately, all classes are bound in a community of interests. Every producer is a consumer, and any advantage that he secures as a producer is sooner or later annulled by his disadvantage as a consumer. Colbert's regulatory system was a mistake. It was hampering production and hardening the arteries of trade. The wisest way is to let men produce, sell, and buy freely within the state. Let the natural ambition and acquisitiveness of men operate with a minimum of legal restraint. So freed, they will invent new methods, enterprises, uses, tools. They will multiply the fertility of the land, the products of industry, and the range and activity of commerce. And the resultant increase of wealth will provide new revenue for the state. Inequities will arise, but the economic process itself will remedy them. Here again was laissez-faire 2 centuries before the heyday of free enterprise capitalism in the Western world. The king and his ministers might be forgiven if they felt that a war against half of Europe was no time to attempt so far-reaching an economic revolution. Instead of reforming the economy, they raised taxes. In 1695, a poll or head tax was decreed, supposedly for every male adult in France. It was excused as temporary. It continued till 1789. In theory, nobles, priests, and magistrates were to be subject to it. Actually, the clergy bought exemption with a moderate subsidy, while nobles and financiers found loopholes in the law. Every device was used to elicit money from the people. Lotteries were organized, offices were sold, the currency was debased, rich men were courted and prodded for loans. The king himself entertained the banker Samuel Bernard, luring millions from him by the hypnotism of the royal aura and charm. Despite taxes and devices old and new, the total revenue of the state in 1697 was 81 million livres. The expenses were 219 million. At last Louis confessed that his victories were bleeding the life from France. He bade his diplomats come to terms with his enemies. Their skill in a measure rescued him. In 1697 they persuaded the Duke of Savoy to sign a separate peace. Louis let it be whispered that he would end his support of the Stuarts and would recognize William III as King of England. William himself was finding that money was dearer than blood. "My poverty is incredible," he complained, but Parliament grew more and more reluctant to pour out pounds to supply his troops. He required as a preliminary to peace the expulsion of James II from France. Louis refused, but he offered to restore nearly all the cities and terrain that his armies had won during the war. On September 20th, 1697, the Peace of Ryswick, near The Hague, ended the War of the Palatinate with England, Holland, and Spain. France kept Strasbourg and Franche-Comté and regained Pondicherry in India and Nova Scotia in America, but French tariffs were lowered to Dutch trade. On October 30th, a supplementary peace was signed with the Empire. Both the Emperor and the King of France expected the early death of Charles II of Spain, and the chancelleries of Europe understood quite well that what had been signed was only a truce in preparation for a greater war in which the prize would be the richest empire in the world. 3. The Spanish Problem, 1698 to 1700. Charles II, childless, was nearing death. Who would inherit his possessions, ranging from the Philippines through Italy and Sicily to North and South America? Louis claimed them not only as the son of the eldest daughter of Philip III of Spain, but through the rights of his dead wife, Maria Therese, eldest daughter of Philip IV. True enough, Marie Therese at her marriage had renounced all claim to the Spanish throne, but that renunciation had been made on condition that the Spanish government pay 500,000 gold crowns to France as her dowry. Those crowns had never been paid, for Spain was bankrupt. The Emperor Leopold I had counterclaims. He was the son of Maria Anna, younger daughter of Philip III. In 1666 he had married Margaret Theresa, younger daughter of Philip IV, and neither of these ladies had renounced her rights of possible succession to the Spanish crown. Always harassed by the Turks, Leopold, for the sake of peace with France, compromised his claims by signing with Louis XIV on January 19, 1668, a secret treaty for the eventual partition of the Spanish Empire. By this pact, says a British historian, he virtually admitted the force of Louis XIV's contention that the French queen's renunciation of her claims was invalid. When, by a second marriage, Leopold had a second son, he renewed his claims, but offered to resign them in favor of this new Archduke Karl. England, the United Provinces, and the German principalities saw with dread the possibility that the vast realm of Spain would fall to France or to Austria, in either case toppling the balance of power. If Louis won, he would dominate Europe and imperil Protestantism. If Leopold won, the Emperor, holding the Spanish Netherlands, would threaten the Dutch Republic and would soon reduce the autonomy of the German states. Commercial as well as dynastic interests were involved. English and Dutch exporters supplied most of the market for industrial goods in Spain and her colonies, and received considerable gold and silver in exchange. They were loath to let that trade become a French monopoly. The preservation of the commerce between the Kingdom of Great Britain and Spain, the British government stated in 1716, was one of the chief motives that induced our two royal predecessors to enter the late, long, expensive war. Anxious to satisfy the merchants of both his native and his adopted lands, and to preserve the balance of power on the continent, William III proposed to Louis that France waive her claim and agree with England that Spain, the Indies, Sardinia, and the Spanish Netherlands should be resigned to Joseph Ferdinand, Electoral Prince of Bavaria, grandson of Leopold. That the Dauphin of France should receive the Tuscan ports and the two Sicilies, Italy south of the Papal States, while the Archduke Karl should be appeased with the Duchy of Milan. Louis accepted the proposal and signed with William on October 11, 1698, the first treaty for the partition of Spain. Leopold angrily rejected the plan. Hoping to keep the Spanish Empire from such fragmentation, Charles II drew up a will on November 14, 1698, making the Electoral Prince of Bavaria his universal heir. The prince confused the situation by dying on February 5th. Louis offered William a new division, the Dauphin to receive the Tuscan ports, the two Sicilies, and the Duchy of Lorraine, the Duke of Lorraine to be compensated with Milan, all the rest of the Spanish Empire, including America and the Spanish Netherlands, to go to the Archduke Karl. William and Louis signed the Second Partition Treaty on June 11, 1699. The United Provinces agreed to it, but Charles II protested against any dismemberment of his possessions, and the Emperor, hoping to win all for his son, supported the Spanish position and refused to accept the partition. Charles, as a Habsburg, was inclined to leave all to the Archduke. As a Spaniard, however, he hated the Austrians, and as a Latin he preferred the French. As a fervent Catholic, he asked the advice of the Pope. Innocent XII replied on September 27, 1700, that the best plan would be to bequeath the Spanish Empire to a Bourbon prince who should renounce any right to the throne of France, so Spain would retain its integrity. Apparently the French diplomats outwitted the Austrians in Madrid as well as in Rome. Public opinion in Spain, alienated by the arrogant manners of its German queen, agreed with the Pope. The general inclination, reported the English ambassador at Madrid, is altogether French. On October 1st, Charles signed the fateful will that bequeathed all Spain and its territories to the 17-year-old Philip, Duke of Anjou, second son of the Dauphin, with the proviso that the crowns of France and Spain should never be united under one head. On November 1st, Charles died. When news of the will reached Paris, Louis was pleased but hesitant. He knew that the passage of Spain from the Habsburgs to the Bourbons would be violently opposed by the Emperor, and that England and Holland would join in resistance. A German historian gives Louis credit at this juncture for pacific aims. It would be unjust to say of Louis XIV that his intention had been from the beginning to throw over the partition treaty so soon as a will favorable to his house should be in his hands. Even when he was sure of such a will, while King Charles was still alive, he ordered his ambassador in Holland to assure the pensionary that it was his intention to adhere to his engagements, rather than accept any offers that might be made to him. In addition to this, he still continued his efforts to obtain the accession of the Court of Vienna to the Treaty of Partition. On October 6th, Louis sent an urgent appeal to the Emperor to accept that Second Treaty of Partition. Leopold refused. Louis henceforth considered the treaty void. Immediately after the death of Charles, the Spanish junta or regency dispatched a courier to Paris to notify Louis that his grandson would be accepted as King of Spain as soon as he came and took the oath to observe the laws of the realm. The Spanish ambassador at Paris was instructed, in case of a French refusal, to bid the courier hasten to Vienna and submit the same offer to the Archduke. In any case, the Spanish Empire must not be partitioned. On November 9th, Louis called the Dauphin, his Chancellor Pontchartrain, the Duc de Beauvilliers, and the Marquis de Torcy, foreign minister, to a council in the apartment of Madame de Maintenon, and asked their advice. Beauvilliers pleaded for a rejection of the Spanish offer as sure to lead to war with the Empire, England, and the United Provinces, and he reminded the king that France was in no condition to face such a coalition. Torcy argued for acceptance. War, he held, was inevitable in any event. Leopold would fight both the partition treaty and the will. Besides, if the offer should be rejected by the king, it would certainly be welcomed by the Emperor, and France would again be surrounded by that same cordon: Spain, North Italy, Austria, and the Spanish Netherlands, which during the last 200 years it had cost France so much blood to break. Better go to war for a just cause, the will, than in an attempt to enforce the partition of Spain against the desire of its government and its people. After 3 days of further deliberation, Louis announced to the Spanish envoys his acceptance of the will. On November 16, 1700, he presented the Duke of Anjou to the court assembled at Versailles. "Gentlemen," he said, "you see here the King of Spain. His descent called him to that crown. The deceased king so ordered it in his testament. The whole Spanish nation desired it, and earnestly entreated me to give my assent. Such was the will of heaven. I have fulfilled it with joy." And to the young monarch he added, "Be a good Spaniard. That is now your first duty. But remember that you were born a Frenchman, and maintain unity between the two nations. This is the way to make them happy and to preserve the peace of Europe." The Spanish Regency proclaimed Philip at Madrid, and all sections of Spain and her dominions soon declared their consent. One government after another recognized the new king: Savoy, Denmark, Portugal, the United Provinces, England, several Italian and German states. Even the Elector of Bavaria, who thought his son had been poisoned by the Emperor, was among the first princes to offer recognition. The crisis seemed surmounted, and the century-long enmity between Spain and France seemed peacefully healed. The Spanish ambassador at Versailles knelt in homage to his new sovereign, and uttered famous words that Voltaire mistakenly attributed to Louis XIV. "There are no more Pyrenees." 4. The Grand Alliance, 1701 to 1702. Philip V, beginning the Spanish Bourbons, was quietly and cheerfully received in Spain, wrote Lord Chesterfield, and was acknowledged as king of it by most of those powers who afterwards joined in an alliance to dethrone him. But the Emperor Leopold felt that this virtual union of France and Spain, if allowed to continue, would be a disaster for the House of Habsburg, so long accustomed to rule both the Holy Roman and the Spanish empires. Reflecting his resentment, pamphleteers roused and expressed public sentiment in Austria by pointing out that Charles II had not been of sound mind when he bequeathed Spain to her ancient foe. Indeed, they claimed, a post-mortem showed the king's brain and heart grievously infected with disease. Therefore his testament was null and void, and the Spanish dominions belonged to Leopold by the unrenounced rights of his mother and his wife. Leopold urged his former allies, Holland and England, to join him in denying or withdrawing recognition of Philip V, even if this meant war. The leader of the United Provinces at this time was Antonius Heinsius, who had been chosen Grand Pensionary after William's departure for England. In earlier days, as Dutch envoy to France, he had been threatened with arrest by Louvois in violation of diplomatic immunity, and he had never forgotten that indignity. Now aged 59, he lived in a modest house at The Hague, cherished books, walked daily to his office, worked 10 hours a day, and served as a living challenge of bourgeois simplicity and republican government to luxurious aristocrats and absolute kings. In November 1700, under instruction by the States General, he sent to Louis XIV a memorial entreating him to reject the will of Charles II as vitally injurious to the emperor and to return to a policy of partition. Louis replied on December 4, 1700, that his acceptance of the will had been made necessary by the emperor's repeated rejection of a partition plan and by the certainty that if France refused the Spanish offer, the emperor would accept it. The actions of Louis heightened Europe's fear of French power. On February 1, 1701, he caused the Paris Parlement to register a royal decree reserving the eventual rights of Philip and his line to the crown of France. This did not necessarily mean that Louis looked toward the union of France and Spain under one king. It was probably intended to ensure an orderly succession to the French throne in case all prior heirs to it should be deceased. In that emergency, Philip could surrender the Spanish crown for that of his native land and so continue the Bourbon line without interruption. But a further procedure of the king justified a hostile interpretation. A treaty with Spain had confirmed the right of the Dutch to guard against the invasion of Holland by maintaining armed garrisons in some barrier towns of the Spanish Netherlands. On February 5th, by an understanding between Louis and the Elector of Bavaria, who was then governing the Spanish Netherlands, French troops entered these towns and ordered the Dutch garrisons to depart. The Spanish ambassador at The Hague informed the States General that this had been done by the desire of the Spanish government. The States General protesting submitted, but Heinsius agreed with William II that the Grand Alliance against France must be renewed. William took the position that the Second Partition Treaty had been an agreement between himself and Louis, that it had remained valid whether Leopold signed it or not, and that French acceptance of the Spanish bequest had broken a solemn pact. Parliament, however, was loath to resume the expensive struggle with France. When the French government notified England of Philip V's succession to the Spanish throne, William resigned himself to congratulating his very dear brother, the King of Spain, on his happy accession, thus giving formal recognition to the new Bourbon regime on April 17, 1701. But as the immense consequences of the Franco-Spanish Union came more clearly into view, as the occupation of Flanders by French troops brought Louis XIV closer to Holland, and his possession of Antwerp gave him control over the English commerce using that port, the English began to realize that the issue was not merely between Bourbon and Habsburg, nor only between Catholicism resurgent and Protestantism at bay, but between English and French domination of the seas, of Europe's colonies, and of world trade. In June 1701, without declaring war, Parliament engaged to sustain William in all alliances that he might contract for the purpose of limiting the exorbitant power of France. To implement this aim, it sanctioned the recruiting of 30,000 seamen and voted £2,700,000. In response to an appeal from the States General, William ordered 20 ships and 10,000 men to Holland, and in July he himself crossed to The Hague. The emperor, claiming the entire Spanish dominion, was already at war. In May 1701, he sent an army of 6,000 horse and 16,000 foot to seize the possessions of Spain in North Italy. He placed in command a young prince who was destined to rival Marlborough himself as a general, Eugene of Savoy. Eugene's grandfather was Charles Emmanuel, Duke of Savoy, His father, Prince Eugène Maurice, settled in France as Count of Soissons. His mother was Olympe Monsigny, one of the alluring nieces of Mazarin. Eugene himself, aged 20 in 1683, asked Louis XIV to give him command of a regiment. Refused as too young, he renounced France and entered the imperial service. He joined with Sobieski in the relief of Vienna and the pursuit of the Turks. He was wounded in the capture of Buda and again in the siege of Belgrade. He led the imperial army to its decisive victory over the Turks at Senta in 1697. He had every charm except those of features and physique. An unsympathetic Gaul described him as this ugly little man with a turned-up nose over an upper lip too short to conceal his teeth. But Voltaire recognized in him the qualities of a hero in war and a great man in peace, a mind imbued with a high sense of justice and pride, and a courage unshaken in the command of armies. Now, aged 38, he guided his forces over the Alps, outmaneuvered the French detachments there, and with successive victories over Catinat and Villeroy, won for the emperor nearly the whole duchy of Mantua in September 1701, long before the War of the Spanish Succession had been declared. Meanwhile, diplomacy had prepared a decade of massacre. In August, Spain granted to France the lucrative asiento, the contract to supply slaves to the Spanish colonists in America. Evidently, France intended to use her overriding influence in Spain to capture the commerce of its possessions on 3 continents. On September 7th, the representatives of England, the United Provinces, and the Empire signed the Treaty of The Hague, forming a second Grand Alliance. Article 2 declared it essential to the peace of Europe that the Emperor obtain satisfaction for his rights to the Spanish succession, and that England and the United Provinces be made secure in their dominions, navigation, and trade. The treaty promised to the Emperor the Spanish possessions in Italy and the Low Countries, but it left open the possibility that Philip V might be recognized as King of Spain. The contracting states pledged themselves to undertake no separate negotiations, to sign no separate peace, to prevent the union of the French and Spanish crowns, to bar French trade from the Spanish colonies, and to defend and maintain any conquests that England or the United Provinces should make in the Spanish Indies. 2 months were granted France to accept these terms. Failing this, the signatories would declare war. Louis met the challenge with characteristic pride. He proclaimed himself in honor bound to defend the will of Charles II and the resolve of the Spanish people that their empire should not be dismembered. Too confident in the power and righteousness of his cause, he appeared at the bedside of the dying James II and comforted him with the promise that he would recognize and uphold James III as King of England. When the father died, Louis kept the promise. We do not know whether this was a magnanimous action, as a magnanimous English historian called it, or a surrender to the tearful pleas of the widow, or a military measure designed to divide England into supporters of William and Jacobite supporters of a second Stuart restoration. In any case, the War of the Spanish Succession was also a war for the English succession, even for the English soul, for a restored Stuart might resume the attempt to make England Catholic. Though France felt that the action of the Allies violated the recognition that nearly all of them had given to Philip V as King of Spain, most of England felt that Louis had violated the Treaty of Ryswick, in which he had recognized William III as King of England, and the recognition of James III was resented as a presumptuous interference in English affairs. A clause was added to the terms of the Grand Alliance binding its signatories to make no peace with France till William should have received satisfaction for the insult offered him by Louis's action. In January 1702, Parliament attainted James III, that is, declared him a traitor and an outlaw. At the same time, by a majority of 1, it passed an Abjuration Act, requiring all Englishmen to repudiate the Pretender and to swear fealty to William III and his heirs. On March 8, 1702, William died, aged 52, too soon to know that he had welded an alliance that for half a century would determine the map of Europe. On May 15th, the Emperor, the States General of the United Provinces, and the Parliament of England simultaneously declared war upon France. 5. The War of the Spanish Succession, 1702 to 1713. Practically all of Europe west of Poland and the Ottoman Empire was involved. The alliance was joined by Denmark, Prussia, Hanover, the Episcopate of Münster, the electorates of Mainz and the Palatinate, and some minor German states. To these in 1703 were added Savoy and Portugal. Together they mustered 250,000 men and assembled a navy far superior to the French in numbers, equipment, and leadership. France had now 200,000 men in her armies, but these were distributed along many fronts in the Rhine region, Italy, and Spain. Her only allies were Spain, Bavaria, Cologne, and, for a year, Savoy. Spain was a liability, requiring French armies to defend it, and the Spanish colonies were at the mercy of the Dutch and English fleets. We must not lose ourselves in the royal game of human chess that ensued, sanguinary almost beyond precedent. Now came the masterly and gory campaigns of Marlborough and Eugene of Savoy. Perhaps never since Caesar had the genius of war been so combined with the art of diplomacy as in Marlborough, skilled in the strategy of planning operations and moving armies, in the tactics of manipulating infantry, cavalry, and artillery with rapidity of perception and decision as the needs of battle changed, and yet also patient and tactful in dealing with the governments behind him, the personalities around him, even with the enemies that looked to him as a statesman conscious of realities and possessed of authority. He was sometimes merciless and often unscrupulous. He poured out the blood of his soldiers in any quantity needed for success, and he communicated with James II and III to gild his own fate should the Stuarts return to power. But he was the organizer of victory. Louis XIV, perceiving that the whole splendor of his reign now hung in the balance, and that the dispute over Spain had become a contest for continents, called upon France to send him her sons and her gold. By 1704 he had 450,000 men under arms, as many as all his foes combined. Hoping to bring the costly conflict to an early issue, he ordered his main force to march through friendly Bavaria and attack the final citadel of the enemy, Vienna itself, which even the Turkish hordes had failed to take. An insurrection in Hungary occupied imperial forces in the east and left their capital almost denuded of defense. While a French army under Villeroy was supposed to chain Marlborough to the Low Countries, French troops under Marsin and Tallard joined those of the Bavarian Elector and pressed farther and farther into Austria. The emperor, again as in 1683, fled from Vienna, knowing that his capture by the enemy would be a disaster to the Allies' cause. In this crisis, Marlborough, against the pleas of the Dutch States General, but with the secret consent of Heinsius, decided to risk the invasion of Holland by Villeroy and march night and day from the North Sea to the Danube, from May to June 1704, to save Vienna. Pretending to seek a crossing of the Moselle, he moved southward along the river, luring Villeroy into a parallel movement on the other side. Then suddenly at Koblenz he turned east, crossed the Rhine on a floating bridge, marched down to Mainz, crossed the Main to Heidelberg, crossed the Neckar to Rastatt. Now he effected critical junctions with reinforcements from Holland, with an imperial army under Eugene of Savoy, and with another under Margrave Louis William I of Baden-Baden. The French and the Bavarians were astonished to find Marlborough so far from the positions where Villeroy had been expected to contain him. Marsin, Tallard, and the Elector of Bavaria gathered 35,000 infantry and 18,000 cavalry between Lutzingen and Blindheim, on the left bank of the Danube. There, on August 13, 1704, Marlborough and Eugene, with 33,000 foot and 29,000 horse, engaged them in what France tries to forget as the Battle of Höchstädt, and what England celebrates as the victory of Blenheim. Marlborough's superior cavalry overwhelmed the French center and drove Tallard's routed army into Blenheim, where its surviving 12,000 men surrendered, Tallard himself being captured. Then Marlborough's horsemen rode to the support of hard-pressed Eugene on the right, and helped him force Marsin into an orderly retreat. The human loss was heavy, 12,000 casualties on the Allied side, 14,000 on the Franco-Bavarian. The surrender of 27 battalions of infantry and 12 squadrons of mounted men shattered the reputation of French arms. The Elector of Bavaria fled to Brussels. Bavaria was occupied by an imperial army. Nearly 300 square miles of terrain were cleared of French troops. Leopold returned in safety to his capital. On August 4th, an Anglo-Dutch fleet marked another date in history by capturing the barren Rock of Gibraltar. The English turned it into a fortress that for 2 centuries made them masters of the Mediterranean. Not knowing that it had been decided by these 2 victories, the war continued for 9 more years. An English fleet took Barcelona on October 9, 1705. An Allied army protected a revolt of Catalonia against Philip V, and established the Archduke Karl at Madrid as Charles III on June 25, 1706. But the sight of Austrians and Englishmen ruling the country roused the Spanish from their unworldly torpor. Even the ecclesiastics urged them on to resistance. The peasants armed themselves as best they could and cut the Allied line of communications between Barcelona and Madrid. The English Duke of Berwick, James Fitzjames, natural son of James II, led a Franco-Spanish force from the west, recovered Madrid for Philip V on September 22nd, and drove the Archduke and his English heretics back to Catalonia. Meanwhile, Marlborough, after overcoming political obstacles in London and The Hague, assembled an army of 60,000 English, Dutch, and Danes and marched into the Spanish Netherlands. On May 23, 1706, he met the main French army of 58,000 men under Villeroy at Ramillies, near Namur. In the ecstasy of battle and forgetting that generals must die in bed, he dashed to the front and was knocked from his horse. His aide, while helping the Duke to another mount, had his head blown off by a cannonball. Marlborough recovered, realigned his troops, and led them to another bloody victory. His army suffered 5,000 casualties, the French 15,000. He advanced through negligible resistance to the capture of Antwerp, Bruges, and Ostend. There he had a direct line of communications with England, and was only 20 miles from France. Marshal Villeroy, 62, retired to his estate in grief, but with no reproof from the king, who told him sadly, "There is no more luck at our age." Everywhere now, except in Spain, the French were in peril or retreat. In Vienna, Joseph I, 27, succeeded in 1705 his father as emperor and gave vigorous support to his generals. Eugene of Savoy drove the French from Turin in 1706, then from all Italy in 1707. By the Convention of Milan, the duchies of Milan and Mantua became parts of the Austrian Empire, and the rule of the Mantuan Gonzagas, begun in 1328, came to an end. The kingdom of Naples, so long a viceroyalty of Spain, fell in its turn to Austrian arms, though it continued to be formally a papal fief. The papal states remained papal by permission of the emperor, whose German troops had marched through them against the will of the helpless pope. Venice and Tuscany preserved a precarious independence. Louis XIV was a changed man. The pride of power had almost left him, but he maintained the calm dignity of his state. In 1706 he offered the Allies terms of peace that 5 years earlier they might have been glad to accept. Spain to be surrendered to Archduke Karl, Philip to be content with Milan, Naples, and Sicily, barrier towns and fortresses to be restored to Dutch control in the Spanish Netherlands. The Dutch were disposed to negotiate, the English and the Emperor refused. Louis turned wearily to recruiting new armies and levying new taxes. Even baptisms and marriages, to be legal, had now to pay a tax. The population of France, desperate in poverty, baptized its own children and married without priestly aid, though the offspring of such unions were officially branded as illegitimate. Revolts broke out at Cahors, in Quercy, in Périgord. Peasant mobs seized town offices and seigneurial chateaux. Living skeletons, squelettes, of starving people clamored at the gates of Versailles for bread. The Swiss Guard drove them away. Placards appeared on Paris walls warning Louis that there were still ravaillacs in France, that is, men willing to kill a king. The new taxes were abandoned. Early in 1707, the Marquis de Vauban, whose military engineering had been a vital element in French victories a generation earlier, published in his 74th year a proposal for a juster tax, projet d'une dîme royale. He described the misery of France. Nearly a tenth of the people are reduced to beggary, and of the other 9/10 the majority are more in a condition to receive charity than to give it. It is certain that the evil has been pushed to excess, and that if no remedy is applied, the people will fall into such destitution that they will never recover. He reminded the king that it is the lower class of the people which, by their labor and industry, and their contributions to the royal treasury, enrich the sovereign and his realm. Yet it is that class which now, through the demands of war and the taxation of its savings, is reduced to living in rags and crumbling cottages, while its lands lie fallow in the absence of its recruited sons. To relieve these most productive classes, Vauban, adopting some ideas from Bois-Guilbert, proposed to abolish all existing taxes and replace them with a graduated income tax, exempting no class, landowners to pay 5 to 10%, workers not more than 3.5%. The state should maintain its monopoly on salt, but custom dues were to be charged only at national frontiers. Saint-Simon describes the book and its reception. It was full of information and figures, all arranged with the utmost clearness, simplicity, and exactitude. But it had a grand fault. It described a course which, if followed, would have ruined an army of financiers, of clerks, of functionaries of all kinds. It would have forced them to live at their own expense instead of at the expense of the people, and it would have sapped the foundation of those immense fortunes that are seen to grow up in such short time. This was enough to cause its failure. All the people interested in opposing the work set up a cry. What wonder, then, that the king, who was surrounded by these people, listened to their reasons, and received with very ill grace Maréchal Vauban when he presented his book to him. Louis reproached him as a dreamer whose plan would have upset the finances of the kingdom in the crisis of war. A decree in council on February 14, 1707, ordered the book to be seized and exposed in a pillory. 6 weeks later, disheartened by his disgrace, the old marshal died. The king uttered some words of tardy regret. "I lose a man well affected to my person and to the state." The taxes and the war continued. In August 1707, Victor Amadeus II, Duke of Savoy, who had begun as an ally of France, joined Eugene of Savoy and an English fleet in besieging Toulon by land and sea. If this fell, they planned to attack Marseille. If that too fell, France would be shut out from the Mediterranean. A new French army was raised and was sent to thrust back the invaders. It succeeded, but in that campaign much of Provence was laid waste. In 1708 the king mustered an army of 80,000 men, placed it under Marshal Vendôme and the Dauphin's son, the popular Duke of Burgundy, and dispatched them to stop the Allied advance in Flanders. Marlborough and Eugene, likewise with 80,000 men, met them at Oudenarde on the Scheldt on July 11, 1708. The French were overwhelmed, losing 20,000 in dead or wounded and 7,000 prisoners. Marlborough wished to push on to Paris, but Eugene prevailed upon him to besiege Lille first, lest its garrison cut the Allies' line of communications and supplies. Lille was taken, but after a siege of 2 months, and at the cost of 15,000 men. Louis felt that France could fight no more. This book is continued at this point on the other side of this cassette. Please reverse or turn the cassette over now. The Story of Civilization, Volume 8, The Age of Louis XIV, by Will and Ariel Durant. Part 2, concluded. Louis felt that France could fight no more. The misery of his people was made crueler by the severest winter in their memory, from 1708 to 1709. For 2 months all rivers froze. Even the seas froze along the coasts, so that heavily laden carts moved safely on the ocean ice. Almost all vegetation was killed, including the hardiest fruit trees and all grain in the earth. Nearly all newborn infants died in that terrible season. One exception was the king's great-grandson, the future Louis XV, born to the Duke of Burgundy on February 15, 1709. Famine followed in the spring and summer. Monopolists cornered the bread supply and kept the price high. Saint-Simon, usually hostile to the king, reported that Louis himself was accused of sharing in the profits of the monopolists. But, says Henri Martin, history is too deliberate to take the gloomy imagination of Saint-Simon without distrust. The situation was saved by importing 12 million kilograms of grain from the Barbary States and elsewhere, and by planting barley as soon as the ground thawed. Humbled by the defeats of his armies and the calamities of his people, Louis sent the Marquis de Torcy to The Hague on May 22, 1709, to ask for peace. Torcy was instructed to offer the surrender of all the Spanish Empire to the Allies, to cede Newfoundland to England, to restore the barrier towns to the Dutch, and to end all French support of the Jacobite cause. He tried to bribe Marlborough, but failed. On May 28, the Allies presented to Torcy an ultimatum requiring not only that Spain and all its possessions be yielded to the Archduke, but that if Philip should not have quit Spain within 2 months, the French army was to join the Allies in expelling him. Else, they argued, France would be left free to reorganize its fighting power while the Allies were engaged in the peninsula. Louis replied that it was too much to ask of him that he should use force to expel his own grandson from a Spain that had just rallied to Philip's support. "If I must fight on," he said, "it shall be with my enemies rather than with my children." The demands of the Allies aroused the resentment of France. Recruits came more willingly to the colors, if only to find food. Nobles sent their silver to the mint, and French vessels, eluding the British and the Dutch, brought from America bullion worth 30 million francs. A fresh army was raised, 90,000 strong, and was placed under Marshal Villars. who had never yet been defeated by the Allies. At the same time, Marlborough assembled 110,000 men. The two swarms met at Malplaquet, just within the French frontier against Belgium, in the bloodiest battle of the 18th century. Marlborough lost 22,000 men in this his final victory. The French suffered 12,000 casualties, including the brave Villars, who, 56 years old, charged at the head of his troops and was borne from the field with one knee shattered by a cannonball. The French retreated in good order, but the Allies went on to capture Mons. "God Almighty be praised," wrote Marlborough to his Sarah. "It is now in our power to have what peace we please." It seemed so, for France had apparently made her last effort. How could she find another army among her depleted families, or feed it from her abandoned fields? Agriculture, industry, transport, commerce, finance, all were in chaos. All were caught in a spreading disintegration that invited the occupation and dismemberment of the country by its advancing foes. The king, once the God-given idol of his people, was losing their affection, even their respect. He had always shunned Paris, remembering the hostile horde of the Fronde. The city had resented his long resentment, and the wit and insults of pamphlets and placards had stung his absolutist pride. Men wondered why, amid the destitution of France, the halls of Versailles were still thronged by idle, costly, gambling courtiers. Though the king and his wife were now pious and subdued, the expenses and personnel of the court remained undiminished to the last. Some breadless Parisians chanted a revised version of the Lord's Prayer, sparing neither Louis nor his mate, nor his new Minister of War and Finance. "Our Father, which art at Versailles, thy name is no longer hallowed, thy kingdom is no longer so great, thy will is no longer done on earth or on the sea. Give us our bread, which on every side we lack. Forgive our enemies who have beaten us, and not thy generals who allowed them to do so. Do not succumb to all the temptations of Le Maintenant, but deliver us from Chamillard." "The king," mourned Madame, "is reproached for all his expenditure. They would like to do away with his horses, his dogs, his servants. They would like to stone me because they imagine that I never tell him anything unpleasant for fear of grieving him." The nobles were still loyal to the king who entertained and protected them, but their patriotism flagged when, as a last resort, he asked for a tenth of their income in 1710. The universal deme that Vauban, 3 years before, had proposed as a substitute for all other taxes was now added to all other taxes, and the poor had the consolation of seeing the hated tax-gatherers enter the homes and scrutinize the accounts of the rich. The king was loath to invade gilded privacy, but his confessor, Father Letellier, assured him that, in the opinion of the doctors of the Sorbonne, all the wealth of his subjects was his, and when he took it, he only took what belonged to him. The upper middle classes likewise suffered some cooling of martial ardor when interest ceased to be paid on government bonds. The recoinage and debasement of the currency brought some profit to the king, reported Saint-Simon, but ruin to private people and a disorder to trade which completed its annihilation. Great bankers like Samuel Bernard declared bankruptcy, disrupting nearly all business in Lyons. All was perishing step by step. The realm was entirely exhausted. The troops were not paid, though no one could imagine what was done with the millions that came into the king's coffers. In March 1710, Louis again asked the Allies for peace. He offered to acknowledge the Archduke as King of Spain, to give no assistance to Philip, even to contribute funds to aid in dethroning him. He would surrender Strasbourg, Breisach, Alsace, Lille, Tournai, Ypres, Menin, Fournes, and Maubeuge to the Allies. They offered him not peace, but a 2 months' truce. In that period, Louis, with French forces unaided by any other, was to expel Philip from Spain. If he failed to achieve this within the truce period, they would resume the war. Louis published these terms to his people, who agreed with him that they were impossible. Somehow France raised new armies. When the Archduke again invaded Spain with a force of Austrian and English troops and fought his way to oust Philip once more from Madrid, Louis sent to his grandson 25,000 men under the Duc de Vendôme. Aided by Spanish volunteers, the Duke defeated the invaders at Brihuega and Villaviciosa in December 1710, and so definitely restored Philip to his throne that Spain remained Bourbon till 1931. Meanwhile, the political wind was veering in England. In 1706, Queen Anne had written, "I have no ambition but to see an honorable peace, that whenever it please God I shall die, I may have the satisfaction of leaving my poor country and all my friends in peace and quiet." Anne had been kept to the war policy by Marlborough's fiery Duchess. That influence now waned. In 1710, the Queen dismissed Sarah and openly sided with the Tories. The merchants, manufacturers, and financiers had profited from the war and had supported the war-making Whigs. The landowners had lost as war raised taxes and inflated the currency. They seconded the Queen's longing for peace. On August 8th, she dismissed Godolphin, Marlborough's right-hand man. Harley headed a Tory ministry. England turned toward peace. In January 1711, the English government secretly sent to Paris a French priest, the Abbé Gautier, who had long resided in London. Gautier went to Torcy at Versailles. "Do you want peace?" he asked. "I come to bring you the means of concluding it, independently of the Dutch." Negotiations proceeded slowly. Suddenly, at the surprisingly early age of 32, Joseph I died on April 17, 1711. The Archduke became the Emperor Charles VI. The English and the Dutch, who had promised him all Spain, found that their costly victories were confronting them with a new Habsburg Empire as vast as that of Charles V, and as dangerous to Protestant nations and liberties. The English government now offered Louis recognition of Philip V as King of Spain and the Spanish possessions in America on relatively moderate conditions, securities against the union of France and Spain under one crown, barrier fortresses to protect the United Provinces and Germany from any future French invasion, the restitution of French conquests, the recognition of the Protestant succession in England, and the expulsion of James III from France, the dismantling of Dunkirk, the confirmation of Gibraltar, Newfoundland, and the Hudson Bay region as English property, and the transfer from France to England of the right to sell slaves to Spanish America. Louis assented with minor modifications. England notified The Hague that she favored making peace on these terms. The Dutch agreed to them as a basis for negotiation, and plans were made for a peace congress at Utrecht. Marlborough, who had found war profitable, was dismissed on December 31, 1711, and was replaced by James Butler, 2nd Duke of Ormond, with instructions not to hazard English troops in battle until further orders should be received. While the Congress assembled at Utrecht on January 1, 1712, Eugene of Savoy, considering the English terms of peace to be a betrayal of the imperial cause, continued the war. Day after day he pushed forward against the line of defenses built by the industrious Villars. On July 16th, Ormond was notified by London that England and France had signed an armistice, and that consequently his English regiments must be withdrawn to Dunkirk. These obeyed, but most of the continental contingents under Ormond's command denounced the English as deserters and placed themselves under Eugene's command. The prince had now some 130,000 men, Villars 90,000. But on July 24th, the alert Maréchal pounced upon a detachment of 12,000 Dutch at Denain, near Lille, and annihilated it before Eugene could come to its aid. The prince retired across the Scheldt to reorganize his unwieldy army. Villars advanced to capture Douai, Le Quesnoy, and Bouchain. Louis and France took heart. These were the only French victories of the war on the northern front, but with the success of Vendôme in Spain, they gave new strength to the French negotiators at Utrecht. After 15 months of protocol, punctilio, and argument, all parties to the war except the Emperor signed the Peace of Utrecht on April 11, 1713. France yielded to Britain all that she had promised in the preliminaries, including that precious asiento, or slave trade monopoly, which lies like a badge of shame upon that age. And the ancient enemies made mutual concessions on import dues. The Dutch restored to France Lille, Aire, and Bethune, but kept control of all the Netherlands until peace should be made with the Empire. Meanwhile, the Elector of Bavaria was to hold Charleroi, Luxembourg, and Namur. Nice was returned to the Duke of Savoy. Philip V retained Spain and Spanish America. He refused, then, on July 13th, consented to cede Gibraltar and Minorca to England. Eugene of Savoy fought on, bitter against the British for signing a separate peace. But the imperial treasury was empty, his army was reduced to 40,000 troops, and Villars was advancing against him with 120,000 men. Finally, he accepted the invitation of Louis XIV to meet Villars and work out terms of peace. By the Treaty of Rastatt on March 6, 1714, France retained Alsace and Strasbourg, but she restored to the Empire all French conquests on the right bank of the Rhine, and she recognized the replacement of Spanish by Austrian rule in Italy and Belgium. So the treaties of Utrecht and Rastatt achieved little more than what diplomacy might have peacefully achieved in 1701. After 13 years of slaughter, impoverishment, and devastation, these pacts settled for 26 years the map of Europe, as the treaties of Westphalia had settled it for a generation after the 30 Years' War. In both cases, the task was to establish a balance of power between Habsburg and Bourbon. It was done. Between France and England and America, a balance was established, which would hold till the 7 Years' War from 1756 to 1763. The chief losers in the sanguinary contest for the Spanish succession were Holland and France. The Dutch Republic had gained terrain on land and lost power on the sea. It could no longer match England in shipping, seamanship, resources, or war. Its victory exhausted it and began its decline. France, too, was weakened, almost fatally. She had kept her nominee on the throne of Spain, but she had failed to preserve his empire intact. And for this tarnished triumph she paid with 1,000,000 lives, the loss of her sea power, and the temporary collapse of her economic life. Not till Napoleon would France recover from Louis XIV, only to repeat his tragedy. The victors of the war were Austria on the continent and England everywhere else. Austria now held Milan, Naples, Sicily, and Belgium. She would be the strongest force in Europe until the accession of Frederick the Great in 1740. England thought more of controlling the sea than of expanding on land. She acquired Newfoundland and Nova Scotia, but valued more her mastery in the avenues of trade. She compelled France to lower her tariffs and to dismantle the fort and port of Dunkirk, which had been a threat to English shipping. With Gibraltar in Spain and Port Mahon in Minorca, England held the Mediterranean in fief. These gains made no spectacular show in 1713. Their results would be written in the history of the 18th century. Meanwhile, the Protestant faith and succession had been made secure in Britain against everything but the birth rate. A chief product of the war was the intensification of nationalism and international hate. Each nation forgot its gains and remembered its wounds. Germany would never forgive the double devastation of the Palatinate. France would not soon forget the unprecedented slaughter in Marlborough's victories. Spain suffered every day the indignity of Gibraltar in alien hands. Each nation bided its time for revenge. Some gentle souls, thinking that Europe was a continent of Christians, dreamed of a substitute for war. Charles Castel, Abbé de Saint-Pierre, accompanied the French delegation to Utrecht. Returning, he published his Projet pour rendre la paix perpétuelle in 1713, a plan for perpetuating the newfound peace. Let the nations of Europe confederate in a League of Nations with a permanent Congress of Representatives, a Senate for the arbitration of disputes, a code of international law, a combined military force for action against any rebellious state, the reduction of each national army to 6,000 men, and the establishment of uniform measures and currency throughout Europe. Saint-Pierre expounded his scheme to Leibniz, who, no longer so sure that this was the best of all possible worlds, sadly reminded the Abbé that some sinister fate was always interposing betwixt man and the attainment of his happiness. Man is a competitive animal, and his character is his fate. 6. Twilight of the God, 1713 to 1715. Judged in terms of his time, Louis XIV was not the ogre that hostile historians have made him. He merely applied on a larger scale, and for a while with invidious success, the same methods of absolute rule, territorial expansion, and martial conquest that characterized the conduct or the aspirations of his enemies. Even the cruelty of his armies in the Palatinate had a precedent in the sack of Magdeburg in 1631, and an epilogue in the massacres of Marlborough. Louis had the distinction of living so long that the Furies could revenge upon him in person, rather than upon his children, the sins of his pride and power. History has not withheld from him some admiration for the courage and dignity that he showed in defeat, and it has allowed him some pity in the disasters that almost destroyed his children simultaneously with his armies and fleets. In 1711, his only legitimate son, le Grand Dauphin, Louis, died, leaving the king with 2 grandsons, Louis, Duke of Burgundy, and Charles, Duke of Berry. The younger Louis developed good qualities under Fénelon's tutelage and became the solace of the monarch's old age. In 1697 he married Marie Adélaïde of Savoy. whose beauty, wit, and charm reminded the king of Madame Henrietta and his happy youth. But on February 12, 1712, this gay spirit succumbed to spotted fever at the age of 26. Her devoted husband had refused to leave her sickbed. He contracted the disease and died of it on February 18th, aged 29, only a year after his father's death. Their 2 sons caught the infection from them. One died on March 8th at the age of 8. The younger survived, but remained so weak that no one dreamed that he would live to rule France as Louis XV till 1774. If this frail lad should collapse, the heir to the throne would be Charles, Duke of Berry. But Charles died in 1714. There was another possible successor, Philip V of Spain, younger son of Le Grand Dauphin, but half of Europe was pledged to keep him from uniting the 2 crowns. Next in line was Philippe, Duc d'Orléans, grandson of Louis XIII and nephew and son-in-law of the king. But this Philippe had a laboratory, carried on experiments in chemistry, and was therefore accused, in public gossip, of having poisoned the Duke and Duchess of Burgundy and their eldest son. The physicians who performed the 3 autopsies were divided on the question whether poison had been used. Philippe, furious under these suspicions, asked the king to give him a public trial. Louis believed him innocent and refused to lay upon him the burden and stigma of such an ordeal. Should these lines of succession fail, a last resort remained. The king had legitimized his illegitimate sons, the Duke of Maine and the Count of Toulouse. Now, in July 1714, he issued an edict, which the Parlement of Paris registered without protest, that in default of princes of the blood royal, these quondam bastards should inherit his throne. And a year later, to the horror of Saint-Simon and other nobles, he decreed that their rank should be equal in law to that of the legitimate princes. Their mother, Madame de Montespan, was dead, but their foster mother, the wife of the king, loved them as her own, and used her influence to promote them in honors and power. It was amid these problems and bereavements that Louis faced the final crisis of the war. When he bade farewell to Villars, who was leaving to meet the advance of Eugene on the Belgian front, the king, now 74 years old, for a moment broke down. "You see my condition, Maréchal," he said. "There have been few examples of what has happened to me. To lose in the same month my grandson, my granddaughter, and their son, all of great promise, and all most tenderly loved. God is punishing me. I have well deserved it. I shall suffer less in the next world." Then, recovering himself, he continued, "Let us leave my domestic misfortunes and see how to avert those of the kingdom. I confide to you the forces and salvation of the state. Fortune may be adverse to you. If this misfortune should happen to the army you command, what would be your feeling as to the course which I should take in person?" Villars did not reply. "I am not surprised," said the king, "that you do not answer me at once. While waiting for you to tell your idea, I will tell you mine. I know the reasonings of the courtiers. Almost all wish me to retire to Blois if my army should be defeated. For my part, I know that armies of such size are never so much defeated that the greater part could not fall back upon the Somme, a river very difficult to cross. I should go to Péronne or Saint-Quentin, gather there all the troops I might have, make a last effort with you, and we should perish together or save the state." Villars' victory at Denain cheated the king of such a heroic death. He survived that battle by 3 years, and the peace by 2. Excepting the anal fistula, long since cured, his health had maintained itself reasonably well for 70 years. He ate immoderately, but never grew fat. He drank moderately. He let few days pass without some active exercise in the open air, even in the severe winter of 1708 to 1709. It is difficult to know if he might have lived longer with fewer physicians, and whether the purges, bleedings, and sweats to which they treated him were a greater curse than the ills they were intended to relieve. One doctor in 1688 gave him so strong a laxative that it acted on him 11 times in 8 hours, after which we are told he felt somewhat fatigued. When Rigaud in 1701 made the painting that stands so prominently in the Louvre, he pictured Louis as still insolent, with strength and victory and robes of state, black wig concealing white hairs, and swollen cheeks attesting appetite. 7 years later, Coisvox, in the splendid statue in Notre Dame, showed him kneeling in prayer, but still more conscious of royalty than of death. Perhaps the artists clothed him in prouder pride than he felt, for in those failing years and mounting trials he had learned to accept reproof humbly, at least from Maintenon. He became as a child in the hands of the fanatic Jesuit Letellier, who had succeeded Père Lachaise as the king's confessor in 1709. The inheritor of Charlemagne asked pardon for his sins from the son of a peasant. The strong infusion of Catholic faith and piety that he had received from his mother rose to the surface now that passion ebbed and glory lost its glow. Rumor said that the king, in the surge of his devotion, had become a Jesuit affiliate in 1705, and in his final illness it added that he took the fourth vow as a full member of the Society of Jesus. In January 1715 he lost his famous appetite, and ailed so visibly that in Holland and England wagers were laid that he would not survive the year. Reading news dispatches to this effect, he laughed them off, and continued his routine of conferences, reception of ambassadors, reviewing of troops, hunting, and ending the day with his 79-year-old wife, the faithful, weary Maintenon. On August 2nd he drew up a will naming the Duke of Maine guardian to Louis XV, and appointing the Duke to a council of regency that should rule France till the boy should come of age. On August 12th, sores broke out on his leg. They became gangrenous and malodorous. Fever set in, and he took to his bed. On August 25th he wrote a codicil to his will, naming Philippe d'Orléans chief of the Council of Regency, with a deciding vote in a division. To two magistrates who received this document he said, "I have made a testament. They," presumably Madame de Maintenon, the Duke and Duchess of Maine, and their supporters, "insisted that I should make it. I had to purchase my repose, but as soon as I am dead it will be of no account. I know too well what became of my father's testament." That confused will was destined to write a chapter in French history. He died like a king. After receiving the sacraments, he addressed to the ecclesiastics at his bedside a supplementary and unwelcome confession. "I am sorry to leave the affairs of the Church in their present state. I am perfectly ignorant in the matter, as you know, and I call you to witness that I have done nothing therein but what you wanted, and have done all that you wanted. It is you who will answer before God for all that has been done. I charge you with it before him, and I have a clear conscience. I am but a know-nothing who have left myself to your guidance." To his courtiers he said, "Gentlemen, I ask your pardon for the bad example I have set you. I have to thank you sincerely for the manner in which you have served me, and the fidelity you have always shown to me. I ask you to give the same zeal and devotion to my grandson which you have given me. He is a child who may have to suffer much. I hope you will all work for union, and that should anyone fail in this, you will seek to call him back to his duty. I perceive that I am allowing my feelings to overcome me, and am causing you to do the same. I ask your pardon for all this. Farewell, gentlemen. I trust that you will sometimes remember me." He asked the Duchess of Ventadour to bring in his grandson, now 5 years old. To him, according to the Duchess, he said, "My child, you are going to be a great king. Do not imitate me in the taste that I have had for building or for war. Try, on the contrary, to be at peace with your neighbors. Render to God what you owe him. Recognize the obligations you are under to him. Make him honored by your subjects. Try to comfort your people, which unhappily I have not done. My dear child, I give you my benediction with all my heart." To two servants whom he saw in tears, "Why do you weep? Did you think me immortal?" And reassuringly to Madame de Maintenon, "I thought it would be harder to die than this. I assure you it is not a very terrible business. It does not seem to me difficult at all." He asked her to leave him, as if he were aware that after his death she would be a lost soul in a class-conscious court. She retired to her apartment, divided its furniture among her attendants, and departed for Saint-Cyr, which she would never leave till her death in 1719. The king had spoken too confidently. He suffered a long night of agony before he died, September 1st, 1715. Of his 77 years he had spent 72 on the throne, the longest reign in European history. Even before his last hour, the courtiers, anxious for their berths, had deserted him to pay homage to Philippe d'Orléans and the Duke of Maine. Some Jesuits gathered around the corpse and performed the ceremonies customary for one who had died in their order. News of the king's death was received by the people of Paris as a blessed deliverance from a reign that had lasted too long and had seen its glory tarnished with misery and defeat. Very little pomp was wasted on the funeral that bore to Saint-Denis on September 9th the corpse of the most famous king in the history of France. "Along the route," said Voltaire, "I saw small tents set up where people drank and sang and laughed." Duclos, then 11, later recalled that many persons were unworthy enough to pour forth insults on seeing the hearse pass by. At that moment the Parisians remembered his faults with a blinding clarity. They felt that his love of power and glory had led France to the brink of ruin. They resented the pride that had destroyed local self-government and had centered all rule in one unchallengeable will. They mourned the millions of francs and the thousands of lives that had been spent in beautifying Versailles, and they cursed the neglect with which the king had treated his turbulent capital. A small minority rejoiced that the persecution of the Jansenists might now cease. A large majority still applauded the expulsion of the Huguenots. In retrospect, it was clear that the invasion of Holland in 1672, the invasion of Germany in 1688, and the hasty seizure of the barrier towns in 1701 had been massive blunders, raising a swarm of foes around France. But how many Frenchmen had condemned those invasions or spoken a word of conscience about the double devastation of the Palatinate? The nation had been as guilty as its king, and held against him not his crimes but his defeats. Barring a few priests, it had not condemned his adulteries, and had shown no enthusiasm over his moral reform, his piety, or his fidelity to his morganatic wife. It forgot now that for many years he had graced his power with courtesy and humanity, that until the demon of war enthralled him, he had supported Colbert in developing French industry and trade, that he had protected Molière against the bigots and Racine against the cliques, that his extravagant expenditures had not merely indulged his own luxury, but had dowered France with a new heritage of art. What the people felt most keenly and most justly was the immense price they had paid in blood and treasure for the glory that had now collapsed in the death of the king and the desolation of France. There was hardly a family in the nation that had not lost a son to the wars. Population had been so reduced that the government now gave rewards to the parents of 10 children. Taxes had stifled economic incentive. War had blocked the avenues of commerce and had closed foreign markets to French goods. The state was not only bankrupt, it owed 3 billion francs. The nobility had lost its usefulness by being turned from local administration to prancing about the court. It had shone only in its expensive dress and its martial bravery. A new nobility had been created by wholesale auction of titles to rich commoners. In 1 year alone, the king had ennobled 500 persons at 6,000 livres each. So some ancient families fell vassal to the sons of serfs. As war became no distant contest of mercenaries and gladiators, but a pervasive and exhausting test of national resources and economies, the middle class rose in number and power to challenge the baron and the priest, and financiers prospered amid the general decline. For in modern states, the men who can manage men manage the men who can manage only things, and the men who can manage money manage all. In judging Louis XIV, we must remember Goethe's humane dictum that a man's vices are usually the influence of his time, while his virtues are his own. Or, as the Romans had put it with characteristic brevity, vitium est temporis potius quam hominis. Vices are of the age rather than of the man. The absolutism, the persecuting bigotry, the lust for glory, the taste for war, were in him as a child of his time and his church. His generosity and magnanimity and courtliness, his appreciation and stimulation of literature and art, his ability to carry a burden of concentrated and far-reaching government, were his personal qualities, making him every inch a king. In Louis XIV, Goethe wrote, "Nature produced the consummate specimen of the monarchical type, and in doing so exhausted herself and broke the mold." Louis XIV, said Napoleon, was a great king. It was he who raised France to the first rank among nations. What king of France since Charlemagne can be compared with him in all his aspects? He was, in Lord Acton's judgment, by far the ablest man who was born in modern times on the steps of a throne. He waged devastating wars, indulged his pride extravagantly in building and luxury, stifled philosophy, and taxed his people to destitution. But he gave France an orderly government, a national unity, and a cultural splendor that won for her the unquestioned leadership of the Western world. He became the head and symbol of his country's supreme epoch. And France, which lives on glory, has learned to forgive him for almost destroying her to make her great. This concludes the reading of The Age of Louis XIV by Will and Ariel Durant, Part 2. This book was read by Alexander Adams. Additional titles by Will and Ariel Durant in the Books on Tape library include The Age of Faith and The Renaissance. For additional information about them or for help with topics of related interest, please call our customer service department or check our catalog index to find review material. If you have enjoyed these tapes, you may want to consider buying this audiobook and donating it to your local library so that others in your community can enjoy it too. The donation will qualify as a tax write-off. Books on Tape produces many new unabridged audiobook titles each month. To find out more about them or to arrange a library donation, or to speed your next title to you without delay, call our customer service department.
We hope you enjoyed this reading. Please continue listening to sample another Books on Tape bestseller.
A Dance to the Music of Time, the Fourth Movement by Anthony Poe. Volume 6 consists of 2 novels, Temporary Kings and Hearing Secret Harmonies. Copyright 1973 and 1975 by Anthony Poe. This recording of the full-length reading of A Dance to the Music of Time, Fourth Movement, was published by arrangement with Harold Ober Associates in conjunction with David Hyam Associates Limited, and was produced in 1996 by Books on Tape Incorporated, which holds the copyright thereto. This book is read by David Case. A Dance to the Music of Time, Fourth Movement, Temporary Kings. This book consists of 6 chapters and is 280 pages long. The book bears a dedication for Roland. Chapter 1. The smell of Venice suffused the night, lacustrine essences richly distilled. Late summer was hot here. A very old man took the floor, hoarse, tottering, a few residual teeth, arbitrarily assembled and darkly stained, underpinning the buoyancy of his grin. He rendered the song in slower time than ordinary, clawing the air with his hands, stamping the floor with his feet, while he mimed the action of the cable, straining, creaking, climbing, as it hauled upward towards the volcanic crater, the capsule encasing himself and his girl, a journey calculated to stir her ungrateful heart. Yame, vimontiam sula, yame, vimontiam sula, funiculi funucula, viamontiam sula. A first initiatory visit to Italy, travelling as a boy with my parents, had included a week at this same hotel. It overlooked the Grand Canal, then small, rather poky even. Its waterfront now extended on either side of the terrace, where, by tradition, the musicians' gondola tied up. Near tourist outfits replaced evening dress, antique as the troupe itself. In other respects, the pattern remained unaltered, notably this veteran and the business of his song. Could he be the same man? A mere 40 years? Indeed, 3 or 4 short of that. Might well have passed without much perceptible transmutation in a facade already radically weathered by time when first observed. The gestures were identical. With an operatic outthrust of the body, he intimated the kingdoms of the earth ranged beneath funicular passengers for their delectation. Si vede Francia procida alla Spagna, e io vego te. The century all but within his grasp, the singer might actually recollect the occasion for which the song had been composed. On that great day, as the words postulated, himself ascended Vesuvius, accompanied by his inamorata, snug together in the newly installed spaceship, auspicious with potentialities for seduction. Had a dominating personality, the suggestive rotations of the machinery, Procida's isle laid out far below, like a girl spread-eagled on her back, all combined to do the trick? The answer was surely affirmative. Even if marriage remained in question, conceivably the librettist's deference to convention, at least warmer contacts must have been attained. The stylized movements of the hands were reminiscent of Dickie Umfreville at one of his impersonations. He too should have harnessed his gift in early life to an ever-renewing art from which there was no retiring age. To exhibit themselves, perform before a crowd, is the keenest pleasure many people know. Yet self-presentation without a basis in art is liable to crumble into dust and ashes. Professional commitment to his own representations might have kept at bay the melancholy, all but chronic, Frederica and his stepchildren complained, now that Umfreville had retired from work as agent at Throbworth. Sometimes, after a day's racing, for example, he might return to the old accustomed form. Even then a few misplaced bets would bring the conviction that luck was gone for good, his life over. Christ, what a shambles! Feeling my back, too. Trumpeter, what are you sounding now? Defaulters, old boy, if your name's Jerry Hattrick. You know growing old's like being increasingly penalised for a crime you haven't committed. Which ones haven't you committed? Said Frederica. You've never grown up, darling. You can't grow old till you've done that. Sufferance as well as affection was implied, though Frederica had never tired of Umfreville in spite of being often cross with him. I feel like the man in the ghost stories scrambling over the breakwaters with the horrible thing behind him getting closer and closer. There hasn't been a good laugh since that horse box backed over Buster Fox at Lingfield. As a rule, Umfreville disliked mention of death, but the legend of Buster Fox's immolation under the wheels of a kind of Houyhnhnm juggernaut, travelling in reverse gear, was the exception. It had resolutely passed into Umfreville myth. Captain Fox's end, he had been promoted during the war, was less dramatic, though certainly brought about by some fatal accident near the course, terminating forever a risk of seeing an old enemy at future race meetings. It would be worth asking Umfreville if he had his own version of funiculi funicula, an accomplishment by no means out of the question. The present vocalist to some extent controverted Frederica's argument, supporting Moore's St. John Clark's observation that growing old consists abundantly of growing young. The aged singer looked as if thoughts of death, melancholy in any form, were unknown to him. He could be conceived as suffering from rage, desire, misery, anguish, despair. Not melancholy. That was clear. Additionally so after the round of applause following his number. The clapping was reasonably hearty, considering the heat, almost as oppressive as throughout the day just past. Dr. Emily Brightman and I joined in. Acknowledgment of his talent delighted the performer. He bowed again and again, repeatedly bearing blackened, sporadic stumps, while he mopped away streams of sweat that coursed down channels of dry, loose skin ridging either side of his mouth. Longevity had brought not the smallest sense of repletion where public recognition was in question. That was, on the whole, sympathetic. One found oneself taking more interest than formerly in the habits and lineaments of old age. In spite of the singer's own nonchalance, the susceptive tunes of the musicians, the gorgeous drop scene, the second carafe of wine, infected the mind not disagreeably with thoughts of the evanescence of things. At the beginning of the century, Marinetti and the Futurists had wanted to make a fresh start, whatever that might mean, advocating, among other projects, filling up the Venetian canals with the rubble of the Venetian palaces. Now the Futurists, with their sentimentality about the future, primitive machinery, vintage motor cars, seemed as antiquely picturesque as the Doge in the Bucento, wedding his bride the sea, almost as distant in time. Though true that a desire to destroy, a hatred and fear of the past, remained a constant in human behaviour. "Do you think the soubrette is his mistress, his great-granddaughter?" asked Dr. Brightman. "They seem on very close terms." "Perhaps both." From our first meeting at the opening session of the conference, when friendly contacts had been achieved by mutual familiarity with Borage and Hellebore, my book about Burton, and her own more famous work on the triads, Dr. Brightman had made clear a determination to repudiate the faintest suspicion of spinsterish prudery that might, very mistakenly, be supposed to attach to her circumstances. Discreetly fashionable clothes emphasized this total severance from anything to be thought of as academic stuffiness, a manner of dress quietly but insistently smart. One of her pupils at the university, our niece Caroline Lovell's best friend, alleged a reputation of severity as a tutor, effortless ability to reduce to tears, if necessary, the most bumptious female student. Dr. Brightman, it was true, was undoubtedly a little formidable at first impact. We touched on the Dark Ages. She spoke of her present engagement on Boethius, in a form likely to prove controversial. The male Don of her name, known to me when myself an undergraduate, appeared to be only a distant relation.